Welcome to this complete Python course with handwritten notes. Python is the fastest growing language with tons of opportunities in the field of artificial intelligence, machine learning, and web development. My name is Harry and I will be your instructor throughout this course. We'll start from the very basic level and we'll then raise the bar like anything. The prerequisite of this course is nothing but only your time. You just have to come with your time and we'll together explore the possibilities and the concepts of Python. If you appreciate this initiative, I want you to give this video a thumbs up and drop a comment saying this video is helpful. Make sure you write a comment for me. Your feedback really makes me very happy. This course is divided into 13 chapters and 3 projects. Out of these 3 projects, we have 2 projects as a games and one of the projects is a Django Jumbo website. We'll learn to make a website in this course as well. If I was to suggest you one language that can help you do wide variety of tasks, that would be Python. Yes friends, that's the beauty of Python. Since the evolution of Python, a lot of things have changed. A lot of operators have been introduced. A lot of new concepts in Python like f strings have been introduced. We are going to see the updated concepts of Python throughout this course. For your ease and help, I have also included a cheat sheet with this course. I'll give you the PDF of handwritten notes. All this for free. You don't have to pay me anything. For your convenience, I have also timestamped this video so that you can see the chapters and navigate to the different parts of this video using the YouTube features. After you complete this course, you can add all these projects to GitHub and that will definitely help you enhance your portfolio. So enough of talks, make sure you like this video and let's get started. So as you can see that I'm inside this folder on my computer and this is nothing but the set of notes that I've created for you guys. You can refer to these notes after you have completed your Python learning and it is an amazing material for revision, let me tell you. So I'll be starting with the chapter 0 which contains how you can install Python, what Python is and more importantly what programming in general is. So let's open this PDF. As you can see, I have this PDF open. Let's discuss about what programming is and then we'll move on to Python, we'll install Python and we'll take things forward from there. So what is programming? Just like we use Hindi or English to communicate with people. So just like we have languages like English, Hindi, we have French, we have German, just like we have all these languages to interact with different kind of people. We have Python programming language to interact with the computer. We have C language to interact with the computer. We have Java, we have C++, we have JavaScript. There are a lot of languages out there which can be used to interact with the computer. Now let us say I have this pen and you need this black pen urgently. What will you say? You will say, hey Harry, give me this pen. But let us say I want this computer to start recording my screen. I cannot simply say, hey computer, start recording this screen. This computer is not going to understand. Now there are some special programs which can be programmed that way. I'm not talking about those. I'm talking about the direct instruction. If I say send an email to this person, to this computer which is not even turned on, this is not going to do that. So in order to interact with this machine, in order to communicate with the computer, what I'll have to do is I'll have to write a computer program and I'll have to write this computer program in some sort of programming language. So programming is a way to interact with the computer. It's a way to instruct the computer to perform various tasks. The tasks which computer can perform obviously. Now what is Python? Python is a simple and easy to understand language and it is one of the most easy to learn, one of the most loved and one of the most popular programming languages out there in the market. So it is a very interesting language to learn and this is an amazing time to learn Python, and the code written in Python feels as if we are simply reading simple English. So it's pretty easy for people to catch up and grasp what Python is. So this pseudocode nature of Python makes it easy to learn and understandable by beginners. Now let's get started with Python and let's install Python on this computer. In order to install Python on this computer, what I'm going to be doing is I'll simply write install Python and I'll simply follow this link python.org/downloads. This is the official Python website and I'll download the Python interpreter from here. Now you can see that I am being welcomed with this Python 3.9.4, which is a current version of Python. Let me tell you, this might not be the case for you. You might see some other version of Python. The version of Pythons keep changing every now and then. There is a new version with minor updates and tweaks in the market. So no worries if this version doesn't match. In fact, there is a high probability that this version will not match when you start downloading Python, because you might see this video later in the future. So let's click on this download Python 3.9 and let's run this piece of software. You can see that I'm being welcomed with this install Python 3.9.464-bit. Now it kind of sensed my operating system and gave me the required file. If you are on Mac OS or if you are on Linux, you will be welcomed with some other button which will download some other kind of file to your system. Since I am on Windows, this particular website has given me an option to download exe file using this button, and I have executed that exe file. As you can see, after I executed that exe file, I can see this pop-up and I can simply choose options from this pop-up. One of the most important options that I'm going to be checking is add Python 3.9 to path. You need to check this checkbox because I want my Python to be available from all the folders inside my computer. I'll tell you what it means, but just check this option and click on customize installation. Yes, we are going to go ahead with customize installation. Don't click install now, just click customize installation, click next, and then click this browse button. But before clicking this browse button, I want you guys to create a folder called Python inside your local disk C. By default, your Python will not be installed inside your local disk C, but let me tell you, if you install Python inside a folder which is very easily accessible like local disk C, Python, you can easily use Python and its resources. You can look into the folders, you can look into how Python works in the future. So it's just a great way to install Python. Simply go to this browse button and choose this folder. So I'll click this PC, local disk C and Python, and I'll click on OK and then click on install. And this will ask me whether I want to install Python on my machine or not. I'll click yes, and this will start installing Python on my system. I'll wait for a while, and this is fairly quick. It might take some time on your system. Just give it some time, and setup was successful. We have successfully installed Python on our computer. Let's click close and let's see if Python works from our PowerShell. So right click on Windows and click Windows PowerShell. And once you click on this, you will be shown this Windows PowerShell. I'll simply type Python here and bang, you can see 3.9.4 Python is working on this machine. Now I'll tell you how this Python works. You can simply play around with Python by typing 7 minus 4, which will give me the result, which is 3. When simply say 54 plus 7, which is 61, you will see 61. You can perform basic mathematical calculations. Python will do it for you, but this is not the kind of task we want Python to do for us, right? So let's type exit and opening closing parenthesis to instruct this interpreter to exit. Now I'll close this window and I'll move ahead with the chapter 0. So now we know what programming is, we know what Python is, we have Python installed in our system, and we'll look into the features of Python now. It is very easy to understand programming language. You will get to know while we move forward with this course. Very less development time is involved with the Python applications thanks to the easy to understand syntax. It's free and open source. It's a high level language. It's portable. You can either use it on Windows. You can tomorrow buy a Mac machine and you can simply use Python there, or you can go and buy some Linux machine, or you can buy some other OS of your choice, and Python will just work fine like the way it used to work in your previous machine. And it is fun to work with. You will get to know about this one after you make some programs with me. So we have already installed Python. I have simply mentioned that Python can be easily installed from python.org. While you click on the download button, Python can be installed right after you complete the setup by executing the file on your platform. This is fairly simple and straightforward. I have demonstrated this for you, and I've even mentioned just install it like a game. So it's fairly easy and straightforward to install Python. Along with Python, we want to install another piece of software which is called Visual Studio Code, and I'll tell you what it is. It's simply a modified notepad. Now I called Visual Studio Code a modified notepad just to make things simple. Visual Studio Code is a source code editor. It will make things easy for you while you're writing code in Python. Now a very simple question you might ask, can't I write the code in notepad itself?
The answer is yes, you can. You can definitely write Python code in Notepad itself, but it's not a great choice. It's not a good idea to use Notepad because of the reasons I'll mention. Let's install this Visual Studio Code. Simply open this code.visualstudiocode.com and click on Windows. Since I'm on Windows, I'll be clicking on Windows option and you can see that this is downloading. Let me execute this file and let me run it. Once I run it on my machine, I'll accept the agreement. I'll read this agreement and click on next and choose all these options if you haven't already. Just check whether these options are chosen by default or not. If they're not, go ahead and check them one by one and I'll tell you what these options will do. They'll simply make your life easier in the future. Don't forget this step. Just check all these buttons and click next and then click install, and this will install Visual Studio Code on your computer. Now many people will ask me that I have already installed Visual Studio Code and I haven't checked all those options. What do I do? You can rerun the same setup and check those options and you'll be just fine. But don't forget to check those options. We'll simply uncheck this launch Visual Studio Code and click finish because I don't want to open Visual Studio Code at this point. Now what is Visual Studio Code? What did we just install? You might ask. Let me go to a folder. Let me go to this particular folder, which is introduction. What I'm going to be doing is I will open this folder inside Visual Studio Code. What does it mean? What does it mean to open a folder inside Visual Studio Code? Let me right click here and I'll see this option which I was not seeing in the past, which is open with code. This is Visual Studio Code. Just click this option and Visual Studio Code will be opened with this folder as the context. What does it mean? If I show you this folder, you will see that this folder contains this file which is chapter0.pdf, and if I show you my Visual Studio Code, you can see that chapter0.pdf is here as well. What does it mean? It simply means that this folder has been opened inside Visual Studio Code. I have access to all the files inside this folder through Visual Studio Code. Now let us create a file using Visual Studio Code by clicking on this icon. This is simply to create a new file. This button is for creating a new folder and this is to refresh the Explorer. So whatever is here will be reflected here if you click, and most of the times this is auto updated, but in case if you have a lot of files inside your folder, you need to click this, but we'll hardly use it. Let's create a new file and I'll call it testfile.txt. And you can see that I am able to edit this file. I can close my terminal or I can open my terminal by clicking on new terminal, and this will open a new terminal with this folder as the context. This is the same folder which is here. I mean, the same folder in which Visual Studio Code is open. Just think about how cool is that. You will see this testfile.txt. If I edit this testfile.txt and I type something, let us say 1, 2, 3, 4, and if I save, you will see all the changes being reflected here as well. So this is truly amazing because whatever is being displayed here is being displayed here, and I have a bird eye view of all the files inside my folder from VS Code. And I also have an integrated terminal inside VS Code. So if I were to fire any commands from here, I can do that. I can type Python and this will open the Python interpreter. I'll close this for now, but I just wanted to tell you that you can have all the things that you need inside one single program at one single place. You can close them, minimize them whenever you want. And this particular program is going to make a life a whole lot easier when it comes to coding Python programs. So we'll see how we'll write a lot of Python programs in the coming chapters. So this was a basic introduction of Python. I just wanted you guys to be comfortable with Python. I hope everybody was able to install Python correctly. I want to make sure that each and every one of you were able to install Python, Visual Studio Code, and you were able to access my notes correctly. So I'll be following these notes, all the notes which I've written. This was chapter 0. We'll be moving to chapter 1 soon. And let's move on to chapter 1 to discuss more on Python, and let's start writing Python programs. Let's move on to chapter 1 now. So let me get started with chapter 1 by opening this PDF which I've created for you. So this is the PDF file which I've created for you. I am not sure why it's not opening. Let me reload. Let me open my Google Chrome yet again, and yeah, it works fine. I don't know what happened in the first go. Anyways, so chapter 1 is modules, comments and pip. So let's write a very first Python program and let's create a Python file and let's see how Python works. But Much before that, what I'm going to be doing is I'll open this particular folder, which is 1.chapter1 in VS Code. Remember, we opened this chapter in VS Code. Now we are going to be doing the same thing for chapter 1. So let's right click here and click this open with code option. This will open this folder in VS Code and I'll see all the files which are present in this particular folder here. So I can create a new file here and it will be reflected here. We have already seen that. We have no doubts about that. Let's create a file called hello.py, and .py is an extension that we use for Python files. Now, the moment I made a file named hello.py, my VS Code is telling me no Python interpreter is selected. You need to select a Python interpreter. So you can click either here or either here, select Python interpreter. So let me click here and you can see that I'm getting this option Python 3.9.4. So automatically my computer, my VS Code has sensed that I have this python.exe installed on my computer. So I'll click this and it will select Python 3.9.4. And now this knows that I have Python 3.9.4 installed on my machine. Let me click on this extensions icon and I'll tell you what are the extensions that I'm using. So extensions in VS Code perform more than what it already does. What I mean by that is we can have a Python extension and we'll get a lot of convenience options, and we can have live server, we can have different sort of extensions which does different things. We are going to be installing Code Runner, which is an extension. And let me install Code Runner. Code Runner is an extension which helps in running a code. I have already installed this Code Runner, and the moment I install this extension, I'll see a button right here. As you can see, I can use this button to run my code. Let me close this. So another option I'm being welcomed with is Pylons extension. My VS Code wants me to install Pylons extension. So let me install this, and this basically gives me a lot of features. You can have a look at this GIF and you'll see what kind of features we'll get with Pylons. And gc.collect, so you can see that gc was a module and it automatically showed the available options that a person can use with gc. We will see what this means and how this is going to help us. For now, I'll just click install and Pylons extension is now installed. It's saying reload this window to activate. So I clicked yes and it reloaded my window and my Pylons is installed. So at this point, you should have Code Runner installed. You should have Pylons installed. So let me do one thing. Let me write print, and the moment I write print or even PR, it shows me print. So this is what Pylons basically does. It kind of predicts what I'm going to type. So the moment I type PR, it predicted that I'm going to type print. And if I press enter, you can see that print has been written here. So if I write hello world in double quotes, you might be thinking, why have I used these double quotes here? Bear with me, just type whatever I'm writing and you'll be able to follow in the future. So for now, you just have to type this as is without thinking much about it. Just type print hello world, save this file by clicking Ctrl S on your keyboard and click this button. So the moment you click this button, you'll have an option to run the code. Click on run code and you can see that this prints hello world. Now I'm going to make a change here. What I'm going to be doing is I'll click on this gear, I'll click on settings and I'll simply type Code Runner and I'll see all these options. Do you want to clear previous output when you are running a file? Yes, I do want to clear my previous output, because if I am running a program, I want to see the fresh output of that particular program. I don't want to see the previous output along with the output of my current program. So I'll check this, and also what I'll be doing is I want to run my Python file in terminal. So let me check this one as well. Code Runner run in terminal. So now instead of showing me output window, it's going to show me terminal so that I can type further commands if I want to in that terminal. So let me tell you what it does. Let me save it and let me run the code for you. And if I run this file, you can see that it is directly running in terminal. You can also run in terminal by clicking this one, run Python file in terminal, but I simply run the code in terminal anyway. So I changed my setting to run the code in terminal. So now if I click run code, it will simply run this particular file for me in Python and hello world has been displayed. Congratulations, this was your first program in Python. If it was your first ever program, write congratulations in the comment. It's a great moment for you. I hope you are enjoying programming, and this is something which is bare minimum in programming. Whenever you are starting out with a programming language, this is the first thing that we do. We write hello world programs, and you have successfully done that in Python. Let me get back to the PDF that I've created for you. Let's write a very first Python program, create a file called hello.py, and paste the below code in it. We did exactly the same thing. We wrote print hello world, and let me tell you what print is. Print is a function in Python. We'll read more about functions later, but for now let me tell you, print something will print that particular something on the output window. As you can see that we simply type print hello world, and hello world was printed as is in the output window, and we are using these double quotes because we want to print hello world as it is. We don't want to reference a variable, which we'll talk about in this course. So let me get back to this PDF and let me talk about how to execute this file. So you can execute this file by using code runner extension. You can also execute a Python file by typing python space name of the file. So I'll type python and I'll type the name of the file. This can also help me execute the Python program. So you don't exactly have to use this extension, but this simply makes your job easy. You can simply click on this icon and click run code, and this will make your job easy, and you'll be able to run these kind of code snippets. So any file I want to run, I can simply open that file and do this, or I can type python Python and then hello.py. So I simply pressed H on my keyboard and pressed tab key on my keyboard, and it auto completed this to hello.py, which made my life a whole lot easier, because if I have my program names which are quite longer, it will be convenient for me to use tabs. So if my program name was, let us say, chapter 1 practice set.pdf.py, let's assume it was that way. So if I type Python and I pressed C, so you can see that it auto completed it for me. So when you type something and you press tab, it tries to guess what you want to type. So it tries to match all the characters which you have written with this, and will try to guess whether you are typing chapter 1 or you are typing hello or you want to type play. So this is Windows feature, specifically terminals feature. Let me get back to the PDF that I've created for you, and let's now move to modules. What modules are? So module in a Python is a file containing code written by somebody else. So this is usually a file which is not written by you. You might be an author of the module, that's why I've written this usually here, but in most of the cases, if you are beginner and you're using a module, you are basically importing somebody else's code which has been written by that person, and you can use that code without actually having to know how that code works. Let me give you an example. You are using a phone to make a call to your friends. Now you don't have to know how that phone exactly works, but you are making the call. You are able to make the phone call to that friend. So since you are making a phone call to that friend without having to know it, you are kind of using that module as a black box. You are using this phone as a black box. In a very similar fashion, we can import modules in Python, which can help us in doing different kind of work, and we can simply use those modules, import those modules into a program, and we can use those kind of programs. So let me show you an example of a module. So if I want to show you the example of a module, what I'll do is I'll create a Python file called mod.py, and I will import time. So time is a module which can help me to wait for a few seconds before doing something. So time has a function which is sleep, and I can specify the number of seconds I want to wait for while this line is executing. Let me wait for 2 seconds, and let me print hello world, or let me print 2 seconds have passed since this program ran. Okay, so this is something which I'm printing. By the way, let me tell you that you can minimize the explorer if you're running out of space and you have a small monitor. You can simply do that, and you can also close different files and open different files. That's your choice. I prefer to just open the file which I'm working with, and if I'm working with a framework, I simply open the files which I am specifically working with. Okay, so in this program, what I'm doing is I'm importing a module named time. So time is a module which has a function called sleep. I can use that function to wait for 2 seconds and then perform a task. So if you want to wait for some time and then perform a task, you can use this module. Let me click here and let me run this code. As you can see, the program has not ended immediately. It has not printed this particular line immediately. Rather, what it has done is it waited for 2 seconds and then it printed this particular line for me. Let me show it to you once again. It is waiting for 2 seconds before it printed. 2 seconds have passed since the program ran. So basically this kind of program can be written using modules, and there are different kind of modules. This was a very simple example of a built-in module. I didn't have to do anything to install this module. This was already available out of the box. And let me talk more about module now. So yeah, this was all about module. You can use somebody else's code and it makes your life a whole lot easier. Now let's talk about pip. Let's talk about what pip is. Now let us say I authored a module and you want to install that module. So if you want to install a module which is authored by me, what you can do is you can use pip to install that module. So let me give you an example. So pip is a package manager for Python, and you can use pip to install a module like Flask, which can help you to build amazing websites or APIs. Now you don't have to know what Flask is, but this is just an example of a module. Pip is a package manager which will manage all sorts of packages like Flask or Django. There are tons of other packages as well. Flask and Django is one example. We can use pip to install a module on your system and it will simply install it, and now you'll be able to use it. There are two types of modules in Python. One is built-in module and the other one is external modules. Now built-in modules are the modules which are available out of the box. You don't have to do anything to get them to your computer. You just have to import them, as we did here. As you can see, I imported this time module. Did I do anything special to get this module to this computer? No. I simply installed Python and I went ahead with using this module. Can I do the same thing with Flask? Can I say import Flask? We know Flask is a module. But the moment I say import Flask and I try to run this program, you can see that I'm getting this error. No module named Flask. So basically my Flask module has not been installed on this computer. I need to get that module, and I can get that module using pip. So I can use pip install Flask, and this will install Flask on my computer, as you can see. So it is getting all the files which it needs, and finally it successfully installed all these packages which were required for Flask to function properly. And now if I click on this run button and click on run code, this will execute this particular program without any hassles. It will not throw any module not found error as it was throwing in the past. So this way what I can do is I can simply install a module, get that module, and I can import that module to my program and I can make it work. So super simple, isn't it? So let me comment this out, and having said that, let me also tell you about what comments are. So what I basically did here was I pressed Ctrl +/ on my computer, and that commented this line out. What it means is simply I can press Ctrl / on my computer and I can either comment or uncomment a line. What does commenting a line means? Sometimes I want to write something in my program which I don't want to execute. For example, I want to write waiting for 2 seconds. So I basically want to tell user or the programmer which is looking at the code of this program that I'm waiting for 2 seconds here. Let me wait for 2 seconds here. So I'm doing this thing here. But if I save this and I try to run this particular code, I'm getting syntax error. And it is right, syntax error is expected here because waiting for 2 seconds is not a syntax. This is not valid Python code. But I want to keep this line here to instruct fellow programmers or developers that I am doing this to wait for 2 seconds. And I can write something meaningful here, like why I am waiting for 2 seconds, what the purpose of this particular line is. But I just want to write this. So there is a way to write it. There is a way to tell your Python interpreter that I want to keep this line here, but ignore this and do not treat this as a source code. So if I do this and if I save, you can see that I'll be able to run this code successfully. So 2 seconds have passed and the program ran, so I'm not getting any syntax error, which means if I want my Python interpreter to ignore something, I can use these pound symbols and write something, and that will be treated as a comment, which means my Python interpreter will ignore that particular line or set of lines. Okay, so let me get back to my PDF which I've created for you. So some examples of built-in module are OS, ABC, etc. Some examples of external modules are TensorFlow, Flask, etc. You can use these external modules. Sometimes you need to learn specific concepts before diving into these modules. For example, you need to learn machine learning. If you want to get into TensorFlow, you need to know what machine learning exactly is, why you want to learn machine learning, and all those kind of stuff. Then only you will be able to use the functions and classes available in TensorFlow. Now we'll get to object-oriented programming in the later chapters, but this was the introduction of modules. I hope you got what built-in modules are and what external modules are. So moving forward, let's discuss what REPL is. Now we have something called REPL in Python, and it's nothing fancy, just the name of REPL is fancy, believe me. What we are going to be doing is we'll right click on a start button and open terminal or PowerShell. If you are on Linux or you are on Mac, feel free to open PowerShell or terminal or git bash or whatever terminal you use on your operating system. I'm using PowerShell, so I'll simply type Python. If you have installed Python the right way, just like I did, you'll see this kind of prompt. This prompt is called REPL. Now what does REPL stands for and what REPL is? It's called read, evaluate, print, loop. So what it basically does is you are writing some sort of statements. We actually saw one way of executing Python programs, which is writing Python scripts. We create a file, we give it .py extension, and we simply put code inside of that. Now I'm importing time, importing Flask. All of these lines are executed one at a time, one by one, from top to the bottom. But in case of REPL, what we are doing is we'll keep on typing here and it will keep on getting executed as we press enter. For example, if I say print and I say hello world, and if I do something like this, it will print hello world for me. So it's basically executing it. It read this statement, it executed it, it printed the output, whatever the statement returned, and finally it once again is ready to accept my input. So it's kind of a loop. It's a loop. I'm writing something, I'm getting something, and then once again it's ready to take inputs. So it's basically a kind of loop. As you can see that I have mentioned about REPL here, we can use Python as a calculator by typing Python enter on the terminal. This is my terminal. I'm using PowerShell as my terminal. I can use this Python as a calculator. Now, once again, I again want to emphasize on the fact that we don't want to use Python just as a calculator. I know you have calculator in your phone, or maybe you might have that scientific calculator that we used to buy at college. I hope you have one if you have attended college. Anyways, so basically 3 plus 5 is 8 and 7 plus 8 is 15, and we can perform multiplication operations, we can perform different sort of operations. We'll read about operators more and more as we proceed, but you can see that it works just like basic mathematics works. Okay, so we can use Python as a calculator like this. I just wanted to mention about REPL. So this is REPL, and it's not like you'll never use REPL. You will write scripts for complex programs, but sometimes let us say you want to see that whether we can use single quote or double quote in this print statement or not. You can simply type it here and you can try it out, and let us say I want to test single quote and I want to see whether this works or not. This definitely works. So I can use this REPL to test something on Python. So let us say I want to check whether x works or not in Python. If I say 7x9, will it print 63 or not? Definitely it will not print, but let us assume I want to check it. I can check it using REPL. So since REPL is throwing an error, I don't have to create a file and then set up Visual Studio Code, set up my workspace, and then once again Python hello.py or whatever the name of the Python file is. You don't have to do all that. Simply open the terminal of your choice, type Python, print enter, and you are good to go. So this is something which is very, very handy when it comes to executing individual Python statements as opposed to the entire Python script. So this is called REPL, and I've mentioned it in the notes as well. Now let's talk about comments and discuss about what comments are. So comments are used to write something which the programmer does not want to execute. So basically you can mark the name of the author, you can leave some comments for the fellow programmers. Let us say you are leaving the company, or you might leave the company you are working for in the future, and you want to leave some sort of comments for people who might join in the future. You want to write some say something, some kind of behavior about the machine which the particular company is using, or let us say you want to type the date when the program was written. You can do all that using comments in Python. We have already discussed about comments. There are two types of comments in Python. We have a single line comment and we have a multi-line comment. Let's discuss about these two kinds of comments, and I'll create a file called comments.py, and I'll simply say import time.sleep. We now know how sleep function works. It will simply wait for 1 second, and let me say print waiting for say 1 second, and then once again I'll press Ctrl D to replicate it. Now you can set your shortcuts here in Visual Studio Code, keyboard shortcuts, and copy line down. So for me, copy line down is Ctrl+D. You can change this binding by clicking here, and if you click here you can enter the desired key combination and press enter. So this is something you can do in your Visual Studio Code to customize it for shortcuts. I have already customized my Ctrl+D. I don't want to waste a lot of time in explaining Visual Studio Code, because a lot of people use PyCharm for Python, a lot of people use some other kind of IDE or source code editor, so I don't want to spend a lot of time in editor. But in case you are following along and you are using Visual Studio Code, you can have some sort of keyboard shortcuts. And once again, if you don't want to use keyboard shortcut, or if you are not able to understand how keyboard shortcuts or certain thing works in Visual Studio Code, or if you don't want to spend a lot of time doing all this, you can simply select the line, copy the line, paste the line, and waiting for 1 second, completed. Okay, so if I run this particular file, let me click here and click on run code. You can say it waited for a second. Let me run it. Waited for a second, and then the second line prints and the program gets terminated because all the 5 lines inside the program has been executed. If I want to instruct a programmer which might see this script in the future, and I want to tell that programmer that, hey buddy, you can change this delay to something more like 5 seconds or something less like 0.2 seconds in the future. So if I write it for him here, if I write feel free to change the delay as per the instructions from your boss. Let us say I want to add this line for the guy who might see this script in the future. As you can see that Visual Studio Code has says that this is not a valid Python code. It has seen that there is some issue with this Python script, and that this Python script might not run in this condition. So if I run this code, you can see that it is basically complaining that what is this? I don't know what feel free is. I don't know what to change is. I don't know what the delay is. I do understand what import time is. I can import time. I can print this. But while scanning the script before executing it, it found some syntax error. And when a syntax error is present in your script doesn't execute at all. During the initial scan, Python found that these set of words are not valid Python code. This cannot be tolerated by the Python interpreter, and it throws an error. So what is an option for you? You are saying that I want to leave this message for the fellow developer who might see this code in the future, or maybe in the next 2-3 days, and you really want to tell this to your fellow programmers. You can either do this, or if you have more lines in your comment, if you want to write something else, let us say I want to add author, date, time. If I want to add all these 3 in my Python code, I can simply select all these 3 lines and press Ctrl/ on my keyboard. This will make all these 3 lines as single line comments. But in the past, when people didn't had the luxury of using these kind of IDEs or luxury of using the powerful computers, they used to do everything manually, and they used to do something like this. So this is a multi-line comment in Python. You can have these 3 single quotes, and you can have the author, date, time, or whatever kind of comment you want to put in your Python script. You can keep it here, and your Python script will still execute, because now you have explicitly told the interpreter that this line is not a valid Python code. I don't want you to execute this line. I rather want you to ignore these three set of lines and this particular line. So these are two ways of telling Python that I want to ignore some part of my code. So this is a single line comment which is used to ignore single line in the code, and this is a multi-line comment which is used to ignore multiple lines in the Python source code. I hope this is very clear. I hope you understood what I want to say, and I hope this is helpful. So let's get back to the chapter 1, and I hope you understood whatever I told you in chapter 1. Chapter 1 is completed, and I hope you enjoyed chapter 1. Let's move on to chapter 1 practice set now, where we are going to practice few questions on chapter 1. We'll see how comments, we'll see how modules and all these things which we have learned in this chapter works in action. Let's move on to chapter 1 practice set now. So here is my chapter 1 practice set which I'm going to be using for this particular practice session of this chapter. So write a program to print twinkle twinkle little star poem in Python, and this is straightforward and simple. I know you can do that, but let me solve it for you. Let me boost some confidence for you, because maybe you are not able to do this. Maybe you just skim through the chapter 1 and you are still learning print statement. Whatever be the case, just give it a try. And in case if you're not able to solve this question, I urge you to still be patient and just keep on listening, and you'll definitely be able to code. So let me search for this twinkle twinkle little star poem. Oops. Okay, so it just popped up. Twinkle twinkle little star poem. How I wonder what you are. Let me see if I can get the lyrics, and I'm going to be printing all of this one by one. Okay, so let me create a new file. I'll say practice set. So let me create a file. I'll say practice.py, and let me paste it right here. But as you can see that this is giving me some sort of error. So if you want to print this poem, what you can do is you can simply say print, and then you can copy this particular line, twinkle twinkle little star, and then once again you can cut this and you can print it once again, and you can continue with the entire poem. But let me give you another option which is much better if you're using Visual Studio Code. So now that we have this particular poem inside a file, what I want you to do is I want you to click here. Just click here. Bring your cursor to the first line at the starting of the first character. Now hold Alt key on your keyboard. So you guys have Alt key on your keyboard. Just hold that and start clicking on twinkle twinkle little star. How I wonder what you are. So whenever I click, I can see that cursor is blinking at that point, and if I type something, that particular character will be typed on all the cursors. Can you see that how amazing it is? What I'll be doing now is I'll press Alt on my keyboard. Now I'll press Shift on my keyboard, and then I'll click on line number 12, specifically the very first character of line number 12. And you can see these cursors are appearing at the start of each and every line. So if I write print now, print, and if I type something like this, you can see that I have typed print, opening parenthesis and double quote. Now if I press end key on my keyboard, you can see all these cursors are moving towards the end. I can type a closing character like this, closing double quote character, and then I can close all these parentheses by using closing parentheses. Now if I save this, you can see that I can run this code, and bam, my poem is here. So in case you thought this was a bit of overwhelming, I kind of taught you how you can use multi-cursor functionality of Visual Studio Code. Multi-cursor functionality of Visual Studio Code is amazing because it allows you to edit not only at one place but at different places wherever your cursor is placed. So I can edit all the commas like this, or I can simply select here, press Alt Shift, and then I can click here, and I can see all the cursors have appeared at the starting of the line. So I can manipulate however I want, but this comes with practice. So I want you guys to practice this multi-cursor functionality of VS Code, because this sometimes saves a lot of time, believe me. So let me save this file and let me do one more thing. So I'll close my Visual Studio Code and I'll tell you why in a second. But I want to rename all these files and I want to better manage these files. So let me number these files in the order in which I have written these. So 01, 02 and 03. So I hope the order is correct, but in the future we'll maintain this order. 03, this is the fourth program of chapter 1. So let me write 04 underscore, and this way you will better be able to manage all the programs after I give you the zip file of this folder content. So I'll be zipping all these folders and I'll be providing a link in the description for you to download the content so that you will have access to the notes, the practice set and all the programs that we are going to be writing in this course. So let's come back to Visual Studio Code. I will right click and click on open with code to open this particular folder in VS Code, and we were on practice. So let me rename this and make it practice underscore 1. So this is question number 1 of the practice set. So this is how you write the poem. Another way of writing the poem is you can simply say print triple quote. Let me copy the poem once again. I lost the poem. Let me copy it. You can paste it, and once again you can type triple quotes. So print twinkle twinkle little star, how I wonder what you are. You can print all these things, and then what you can do is you can close it with the triple quote. So you cannot do the same thing with double quote, by the way. If you are wondering, that will work. If you do something like this, you will get an error. If you are using double quote or a single quote, you will have to close the double quote in the same line itself. But if you want to print multiple lines, you can use triple quotes like this. I'll press Ctrl Z on the keyboard to undo, and this is how you can print the poem as well. So if I remove this, or rather if I press Ctrl/ on my keyboard to comment this out, you can see that print twinkle twinkle little star, the entire poem, it will be displayed once I run it. So you can see that the effect is very similar, except the fact that I'm able to paste the entire text which I want to print here, as opposed to typing each and every line individually. I hope you got both the approaches, and both the approaches are fine, but the second one is a bit clever approach. First one is also clever in the way that we posted it, but again, you need to know both of these approaches and you need to have all the tools in your tool belt. Let's move on to let's move on to question number 2 now. Where is my practice set? Here is my practice set. So let's move on to the next question of practice set. It says use REPL and print the table of 5 using it. So let me open REPL. I can either use this PowerShell, control scroll to zoom in. I'll control scroll to zoom in for you to see it clearly. Let me fire Python so that you can see the REPL. So this is REPL, read, evaluate, print loop. Okay, I need to type 5 multiplied by 1. This is 5. I can do 5 multiplied by 2. I can do 5 multiplied by 3. 4, 5, 6, and I know that you are not interested in watching me type this all the way to 7, 8, 9 and 10, but let me finish it very quickly. So I'll simply use arrow keys, and then I'll say 5 multiplied by 9 and then 5 multiplied by 10, and my bad, I have entered 5 multiplied by 8 twice, but you got the point how to use the REPL. So this is how you can print multiplication table of 5, but there is a better way to print multiplication table using loops, which we are going to see in the further chapters. But for now we have solved the problems. You should be happy about that. So this is how we solve this particular problem using the tools which we have learned so far. So this is not the best way of printing the multiplication table of 5, let me tell you, but we solved it using REPL, so you should be happy. Let's move on to the next question, which is install an external module and use it to perform an operation of your interest. Now this is a very generic question. You can install any module, you can install any sort of module, and that will do. So I've created this file for solving this particular problem, and what I'll do is I will be using some module. I'll install that module first of all, and then I'll show you what we can do using that module. Okay, so let me search on the internet text to speech Python. So I'll type something and I want Python to speak it up. Okay, so let's see if it is possible using this module. I just randomly searched the internet and I was landed on this page. I'll pip install pyttsx3 I'll try to install this module and hope everything works fine. Let me install this module, and it is collecting pyttsx3, and let me see how to use it in the meantime. And let me copy this and paste it here, and let me see if I'm able to make it speak whatever is written here. So let me say, hey Harry, I am a Python module. Welcome to the world of Python, and feel free to replace Harry with your name. And this module is installed. Let me see if it works. If it works, it will be amazing. It will be a very good experience for a beginner to listen.
Hey Harry, I am a Python module. Welcome to the world of Python.
Wow, that was amazing. That was very satisfying because of the fact that we just started learning Python and we are able to do something like that. So this is amazing. So I'll tell you how you can customize this particular thing to create a software which can take user input and speak whatever you are typing. So that way, if you want to remain silent, or if for some reason you cannot speak or don't want to speak, you can simply use the software to type something and convey whatever you want to say to a person who doesn't want to read. So without texting, you are kind of speaking to somebody, but you're not actually speaking to somebody because Python is doing that job for you. I hope you are enjoying this course. Let me know in the comment section if you are enjoying this course, and I'm trying to make it as enjoyable as possible, believe me. So let's move on to the next question. This was amazing. This question was very satisfying. So it says, write a Python program to print the contents of a directory using OS module. Search online for the function which does that. So the question mentions that OS is a module. OS is a Python module, and the question asks you, search for the function which is able to print the contents of a directory. So I have a directory here. This is a directory and it has a .vs code folder. It has hello.py file and a bunch of PDF files along with a .mp3 file. I want to see what is the content of this folder by using Python. Let's make that program. So this is question number 4. So let me create a file called 06 or 6 program practice_4, because this is our question number 4. This is our 4th question. Import OS. Let me see if import OS works. That will tell me whether OS is working or not. Oh, I forgot to type .py. So I'll select this, I'll click on it, and then I'll press F2, and then I can change the name of this file. I can also do something like right click, rename, and I can change the name of the file. So you can do whatever you like to rename a file in Python. I'll move ahead and run this particular .py file as is. I'll just try to see if OS works, if OS is a module which actually is present on this computer and is working correctly. If it doesn't, I'll get a module not found error. If it does, I'll see nothing. Let's see. Let's run this file. Okay, so I see nothing. I don't see any error. If I say import Harry, I'll definitely see error because Harry is not a module in this installed in this particular system. So if you create a module named Harry and you installed it, that is a different story altogether. But I don't have any module which is called Harry installed on this computer. So I'll say run code and I'm getting this module not found error. So basically what my Python program is telling me is this module is not present. So you're better off solving this issue. I'm not going to run any further statement. So this is what Python interpreter is telling you. Okay, so we are importing OS and we'll run it and this works fine. So we are happy. Now we are in search of a function which can print the content of a directory, and let me tell you, it's called listdir. Now you might not know how listdir works, but you can print os.listdir and you can simply get all the contents inside a folder. So I'll simply show you how this works. And you can see that I have all these files and folders which are present inside this particular directory. And I can use this program to print all the files which are present on this particular folder. Which folder? The folder where terminal is running. My terminal is running inside this folder 1.chapter1, and I can run this program anywhere. I can take this file to somewhere else. I'll show you. If I copy this 6_practice set.py and if I paste it here, and now if I try to run it, let me open PowerShell here. I press shift on my keyboard and then I press right click, shift right click, open PowerShell window here. This will open PowerShell window here, and I can say Python 06 and I'll press a tab to autocomplete. I repeat, tab tab key on your keyboard to autocomplete. Press enter key and you can see the story is different now. You are seeing the chapters, the folders and the files which are present inside this particular folder. So all these chapters are displayed, all these folders, all these chapters which are nothing but Windows folders are being displayed. And also this particular file will be displayed, this 06 underscore practice4.py, because this is also a part of this folder. So I'll delete this file from here because I don't want to confuse you. I want to keep things organized before I give all the source code to you. So this is how you can list all the directory contents using Python. Now the question mentioned that if you don't know the name of that function, how do you do that? So you simply go to Google and you say os plus, or rather Python os plus, and then you type list all directory content and you'll be welcomed with a lot of links. I trust Stack Overflow personally, and you can see that this particular function is here with the answer, and this answer has received 5043 votes. So this should definitely work, and this worked as we saw. So we solved practice 4, question 4 of the practice set. Let me move to question number 5 now. Label the program written in problem 4 with comments. So you can label this program with comments. So let me label this program with comments. I'll say importing the module, then I'll say function to display all the directory content. Okay, so this is how I can label a program with comments. I can also type author Harry, and then organization, programming with Harry, and so on. I can write date, I can write co-author, I can write all those things. Okay, so this is how you label a program with comments. Okay, you can add comments to your program, but one suggestion I want to give you here is that you don't have to add useless comments to your program. Whenever you are writing a program as a programmer, you need to ensure that whatever you are writing is useful for the fellow programmers. You don't have to write something which is not useful. For example, writing importing the module is completely useless, because when somebody sees import OS, they know that you are importing the OS module. So you don't have to explicitly mention that using a comment. You should mention something which the programmer might not know. You should not say that I'm printing here, because that's so straightforward. If you're using print function, you're definitely printing. Okay, and even about the os.list.dir, you should not write details about a function inside a program, because if somebody wants to know about list.dir, they can go to the OS documentation online and they can, come back and have all the knowledge about how list.dir works. What you want to write in your program is how and why your program functions the way it functions. And you should add the information which anybody maintaining the code or anybody who is going to improve the code might need. So I hope you like this practice set. Chapter number 1 is complete, and I hope you enjoyed chapter number 1. Let's move on to chapter number 2 now. So let me open this PDF of chapter 2 and let's get started with chapter 2. So I'm going to be opening this chapter 2 PDF, and let's talk about variables and data types now. What is a variable and what are data types? This is something we are going to discuss in this chapter. Now, so far what we have seen is we can create programs like this, where we are basically executing the line of codes which doesn't include any variable. Okay, so we simply executed a print statement. Whatever is given to the print statement inside the double quote, it will print it as it is something which we have seen so far. Now let's close this and let me open this particular folder in VS Code. So what I'm going to be doing is I will close this and I'll create a new file which is 01 underscore variables.py, and I'll tell you about variables. Okay, so let me select a Python interpreter and let me close this. So at home, you might be having sugar, you might be having rice, you might be having some place to store the drinking water. Now, why am I talking about all that? You must be thinking, like, why am I concerned with the place where you're storing your drinking water? So I am going to compare these variables with the place or the container where you are storing your water or rice or grains for that matter. So variables are basically containers in memory. They are basically responsible to store anything which can be used later. It can be a number, it can be a string, it can be a number with decimals. Let's see what kind of variables we can use. So if I come back to my notes, I have written a variable is the name given to a memory location in a program. So it's basically a container which can store something. It's a location in memory which can store something. So if I say a is equal to 30, now a has been created as a variable which contains this number which is 30. So 30 is inside a. So variables are containers to store a value. Now you can see b is equal to double quote Harry. So whenever I'm writing a double quote, I am basically saying that this is a string and this should be treated as is. I'll tell you why we use this double quote. Let me come back to this program. If I say a is equal to 34 and if I run this program, I'm running this program to ensure that I'm not doing any syntax error. I'm ensuring that I am not writing something which is syntactically wrong. This is valid and this is basically telling Python to store 34 inside this variable called a. Now, can I print this a? Yes, I can. So I'm printing this a and 34 will be printed on the screen and not a. I hope you understood why a is not printed and why 34 will be printed. So if I run this, I will have to not select anything and run the code. So if you select something and try to run it, it basically tries to run that selected part. So I'm simply clicking somewhere and I'll simply say run code so that I am actually executing this entire file. So a is equal to 34 and if I say print a, then 34 is being displayed. Now let us say you want to display character a on the screen. Let us say you want to display a as is here. You will say I have written print a if there were no double quotes. You will say I have written a and a is not displayed. What's wrong with Python? So there is a confusion. There is a dilemma on what should be printed if somebody writes print a. To avoid this sort of dilemma, what Python programming language syntax enforces is that if you want to see something as is, put it inside a double quote or single quote. If I say a, now what I'll see on the screen is the literal letter A. I'll be seeing this 34 and this line will be printing the letter A. Let me show it to you. So you can see that 34 is printed, then A is printed. This is printing a number. This line is printing a string, which is A. I can say a duck, and if I print this, you can see that a duck has been printed. So this is kind of how variables work. I'll come back to the notes now. I can even say C is equal to some decimal number. I can say C is equal to 56.23, and if I print C, you can see that I can say print C and this will print this number as is if I run this code. So 34, a duck, and I was expecting some number here which is printed. Okay, so 34, a duck, 56.23. So I hope you have understood how these kind of things work in Python. We can create containers in memory and we can allocate something to be stored in those kind of containers. Coming back to the notes, I have talked about data types. So let's talk about data types. Now, what data types are? Primarily there are following data types in Python. We have integers, we have floating point numbers, we have strings, booleans, and none. Let me talk about all of these briefly and then we'll dive deep into each one of these. Integers are basically the counting numbers 1, 2, 3, 4. Even negative counting numbers are integers. -1, -2, -3 are integers. 0 is an integer. Now let's talk about floating point numbers. Floating point numbers are real numbers which can be represented in the form of decimals. So we can have 34.22. It's a floating point number since we have a decimal there. 61.22. You can have tons of examples as floating point numbers. Now let's talk about strings. String is basically used to store sequence of characters. If I were to store twinkle twinkle little star poem in some sort of container, I'll create a string variable aka string container. That particular container will contain that twinkle twinkle little star poem. So string is used to store sequence of characters. Now let's talk about boolean. Sometimes we want to just store the information on whether something happened or not happened. So either I am wearing a black shirt or I'm not wearing a black shirt. It's a Boolean variable. It can be true or it can be false. Either I'm going to eat the pizza or I'm not going to eat the pizza. This is a Boolean variable. It can be true or it can be false. So Booleans are basically used to store either true or false. They cannot contain anything other than true or false. Thus they save a lot of memory by doing that. So sometimes when we just need to store the information on whether some event is happening or not, we use Booleans. Now none in Python is a data type which is used to tell Python explicitly that none of these data types are stored in this variable, and this variable is not being allocated something. So let me show you what it means. If I say a is equal to none, so if I say, or rather d is equal to capital none, and if I print d, I'll be seeing none. Okay, so none is something which is nothing. So we have a data type for nothing in Python, and that is none. It is used in a lot of occasions. We'll talk about when to use none and when not to, but for now, just think of none as nothing. It doesn't have any data type. It's kind of is just none. So you can store this particular information that this variable contains nothing using none. Okay, so I hope that you got the point. Now I'll be opening this notes and we'll talk about integers in details. Now Python is a fantastic language that automatically identifies a type of data for you. So if you are coming from a language like C or C++ or Java for that matter, you'll have to explicitly mention that I am writing this particular variable as string, or I'm writing this particular variable as float or boolean or even none. So in Python, you don't have to mention all these things. You don't have to mention whether your variable is a string or your variable is a floating point number or boolean. Python basically automatically does all those things for you. So let me open this file, and as you can see that while allocating 34 to A, we are not writing whether A is an integer or not. In a very similar fashion, we are not mentioning that C is a floating point number. In a very similar way, we are not mentioning that a duck is a string, or I can even say E is equal to a duck, and I can print E, and I don't have to mention whether E is a string or not. Python is smart enough to identify that a duck, since it's inside double quotes, is a string. So if I run this particular program, you can see 34, a duck, 56.23, none. This program executes perfectly without any errors. Now we understood how these variables are created. We made few of the variables, and now we'll understand what kind of names are valid variable names. What I mean by that is when we create a variable in Python, there is some sort of rules which are imposed when you try to create a variable name. And I'll give you an example. If I try to create 76i is equal to 54 or 45, this is not a valid variable name. If I try to run this program, I'm going to get a syntax error. And the reason for the syntax error is that this is not a variable name which is valid. So what did I do wrong? What was the mistake that I committed? I'll tell you about it. Let's come back to the notes and talk about what are the rules for defining a variable name in Python. And this also applies to other identifiers as I've written here. So let's talk about what identifiers are, what variables are, and what keywords are. I have mentioned this in the notes, but let's talk about it in detail. Variable are container to store a value, as we have already talked about. We have already discussed about variables. Keywords are some of the reserved words in Python which Python programming language has specific meaning of. For example, none is a keyword and the meaning of none is nothing. It is a data type. I'll give you another example of a Python keyword, and it is in. In is a keyword, for is a keyword, while is a keyword, and there are a lot of keywords which have different sort of meaning in Python. We are not going to use all these keywords as a variable names. Now let's talk about what identifiers are. Identifier is something which has been named by us. For example, I can call this Harry variable as B. I can call this 30 variable as A. I can name another variable as C. I can create a variable name number of boxes or number of attempts and so on. I can create a lot of variables. So something which has been named by the user is identifier. I gave that particular thing, that particular storage, a name so that I can identify it in the future. Just like your parents have given you a name to identify you and distinguish you from somebody else, in a very similar fashion, identifiers in Python work. Now, what can be an identifier? It can be a class, it can be a function, it can be a variable name. We haven't discussed yet about class or function. We have discussed about variable names, and we are going to continue the journey of variables in this chapter. Let's talk about what are the rules for defining a variable name or any identifier for that matter. A variable name can be alphabets, it can contain digits, it can contain alphabets, it can contain underscores. A variable name can only start with an alphabet and underscore. So the first rule is it can only contain either of alphabets, digits, or underscores. You cannot have any special character in variables. So special characters in variables are not allowed. You cannot use dollars, you cannot use pound symbol, you cannot use some other special symbol like exclamation mark, @ These are just not allowed. The second rule for creating a variable name is that the variable name can only start with an alphabet and underscore. You can either use alphabet or you can use underscore to create a variable name. Let me show you an example of invalid variable name which violates rule number 1 and rule number 2. So rule number 1 was it should contain alphabets, digits, or underscores. Let me get back to my 01 variables.py file and let's try to create a variable which doesn't contain just alphabet, numbers, or symbol. So if I try to create this variable, you'll see that I'm getting syntax error. Ampersand is just not allowed because it is a special character. Star is not allowed in a very similar way. Just like ampersand was not allowed, star is also not allowed. So let me save this before running and you can see that it's invalid syntax. Once again, if I try pound symbol, I'll get an error. And you can see that if I try a pound symbol, it's saying IK is not defined. So basically when I use or try to use pound symbol, it is getting confused and it is thinking that I'm trying to write a comment, but I was trying to create a variable with pound symbol. So these things are just not allowed. Your variable name should only contain alphabets, digits, and underscores. Let's talk about another rule of variable names, which is it can only start with an alphabet and underscore. Now let us assume that my variable contains alphabet, digits, and underscores. Let's create a variable. Let's say IK. IK is a variable which is valid, and I can show you by running this program that it just works fine. No problem whatsoever. I'm not getting any syntax error or anything. But if I try to make it 5IK, if I start the name of this identifier with a number, it's not allowed. I cannot use this. I cannot use number to start. I can definitely have number here or here for that matter. I can do that, but I cannot start my variable name with a number. It's not allowed. If I try to do that, I'll get a syntax error. You can see I'll get a syntax error. This is invalid syntax. It's telling me that you cannot just use 5 as starting character of a variable name. Okay, so I hope you got the point. I'll remove this and I'll show you that 5 here works and 5 here also works, and this is just fine. This is working just fine because it's not starting with any number. It's just not violating any rule which I talked about for creating variable names. The third rule is it can start with a digit. It just cannot start with a digit. It can only start with the alphabet or an underscore. Okay, so no white space is allowed to be used inside a variable name. You cannot use white space because if you try to use white space, you are going to get an error. And the reason is that Python wants your identifier to be separated from other part of the syntax. A white space is sometimes used as a part of syntax in Python, and Python doesn't want its users or its internal mechanism to get confused with what is a variable and what is a white space. So it doesn't allow you to keep white space inside variable names. I hope this is clear and this was very straightforward. So these were some of the rules for creating a variable name, and we can now see some of the valid variable names. I have given example of some of the variable names. Harry is a variable name, it's valid. 18 is a variable name, it's valid. 7 underscore is valid, underscore 7 is valid, and so on. Okay, you can have a lot of variable names which are valid. I want you to write 2 or 3 in the comment section below. If you do that, you'll definitely practice. So just leave a comment with few variable names, and we'll now move on to operators in Python. What exactly are operators in Python and why operators in Python are important? So what exactly is an operator if I talk about it from mathematical perspective? Operator is something which acts on something called operands and produces a result. For example, if I apply plus operator on 5 and 7, I'll get the sum of 5 and 7, which is 12. If I try to apply minus operator between 5 and 2, I'll get 3. 5 minus 2 is 3. Okay, so this is how operators work in Python. There are some common operators which I'll be talking about in Python. So we firstly have arithmetic operator. Let's talk about arithmetic operator. I'll create a new file 02 underscore and I'll say operators.py. So this will simply keep my different topics separate from each other. So what I'll do is I'll try to create a variable name a3 is equal to 45. Is it valid? Yes, definitely it is valid because it's not violating any rules. It's not starting with a number. It doesn't contain any special characters. It's starting with a letter and it has a number, and a variable name can have a number. Okay, so a is equal to 45 I'll say, and I'll say b is equal to 64. Okay, now I'll try to use some of the operators and I'll try to demonstrate all these operators to you. So let's talk about arithmetic operator. So we have arithmetic operators in Python. So let me demonstrate all kinds of arithmetic operator to you. So I'll print a plus b. I'll say a plus b is equal to, and I'll use comma. Let me tell you that you can print multiple values using print statement. You can use comma and all the values will keep on printing through single print statement if you use comma. So what I'll do is I'll say a plus b is equal to, I'll say comma, and then I'll do a plus b. And in a very similar manner, what I'll do is I'll say a minus b. And let me do one thing here. Let me make my a as 75. I just want to make a greater than b. There's no logic behind it, but since I am subtracting b from a, I just want to keep things simple and I want to make my a greater than b. So let's see what the output of this comes. And you can see that a plus b is equal to 139, a minus b is equal to 11. So as we can see that a plus b 75 plus 64, let me make it a bit simple. Let me make it 7 and 3, so that 7 plus 3 will be 10 and 7 minus 3 will be 4. That's a bit easy, right? So let me now demonstrate some other operators. So we have times and we have divide. So multiply and divide. Okay. And the main thing which is multiplying and dividing is the second part. This is simple string which I'm printing. This is actually performing the calculation and printing the result. So you need to make sure that you have star applied to the both sides. This is simply merely printing this as is here. Okay, so let me show you. So if I say a divided by b is equal to, this will be printed as is, and this will actually perform the calculation. So you need to make sure that you are changing this to slash here as well as here. Okay, so you can see that a plus b is 10, a minus b is 4, a multiplied by b, which is 7 multiplied by 3 is 21, and a divided by b is 2.333333. Okay, I hope you got the point, and let's now talk about assignment operators. So the value of a was 7 and the b was 3. We'll have another set of variables for our assignment operators. I'll say c is equal to 5 and d is equal to 7. Now what I'll do is I'll try to print 5 and 7 by printing c and d, and no surprises, I'll get 5 and 7 printed on the screen. Okay, and let me do one more thing. What I'll do is I'll create a print statement. I'll say demonstrating assignment operators in Python. Okay, so whatever is printed above this line can be ignored because that was the output of arithmetic operators. Now we'll talk about assignment operators. So let me copy this. I'm just trying to make this code very structured for you, because in case you want to revise, in case you are coming back to the notes and trying things out yourself, I want you guys to have the code at a single place, and I want it to be in a particular order, in the same order in which I am demonstrating all these things to you. So that will make things easier for you. Let me now do one more thing. Let me try to demonstrate assignment operators, sorry. What I'll do is I'll say c is equal to 5. So is equal to is an assignment operator in itself. What it does is it takes this right value and it assigns it inside c. So what it is doing is this is taking this constant, which is 5, and it is putting it inside the container. So just like I'm putting this pen inside the mug, I'm not going to do that, but I'm just trying to demonstrate. I'm just trying to make a point. I'm not putting this pen inside the mug. I don't want to do that. So 5 is put inside C. Okay, so we can put 5 inside C. So C is the name of a memory location, and 5 is a constant which I want to put inside that memory location. I hope I made it very clear now, because we have been talking about variables since a while now. Similarly, 7 is put inside a container whose name is D. So 7 has now been put inside D, just like I was about to put, but I'll actually not do that. I can put this pen inside this mug. I'm not going to do that. I use this mug to have my coffee. So what I'll now do is I'll say C plus is equal to 5, and I'll once again print C and D. Now how did I copy a line below? I told you I used Control D. I have my keyboard shortcut set. And how did I move the lines? I pressed Alt key on my keyboard and I used my arrow keys to move this line. So whenever you have cursor somewhere and you press Alt key and then you move your line using up down arrow key, you can use that. Okay, you can use your up down arrow keys to move the line. So C plus is equal to 5 and D plus is equal to, I'll give it simple. I'll say 1. I'll say plus equals to 1. And what this will do is, this is an increment operator. This will add 5 to C and 1 to D. And I'll show you the output here. Firstly, 5 and 7 will be printed on the screen, and then 5 plus 5, which is 10, and 7 plus 1, which is 8, will be printed on the screen. So let me run this for you. So 5, 7 and 10, 8 has been printed on the screen. So this is how these assignment operators work. Let's talk about some other assignment operator. Another assignment operator is minus equals to plus equals to, has already been demonstrated by me. I want you to practice minus equals to by yourself. Let's come to comparison operators now, and let's talk about what comparison operators will do. So what I'll do is I'll simply press Ctrl D, I'll replicate this, and I will say demonstrating, go to the next one, comparison operators in Python. So I'll simply keep the code structured so that you can later come back to this code and you can simply revise peacefully. So A, B, C, D, E, F. So let's say E is equal to 6 and let's say F is equal to 9, and I have given an extra space here, which is why Python is complaining. And let me make a point here. You cannot add a tab or a space unnecessarily in Python. If you try to do that, you will get syntax error. If I try to run this file after giving a single space, you will see indentation error, unexpected indent. And we'll talk more about indent in the future. But make sure, if you're coming from a language like C, C++ or Java, I know spaces are allowed there, but don't try to do that in Python. You need to keep the code as is until we reach the point where we discuss about indentations, for loops, while loops, and so on. So print demonstrating comparison operators in Python. E is equal to 6 and F is equal to 9. Now if I try to print E double equals to F, what will be printed on the screen? So if I say E double equals to F, you might think that E will be assigned to F, but no, double equals to in Python means comparison. And when you are doing a comparison, if I ask you a comparison question, if I ask you which car is better, Hyundai i20 or Tata Altroz, you are kind of making a comparison. If I tell you that Hyundai i20 is just equal to Tata Altroz, they both are equal. They both are just equal in features and in comfort and luxury. So I'm making a point here. I'm making a statement here. Now this statement can either be true or it can be false. In a very similar way, I'm saying E is equal to F here. It can either be true or it can be false. In this case, it is false because 6 is not equal to 9. We know that. And if we try to run this, you can see that it's false is printed on the screen. This particular thing is returning false. If I say E is greater than F, is it true? Is 6 greater than 9? No, it's once again false. So another false will be printed on the screen. Is E lesser than F? Yeah, that's true. So true should be printed on the screen. I am waiting for the output. Did I run it? Yes, I did. False, false, true. So when I say E is less than F, true is printed on the screen, because E was actually lesser than F. 6 is less than 9. Okay, we all know that. And comparison operators are used for logic building in the program, and we are going to use comparison operators in a lot of our projects. In almost every project, I can say I use comparison operators. They are so useful, they are so handy, and you'll definitely use them a lot of times. So let's talk about what kind of comparison operators we have. Double equals to is a comparison operator which compares two variables whether they are equal or not. Greater than is another one which compares whether a given number is greater than another number or not. Greater than equal to is another one. Lesser than is one. Not equals to is one. And I want to demonstrate this one. If I say E is not equals to F, this is true. E is not equals to F. And let me do one thing. Let me keep the E less than F. And you'll see two falses and two trues here. So false, false, true, true, because this is false, this is false, this is true. And once again, E is not equals to false, F is true, because 6 is not equals to 9. Let's try to run this program, and you can see that false, false, true, true has been printed on the screen. So this is how comparison operators work in action. Let's come back to the notes and let's talk about logical operators now. So logical operators are also used to impart logic to a program. The difference between these is that the comparison operators are used to compare two identifiers, an identifier with a constant or two variables for that matter. But in logical operators, what we do is we try to add two types of comparisons with each other. I'll tell you what I mean by that. So I'll close this and I'll say Control D, and I'll say logical operators in Python. Let me copy this, and E is 6 and F is 9. If I say E double equals to F and E is greater than F. So and returns true only if both of the conditions are true. If I say I am a good boy and I like ice cream. So if I don't like ice cream, the entire statement is false. If I say I am a good boy and I like coffee, if I'm not a good boy, the entire statement is false. Okay, so both of these statements have to be true. In case of OR, either of the two statements can be true and true will be printed on the screen. We also have another logical operator which is not, and I can pass not of E greater than F. I can do not of something to convert false to true and true to false. Let's see how these work in action. So if I run this code, you can see that E equals to F and E greater than F, this returns false. This once again returns false because this is false and this is also false. So both of these is false, hence it is false. If either of these is true, this will return true. I'll show you. If I make E is less than F, which is true, and if I make E equals to F, which is false, then false or true will actually return true, because when we are using OR logical operator, either of these conditions, if either of these conditions is true, then true is returned. But in case of AND, if both of the conditions are true, then only true is returned. Let me demonstrate this for you, and you can see that true is now printed on the screen. In case of NOT, if something is returning false and we are using not on top of that, what will happen is it will reverse true to false and false to true. So E greater than F was actually false because E was not greater than F. You can see E is 6 and F is 9. But what happened was we are using a not operator. So not operator will reverse false to true and true to false, and this is what happened, and hence we see true printed on the console. So this is how operators work in Python. Now let's talk about the type function and typecasting, and what does type function return and what typecasting mean in Python. So type function is used to find the data type of a given variable in Python. Remember, I told you that you don't have to explicitly mention the type of a variable you are creating in Python. Python automatically takes care of that. But you can actually get the type of the function, the type which Python thought would be fine for your variable. You can get that type using the type function. I'll give you an example. I'll make another file. Let me call it 03 underscore type.py. And let me create a variable called A. This is A, and let me say B is equal to 34. if I print A and if I print B, you'll see A and B printed on the screen. This is A and 34 will be printed on the screen. No surprises there. But if I say type of A, let me replicate it once again. If I say type of A and if I say type of B, I'm basically asking Python, I gave you something to be stored inside A. What was the data type that you chose to store this? Did you get the point? Let me show it to you. Let me run this code and you'll see. So A was a string. Okay, so let me make it B. I made it AA. Since A is a string, I'm getting this class str, and since B is an integer, I'm getting this class int. So if I make B is equal to none, or let me create another one, and let me once again create another one, and you'll see that all these variables will be printed and the types will also be printed. We'll print the types and variables for all these 4 variables. So let me type ABCD and let me run this code, and you can see that A was a string, B was an integer, class for none is none type, and then class for this false or true kind of variable is bool. So this is how Python actually takes care of the variables when you try to assign something inside some bucket. Okay, so this is what type function do, and this is how it works. And now let's talk about typecasting. I have given it in the notes. I have mentioned it just because if you are revising after a long time, you can simply look into the notes and you will have all the things that you need in the notes itself. So a number can be converted into a string and vice versa. So you can convert a number to string, and you can also convert a string to number if it is possible. I'll tell you how. So as you can see that, let me get another file for this one, just to keep things simple, typecasting.py. So just to keep things simple, what I'll do is I'll say A is equal to 56 and B will also be equal to 56. But since B is inside double quotes, B is a string and A is an integer. So if I try to print A equals to B, this will return false because A is not equals to B. So let me run this code for you and you can see false is printed on the screen. This is one of the most common bugs in Python that people encounter. They try to compare a number which is actually equal to a string, but since the one is number and the other one is string, Python doesn't consider them as equal, and people start freaking out why 56 is not equal to 56. It's actually because B is a string and A is an integer, it's a number. Okay, so in order to convert this B to a number, I can typecast it to a number. I can typecast it to an integer. I can say C is equal to, I can say C is equal to int of A. I'm basically saying that I actually want, int of B. So what I'm basically saying here is I'm saying I need to create a variable C and I want to store B into it, but not actually B. I want to first convert that B into an integer and then I want to store that into C. Are you getting the point? Are you getting what I'm saying here? So 56 was a string and it is a string which can be converted into a number. You cannot convert Harry into a number. That's not possible. 56 is a string which represents a number, but it's actually stored as a string. And I want to convert this to a number and store it into C. So if I print type of A, and let me do the same with type of B and type of C, B and then we'll say C. And A, B and C will be printed, type of A, type of B, type of C will be printed. Let me do that. And A equals to B and A equals to C will be printed. Okay, so let me do all these things in order, just so that things are organized. So firstly what I'll do is I'll use Alt and I'll use multi-cursor functionality in VS Code. And A, B and C will be printed, then whether A is equal to B or A is equal to C or C is equal to B is printed. I'll print all these 3 things so that you can know what kind of variable is equal to which one. Okay, so let's run this code and see what the output of this turns out to be. So when you try to print A, B and C, when you are printing it, it seems that A is equal to B is equal to C. So double equals to should return all true, but that is not the case. A is an integer, B is a string, and C is again an integer because I'm assigning B into C, but not just B. I'm changing it first to an integer, then I'm assigning it to b. So b equals to c is actually false. A equals to c is true. So you can see a equals to b. This is false because a is not equals to b. A is an integer, b is a string. A equals to c is true because a is an integer, b is an integer, and a is an integer, c is an integer, and c is equals to a. So this is equals to true. This returns true because a double equals to c. And I hope you got the point that double equals to is a comparison operator and single equal to is an assignment operator, as opposed to what we speak in our daily natural language. We use equals to for the equality, but here we don't use equal to as equality. We use double equal to as equality. Equal to in Python is assignment operator, and double equal to in Python is comparison operator. So a double equal to b will return false, a double equal to c will return true, and b double equals to c will return false. You can see type of a, b, and c will return int, string, and int respectively. You can see this is an integer, once again string, and once again this is an integer. What will happen if I try to make it 56y? What will the value of c be in this case? The answer is that this program will throw an error because 56y is not convertible to integer. So if I try to run this program, I'll get disappointment, I'll get this error. I'll get to see value error invalid literal for int with base 10, 56y. So Python is basically helpless. It's saying, how do I convert this 56y to a number? I know how to convert 56 to a number, but what on earth do you mean by 56y? So this is what Python interpreter is saying. It's helpless, it fails, and it throws a value error invalid literal for int with base 10. I hope this is very clear to you now, and I encourage you to try all these examples in your interpreter, in your VS Code at home. We'll move on and we'll discuss about input function now. So input function is basically used to take input from the keyboard. So if you are a user and you want to take input from the keyboard, you can use input function. I'll tell you how you can do that. Okay, so let me delete this temp code runner file. So this is something which I have not created. Basically, when you select a piece of code and you try to run it, a temp code runner file is created and selected text is pasted into that temp code runner file. I didn't intend to do that, that's why I deleted that code runner file. I'll say 05 underscore input.py and I'll demonstrate input function for you. If I say a is equal to input and I say enter your name, and then if I print your name is A, what will the output of this program be? Let me run this program. So the moment I run this program, you can see enter your name. If I say Harry, your name is Harry. So this works. So let me do one thing. Let me make it like this. Enter your name colon space and then your name is whatever I enter. So when I enter Harry, what actually happens is, let me type Harry. What actually happens is A is assigned to whatever has been typed in the form of string. The data type of whatever I entered will be a string. You need to make sure that whatever you are entering will be a string, and if you intend to use that as a number or as an integer, you need to typecast it. I'll tell you what I mean by that. If I say my name is 56, let us say my name is 56, just assume it for a second. 56, your name is 56. If I try to now add 3 to 56, what will happen? Will I be getting the desired result? Or let's create a program to add two numbers. So let me comment this out and let me say A is equal to input, enter first number. And this is a classical example of string concatenation and arithmetic calculation in Python. So enter first number, enter second number. As you can see that A will be assigned to whatever I enter as first number and B will be assigned to whatever I entered as second number. And if I print the sum is, and if I say A plus B, you might think that the numbers will be added, but they will be not. And I'll tell you why they will not be added. So I'll use a comma, A plus B, and let me run this program. Run code, enter first number 4 and the second number 8. The moment I press enter, I'll get 48 and not 12. The reason is that 4 is a string 8 is a string, and when you use a plus character between two strings, they are simply concatenated. I don't want that. I want to add them. I want to treat these variables a and b as integers. Can I do that? Yes, I can do that. But how? I'll have to typecast both of these to numbers, to integers. Let me do that. So before adding, what I'll do is I'll say sum of int a plus int b. So I'm converting a to an integer, then I'm converting b to an integer, and then I'm performing arithmetic calculation between these two. So now if I run this program and if I enter 4 and 8, did you see that? The sum is 12. And when you're giving your prompts, you can add an extra space like this, just so that your program looks good. So enter first number 6 and the second number 2, 8 is the answer. So this is how input works in Python. One thing that you need to ensure is that whatever you are using after taking output from the input, it will be a string, and if you intend to use it as a string, well and good, but if you intend to use it as a number, if you intend to use it as an integer, make sure you typecast it, because by default input will return a string. So I hope you got the point. You can put your prompt inside input and the prompt will be shown to the user, and you will be able to take input from the user. So input function allows the user to take input from the keyboard as a string. This as a string is very important because this will return a string. A is equal to input enter name. If A is Harry, the user entered Harry. If A is 34, user entered 34. And I've used these double quotes because the output of input is always a string. I have explicitly mentioned this in notes because I want you guys to understand this important point. It is important to note that the output of input is always a string. Even if the number is entered, the output is string. Even if a floating point number is entered, the output is a string. I hope you got the point, and I hope you understood how input, how operators, and how these variables, data types, and all these things work. So I hope you understood chapter 2. We have come to an end of chapter 2. We'll now go to chapter 2 practice set, where we'll discuss and practice questions regarding chapter 2. Let's move on to chapter 2 practice set now. Let's now move forward and open this practice set which I've prepared for you. So this is the question set which I've prepared for you. We are going to practice all the things that we studied in chapter 2, and let's write our very first program. So a super simple question has popped up. Write a Python program to add two numbers. So what I'm going to be doing is I'll open VS Code here in this folder, and I'll say 06 underscore, and I'll say practice1. Okay, practice01.py. So basically this is a question that I'm solving from practice set, which is why I've named it practice01.py. So it'll be easy for you to find out which question solution is where. Okay, so write a program to add two numbers. So I'll just say the first number is A, and I'll say enter the first number, and then I'll say B is equal to input, enter the second number, and then I'll say print the sum of these two numbers is, and I'll say A plus B. Super simple, isn't it? This is wrong, and I want you guys to comment in the comment section below why this is wrong, because I have discussed it a lot of times, and I want you guys to at least make out now what is wrong with this program. So if you have pointed out correctly, the problem is that we have not typecasted the input into an integer. When we are adding two numbers, we want to add them in the form of integers, not in the form of string. So if I run this program, let me save this program and run it for you. You can see enter the first number. Let us say 4. 7 is 4 plus 7, 47. No, we know that it's wrong. What is wrong with the program? We haven't typecasted the inputs. So we'll say end, and I'll press end on my keyboard to make these arrow go towards the right of the respective lines. And then once again a closing bracket. Let me Control S to save, and let me run it again, and let me punch in the same inputs 4, 7, and yes, this is correct now. 4 plus 7 is 11. I hope you understood what was wrong initially when I didn't use this int, when I didn't typecasted my output of input into an integer. Okay, so by default input will always return a string. Even if you punch in a number, it will return a string. You will have to convert that string to a number. Now once again, let me tell you something. If you enter something which is not a number, or rather I should say which is not convertible to number, you'll get an error. Let us say if I enter this, I'll get an error. So this is a runtime error which is thrown, and basically Python interpreter is telling me that, hey, this is not valid. Okay, this is not something which is allowed. How do I convert this particular thing entered by you into a number? So this is something Python interpreter is telling you. So it throws an error, it fails. It tried to recover it, but it couldn't. It said df534 cannot be converted to any number, and hence the error. Okay, I hope you understood how we solve this problem. Coming back to our practice set, question number 2, write a Python program to find remainder when a number is divided by 2. So whenever you are dividing a number by 2, what is the remainder? So this is a very interesting problem, and let me tell you that we have an operator in Python for the same, and it is an arithmetic operator. So let me create a file here. I'll name it 07 underscore, and it's going to be practice2.py. So .py is the Python file extension, in case you don't know. So let me start writing the solution to this problem. So I need to find out the remainder when a number is divided by 2. So in order to do that, first I need to grab the number. I can either say int input, I can say int of input of, and I can say enter the number, and I'm basically giving user an option to enter that number. Okay, now what I'll do is I'll say remainder, let me say print remainder when the number is divided by 2 is, and the remainder is, let me tell you, it's a single line. It's an operator in Python which returns this, and it's called modulus operator, in case you don't know it. So it's an arithmetic operator, and you can simply say number %2. So if you say number %2, not dollar, it's number %2, and if you save it, you can see that remainder when number is divided by 2 is, you'll get it. Okay, so let me run this. Let me punch in 76, and when 76 is divided by 2, we all know that the remainder is 0 because 76 is divisible by 2. Okay, so let me try some other number which is not divisible by 2. Let me say 3, the remainder is 1. And I can do this with any number. I can even say when some number is divided by 3, what is the remainder? I can find it out by using this modulus operator. So our question said that find the remainder when a number is divided by 2, and we did it. So this is how you find out the remainder when a number is divided by some given number. So modulus is the operator, modulus is the guy you need to go for. So let's move on to question number 3 now, and let me create another file for that. I know I'm creating a lot of files, but this will come in handy when you are coming back to the notes and referring for the solution. It's going to be very, very helpful for you. We will end up with a lot of files, but again, this will be helpful. This will keep all these files in an organized way. So question number 3 says, check the type of variable assigned using input function. So basically, let me tell you what this question wants you to do. Whenever you are using input, what is the type of the variable that is returned by input? This is the meaning of the question. It seems a bit vague, but let me tell you the meaning of this question. So what I'll do is I'll say a is equal to input, and let me say enter something. It can be anything. It can be whatever you want. So far what we were doing is we were saying enter first number, second number, enter this number, that number. So we were punching in just the numbers, but here you can read whatever you want. And once you do that, what I'll do is I'll say the type of a is, and then I'll say type of a. So type is the function that we need to use, and this has to be string if what I told you is correct. So let me type in something. If I am typing in some number, it is class string. If I'm typing in some decimal number, the type is once again string. And if I'm typing some sort of, let me type in something, Harry is a good boy, and you can see the class is string. Okay, so I hope you are very, very clear about what input is returning. Input returns the characters entered by the user in the form of string. Okay, Coming back to question number 4, use comparison operators to find out whether a given variable a is greater than b or not. So there is a variable a, there is a variable b, the values are 34 and 80, and you need to use comparison operator to find out whether a given variable a is greater than b or not. Let us say that you don't know which number is greater than the other number which is given to you, and now you want to use comparison operators in Python. So let me create another file for you. I know I'm creating a lot of files just for organizing the code correctly. So this is question number 4. So practice 04, and I'll be using comparison operators for comparing these numbers. So a is 34 and b is 80. So I'll say b is equal to 80, and then I'll say a is greater than b is, so it can be true or false. So I'll say a is greater than b. Is a greater than b? No, it is not. A is greater than b is false. So if it is false, then a is not greater than b. If it is true, then a is greater than b. So if I make a greater than b, I'll find that this is returning true. Let me try this out. Let me run this piece of code for you. At this moment, a is greater than b is returning false. But once I change this to 346, this will change to true. As you can see, this has been changed to true. And I don't need any space here. And one thing that you might have noticed is that whenever you are typing something inside print and you're typing another argument, which is comma separated argument, the second argument is auto appended with a space. What I mean by that is when we are printing this and this using print statement and using this comma, then a is greater than b is colon. We don't have a space here, but still the space will be printed. Let me show you once again. A is greater than b is true, colon. I didn't type this space. This space has automatically been added by the print statement. So if you use comma separated values inside print statement, all those values will be spaced with this character. A white space will automatically be placed between those. So I hope this is clear and you are able to follow up till here. Now let's move to question number 5, which is write a Python program to find average of two numbers entered by the user. So finding average of two numbers is pretty straightforward. Just add those numbers and divide them by 2. But I want you guys to make this program. So I want you to pick your keyboard up and start typing the code. This is very simple. I'll skip this question and I'll move on to question number 6, which says write a Python program to calculate square of a number entered by the user. So basically you need to take a number from the user and then you have to multiply that number with the same number using star operator. Let me show it to you in action. So I'll create another file 10_practice10.py and I'll say a is equal to int input, enter the number, and I'll say print the square of this number is, and I'll say a star a. This was super simple. So if you enter 9, the square of 9 is 81. So let me do one more thing. Let me add a colon and a space here. Let me run this code. Enter the number 7. 7 multiplied by 7 is 49. If you do the same with 11, you will get 121. Let me show you. So this is how you find out square of a number using Python. Fairly simple and straightforward. I hope you enjoyed this practice set. Make sure to download the notes from the description and make sure to keep a printout of all these notes and source code. Not source code, just the notes. Source code can live in your computer, but notes are something you need to take printout of because it's really very convenient when you have all these notes handy. But if you are a PDF person, you can even keep the PDF of all these notes. Let's move on to chapter 3 now and dive more into the awesomeness of Python. We'll now get started with a new chapter, which is string. String is basically a data type in Python, and a string represents a sequence of characters enclosed in quotes. Now we talked about what an integer is, we talked about what a floating point number is. Now we are going to deep dive into what strings are, what are the methods that we can use with strings, how do we slice a string, And we are doing all this just because we are going to use string a lot in our Python journey. So what I'm going to be doing now is I will create a program called 01 underscore string.py, and what I'll do is I'll write some code inside this program. So I'll create a sample variable name and I'll put Harry inside this. So when I'm doing this, I'm essentially telling Python interpreter, hey Python interpreter, this is a string, this is a sequence of characters. Please put this sequence of character inside name. Name is my variable. I want HARRY to be stored inside this variable. So now whenever I say name, Python knows what I'm talking about. I'm talking about this sequence of characters. I'm talking about the memory location where this sequence of characters is stored. Okay. So what I'll do is I'll simply print this, and I'll simply once again print type of name. We already did this in previous chapter, and no prizes for guessing. Harry and str will be printed. Okay, so Harry is printed for name, and type of name prints str because this is a variable of type string. Okay, so far this much is clear to all of you. This is something I will expect from you. At this point, let's create another variable name 2, and let me store John into this variable. If I say name 2 and if I store John in this variable, I'll see John and class str, but this time instead of using double quotes, I'll be using single quotes, and I'll simply run this code and you can see Harry class str, John class str has been printed on the output screen. Now, why does Python offer these two types of codes, and why not just a single code? So let me explain this to you. Let us say you want to add a single quote inside somebody's name. For example, Adam D'Angelo. So this is the name of Quora founder, Adam D'Angelo, if I've spelled it correct. So there is a single quote in the name. And since there is a single quote in the name, I can use double quotes to enclose this name and store it inside this variable. So if I try to run this program, I can successfully run it. Adam D'Angelo, John, class str. Okay. What will happen if I don't use double quote? What will happen if I use a single quote? If I use single quote, Python interpreter will get confused as to where this particular string is ending. It will think that I'm starting the string here and I'm ending the string here, and this is some crap which I've written here, and I don't want to confuse my Python interpreter. So what I'll do is, when I know that my string will contain a single quote, I'll enclose it with double quotes. If I know that my string will contain double quote, let me add a double quote here, I'll enclose it with single quotes. So if you know that your string is going to contain double quotes, use single quotes. And if you know that your string is going to contain single quotes, enclose them with double quotes. Okay, so this is basically why we have single quotes and double quotes, both of these in Python. So let me run this code and you can see, am I making some mistake? No, let me save it. Let me try to run it once again, and you can see Adam D'Angelo class str, John class str. Let's now talk about another type of code that we have in Python, which is a triple quote. And we have already used triple quote, if you remember. We have used it while we were writing the Twinkle Twinkle Little Star poem. I hope you enjoyed that poem. I'm going to type that poem yet again just to remind you what we did in our previous chapter, if I'm not wrong. Twinkle twinkle little star, how I wonder what you are. So what I'll do is I'll simply copy the lyrics from this poem. Let me copy this lyrics. Let me paste it here. And let me once again enclose it inside triple quotes. And if I do the same thing with name 3 now, you will see that name 1, name 2 and name 3, all these 3 strings will be printed along with their respective types, which is str. So when I'm using double quotes, type is str. When I'm using single quotes, type is str. When I'm using triple quotes, type is once again str, except the fact that now I can use single quotes, double quotes, as well as new line characters inside my string. So this is very handy when you have single quotes. Let me put a single quote inside this particular string, and let me put a double quote as well. And if I run this program, I'll get no syntax error whatsoever. And you can see my single quote and double quote, all of these things will be visible. So let me save this program before running. Don't forget to save the program before running. And you can see I have my single quote here and I have my double quote here, and I can successfully print my string using print statement which contains single quote and double quote. So my string contains a single quote, my string contains a double quote, my string contains a bunch of new line characters. Still I am able to print that string to the console using print statement. So I hope you understood the use of three types of quotes. We have a single quote, we have a double quote, and we also have a triple quote. So the use is use single quotes when you have double quotes in your strings, use a double quote when you have single quotes in your strings, and use triple quotes when you have a lot of new line characters, single quotes and double quotes in your strings. So I hope this information will be very useful. I have compressed all the information which I gave you in the form of these notes. So make sure you download your copy of notes from the description. I'll provide the link. Make sure you have these set of notes, and you can download these notes in a single click from the description. Let's now talk about string slicing and why would you use string slicing. So a string in Python can be sliced for getting a part of the string. So let us say name is equal to Harry is a string, and I just want to get first two characters from the string. How do I get the first two characters from the string? So if you want to get first two characters, or say first three characters, or two characters starting from the third character, if you want to do operations like this, what you can do is you can use string slicing. Let me show you slicing in action using my Visual Studio Code. So I'll say 02 underscore slicing.py. Let me delete this temp code runner file. I don't want to use that. I'll say name is equal to Harry. Okay, so name is equal to Harry is a string, and I want to get first two characters of this string. So let me explain you how string slicing works in Python. So HARRY is the sequence of characters which this particular variable holds. So listen to me very carefully. This is very important. Now, if I talk about H, this is marked as 0. So index in Python starts from 0. If you're counting something in your regular life, you count from 1, 2, 3, 4, 5, 6. But if you want to do the same thing in Python and in some other languages like Java, C and C++, the counting starts from 0. So you count from 0 instead of counting from 1. So you say this is index 0, this is index 1, then index 2, index 3 and index 4. So 0, 1, 2, 3 and 4. So we have 0, 1, 2, 3, 4, in total 5 indices, and now I can use string slicing to print a part of string. First let me print the entire string. If I print the entire string, you can see Harry has been printed. Now what I'll do is I'll simply print, I'll say name, then I'll use a square bracket. This is important. Just look at the syntax, how I'm writing these square brackets. I'll say 0. I'm basically saying I just need index 0 out of all the characters in this string. So out of HARRY, I want to get the character which is present at index 0. Okay, I hope you got the point. Let me run this code. And let me save this file. I forgot to save the file before running the code. Let me run this code, and you can see when I'm saying print name, Harry has been printed, and for this line I get this output which is just a single H. Isn't it interesting? You can get any character of your choice from the string using print name, square bracket and the name of the index. So if I were to write 1, I'll get A. If I were to write say 3, I'll get 0, 1, 2, 3, I'll get R. If I write 4, I'll get Y. So let me run it for 4, I'll get Y. What will happen if I try to run it for 5? I know this is not valid, but still if I try to run it for 5, what will happen? This will give me an error. Python interpreter will tell me that this is an index error, index out of range. So Python interpreter is basically telling me that index starts from 0. So this is 0, this is 1, this is 2, this is 3, this is 4. I don't know what 5 is. So go and find out what 5 is. I don't know. Don't ask me. So this is basically Python interpreter telling you, don't ask me what index 5 is. I don't know. You are asking me the wrong question. This is basically what Python interpreter is telling you when you are saying print name 5. So we'll make sure that we are in the range our index is not out of range, and we'll make sure that a program doesn't throw this kind of error, because once a program throws an error, it will terminate, and it is a bad user experience if your program terminates out of the blue. You don't want that. You don't want your program to terminate out of the blue. You want a good user experience. You want to handle all the exceptions. You want to make sure that whatever you are typing in the code is valid and will not throw an error. Okay, so with that said, we'll move forward and we'll talk about advanced slicing. So a string in Python can be sliced for getting a part of the string. As we saw, we got a single character out of the string. As you can see, I have drawn this string HARRY. The length of this string is 5. If you find out the number of characters in this string, they are 5. But we start marking 0, 1, 2, 3, 4. We start the index from 0. Now, since the length of this string is 5, we can start counting from reverse, and we can write -1, -2, -3, -4, -5. So either you can call these 0, 1, 2, 3, 4, or you can start counting from backwards and come -1, -2, -3, -4, and -5. So the index in a string starts from 0 to length -1. So if the length of the string is 5, you'll have 0, 1, 2, 3, and 4 as indices. And in order to slice a string, we use the following syntax. So one way of getting a single character from the string was writing the name of the variable, and then using these square brackets and typing the index of the string which you want. Now, since I want 0, 1, 2, 3, 4, since I want this character, I'll write index of this character, which is 4, starting from 0. This particular character comes at 4th index. Now, if you want to get a part of the string, say first 2 characters or first 3 characters, you can always use this syntax, wherein what you do is you say the name of the variable, which is name, and you can use these square brackets, and instead of just writing an index inside the square brackets, what you can do is you can mention the starting index and the ending index. So I can say 0 to 3, and this will print all the indices except 3 and including 0. So what it will do is it will count from 0, 1, and 2. 3 is not included. So this particular index is not included. First index is included, last index is not included. So I hope you got the point. You can say SL0 to 3, it will return you HAR if your variable contains HARRY, which is my name. Characters from 0 to 3, characters from 1 to 3. If you type 1:3, including 1 and excluding 3. Okay, this is important. This is very important. So if I show you name 4, let me not say 4, let me say 1 to 2 or 1 to 4. So this will give me character at index 1, character at index 2, character at index 3, but not character at index 4. So I'll get 3 characters, which are 1, 2, and 3. So I'll get ARR. Let's see if I get ARR after running this. Let me run this code, and yes, I indeed get ARR. So this is how advanced string slicing works. You mention the first index, you mention the last index, and you get the result. Now there is a concept of negative indices which you might use. I already told you that you can mark your negative indices starting from 1 from the back side of the string, and you can come all the way to the beginning. So if I were to mark negative indices in this particular variable, what I'll do is I'll say -1, -2, -3, -4, and -5. So what I'll now do is I will tell you about negative indices. Negative indices can also be used as shown in the figure above. I already demonstrated it here. And -1 corresponds to the length -1 index, and -2 to length -2 index, and so on. So -1 is the last character of the string, and we can always use negative indices in place of 4. So you can either write 4 or you can write -1 in this case. You can either write 2 or you can write -3 in this case. So for a different string, the counting will be different. Make sure, do not try to learn these indices by heart, because you might have just 3 characters in your string, and then starting from the end, if you start marking your string from -1, -2, -3, -4, your second character might not be -4. So let us say you have a variable which is following. So you have a string which has FOLLOWING. So it basically has 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. If I were to mark this particular string with negative indices, what I'll do is I'll mark G as -1, N as -2, then -3, -4, -5, then L will be -6, this L will be -7, -8, -9. So I hope you got the point of negative indices. They are not used as much as positive indices, but again, you might encounter them in some source code and you might want to learn about it, which is the reason I mentioned them in these notes. So let's talk about slicing with skip value. What is a skip value? We can provide a skip value as a part of our slice like this. So if you have a word amazing, you can use 1 to 6 and you can say, I want to take every second character. So this is basically taking every second character from the string. Let us see if we can create another file and demonstrate this thing. So skip underscore value. So I'll say skip underscore value.py. I'll say my str, which is the name of the variable. I'll say this, or let me say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so this is A, B, C, D, and let me save it. Let me now try to print my str. Let me print 2 to 6, and let's try to predict output of this. So my str 2 to 6 will include index 2 but exclude index 6, so it will go all the way from 2 to 5. So 0, 1, 2, 3, 4, 5. So this should be the output, C, D, E, F. So I am expecting C, D, E, F to be the output of this program, and indeed I am true. I am right. C, D, E, F will be the output of this program. Okay, so I hope you got the point of slicing. We can even use negative slices. You can try it with negative slices, but I'll now demonstrate skip value. So I'll say, let's say I want to get 1 to 9 with a skip value of 2. Let's try skip value of 1. What does skip value of 1 means? Skip value of 1 means I want to skip no characters. Okay, so what I'll do is I'll simply run this code, and what you will see is you'll see this particular line. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 9 is not included. Index 9 is not included. Now if I write 2 here, it will take every second character. So if I write 1 here, it will take every first character, means it will take all the characters. If I write 2 here, it will take every second character. So the output which I'm expecting now is B, D, F, and H. How do I know this? The output will be B, D, F, and H. I know this because I'm starting from the index 1 and I'm skipping one character. I'm skipping one character. I'm saying start from B and then go all the way to D, then go to F, then go to H. Keep skipping one character. So B, D, F, and H. Let's try to run it, and you can see B, D, F, H has been displayed. So B, D, F, H has been printed to the console. What if I add skip value of 3? What will be the output in that case? As you can see, the output in that case is B, E, H. And how do I know it is B, E, and H? Let me do one more thing. Let me try skip value of 1. That is no skip value, and let me see the string if I'm not using any skip value. So this is the string which is printed by as a result of this line without any skip value. So B, C, D, E, F, G, H, I is the output of this particular line. If I use skip value of 3, I'm basically saying skip 2 characters. So B will be printed, 2 characters will be skipped. E will be printed, 2 characters will be skipped. H will be printed, 2 characters cannot be skipped, so that's the end of the output. So I hope how skip value works seems very intuitive to you and you don't have any confusions regarding the skip value part. So this is how skip value works. I have shown an example in the notes as well. In case you forget about skip value, you can always come back to notes, turn few pages, and you'll have everything at your disposal. Okay, so there are some other string slicing techniques. You can skip this 0. If you want to write 0, you can skip it, and that simply means that you want a 0 here. If you want to go all the way towards the end of the string, you can simply skip the second index which we were using here while slicing. So you can do all these kind of things, but I suggest you to use the first index as well as the last index. If you keep both of these, things are pretty intuitive and simple for the person who is reading your code. So this will print amazing, this will also print amazing, and I hope now you are pretty comfortable with how these kind of things are working. Let's come back to the string functions and let's talk about string functions, why string functions are important and why would you want to use string functions. Now, string is something which is used a lot in a Python program. String is something which you are going to use a lot if you want to start your journey as a Python programmer. Some of the mostly used functions to perform operations on or manipulate strings are, I'm now discussing some of the methods which can be used to manipulate strings. So let's do one thing. Let's create a separate file to do all these things. I'll say 04 underscore string underscore functions.py. Okay. So I'll say string is equal to, or let me simply copy this my str. I'll use a string and I'll simply say print length of this my str. What is the length of this my str? I haven't counted it. I know it is 26, but let's see what Python has to say. So if I run this code, the number of characters in English alphabet is 26, which is how I know this, but you can count it. You can count it. Don't believe Python, don't believe me, just count it and get some satisfaction. So this is a function which is used to print the length of a given string. How many characters are present in a given string? So len will simply print the length of the string. Coming back to the nodes, I've written it here. This function returns the length of the string. So len of Harry is 5. In this case, we have 26 characters, which is why 26 is being printed on the screen. Okay, so coming back to the next important method of string, ends with. This simply returns whether particular string ends with a given set of characters or not. So Harry ends with RRY, you all know that. So this function will return true. So this function tells whether the variable strings ends with the string RRY or not. So whether a given variable, so string is a variable, whether this string ends with RRY or not. Let me demonstrate it for my example because things might go messy if you don't understand them well. So my str dot ends with, does it end with RRY or EER? No, it doesn't. So this should print false. So as you can see, this has printed false on the console. 26 false, 26 for len my str and false for this particular line. Now if I replace this with XYZ and if I use Ctrl S to save, and if I now try to run the program, see the magic. This returns true because indeed my string now ends with XYZ. So since my string ends with XYZ, ends with function returns true now. So I'm asking my Python interpreter, hey Python interpreter, does this string ends with XYZ? My Python interpreter is saying, wait, let me check, let me match the last 3 characters. Oh yes, your string ends with XYZ, so it returns true. Okay, so this is programmatically used to detect whether your string ends with a particular set of characters or not. Okay, I hope this is very intuitive and I hope you understood ends with. Similarly, we have starts with, so you can say starts with, and does it starts with XYZ? No, it doesn't starts with XYZ, it starts with ABC. So this should return false. Let me see, this returns false. If I replace it with, I'm simply keeping the code which I've written for you because you might want to refer to this file and get the code which we have written throughout the video. I don't want to overwrite any code. So if I write ABC and if I use the starts with function, this will return true because indeed this string starts with ABC. Let me run it for you. And yes, your string ends with XYZ and yes, your string starts with ABC. So it starts with ABC. It also starts with ABCD because first 4 characters of the string are ABCD. So it will again return true. So I hope you got the point. I hope you understood how starts with and ends with functions work. So coming back to the nodes, we have another function called count. So this function will count the total number of occurrences of any character in your string. So if I say my string.count, so if I say print my string.count, and if I count the occurrences of character A in the string, if I want to get the occurrences of this particular substring in my string, there is only one A in my string. So this should return 1. As you can see, this is returning 1. If I add a bunch of A's to the end, definitely it is going to return 4 now because I have added 3 more A's. So you can even get the occurrence of AB in the string, and there is only one AB, which is why 1 is printed. But if I add another AB towards the end, you can see that there are 2 ABs now. This is first AB, this is second AB. So there are 2 ABs in the string now. I hope this is very clear, and you can also check that starts with and ends with all these functions are updating with the correct value. Since the string no longer ends with XYZ now, I'm getting false here. And since the string starts with ABCD even now, this is printing true. So this is how all these functions work. So we have seen len, ends with, starts with. We'll now look into capitalize, which is an amazing function. This simply capitalizes the first character of a given string. So capitalize in English means you want to make first character of any given word as capital. So let me write a line for you. Make sure I can always overwrite my string. I can always say my name is Harry, okay? And if I run this code, I want to use this function mystr dot capitalize. Let me run this code for you, and my name is Harry has been printed, but with a minor change. The slight change which I see is that M in my string is small m and M in this string is capital M. So it will basically capitalize the string. It will see the first character and it will change it to uppercase. What if my first character is already uppercase? It will not do anything. It will simply print the same thing. It will check whether my string is already capitalized or not. If it's already capitalized, it will not do anything else with my string. So if you have small m here, you can simply, capitalize your string and get this M character changed to uppercase M. Coming back to the nodes, we have another function called find. This will basically find a word and returns the index of first occurrence of the word in the string. Let me explain what this means. So inside my name is Harry, I have Harry, but at what index? At which index is this Harry word present in my string? This is something which is returned by find. So I can say find Harry in this string, or let me keep it simple, find name in this string. If I try to run this code, you can see from starting from index 3, I'll have name. Let me see if it is true. 0, 1, 2, 3. Yes, starting from 3, I have name, which is true. If I have another name at the end, will it return me this particular index, which is 3, or will it return me index of this particular character? The answer is it will return me 3, because this function returns index of first occurrence of the string. So mystr.findName will return 3 once again, because this function returns first occurrence of the word in the string. So looking at our next function, which is replace, you can always replace a given word with another word in the string. So this function replaces the old word with a new word in the entire string. Let me demonstrate it for you. Let us say I want to change name to something else. Let us say I want to change name to date. Okay. So what I'll do is I'll simply say print, and I'll say mystr dot replace, and I'll say I want to replace name, and I want to replace name with some other string. Let me say underscore underscore, or let me say my date is date. So if I run this particular code, my date is Harry date. So my name is Harry name has been changed to my date is Harry date. So this doesn't make any sense, but I hope this function and these functions all together make sense to you now. So I hope you got how len works, how starts with works, how ends with works, how count works, how capitalize works, how find works, how replace works. So these are the set of functions which you are going to use a lot in your Python journey, believe me. So keep your notes handy, and you'll definitely come back to this page, and this page will prove very, very useful to you. Now, before we wrap this chapter up, let's talk about escape sequence characters. So, escape sequence characters are sequence of characters which have a backslash. Now, what does it mean? Escape sequence characters comprises of more than one characters. We have a backslash and we have another character. But there's a difference. It represents a single character. So we are typing more than one character, but despite that, it is representing a single character. How is it possible? Let's check this out. Let's try to understand how this is possible. So I am typing escape sequences.py and I'll say my name is equal to, I'll say my name is Harry. Okay. And now what I'll do is I'll simply print this particular thing. My name, and no prizes for guessing. My name is Harry will be printed on the screen. Okay. So my name is Harry has been printed on the screen. What if I want to print my name and then a new line character, then is Harry and a new line character, and let us say I want to have a bunch of new line characters in my string. How do I manage that? I can do that using escape sequence characters. I can simply say \n and this will add a new line character here. So \n is an escape sequence character used to add new lines in my string. So I can always run this program and I can see my name is Harry in a separate line because \n is a line break character. It's a new line character. I know I have typed more than one characters, but it is a single character, which is a new line character. And similar to \n, we have some other characters like \t is one. This is for tab. And let me run this code for you. You can see my name is, and there is a big tab here. So a tab is printed and a new line is also printed. So escape sequence characters are used to produce this kind of effects in your strings. So \n is new line, \t is tab, \single quote is a single quote. And if you want to have just \ printed in your string, you can simply use double \. So if I use a single quote inside a single quoted string, it will not work. Or if I try to use double quote inside a double quoted string, it will not work. So what I'll use is I will use a \double quote, which is a double quote character. So these two characters is a part of an escape sequence character, which is a double quote. Let me run this program for you. I'll save it and I'll run it and you can see the double quote is printed. If I don't use this \, I'll get syntax error. Let me show you. So if I don't use this \, Python interpreter will get confused. It will think that I'm trying to start this string here and I'm trying to end it here, and this is something which has been entered by mistake. So Python will get confused if I don't use this \double quote. So this was about escape sequence characters. We have escape sequence \, we have escape sequence single quote, we have tab, new line. We already talked about new line. I hope you now understood what escape sequence characters are. You can go to the internet and you can search for other escape sequence characters which can be used in your Python programs. I hope this chapter was very easy to understand for you and you understood every bit of whatever has been taught in this chapter. We are now going to go to our chapter 3 practice set, where we'll practice a lot of questions regarding strings, string functions, escape sequence characters. So let's move on to chapter 3 practice set now. Let's move on to chapter 3 practice set now. So I'll open this chapter 3 practice set PDF which I've created for you, and this contains a few questions on strings and we are going to solve all these questions. So let's get started with the first question, and before that I'll be opening my Visual Studio Code on this folder. So this is the folder where I've created all the files for this chapter. Let me close all these files and let me create another file 06 underscore practice1.py. So I'm going to solve question number 1 here. Let me open the PDF and see what question number 1 says. It says write a Python program to display a user entered name followed by good afternoon using input function. So what you have to do is you have to enter a name and you will have to make your program say good afternoon Harry, or good afternoon Samiksha, good afternoon Ritika, good afternoon John, good afternoon Jade, whatever the number is, whatever the name is typed. Okay, so let's code this, and this is fairly straightforward. I know this is fairly straightforward. So all you have to do is you have to say name is equal to, and you have to say input, enter your name, and now just say print and type good afternoon, and then use string concatenation. You can use plus to concatenate two strings, and then name. So good afternoon and the name. You can either do this or you can use a comma. If you use a comma, you are basically giving another argument to the print function. You are saying print good afternoon and then print name. Both of the approaches are fine. Let's try this program out. I'll run the code, and as you can see that I'm being asked to enter my name. I'll say Harry and good afternoon Harry is the output of the program. Fairly straightforward, isn't it? So this is how you solve this question. Let's move on to the next question. Write a program to fill in a letter template given below with name and date. And this is kind of tricky, I would say, but not very difficult. If you have already followed chapter 3 nicely, thoroughly, and you have listened to each and everything that I talked about. So in order to solve this question, let me create another file for you, 07 underscore, and I'll make it practice2.py, and let me type this template for you. Dear name, you are selected, and date. So you have to fill this letter template with name and date. Okay, so let me take the name and date from the user. I'll say enter the name, and then I'll say date is equal to input, enter the date, and then I'll say template is equal to, and I'll use triple quotes. Do you know why I use triple quotes here? Because I'm going to use new lines inside the string, and in order to use new lines as is in the string, I need to use triple quotes. Okay, so I'll say dear name, you are selected, and then there is some date. Okay, so dear name, you are selected. You are selected is a new line, and then I have to punch in the date here. And let me check the template. Template is capital name and capital date, and I have these pipe characters as well. So I have to add 3 more pipe characters like this. I'm using alt click to use multi-cursor functionality in VS Code. So let me save this now. So I'll replace this thing with the name and this thing with the date. In order to do that, what I'll do is I'll print template.replace. I'll say replace this particular thing with the name, with the actual name which has been entered by the user. I'll say replace this with name, and then once again I'll chain it up with replace. Once again replace the date with the actual date. And if you're confused how this is working, let me run this program for you first, and then I'll explain how this is working. So let me see if it works. I'll say Harry and enter the date. I'll say 7 October. Dear Harry, you are selected, 7 October. Okay, so this is how it works. Let me explain how this chaining of replace works. So template is a string, okay, and I'm generating a new string by replacing name in the template, this particular string in the template, with the actual name variable. So this particular thing, the selected text, will return a string. I can use this string once again and apply replace function on this string to replace this particular date placeholder with the actual date. So template was a string, so I can use replace with it. And once again, this particular thing was a string, so I can again replace another set of characters with another string. So I hope you now got how this works. You can keep on chaining dot replace, and this will chain up all the calls of replace which you have placed. So I hope this is clear and you understood how this works. Let's now move on to the next question, and let's try to understand how to detect double spaces in a string. So given a string, detect double spaces inside those strings. How do you do that? Let me create another file for you. I'll say 08 underscore practice3.py. And now what I'll do is I'll say my str is equal to, and I'll say this is me, and I'll say and I am a good boy. Okay, so I have to detect whether this contains double spaces or not. So in order to do that, I'll say print, I'll say my str dot find, and I'll detect double spaces. So 1 2. Now if I try to find double spaces inside this string, I should get the index. So as you can see, I'm getting index 10, which means double spaces are present inside this string. What if anything is not present inside the string and you try to apply find? For example, Harry is not present in this string, and if I try to find Harry, what will I get? I'll get -1. Let me show it to you. I'll get -1, and -1 means that this particular string is not present in this string. Okay, so my str doesn't contain Harry. So this is how you can use find to find out whether a given string is present in another string or not. So this is how this program, or rather this question, will be solved. Let's move on to question number 4, which is once again a very easy problem. Replace the double spaces from problem 3 with single spaces. And in order to do this, I'll create another file, practice4.py, and let me do one thing. I'll copy this entire program number 8 to program number 9, because this is very similar. And what I'll do is I'll replace these double spaces with something else. And what was that something else? We have to replace it with single spaces. So let me replace this with single space. So I'll say replace these double spaces with just a single space. And let me remove this. And if I run this program, yes, indeed my double spaces are replaced with single spaces. But I do have triple spaces here. I'll get rid of triple spaces. I don't want triple spaces. So I just have to replace double spaces with a single space. And if I run this program now, you can see that I no longer have any double spaces inside my output string. So this is how you solve this problem. Very simple problem if you understand how strings work, if you understand how string functions work. So write a program to format the following letter using escape sequence characters. So you have a given letter and you'll have to use escape sequence characters to format this. So let me tell you what it means. Dear Harry, this Python course is nice, thanks. Let me create another file for this one. 10 underscore, and I'll say practice5.py, and the letter is Dear Harry, this Python course is helpful. Is there anything else? No. Is nice. Thanks. Okay, so what I'll do is I'll say \n here, and I'll say \n here. So these are two escape sequence characters which I added to the parent string, and let me see how this looks after I print this letter. So once I print this letter, you can see that this looks like this. But won't it be nice if I have a tab here just before this? So if I say \t just before this Python course is nice, this will look something like this. So this is a fairly small letter, which is why this is not looking very good. But if you have a lot of characters inside your letter, then definitely your letter will look good with this tab. I hope I'm able to explain how sequence characters work, and I hope you are able to solve all these 5 questions by yourself. If you are not able to solve these 5 questions by yourself, it's totally fine. I've added these practice sets for your practice. You don't have to know all these 5 questions, because sometimes I'm delivering some concepts using these questions in the practice set. So I hope you are very happy with how strings work, how string functions work, and you feel confident in your Python journey now. So let's move on to chapter 4 now, where we'll move ahead and talk about some more concepts of Python. Let's move on to chapter 4 now. So now that we have some understanding of basic data types, let's now talk about list and tuples. And let me open this chapter 4 PDF for you so that you can look into what I have written in the notes, and that will make your life a whole lot easier when you're trying to learn about list and tuples. Because if you are following the notes, then you have everything at one place and you just have the things that you need to recall at single place. So it's not a 500,000 page book. It is just curated helpful material. So let's talk about what Python list is. So we have talked about strings, we have talked about numbers, they can be integer, floats, we have talked about strings, we have also talked about a lot of other concepts in Python. Now we are going to talk about list. How many times do you create list in your real life? You go to the grocery shop, you go to buy apples, you go to buy banana, you go to buy cereals, you go to buy a lot of things. And when you're going to the market to buy certain things, what you do is you curate the list of all items you need to buy from the market before going to the market. Just in case you forget something, you have the list handy. In the same way, if you're programming something in Python, you can create a collection of items and you can store it in a single container, and list is that container. Let me explain it once again and let me read out what I've written in the notes so that you can have some better understanding of the same. So Python lists are containers to store a set of values of any data type. So you can store any data type in the list. You have no restrictions like you can only store strings or you can only store numbers in a list. You can store whatever you want. You can even store a list inside list. I repeat, you can even store a list inside of list. So this is the beauty of Python. So if I am creating a list called friends, I can say Apple, I can say Akash, I can add Rohan, I can then add 7, which is an integer, I can add false, which is a boolean. So different set of data types inside a single list. Let's see how we can do the same using Visual Studio Code. Let me open this folder in Visual Studio Code and let me create a program 01_list.py. So here I'm going to demonstrate the basic idea of list in Python. So let us say I have a number which is 12. And I have a string, which is, this is a string, a very basic string. And let me have a boolean as well. I'll store false inside this boolean. Now what I'll do is I'll say my list is equal to, I'll use these square brackets. Now these square brackets are used to create a list. Whenever you see these square brackets and a set of items separated by comma inside these square brackets, what you mean is you are creating a list. Okay, so whenever you see this, the programmer intends to create a list. Okay, so let me add A, B and C inside this list, and let me keep it very basic to start with and just print this list. Let's print this list and see what is there inside this list. So let me run this code and you can see 12, this is a string, false on your screen. So these are the 3 items which are there inside the list. And we have this data type which is list. So let's try to run type function. So remember we use type function to find out which data type a particular variable is. Let's do the same with list and see what it spits out. So when I say print type my list, what actually is going to print is the class this my list belongs to. Let's see which class this belongs to. Let me run this code. This belongs to class list. As you can see, we have class list printed on this console. So my list is in itself a data type, which is a list, and list is a collection of items, which can be a boolean, it can be a string, it can be a number, it can be a floating point number. Let me add a few more to demonstrate. I can use variable names or I can use the actual values. Anything works. Okay, so this is the basic idea of list. Now let's talk about slicing in list, or indexing as they call it. A list can be indexed just like a string. We looked into strings and we saw how strings can be indexed. We can use the index 0, 1, 2 to refer to a specific number or any sort of variable inside the list. We can use the same thing in list as we used it in string. Let me tell you how we can do that. Consider this list L1. So list can be indexed just like a string. There's no other concept. It's just simple indexing which we use in strings. So L1 is a list, and what I'm saying is I'm saying it contains 7, 9 and Harry. Now if I say L1 and 0 inside the square bracket, I'm talking about the 7. Remember, indexing starts from 0, do not count from 1. You might have seen a lot of programming memes where they say counting starts from 0, but in actual life counting starts from 1. We all know that. Do not count from 0 in your real life. Just do the same when you are coding in Python. So L10 will give you 7, L11 will give you 9, L170 will give you error. Why will L170 give you an error? Because the index 0, 1 and 2 are the only valid indices for this list. Okay, you cannot use 70 or 700 or 200 for that matter, because this list is just not that large. Okay, so if you say L10 to 2, this will give you the value 0, which is 7, and then it will give you the value 1, but 2 will be excluded. So the first slice is included while the last one is not included. We have seen this in strings, and the same applies for list as well. Okay, so let me do one thing now. Let me add another file. And why I'm creating so many files? I'm creating these files for you so that you can you can come back to these files and you can revise a specific concept. So slicing is there in this file. So if you were to find out how slicing is done in Python, you can simply come back to this list and you will know how slicing is done in Python. Let me write the same string, which is 7, 9 and Harry. Let's write 7, 9 and then I'll say Harry. Let me print L10. Let me print L1 first of all. Let me see what I get. So if I run this code, it says, okay, so I've selected H and then fired the run command. Do not select anything and click here. Just click somewhere. You don't have to select anything, because if you select something, code runner will execute that particular code. You don't want that. You want the entire file to be executed. Do not mistakenly select like I did. Okay, so let's run this code and you can see 7, 9 Harry printed on the console. If I change it to L10, you will see that only 7 will be printed. Okay, so 7 is printed. If I say L11, 9 will be printed. Let's check it. Yes, 9 is printed. If I use 2 and save it, you'll see Harry will be printed. Yes, Harry is printed. So this is how indexing works in list. It's exactly the same thing we saw in strings, but once again, I just wanted to demonstrate you. So if I say 0 to 2, this will include index number 0, index number 1, but not 2. 2 will not be included. Okay, make sure that you kind of somehow remember this, that 0 will be included, 2 will not be included. So L1 0 to 2 will give you 0 and 1, not 2. Okay, so you are going to get 7 and 9 inside a list. So this entire thing is going to return a list. Remember, when we were slicing strings, what was the end value? The end value was a string. You were getting a string when you were slicing a string. So slice of a string is string, slice of a bread is bread, slice of a list is a list. So you can remember it like this. Okay, I hope I'm able to make things easier for you. So print L10 to 2 will give you 7 and 9 inside a list. Okay, so let me run this program for you and you can see 7 and 9 inside a list is printed. What if I use 3? What if I say L10 to 3? L10 to 3 will give you 7, 9 and Harry, because it is going to include 0, 1, 2, no 3. No 3 is included. Okay, so 7 is included, which is 0. Index number 1 is included, which is 9. Index number 2 is included, which is Harry. Index number 3 is not included. So this will not return an error because we are including all these indices. Let me run this program for you and you can see 7, 9 Harry. In case I happen to use 4, and let me press Ctrl D. I have my shortcuts configured, by the way. If you're not able to replicate using Ctrl D, I'll create another video for Visual Studio Code itself. If you guys need a Visual Studio Code video, make sure you drop a comment and I'll definitely make one for you. So L10 to 4 will return you a list which contains index 0, which is 7, index 1, which is 9, index 2, which is Harry. Where is index 3? There's no index 3. So this will only get the data from 7 to Harry. So it is going to print exactly the same thing which we were seeing in L10 to 3. So L10 to 4 is going to print the same thing as L10 to 3, and L10 to 400 is going to print the same thing as well. So let me demonstrate this for you. Let me just zoom in and replicate this, and let me try this out with 40, and you'll see 7, 9 Harry will be printed. Then once again 7, 9 Harry will be printed. Then again 7, 9 Harry will be printed, because we don't have index number 3 present in this list. We have 0, we have 1, we have 2. No index number 3 is present. So let me run this program for you. And you can see 79 Harry, 79 Harry, and 79 Harry. So this is how list slicing works. I hope I'm able to make things easier for you. And now what we are going to do is we are going to look into some list methods. Before we move further and talk about list methods, I want to tell you something. I want to tell you something which I learned through experience. List is going to be something which you'll use a lot in Python. When I say a lot, you're going to use it in every bigger code base you are going to write. So make sure you grasp the concept of list very, very well. You are not going to use tuples as much. You are not going to use dictionaries as much, but you are going to use lists a lot. So make sure you understand these methods, you understand the concept of list, and you make sure that you are very much satisfied when you are going to the next chapter or going to the practice set. So with that said, let's talk about list methods. So we have a sample list here. We have 18722115. So let me create another file for you. Let me delete this temp code runner. This is not something I created. 03 underscore, I'll say list methods. So we'll talk about list methods in this particular file. Let me close this and let me type the exact same list. 1, then we have 8, then we have 7, then 2, then we have 21, then we have 15. So exactly the same list, 1, 8, 7, 2, 21, 15. I just want to make sure that we are using the same list from the notes in example. So my list is equal to this. Now what I'll do is I'll start with the first function. So the first function is sort. It updates the list to this particular list. So if I print my list, I'll say my list, and I want to tell you something else. So let us say you have a variable my list from of numbers. Okay, so this is a pretty long variable name and you might get exhausted by typing it again and again in your program. What you can do is you can type m for my, and then you can type L for list. This is in camel case. Camel case means that the very first letter of your word is lowercase and then the remaining letters are uppercase. So my list of numbers will be written as my, then L will be capital. To specify this as a word, then we have of, then we have numbers. So I can use MLON to type this. So if I say MLON, automatically you can see that this particular variable is being shown. So MLOF and press enter will type this list for you. It's straightforward and it's very simple. So when I have long variable names in my program, and I suggest using long variable names if they are throwing light on the fact why they are created. For example, if you have a single list of numbers, you can name your variable as my list of numbers. Do not name it as A, B, C, D, because you are not going to remember what variable was A, what variable was V. You don't want to do that. You want to make sure that variables you are creating are holding some meaning in their names. Okay, so print my list of numbers is going to print this 18722115. No surprises there. So if I run my list of numbers dot sort and I print this once again, let me copy this and let me paste it again. What you'll see is that the list is sorted now in increasing order, in ascending order. You can see 18722115 was how my previous list used to look. Now what you'll see is 1, 2, 7, 8, 15, 21 is the sorted list. So this is how sort function works. Did you notice something? Dot sort doesn't return anything, but what it does is it updates the list. Let's see what it returns. When I say returns, what if I do A is equal to this and try to print A? And let me run this program once again. So when I say print A, it is not returning anything. It is returning none. So make sure that this is not returning anything, but it is modifying the original list itself. So make sure that it is not returning anything, but it is modifying the list which it is being operated on. Okay, so my list of number now becomes 1, 2, 7, 8, 15 and 21. Okay, so this is how it works. Now what I'll do is I'll move on to the next method, which is reverse. So if I say L1.reverse, it's going to update the list to 15, 21, 2, 7, 8, 1, which means it's going to reverse the list. So let me write it here, and let's not do A is equal to. Let me write a comment here. What I'll do is I'll write a comment, sorts the original list. Okay, so now what I'll do is I'll say reverses the original list. So I don't want to remove this, the original list, reverses the original list, and let me use this reverse method and let's run this program. I'm going to comment this out because I don't want to sort my list and then reverse it. I just want to reverse it. Okay, so let me run this program and you can see 15, 21, 2, 7, 8, 1, just like I've written in the comments, in the notes, is being displayed. Okay, what if I want to append something to a list? Now appending means adding something at the end of the list. What if I want to add something to the end of the list? I can use this append method, and let's use this append method, and I'm going to comment this one out, and I'll say add 9 at the end of the original list. Okay, and I'm going to use append and I'm going to use 9. I'm going to add 9 at the end of the list. Okay, so let's add 9 at the end of the list, and you can see that 9 has been added at the end of the list. So this is basically modifying the original list. It's not returning a new list. This is something that you need to remember. This is modifying the original list. When I'm saying my list of numbers dot append 9, this list is being changed. Okay, not a new list is being returned. Okay, so this is something that you need to remember. Now what I'll do is I'll use insert. Now append will insert at the end of the list. What if you want to insert at a particular index? You can use insert. Okay, so let's try to use this insert. I'll comment this one and I'll say 2,9 and I'll use insert. Now I'll say inserts 9 at index 2. Okay, at index 2. Okay, let's see if it's actually inserting 9 at index 2. You can see 9 has been inserted at index 2. So 0, 1, 2. So at index 2 we now have 9. Previously we had 7 at index 2, but now we have 9 at index 2. So this is something insert function has done. Okay, now let's talk about another function, which is pop. So pop will delete element from the end of the list, and if you specify an index, it will delete the element at that index. Let's see how pop works. Okay, let me comment this out, and what I'll do is I'll say pop. I'll simply say pop. Okay, I'll remove this comment. If I run this, you can see that 15 has been deleted. What if I run pop twice? Will it delete 2 elements from the end? Yes, it will do that. Let's see how this works. So this pop deleted 15, this pop deleted 21. We have 1872 as a final list. Okay, now what if I run pop once again? Will it delete 3 items? Yes, it will keep on deleting as you keep running this method. Okay, so pop will delete 15, 21 and 2 respectively. Okay, now if I run this program, I'll see 187 as my final list. This is very evident. Now what I'll do is I'll simply add it once. I'll say removes an item from the end of the list. Okay, and from the given index from the list. Okay, so if I say pop 2, let me comment this one, you'll see that 7 has disappeared. So at index 2 we had 7 previously, but now we don't have 7 anymore. We have 1, 8, 7, 21 and 15. Okay, so we don't have 7 at index 2, we have 2 because 7 has been removed because we ran .pop2 on our original list. Okay, so this is how pop works. Now let's see how remove works. So if you run remove, you can remove a particular item from a list. What if we have duplicate items? Before that, let's demonstrate remove. Then we'll talk about the case when we have duplicate items in the list. What if I say remove 2? So remove 2 will actually remove this item from the list. Okay, removes a given item from the list. Okay, so from the list. Okay, so my list of numbers dot remove 2 will remove this, and we'll be left with 1, 8, 7, 2, 21 and 15 as the final list. 1, 8, 7, 21, 15 in the final list because 2 will be removed. So 2 will be removed and the remaining items will form the list. So if I say my list of numbers dot remove 2, and if I run this, you can see that 2 has been removed. What if I want to remove 21? I can very well do that. I can simply remove 21 and you can see 21 has been removed. What if we have duplicate items in the list? What if we have 2 21s? What if we have this as a list? What will happen? Let me add spaces here just so that it looks beautiful. These spaces don't matter, but I just added these spaces to make it look beautiful. Okay, you can do one more thing to make it look beautiful. You can simply right click and click on format document, and this will actually install a formatter which will format your code. But I don't want to do this at this point. Okay, we can manually format the code, it's fine. Okay, so my list of numbers was this list. Now I want to remove 21 from this list, but the problem is 21 occurs twice. One after 2 and the other 21 is after 15. How do I remove this 21 from the list? Let me run this code and see which 21 is removed. Okay, so first occurrence is removed, which is good. First occurrence is removed. So first occurrence of a number is of an item is removed from a list. So an item can be a number, it can be a string, it can be a list as well. So let me write removes first occurrence of item, removes the first occurrence of a given item from the list. Okay, so it will remove the first occurrence. So I have written it here, remove 21 from the list, but after watching the video, you know the 21 will be the first occurrence of 21. Okay, we didn't had any duplicate items, so I'll keep my list as original. 187 to 2115, 187 to 2115. Yes. Now let's talk about tuples in Python. So tuple is an immutable data type in Python. What does it mean? What do I mean when I say tuple is an immutable data type in Python? Immutable means something which cannot change. As you saw in the case of list, we were changing the list again and again by running the function. Sometimes we are adding something at the end of the list. Sometimes we are removing something from the list. Sometimes we are appending to the list. The original list is affected. My list of number was being affected and it was changed. The same is not the case with tuples. Tuple is something which cannot be changed. Yes, you heard that right. It cannot be changed. It is immutable. So if I say 04 underscore tuples.py, I can actually show you how a tuple looks like. I can say my tuple is equal to, did you see how I use these parentheses to create a tuple? I can use these parentheses and I can add 3, 6, and 7 inside this tuple. What if I print this tuple? Let me print this tuple and see what is printed on the screen. As you can see, 3, 6, and 7 has been printed on the screen. What if I print the type of this tuple? Let me try to see what type this tuple is. Class tuple should be printed, and yes, class tuple is printed, which means that tuple in itself is a data type. Just like we had strings, just like we had integers, just like we had floating point numbers. Okay, so tuple in itself is a data type. Now this is a data type which cannot be changed. So if I try to change this tuple, I should see something, some error message. Okay, so if I say tuple 0 is equal to 8, I should see an error. You can see that tuple object does not support item assignment. So it's telling me that what you are going to do is not allowed in Python. If you want to do this, you can create a list, but tuple just cannot be changed. Okay, so I'll write here, this will throw an error. So this will actually throw an error. Okay, so my tuple 0 is equal to 8 will throw an error because you cannot change a tuple. Now you can create an empty tuple like this. You can say a is equal to blank parenthesis and it will create a tuple. You can create tuple with only one element and you will need to add a comma at the end. Okay, I'll tell you why. So why is a comma needed when you're creating an empty tuple? So let me do something. Let me comment this out and let me show you how an empty tuple looks like. So if I do something like this, class tuple is printed and an empty tuple is printed. So it is actually a tuple. Okay, what if I write 4 inside this parenthesis? And what if I run it? Class int is printed, but I intended to create a tuple. Why is integer printed? This is printed because something inside parenthesis will be treated as an individual item. Sometimes you might do something like this and accidentally create a tuple. So if you want to say 4 multiplied by 7, you might accidentally create a tuple. So Python doesn't allow you to create tuples of single items like this. So what to do if you want to create a tuple with just a single element inside that tuple? You need to add a comma. You need to add a comma to tell Python that, hey Python, I don't mean 4 here. I actually mean tuple of a single element, which is 4. So Python will say, okay, so you need a tuple with just one element. So you need to add a comma at the end of that element. But if you don't add that comma, I'll literally take this element and assign it to my tuple. So you don't want that. You want a tuple with element 4. Okay, so I'll save it, and if I run it, you'll see class tuple. As you can see, we have 4 comma and the class is tuple because this is a tuple with 4 as the value inside it. Okay, I hope you got this. I hope that was easy. So we saw what tuples are, we saw how to create an empty tuple, we also saw how tuple with one element needs a comma, and we also saw tuples of more than one element. Once defined, a tuple's elements cannot be altered or manipulated. You cannot change the elements of tuples. Okay, now let's talk about some tuple methods. Consider the following tuples. Let me create another file for you. Let me create 05 underscore tuple methods, tuple methods underscore methods.py. So tuple underscore methods.py is a file, and let me add a tuple here, and a is equal to 172. Do not use abc as the name of variables in Python when you're creating your production code bases. This will definitely work, but when you have a lot of variables and you have a, b, dd, bb, ll, kk as your variable names, you'll not be able to make out which variable is doing what. Okay, so you need to have some meaning in your variable names. If you are creating a variable for storing username, go ahead and type username. Don't be lazy. Do not type abcd because it's going to create problems for you in the future. Type username, list of username. List of username is a pretty big variable name, but go ahead and type it because you have powerful IDEs and source code editors like Visual Studio Code these days. They are going to type everything for you. If you have a very large variable name like this, just like I created in list methods, my list of numbers, simply say MLON and press enter, and my list of numbers will be automatically typed by VS Code. So you don't have to be lazy, and you don't have to type abcd as your variable names. Okay, so let's jump to tuple methods and see how tuple methods work. So if I say a.count, this will count the occurrence of a given element inside that tuple. Okay, so a count will return number of items, number of times one occurs in a. Okay, let's see if it works. Let me try to print a.count, and let me say 1. This should actually return 1 because I just have a single one. What if I have 3 ones? What if I add 3 ones inside this tuple? Will it return 3? Indeed, it will return 3 because I have 3 elements inside this tuple. Okay, so this is how count method works. We have another method called index, and this will return the index of first occurrence of a given element inside the tuple. Okay, let's see how it works. So if I say a dot index, and if I say 1, this will not return me 0, 1, 2, 3. This will not return me 3 or 4. This will return me 0 because 0 is the first occurrence of 1 inside this tuple. So I'll see 0. Okay, let me comment this one out. I'll see 0, but if I have 10 at the beginning of the tuple, I'll see 0, 1, 2, 3. I'll see 3 as the first occurrence of 1 because at index 3, 1 occurs for the first time. Okay, or if I make it 2, I can even make it 2 and make it 2 here as well. 2 will occur for the first time at index 2. So 0, 1, 2. So this will return 2. Let me show you. This will return 2. If I make it 12, this will actually return 3 because at index 3, 2 occurs for the first time. 0, 1, 2, 3. So at index 3, 2 occurs for the first time. So this will return 3. As you can see, let me make it as 1, and it will keep the result as same because I am talking about the index of 2. It has nothing to do with 1 or 10. Okay, so this is how index function works. This is how count function works. So this was the curated list of all the methods you want to use with list and tuples. I hope you enjoyed this chapter. Make sure you download the notes and make sure you have a printout of these notes, because if you have printout and have these notes at your disposal, it will be very, very beneficial for you to revise, and even while you are coding, you can refer to these notes and it will be very beneficial for you. I hope this video helps. Now we'll practice about list and tuples, and we'll move on to chapter 4, practice set now. So let's move ahead and look into the chapter 4 practice set which I've created for you. So this is a PDF of chapter 4 which I've created for you. Let me open this folder in my VS Code. Let's close all the tabs in VS Code. So I'll simply say close all. This will close all the tabs, and believe me, I usually do it very frequently. Sometimes when I'm working on a larger code base, what happens is I happen to open a lot of files, and all of those files keep open at the top, and it creates a lot of confusion. I'll show you what I mean by this. So you'll have a lot of files open, and there will be only 2 or 3 files you'll be working with, but a lot of files will be open. Feel free to do this and open the files which you are working with. Okay, so this is something I wanted to tell you. Let's create another file. Let's say 06 underscore, because this is the 6th program of this particular chapter. So I'm saying 06 underscore, and I'll say practice set 1 pr01.py. So this is the practice set question 1 of my chapter number 4. So let's open the PDF and see what chapter 4 practice set question number 1 has to say. So it says write a program to store 7 fruits in a list entered by the user. So it has to be entered by the user. So this is something you need to keep in mind. So you have to write a program to store 7 fruits in a list entered by the user. So 7 fruits have to be entered by the user. So let's do something like this. I'll say f1 is equal to my fruit 1. I'll say input. I'll say enter fruit 1. Okay. And I'll say \n, or rather what I'll do is I'll do this. I'll say enter fruit 1. Then I'll do the same thing with fruit 2. I'll use alt and click here and here to create 2 cursors, and then once again I'll do the same thing here. I'll say enter fruit 3, and then we'll do the same thing with, oops, I added a 3 here. Then I'll do the same thing with fruit 4. So we have 4 fruits, and now what I'll do is I'll simply create a list and I'll call it fruit list. I'll say fruit list contains f1, f2, and then it will have f3, and then once again it will have f4. Okay, so these are the list of all the fruits which have been entered so far by the user. Now what I'll do is I'll print this list as demanded by the question. So I should see the list of 4 fruits which have been entered by the user, and they all will be string. We know that input returns a string. Okay, so let's run this program and see what happens. Enter fruit 1, I'll say banana, then I'll say guava, then I'll say apple, grapes. So banana, guava, apple, grapes. This is how we solve this problem. Okay, quite simple problem, but again I added this so that you get adequate practice. Let's move on to the next question now. Write a program to accept marks of 6 students and display them in a sorted manner. Now this might sound challenging, but it is not, because we have a function which sorts the items in an array, okay, in a list. By the way, now that I have used array in place of list mistakenly, let me tell you, array is something we call to list in other programming language. So the collection of items in other programming languages like C and Java is called an array, and the same thing here is called as a list. Okay, so when somebody says create an array in Python, they mean list most of the times. Okay, so next question says write a program to accept marks of 6 students. Let's accept the marks of 6 students, and I'll use the same program. I'll leverage the same program because we already have so many inputs written. So what I'll do is I'll say 07 underscore pr02.py. So question number 2 from my chapter 4. Okay, so program number 7, practice set question number 2, and the question says that you need to take marks of 6 students as input. So 6 students are entering their marks. Okay, so what I'll do is I'll make it M. I want to make it marks. Let me make it marks, and let me make this enter marks of student 1. I'll say enter marks of student 1, enter marks of student 2, then 3, then 4, then 5. Okay, so marks of student 5, and we need marks of 6 students if I'm not wrong. So what I'll do is I'll add another one and I'll say mark 6, enter marks of student 6. Then I'll do the same with the list. I'll say marks list is equal to, and then I'll say marks 1, then marks 2, marks 3, then I'll say marks 4, and then marks 5. Okay, marks 5. Now what I'll do is I'll print this list. Okay, so I'll say marks list, mn, marks list. Okay, now if I run this program, but before I run this program, I need to run sort function. Okay, I need to run this sort function, but make sure that these marks are supposed to be an integer. You can see that I've written very clearly in the problem statement that accept marks of 6 students, and the marks of 6 students are going to be integers. Okay, so do not confuse these with string marks or with marks of some other data type. Let's make them integer, and let's cast all these values to int. So this might sound like some advanced stuff, but it is not, believe me. I'm simply saying cast all these numbers which are entered in the form of string to an integer. Okay, so I'm converting all of these to an integer. By the way, I pressed end key on my keyboard, so end key on my keyboard is something I pressed, and I can close this now and I can save it. And let me show you that if I enter, so I'm going to enter say 10, then I'm going to enter 20, then I'm going to enter 5, then I'm going to enter 30, then 40, then 50, and then you'll see that I have just 5 marks. Not sure why this happened. 1 2 3 4 5 6, 2 3 4 5. So there's some mistake I made. Marks 2, marks 3. Okay, so I didn't enter mark 6. Let me enter mark 6 as well. So I made a mistake here. But again, if you see, let me type it once again. 10 20 5 30 40 50. I'll enter the same thing. Let me enter it. I'll say 10 and then say 20, 5, 30, 40, 50, and you can see that 5 has been shifted to the beginning of the list. Why? Because I've sorted the list, and if I sort the list, it will sort in ascending order. In case you want to sort a list in descending order, what you can do is you can simply reverse the list after sorting. So dot sort will arrange your list in increasing order, and then if you reverse the same list, you'll find that your list has been reversed, and automatically this will sort your list in decreasing order or descending order. Okay, so I hope you got the point. By default it is ascending order. If you want to keep descending order, what you can do is you can add dot reverse call after the dot sort call. Okay, so let's move on to the next question now. Check that a tuple cannot be changed in Python. This one is going to be very easy, and I recommend that do not create a Python file for this program. What I want to teach you is at times you will have to test certain things in Python. What will happen if you do certain thing in Python and you don't want to create files for all those programs if you want to test something in a single line. So what I recommend in those cases is open your terminal. It can be the built-in terminal from your Visual Studio Code, or it can be your Windows PowerShell, and simply write Python here. What I do is I write Python here and I use REPL, and I've told you about REPL in chapter number 1 if I'm not wrong. What I'll do is I'll simply say a is equal to none, and let me see if I can use sort with none. I cannot use sort with none, I know that, but let us assume that I want to test it. I want to make sure that this returns an error, and I can now confidently say that yes, this will return this error. I don't have to create a file. I don't have to run that file again and again. I don't want to do all that. I don't want to create a folder. I can simply fire up my REPL, and at the drop of a hat, I can simply type something, bang, close the terminal, and you know what happens when you do a certain thing in Python. Okay, so let me try to change the tuple. Let me create a tuple. I'll say a is equal to, I'll simply say 1 2 3, or let me keep it 1 2 4, and you can add this extra comma. You don't have to add it. You have to add it if you're creating a tuple with a single element. This is important, and what most of the programmers do is they keep this comma at the end of the element just to make sure if their tuple has been changed in the future with tuple of only single element, what they can do is they can ensure that their tuple of single element is actually a tuple and not an integer. Okay, but here I want to see if I can change this tuple, so I'll press enter key. Now if I press A, I know that this is a tuple. If I want to see type of A, I can see it's class tuple. No surprises there. But what I want to do is I want to see what A0 returns. It will return 1. Can I change this A0? I can use arrow keys, by the way. I can use up and bottom arrow keys from my keyboard to browse my command history and navigate to all these commands which I've already used in the past. Okay, so I've used type A, I've used A is equal to 1 to 4, I have used A dot sort, I have used A is equal to none. I can use my bottom arrow key now to come back to this command, and let me try changing this to 34. I know I can't do that, but let's check. Yes, type error. Tuple object does not support item assignment. You can't do this. This is something REPL is telling you. You can't do that. Okay, so this is the error you are going to get. So we are going to create Python files in most of the cases, and we are going to write programs into these files. But for quick things, we are going to use REPL, and this is going to be a very good deal for us because we don't have to create files. We don't want to have a folder with messy files. We just want to create files for something we need in the future. You can use this rule of thumb. I create Python files for programs if they exceed 5 to 7 lines. Mostly if they are within 5 to 7 lines, including imports, I use REPL. And obviously if you want to save your program, even if your program is a single line, you can create a Python program. I hope that makes sense. Let's move ahead now and let's talk about the next problem. So the next problem says that write a program to sum a list with 4 numbers. And you can simply do this using a function called sum, but we can also do this using indexing. So let's try to create a list with 4 numbers first. And this is problem number 4. So I'll say 8th program, problem number 4, and let's create a Python file. Now what I'll do is I'll say my list is equal to, what I'll do is I'll say 1, 2, 4, 5, and this is a list of 4 numbers. Now what I'll do is I'll sum this list. So let me sum this list. I'll say sum is equal to 0. So sum is a variable and I have assigned this variable to 0. Now what I'll do is I'll say sum plus equals to, so add this particular thing in sum. Which particular thing? My list 0. Add this to sum and do this for 1, do this for 2, do this for 3, and finally print this. The value of sum is, and you can use plus and then sum. So the value of sum is, or you can even use comma. You can use comma as well. The value of sum is, and you'll see the sum. What is the sum? 4 plus 3 is 7 and 7 plus 5 is 12. Let's see if we get 12. Print it onto the console. Yes, we do get 12. And you don't have to add the space here because when you're using comma, a space is automatically appended. So I don't have to use this space. So a single space is what I needed, not double space. I was getting this double spacing because this particular thing, it was already printing a space and I again added a space after is. I didn't intend it to do that. Okay, so this is something I wanted to tell you. So this is how you add 4 numbers from a list, and we'll talk about how to add a list of length greater than 4, or a list of variable length, or list of any length for that matter. But this was something I added just for your indexing practice. I wanted you to learn list indexing. So let's move on to the next question. And next question says, write a program to count the number of zeros in the following tuple. And let me open this chapter 4 PDF as well, because what I want is, I want you to look into this PDF and look into the methods which we have talked about in this PDF. We have talked about count and we are going to use that count. So let's create this tuple and let's use count function to count the number of zeros in this tuple. So let me create a new file here. I'll say 09 underscore, I'll say pr05.py. Okay. And after I do this, what I'll do is I'll create this tuple first of all, 708009. So 708009, and yes, I need to add commas here. So let me add commas here. Okay, and this is a tuple. Let me use tu is equal to, and now I have to print the number of zeros in this tuple. I'll say the number of zeros in this tuple is, how many zeros are there in this tuple? Count of, so I'll say I want to use tuple.count, and I want to count number of zeros in this tuple, and this will return me the number of zeros in the tuple. Let's see if this works. Let's run this program. and you can see the number of zeros in this tuple is 3. By the way, I also want to tell you that you don't have to use code runner. If you want to simply use a terminal and want to run all these files manually, simply type Python and simply type the file name. I am typing 09 and I'll press tab, and pressing tab will simply add this 09 underscore pr05.py. Okay, so pressing tab auto completes the file name. It will look into all the files in your file system, and if it finds any unique match, what it does is it simply adds the remaining characters, and you can auto complete, so I can press enter and you can see that I can run this program by firing Python and then the name of the file. Okay, so this is easy, and I hope you understood that. Okay, so this was our, okay, I accidentally added this counter. I don't want to add this. So this was our Python chapter 4 practice set. I hope you learned a lot about list and tuples, and believe me, you're going to use this a lot in your Python journey. Let's move ahead and let's move to chapter number 5 now, where we'll explore more Python stuff. So let's now move on to chapter number 5 and see what chapter number 5 has for us. So here is the PDF of chapter number 5, and we are going to be studying dictionaries in chapter number 5. And Python dictionaries are amazing, let me tell you, because you can store key value pairs inside a dictionary and it really feels good. And sometimes you really need all these things. So let's see what a dictionary is, and then we'll look into the syntax, and also we'll start coding some of the Python dictionaries. Let's see why they are useful and how you can use them. So dictionary is a collection of key value pairs, as I've already told you. Just like you have a collection of words and meanings in an Oxford dictionary, you must have definitely used an Oxford dictionary in the past, and this is none other than the Oxford dictionary which you have already used. Let's see the syntax of Python dictionaries, and then we'll move forward. So what I'll do is I'll open this particular folder in VS Code, and let me also create a file. So what I'll do is I'll say 01 underscore dict.py. Let me tell you something. You should never name your program with something which can be a Python internal keyword. For example, never ever name your normal programs as test.py, numpy.py, or say os.py for that matter. You should never ever do that. I see this mistake from a lot of people, and they really suffer, and they wonder why their programs are not working. Their program doesn't work because they are committing all these kinds of mistakes. So let me tell you what a dictionary is. Let's create a dictionary. Let me call it Oxford. Okay, and what I'll do is I'll say Oxford is equal to, and let me say gift and something. So I've written something willingly given to someone to appreciate. So this is the gift. Okay, and let me also write something else. Let me put a comma here, and let me say this, and let me say a keyword in C++. Let me also say YouTube and a video sharing platform. And I'll also say Instagram, and let me say picture sharing platform, and let me save it. And once I save it, I can print this dictionary, and this code is going to work just fine. Let me print this Oxford and let me run it. By the way, if you are wondering how I customize my VS Code like this, I'll tell you in a moment, but let me run this code and show you that this dictionary is actually working. Okay, so let me tell you which theme I'm using. I'm actually using this jellyfish theme, which is actually an amazing theme from Pavel Borker. You can simply install this theme and your VS Code will look just like mine. I keep on changing themes. It's not like I'll stick to this theme in the future. I might change the theme. It depends upon my mood and a lot of other factors. So it's not like the theme matters the most in the productivity. It sometimes matters for me, but again, what I'll do is I'll simply go to settings and show you how I enable font ligatures. So what you can do is you can simply go to your settings and you can search for font ligatures and you can enable font ligatures. So what you have to do is simply type editor.fontligatures true. So you should be having this line editor dot font languages. It might be false or it might be none. What you have to do is simply make this editor dot font languages as true. So what this will do is this will enable few font languages. For example, if you are writing something like this, this changes to this arrow. So what I've done is I've written this and a greater than symbol. So it actually looks like this. And if I say not equals, it looks like this. So all these things are enabled and all these things makes your code a lot more readable. So this is something which is very useful. But coming back to the notes and coming back to the dictionary, it's a collection of key value pairs as we have already seen, and you can have key and value not only as strings, but you can also use lists. You can also use say tuples. Let me show you. So if I put Instagram as let me put my list. Let me put my list as something. So I'll say my list, and what I'll do is I'll simply put a list here. So I can use list as values. I cannot use list as keys. Let me make it clear for you. You cannot do something like this. You cannot do something like this. If I run this, you're going to get an error. Let me run this, and it says unhashable type list. So list is an unhashable types, and you can have only the hashable types as keys. Okay, so this is something that you need to take care of. Okay, so let me remove this line as this is not valid. Let me come back to notes and let me show you how to print a particular value corresponding to a key. So if you want to print a value corresponding to a key, all you have to do is simply say Oxford and the name of the key. So if I say this and I run the program, I should be getting a keyword in C++. So it says none type object is not subscriptable. I've made a mistake here. I should have written this something like this, Oxford this, and if I run this, you can see a keyword in C++, and this is the output from this particular line. Let me comment this line, and you should be only seeing a keyword from C++. A keyword in C++ is printed on the screen as expected. Let's now talk about Python dictionaries. What are the properties of Python dictionaries? So it is unordered. The order is not preserved. It is mutable. It is indexed. It cannot contain duplicate keys. So you cannot have another this, and you cannot have something else as the value. So if I try to do something like this, and if I say that, and if I try to run this, you are essentially overwriting that value, and you need not do that. Okay, so what I'll do is I'll remove this line. So it is definitely unordered. You cannot expect it to preserve orders, and it is mutable, it is indexed, and it cannot contain duplicate keys. So let me show you some of the dictionary methods so that it is clear to you. There is a method called items which returns a list of key value pairs, and this is really very useful when you want to iterate a dictionary. Let me show you. If I open a file, let me name it as 02 underscore dict methods .py, and let me copy this dictionary as is. So what I'll do is I'll copy this dictionary and I'll show you how you can run all the methods on this dictionary. So if I say print oxford.items, I'll get a tuple of key value pairs. So you can see that I have a tuple of key value pairs, a tuple of key value pairs, a tuple of key value pairs. I can actually iterate it using for loop. You'll see how I can do that. I can say for a comma b in oxford.items, and if I do this and if I print a and b, let me say a and b, and let me comment this out, you can see my list 1, 3, 4, Instagram, a picture sharing platform. So essentially what it is doing is it is storing the key in A and the value in B for all the key value pairs in the dictionary, and it's actually printing it because I have written print a comma b. If I want to format it something like this, if I want to say colon and comma, let me run this for you and show you how it appears. So I have a colon here. If I say colon equals to, I mean you can format it however you want to. Okay, there's no hard and fast rule. A will contain the key and B will contain the value. So this is how you can use a.items. It returns a list of key value tuples. Now a.keys, it returns just the dictionary's keys. You'll not have values. So if I say a.keys, I can say something like this. I can say for key in oxford.keys, and if I print key, you'll see that the key is printed. Let me comment this particular thing out and let me run this code for you, and you'll see only the keys of the dictionary is being printed. This is super useful if you want to just print the keys, or if you want to do something with only the keys of the dictionary. Let me go back to this page from my notes. I can actually use a.update, which will actually update the dictionary with supplied key value pairs. So update can actually add an item to the dictionary. It can also change an existing item in the dictionary. Let me show you how. So what I'll do is I'll simply say oxford.update. I'll say I'll supply a dictionary. I'll say Harry, and then I'll say good boy, and then what I'll do is I'll say my list, and you can use single or double quotes, it doesn't matter. Okay, you can either use single quotes or you can use double quotes, doesn't matter. I can say 56 and then I can say 8. Okay, let me run this for you, and we'll actually print the keys from the dictionary, actually the key value pairs from the dictionary. Let me comment this out. If I run this code, what will happen is the my list will change. Okay, so I have actually made a mistake here. I should have written small l. So the keys are case sensitive. You need to use exactly the same case you intend to. So you can see that my list has been changed, and Harry and good boy, this key value pair has been added to my dictionary, and actually I wanted to do that, which is why I ran oxford.update. I hope this is clear to all of you. Let me come back to the nodes and let me show you one more method, which is a.get, and this simply returns the value of the specified keys and values returned. Okay, now why should I use a.get? Why can't I simply do something like this? What if I say this 6? Let us say I have added an arbitrary key which is not present in the dictionary, and if I try to run this program, you can see my program is terminated with an error. If you don't want an error in your program when the keys are not present in the dictionary, what you can do is you can actually use get, and it will return none. So if instead of print Oxford, let me say not present. So not present is a key which is not present in my dictionary. I have gift, this, YouTube, Instagram, my list, but I don't have this not present. If I try to run this program is throwing an error, and I don't want my program to throw an error. So what I'll do is I'll simply say print oxford.get, and I'll use this not present. Now what will happen is my program will not throw an error. Rather, it will print none. It will tell me that this particular key is not present in the dictionary. So this is super useful once again if you don't want your programs to throw errors. And believe me, this really works wonders. You don't have to use try catch, which we are going to be studying in the later chapters. You don't have to use that if you simply want to do a key lookup in your dictionary. Now let's see some of the more methods which are available on docs.python.org. For the sake of time, I'm not going to docs.python.org and look into all the methods of dictionaries, but let me tell you that these are the most commonly used methods which you'll ever use, which you'll ever need. I mean, I can't promise that these are the only methods which you'll ever need, but I can definitely tell you that these are the methods which you are going to need 80% of the times. So you are good to go if you are a beginner, and with practice you are going to learn more methods, and that's how it works. But let's talk about sets in Python. What is a set? Have you ever heard of set in mathematics? If you have heard of set in mathematics, you should be able to understand what a set in Python is. So it's exactly the same set which you have already learned in your mathematics, but this is a programmatic version, I should say. So sets in Python is a collection of non-repetitive elements. In mathematics, we study set as a set is a collection of well-defined objects. Here set is a collection of non-repetitive elements. So if you say s is equal to set, no repetition is allowed. S dot add 1, s dot add 2, this is going to generate a set with 1 and 2 inside of the set. Now if I run s dot add 2 once again, this is not going to add 2 to my set yet again, because 2 is already present in the set. I hope you are getting me. If you are a programming beginner without much knowledge of mathematical operators on sets, You can simply look at sets in Python as data types containing unique values. That's it. You don't have to stress into sets too much at this point. And believe me, when you're writing a simple Python program, all you'll need is the set and the add method from the set. And we use set when we don't want to collect something twice. So at times when I'm doing data scraping or web scraping for that matter, what I want to do is I want to have unique items in my I should say object. I want to have some object which can actually collect unique items. So if you're looking for unique items from a pool of items, you keep on adding to a set rather than adding it to a dictionary or adding it to some other object for that matter. Now let's see the properties of sets. Sets are unordered. You cannot expect sets to have ordered. Now they are unindexed. You cannot access elements by index. You cannot say, let us say if you have a variable called mySet, you cannot say that I want to access third element of the set. You cannot say that I want to access 10th element of the set. This is not how set works. Now there is no way to change items in the sets. So if you have an item, you cannot change the items because it's simply a bag of items. So if you have a bag of items, you cannot say change that item because you cannot access item using indices. I hope I'm making sense here. Now let me create this set here and let me show you some of the operations on sets. So consider this set where I have s is equal to 1, 8, 2 and 3. So 1, 8, 2 and 3 are elements in the set. And what you can do is you can run all these methods on this set. But before I move on to methods, let me show you something. Let me create a set for you and let me show you how sets work. Okay, so let me come back to my VS Code. Let me create a file called 03 underscore sets.py. And once I have this file, what I'll do is I'll create a set for you. So I'll say my set is equal to, is this an empty set? Is this an empty set? No, this is not an empty set. If you hover over this, you are going to get a dict. It's a dict. Why is it a dict? I want to have a set. When you type a set of curly braces, all Python understands is that you are trying to create a dictionary. It cannot read your mind. Okay, so if you want to create a set, you can either specify few values, so it will know that it is not a set of key value pairs, so it's not a dictionary, it's a set for sure. So now if you hover over this my set, it's actually a set of integers. Okay, now what you want is you want to find the length of this set. Let us say you can simply say len of my set, and this will actually return the length of the set, which is 3. So it has 3 elements. Now if I say my set dot add 45, now if I try to access this len of my set, I should get 4 because I've added another item. Now I want all of you to comment below what is going to be the output of print len of my set, because I have added 1 again to the set. So would it be 5 or would it be something else? I want you to comment with the timestamp. Put the timestamp of the video and write a comment so that I can see that and tell me that what will be the output of len of my set. If you guessed it right, it's going to be 4 because it's not going to be 5. 1 is already present in the set. So if I try to add 1 yet again, this is not going to add 1 to the set. Let me show you that it's going to be 4 and not 5 because 1 is already present in the set. If you add an element which is already present in the set, it's not going to add that element. It's simply going to ignore it. Now let me show you something else. If I do something like this, if I do double quotes and 1 and double quotes, if I try to add this particular thing to the set, I want you guys to comment below what's going to happen. Is len of my set going to return 5 now? If not, why? Write a comment below. I want you guys to write a comment below. Okay, so you guessed it right. It's going to be 5 at this point because 1 as an integer, this particular 1 and this particular 1 are 2 different objects in Python's eyes. It's not exactly the same thing because 1 is a string here and 1 is an integer here. So if I run this, you'll see 5. Okay, I hope things are making sense at this point. Let's look into some other methods of Python sets. If you say s.remove, it will update the set and remove that particular element from the set. If you say s.pop, it removes an arbitrary element from the set and returns the element removed. So this is a very interesting function. If you want to return something at random, remove something at random, you can simply use s.pop. So let's try some of these functions. Let's try remove. I've added one, and what I'll do is I'll print the set. I'll say print my set, and let me also remove this. So I'll say my set dot remove, and let me remove 34 from the set, and print set once again. So I'll say print my set, and let me run this program. Okay, so as you can see that I have this particular set which is printed from my line number 4, and I have this set which is printed by my line number 7. So 34, 1, 53, all these elements are present in this set. Now I have removed 34, I have added 1. So since I've added 1, yet again it's not going to have any effect because 1 as a string is already added. And if I print my set, 34 will be removed from that set, and the length will be 4 because I have removed 34, right? So this is how all these functions work. Now if I say print my set dot pop, it's going to remove an element at random and it's going to return that element. So let me print my set after running this my set dot pop, and if I run this program, you can see that it has let me run it once again. It has chosen 1, and 1 has been removed from the set, and the length of the set is 3, and this is the set after 1 is removed from the set. So I have removed 34, I have removed something at random which is 1, I've used pop, so it's going to simply pop an element from out of the set. Let me run this yet again, and you can see that it is removing 1. So this is how it works. Okay, so what I'll do now is I'll simply show you how clear works. So s.clear will empty the set, you can test it yourself. Now what is union and intersection? This is something I want to explain you because this is actually important. And let me tell you something, you don't have to dive deep into this one. This is something which you might already know if you have learned sets in your class 11th or maybe class 10th or 9th in some cases. But this is actually a very easy thing. So union is you are combining two sets. So S is a set, it contains some element, and you are adding some elements from another set to this set. Now that set might already have 8 and 11. If it already has 8 and 11, 8 and 11 will not be added. If it has 8 and 11, it will not be added, and if it doesn't have 8 and 11, it's going to be added. So union is simply adding all these items one by one to the set. What is intersection? What is intersection? Intersection will check which values are there in the set and return only those values out of these values. Let me show you an example. So this is a set, 1, 8, 2, 3 is a set. Now if I say union, I'm going to union this set with this set. 1, 8, 2, 3 union 8, 11. Now 8 is already present in this set. So 11 will be added to this set, and the final set will become 1, 8, 2, 3, 11 as you can see here. Now what about intersection? Intersection will actually see which elements are common between this one and this one. So what are the elements common? Is 8 present in both the sets? Yes, 8 is present in both the sets. Is 11 present in both the sets? No, 11 is not present in both the sets. It's not present here. So 8 is the output. So you'll see 8 as the output. So union means all the elements combined from both the sets. Intersection means elements which are present in both the sets. So this is a Venn diagram. This is something which you might have studied in your mathematics, and you don't have to emphasize a lot into this if you are not a mathematics person. So R1 is this area, R2 is this area, and R3 is this area. R1, R2, R3, these all combined is A union B. A is this circle, B is this circle. R1 plus R2 plus R3 is A union B. If you combine all these areas, you will get A union B. R1 plus R3 is A triangle B. Let's not talk much about it because I think I'm going a lot into mathematics. I don't want to go a lot into mathematics. And R2 is the area which is present in both the sets. So it's A intersection B. Now R1 is A minus B and R3 is B minus A. R1 is not the entire circle. R1 is this particular part of the circle. R1 is actually A minus R2. So if you remove R2 from the circle, this area is R1. I hope I'm making sense here. I hope you understood what I want to explain. And this is all about dictionary and sets. Now what we'll do is we'll move to chapter 5 practice set. We'll have some practice for sets and dictionaries, and it is going to give us some confidence. So let's move on to chapter 5 practice set now. So let's now talk about chapter 5 practice set, which is going to be practice on dictionary. So what I'm going to be doing now is I'll open this chapter 5 practice set and we'll create few programs and we'll understand how these programs use dictionaries and sets. Okay, so let's open this particular folder in VS Code. I'll right click and open this in VS Code. We already have few files open. So let's do one thing. Let me close all these files and let's create another file 04 underscore pr01.py. So we are going to solve problem number 1 here. Let's see what problem number 1 has for us. So it says write a program to create a dictionary of Hindi words with values as their English translation. So you just have to create another Oxford dictionary. It's really very simple thing. Just provide user with an option to look it up. Okay, so you have to provide an option for the user to look it up. So what I'll say is I'll say Oxford is equal to, and I think I've already done this here. But I just have to do Hindi to English or English to Hindi translation. So what I'm going to be doing is I'll say lakdi, and then I'll say wood, and I'll say kursi is chair, and what else? Chaku is knife. And you can use any language of your choice. Let me now give an option to the user to look it up. So what I'll do is I'll say key is equal to input, and I'll ask the user for the key, and the dictionary is going to give the corresponding value. So what I'll do is I'll say input enter the key. Okay, and I'll also say \n, and this is going to print a new line here. Okay, so let's now print I'll say the value corresponding to your key is, and I'll print that value, as simple as that. And what will I use? I'll use dot get. I'll use dot get, and I'll not use the square bracket syntax, because if the value is not found, I'm going to be in trouble. Okay, so what I'll do is I'll say Oxford dot get, and then I'll say key. Now if I run this program, you'll see if I enter lakdi, you'll say the corresponding value to your keys is wood. Okay, and if I enter something else which is not present in the dictionary, you can say that none is printed on the screen. But this doesn't look good, right? I would love to have a prompt telling me that hey, the value is not found in the dictionary. So what I'll do is I'll say if Oxford dot get key is equals to null, none. If this is equals to none, what I would want my Python interpreter to do is I would want it to print value not found, and else I'll say print this particular thing. Okay, so let's run this once again, and if I enter something which is not present in the dictionary, it says value not found, and let me enter something which is present in the dictionary, and yes, the value is found. And let me remove this space because Python automatically adds a space. So let me say chaku, and the value is knife. Cool. This really looks good. Okay, so the problem number 1 is solved. Now let's move on to question number 2, which says write a program to input 8 numbers from the user and display all the unique numbers. And when I look at this word unique numbers, what comes to my mind is, yes, you guessed it right, it's sets. So what I want is I want 8 numbers and I want to pass it through the set, or I can have an empty set and I can have the user enter the numbers, and I'm going to keep adding all these numbers to this set. Let's try this. I'll come back to VS Code and I'll create another program, and that's going to be 05 underscore pr02.py. Okay. So what we are going to be doing now is we will simply say create a set. So I'll say s is equal to set, and then what I'll do is I'll say s dot add, and I'll say input. Okay, and your number. Okay, and I'll run this for say 5 times or 6 times. I don't know. I think I should call it 5 times. That's going to be fine. So I'll say for I in range, and I'll say 5, and this is going to run this loop 5 times. Let me look in the question, like how many times should I run it. It's 8 times, so let me put 8 in here. So if I say for I in range 8, I can add it, and I'll have an indent here, and you can see that s dot add input, and input enter your number is going to add that number to my set, and finally I can print that set. Okay, print s. So let me do one thing. I'll keep on entering 1 and 2. I'll keep on entering 1 and 2. 1 2 1 2 1 2 1 2 2. And you can see finally the set only has 1 and 2. Now you must be wondering what this for loop is. I didn't teach this yet, and why am I using this? So this is a loop in Python, and we are going to learn more about it. For now, think of it as a procedure to run something multiple times, and if you want to avoid this, you can simply say s dot add 8 times, and I'm going to do that. I don't want to use for loops just yet. So let's comment this out and let's do this. So this is 1 2 3 4 5 6 7 8. Okay, so I'm adding 1 and 2 8 times to my set, and also I should be adding some sort of space or backslash n. I'll add a space. Let me run this, and let me say 1 2 1 2 3 4 1 2, and you can say 3, and you can see that 1 2 3 4 have been added to the set. Okay, so this is really very simple and straightforward, no rocket science there. Let's see question number 3 now. Can we have a set with 18 as an integer and 18 as an str as a value in it? Yes, you can definitely have it, because 18 as a string is a different object, and 18 as an integer is a different object altogether. Okay, I hope you got the point. I hope you are able to understand why we can add 18. Let me show you. Let me show you in this program itself. So what I'll do is I'll say I'll add 18. Okay, and then I'll run this program. Let me cancel this program. Control C to cancel. What I'll do is I'll simply say 18, and I'll say 1 1 1 1 1 1 1 1, and you can see that 18 as an integer and 18 as a string has been added to this particular set, which is amazing. Okay, so let me now move on to the next question, which is what will be the length of the following set? If I say s is equal to set, and if I add 20, then 20.0, and then 20, length of s after these 3 operations. I'm going to solve this problem on RAPL. If you remember what RAPL is, I will simply say Python, I'll say s is equal to set. By the way, let me tell you that this particular syntax is going to create an empty dictionary and not set. Okay, so you don't have to use this. If you want to create an empty set, you'll have to say s is equal to set. Okay, so this is how you create a set. And after you create a set, what you can do is you can simply do this s dot at 20, s dot at 20.0. So I'll say s dot at 20, then I'll say s dot at 20.0, and then I'll say s dot at 20 as a string. Okay, and let's see how set looks like. So as you just saw, that 20 is added only once to this set, and the reason is that 20 is equal to 20.0. So if you compare the value of 20 and 20.0, both the values are equal. So 20 and 20.0, only one out of these will be added to the set. Okay, I hope you got the point. So the next question says s is equal to curly braces, and what is the type of s? So the type of S is simply a dictionary. It's very simple and straightforward because when you say empty curly braces, S will be of type dictionary, and S has been used in this question to confuse you, to make you give the answer as set. So S is actually a dictionary and it's not a set. Now the next question, create an empty dictionary, allow 4 friends to enter their favorite language as values and use keys as their names. Assume that the names are unique. So it's a very simple and straightforward problem. You just have to create an empty dictionary. You say S is equal to curly braces, and then what you can do is allow 4 friends to enter their favorite languages as values and use keys as their names. Okay, so you can simply use the names as keys, and you can use this syntax. I just taught you the syntax. It's very simple and straightforward. Okay, let's move on to the next question now. If names of 2 friends are same, what will happen to the program in problem number 6? So you'll have to look into this and solve it yourself, because we have talked a lot about this in theory. So I want you to practice this particular thing and see for yourself what's going to happen. Okay, so this is very simple. I have already talked about this in my in the video, in the chapter number 5, dictionary and sets. Now, if languages of 2 friends are same, what will happen to the program in problem number 6? So let me give you some spoilers here. If the keys are same, then only one of the keys can actually stay. But if the values are same, all the values can stay. You can have multiple keys and you can have exactly the same value corresponding to all those multiple keys, and your dictionary will just be fine. So this is the answer to this problem number 8. Let's move on to question number 9 now. Can you change the values inside a list which is contained in a set S? And again, very straightforward, you cannot do that because you cannot access that list. So since you cannot access that list, you don't have any method to access this list. You cannot use indexing in sets, by the way. You cannot access this particular item, so you cannot change it. And that's the answer to question number 9. So that was chapter number 5 practice set for all of you. I hope you enjoyed chapter number 5 and you were able to understand why we are using all these things. The next chapter now is about conditionals, and conditionals is really very important topic. So let's move on to chapter number 6 and learn about conditionals. From here we are going to start one of the most important topics of the entire Python course, which is conditional expressions. And why am I saying this is important? Because this is something you are going to use most of the times when you are learning Python. So sometimes we want to play PUBG on a phone if the day is Sunday. So let us say the day is Sunday and you don't have to go to the school, you don't have to go to the office or wherever you go, and you have some free time and you decide to play PUBG on your phone. Why did you decide to play PUBG on your phone? Because the day is Sunday. Now let us say somebody asks whether I am playing PUBG on my phone today or not. What is the question you are going to ask? Is today Sunday? If yes, then yes, I'm going to play PUBG. If no, I'm not going to play PUBG because I might be busy in some other work. Similarly, sometimes we want to order ice cream online if the day is sunny. If the day is rainy or if the day is very cool, you might not want to order an ice cream because who eats an ice cream? I mean, you might argue that I love ice cream during rainy season or any season for that matter, but usually people eat ice cream when it is sunny. So let us assume a person like me who eats ice cream when it's sunny outside. So let us say I am deciding whether I'm going to eat ice cream on the basis of weather outside. So this is a decision based on something which is dependent on the weather. Now let us say you are going to hiking only if your parents allow. So you are going to your parents and you are going to ask, do you want to allow me to go hiking with my friends? And your parents might come back to you saying, hey, I don't want you to go for hiking. In a very similar fashion, Python uses if-else conditionals, and we are going to look into all these conditionals. All these are decisions which depend on a condition being met. So your parents are either going to allow you for hiking or not. You are going to eat ice cream based on whether it's sunny outside or not. You are going to play PUBG based on whether it's Sunday or not. So you are looking at the day and you are deciding whether you are going to play the game or not. So all these things depends on a condition being met, and in Python programming too, we must be able to execute instructions on a condition or a set of conditions being met. So if the value of a particular variable is greater than 5, I should be able to do something. Let us say I'm creating a bot, and that bot is basically a table fin. I'm just assuming, let us say I have this table fin and I want this table fin to turn on automatically or when the weather outside or in this room is hot. Okay, so if the weather is hot, then I want this fan to turn on automatically, and this can be done. I can write a program. Let us say I have a temperature sensor. I can say if temperature in degrees centigrade is greater than 27, turn this fan on. If it is less than that, do not turn this fan on. So I can actually auto start this fan based on whether it's hot in the room or not. In a very similar way, Python programming too has some set of if-else statements which can be used to execute few lines of code when a given condition is met. Let's look into these if-else statements and let's get started with coding very soon. So if else and elif statements are a multi-way decision taken by our program due to certain conditions in our code. Now, how do I tell Python that I want to execute some set of code when some condition is met? So I'll simply say if. I'll write this particular syntax. So I've written everything in the notes. I strongly suggest that you download these notes, and they are going to be very beneficial for you. I have jotted down each and everything inside these notes for you people. So if condition 1, and condition 1 is going to be some sort of variable which will evaluate to either true or false. So you can say that condition 1 will evaluate to the value of true or false. So if condition 1 is true, you are going to see print yes. Then I've written this elif here. Elif means else if. Else if condition 2 is true, print no. Otherwise you simply print maybe. So firstly this condition is checked, then this condition is checked, and if both of these conditions are not met, we simply say print maybe. If none of these conditions are met, print maybe will be executed. So this is how this works, but this is not something which will execute. I'll tell you why, because condition 1 is not defined here. So let's look into an example which will actually execute. So let me go back to my folder and open this particular folder in VS Code. I'll simply write a program. I'll say 01 underscore if elif else.py. So it's a very basic program in which I'll simply tell you how you can use these if else statements. So you can say if a is greater than 4, then you simply print a is, so let me use print statement. I'll say, you'll simply say a is greater than 4. Then you'll say elif, if a is not greater than 4, it must be less than 4. You'll say elif a is greater than 2, simply say print a is greater than 2. So you can say a is greater than 2. Okay. Else you can say none. Okay, nothing. Let me now run this code and show you what gets printed. So nothing is printed. Why is nothing printed on the screen? So firstly, this particular condition will be checked. Is a greater than 4? Definitely not. It's not greater than 4. It's 1, which is lesser than 4. This will not be executed. Now the next thing is elif. Is a greater than 2? Definitely not. A is 1. A is not greater than 2. So this particular thing is also not executed. If is not executed, elif is not executed, then definitely else has to get executed and nothing is printed on the screen. But if I change this 1 to 3, things will change, and I'll show you how. If I run this code now, you'll see that a is greater than 2 is printed. Why is a is greater than 4 not printed and a is greater than 2 printed? Not because, do not look at it from the logical perspective. Look at it from the code perspective. Why are certain set of lines being executed? A is equal to 3. Is a greater than 4? No, it's not greater than 4. So this will not be executed. Is a greater than 2? Yes, a is greater than 2. 3 is greater than 2. This will be executed and this if else ladder will end. So when we look at if else statements, we look at if else ladders at once. So this if else ladder has not yet ended. This is linked with this elif and this is linked with else. Now if I start a new if statement here, and this is a new if statement altogether, this if statement has nothing to do with this ladder. I can create another ladder. I can even say if and elif, and I can exclude else. So if I don't write else, this will still work. So let me comment this and show you that this will still work. So this particular thing is an if else ladder. Either if or elif or else will get executed out of these three. But if I make it if, I mean if I change this elif to if, this if else ladder is independent and this is a separate if else ladder. So both of these might get executed or none of these might get executed. Okay, so this depends. I'll show you an example. So let me uncomment this and listen to me very carefully, because this is important. Now a is equal to 3. Is a greater than 4? No. So let me make it 30. Is a greater than 4? Yes, this condition is true. But condition inside elif is also true. So which one will be printed? First one will be printed, second one will be printed, or all three will be printed, or first two will be printed. So let me give you the answer. Only one out of if, elif and else will be executed from a particular ladder. So if I look at these bunch of if, elif, else statements, I look at it as a single ladder. This is a ladder and only one statement will be selected, or rather I should say only one out of these if, elif and else blocks will be selected by Python interpreter. Let me see which is being selected. So a is equal to 30. Is a greater than 4? Yes, a is greater than 4. Then this is selected and the control will directly jump outside this ladder. So it will not execute this particular code. It will not execute this particular code. I hope I'm making sense. Let me show you, let me run this code and let me show you that a is greater than 4 is printed. Now, if this condition is false, so if I write something which is greater than 2 but not greater than 4, if I make it 3, then definitely this particular thing will be executed. Only one out of these will be executed. What will happen if I keep it 30 but I change this elif to if? If I change this elif to if, this particular if else ladder is no longer part of this if elif else ladder. So now we'll have to separate these. This is a different if elif else ladder and this particular thing is different. So only one out of this will be selected and only one out of this will be selected. A is equal to 30. A is greater than 4. So this will be selected. But now the control will not jump out of all these statements, because this if elif else ladder is independent of this particular if elif else ladder. I hope I'm making sense and I'm making it clear for you. So this will be executed and one out of this and this will be executed. Since 30 is greater than 2, print a is greater than 2 will be selected and a is greater than 2 will be printed on the screen. So let me run this and show this to you. A is greater than 4 is printed and a is greater than 2 is also printed. So let's come back to the notes and see how these things are written there. I have written all the notes in a very organized manner. It will be very easy for you to follow. So let me read out the quiz. Write a program to print yes when the age entered by the user is greater than or equal to 18. So you can simply solve this quiz. Let me solve this quiz for you and things will get even more clearer after you solve this quiz. So I'll say quiz.py. So I'll say age is equal to int of input of enter your age. Okay, so let me delete this. I don't want to see this. And then what I'll do is I'll say if age is greater than 89, print you cannot drive. Okay, else I'll say print and then I'll say please drive. Okay, so let me see what the original question was. Write a program to print yes when the age entered by the user is greater than or equal to 18. So I'll change it. I'll say if it's greater than or equal to 18, then print yes. So otherwise print no. Okay, so let's run this code now and let's see if it works. So enter your age 67. Yes, it's greater than equal to 18, I should say 18. And by the way, I'm using this jellyfish theme and I'm using font ligatures, which is why I'm seeing this particular symbol. It's nothing but it's greater than equal to, it's two characters, not a single character. So mind that. I'll run this code and once again I'll enter 7 and you can say no. What if I enter 18? What will happen if I enter 18? If I enter 18, it says yes. And I can even make my code look beautiful if I, type something like this. Let me run this code now. Let me never select something and run the code, because if you select something, it copies that selected content to a temp code runner file, and that temp code runner file is executed. So a lot of beginners gets confused. Even I used to get confused when I used to run Python using VS code runner extension, and accidentally I used to select some text and I used to run my code, and what happens is all the code is copied to that temp code runner file, and that temp code runner file is executed, and it really confuses the beginner. So let's click somewhere and run this code, and let's see if I can enter some age. Let me enter 19 and you can see yes is printed on the screen. So this program works. We have solved the quiz. Let's talk about relational operators. What are relational operators? Relational operators are used to evaluate conditions inside the if statements. So if I want to see if something is greater than something or not, or if something is lesser than or equal to, or greater than or equal to, then I'll use some operators which are called relational operators, and you must be familiar with all these operators. So double equals to is used for equals, greater than equal to is used for greater than or equal to, less than equals is used for less than or equal to. So we have some more of these operators. For example, less than, greater than, not equals to. Now let's talk about logical operators. In Python, logical operators operate on conditional statements. So we have and, we have or, and we have not. Let's look at both these operators one by one. So I'll create a file for relational operators. Let me come back to my VS code. I'll say 03 underscore relational operators dot py, and let me write some code here. So what I'll do is I'll simply say a is equal to true, or let me say a is equal to 435, and I'll say b is equal to 64, and I'll say print a greater than 5. So is a greater than 5? No, it's not greater than 5. So I'll expect a false here. I'm sorry, a is greater than 5. 435 is indeed greater than 5. So true will be printed on the screen. So I should expect true. Now what I'll do is I'll simply say is b greater than or equal to 64? Indeed, it's greater than equal to 64 because it's actually equal to 64. So I'll expect a true. But what if I say b is greater than or equal to 164? This is false, so I'll expect a false here. So this is how logical operators work, and they'll simply make all these statements evaluate to either true or false, and you can use these inside your if-else statement. So if you have a true inside if-else statements, what happens is that particular block will be executed. If you have a false inside if-else statement, then if will not be executed, else will be executed. So we have seen all these things in our if else.py program. So let's come back to VS code and let me create another file for logical operators, and I'm going to give all this code to you, so do not worry about this. Logical operators.py, and we are going to talk about some of the logical operators. So I'll say a is equal to true, and I'll say b is equal to false, and I'll print a and b. What will a and b return? True and false. And operator will return true only if both of a and b are true. Is a true? Yes, it is true. B is not true. So this will evaluate to false, and I will expect a false in my output window. Okay, so let me now print a or b. So a or b, or will return a true if either of a or b is true. A is true, b is not true. So this will return true. It just need one out of a or b to be true, and it will return a true. Otherwise it will return a false. So you can see that true has been printed. What if I say not of a? Print not of a. and this is going to invert A. So if A is true, it will become false. If A is false, it will become true. Let's see if this works. And yes, A was true and it is now false. Okay, so I hope this makes sense. So this was about relational operators and logical operators in Python. So in Python, logical operators operate on conditional statements. So you can have a true and you can have a false, and true and false can be supplied as operands to and, or, and not operators. I hope this makes sense. So this was about logical operators. Now here I have talked about elif clause a bit, and I think I have explained you elif clause already. Let's talk a bit about elif clause. So elif in Python means else if, and you should know this by this time. Elif in Python means else if. An if statement can be chained together with a lot of these elif statements followed by an else statement. So look at this ladder. If condition 1, then some set of instructions will be executed. Elif condition 2, some set of instructions will be executed. Elif condition 3, some set of instructions will be executed. And at the end we have this else, and we have a lot of code here. So only one out of this ladder will be executed. So this ladder will stop once a condition in an if or elif is met. So what will happen is, it will check for condition 1. Let us say it evaluates to false. It will come back here and it will say, is condition 2 true? If it is not true, it will check condition 3, and it will keep on doing with other elif statements. And once it finds something which evaluates to true, let us say condition 3 evaluates to true, it will stop the ladder and it will skip all the elif statements along with the else statement, because only one out of all these, I should say if, elif and else statements will be executed. Only one out of these blocks will be executed. So this is how elif works. So there can be any number of elif statements, and the last else is executed only if all the conditions inside elif and if fails. Okay, so if failed and elif failed. I mean, when I say fail, I mean all the conditions inside if and elif evaluated to false. So if all the conditions evaluates to false, last else will be executed. So one out of all these statements will always be executed. You can skip else, you can skip elif. If there is only if, then the condition will be checked, and if it is true, then the block will be executed, otherwise it's not going to get executed. So there can be any number of elif statements, and only one out of these if, elif, else statements will be executed. I hope this is clear, and if not, it will definitely be clear in chapter 6 practice set, because I have designed chapter 6 practice set in a way that will make it very easy for you to understand these things. So we'll move on to chapter 6 practice set now, and we'll do some practice on conditional expressions. Let's move on to chapter 6 practice set now. So here is the PDF of chapter 6 which I've put together for you, and we are going to start coding some of the solutions for all these questions. So here is the question number 1. Write a program to find greatest of 4 numbers entered by the user. So you have 4 numbers, you have to find which one is the greatest, and you have to print it and show it to the user. So what I'm going to be doing is, I will create a file. This is the 5th program, so I'll say 05 underscore, and I will say pr, and then I'll say underscore 01 dot py. And what I'll do is, I'll simply say a is equal to 45, b is equal to 6, and then I'll say c is equal to 86, and we have another number d is equal to 23. These are the 4 numbers. Now what we'll do is, we will find out the greatest of these 4 numbers. So let me say if a is greater than b, then do this, and if a is greater than b, then b is the winner, or a is the winner. Any one of these is going to be the winner. Any one of these is going to be the greatest. Whatever is the greatest, I'll set it inside max. I'll say max num. So max num is a number, and I'll say a is the max number if a is greater than b. If a is greater than b, max num is a, else max num is what? Max num is b. So we have greatest of a and b. In a very similar way, I'll find greatest of c and d, and I'll have another max num. So let me call this max num 1, and let me call it max num 2, And let me replace A by C and B by D. So we have a C, we have a D, we have maximum 1, we have maximum 2. Maximum 1 is greatest of A and B, maximum 2 is greatest of C and D. And now we have to find out which is the greatest of the 4 numbers. And the greatest of 4 numbers will be the max of maximum and max 2. So whichever is the greatest out of maximum and max 2, who will be the winner? So what I'll do is I'll say if maximum 1 or maximum 2 is greater than maximum 1, I'll say max num is equal to what? It will be max num 2, otherwise max num is equal to max num 1. So I'll say max num is going to be max num 1. So let me say max num 1 and let me save this. And now what I'll do is I'll simply print my maximum and I'll say maximum number out of these 4 numbers is what? We'll print it, whatever it is. Okay, so we'll say max num. So max num is the maximum of all these 4 numbers. Let's run this program and see if it works. And maximum of the 4 numbers is 86, which is indeed true. Let me make it 457 and let me see if the output changes to 457. And yes, it indeed changed to 457, which means the program works and it works great. So let's now move on to the next question, which is write a program to find out whether a student is pass or fail if it requires 40% and at least 30% in each subject to pass. So let us say you have 4 subjects, you need 30% at the very least to pass each subject, and you need overall 40% to pass. So assume there are 3 subjects and take marks as an input from the user. So while you are taking input from the user, you need to ensure that you are taking an integer. You are not taking a string. If you take string, then you will be in trouble. So this is something you need to remember while solving problems like this. Okay, so let's solve this problem. Let's solve problem number 2 and we'll gain some confidence after solving this. So let me create a new file. It's a 6 program and second question. So this is how I'm going to name the file. And what I'll do is I'll say m1 is equal to int of input, and I'll say enter the marks for subject 1. Okay, and I'm going to repeat it for m2 and m3. So m2 and m3 are marks for subject 2 and subject 3 respectively. So let me now see what is the overall percentage. So I'll say overall is equal to m1 plus m2 plus m3 divided by what? Divided by 3. This is going to be the average of m1, m2 and m3. And if I multiply this by 100, what I'm going to get is I'm going to get the overall percentage. So this is the overall percentage. Now what I'll do is I'll check whether the overall percentage is greater than 40. I'll say if overall is greater than or equal to 40, then you are pass. Then we'll say print you are pass. You have passed. Okay, you have passed the exam. Otherwise what I'll do is I'll simply say that if the overall percentage is not greater than equal to 40, then you have not passed. Okay, so I'll say print you have not passed. So let me print this. So I'll say you have not passed. But wait a second, what if the individual percentages which is m1, m2 and m3 are not greater than or equal to 33? What if this kind of case occurs? Then you are not passed. So what I'll do is I'll check m1 if m1 is greater than or equal to 33 and m2 is greater than equal to 33 and m3 is greater than or equal to 33. If this is the case, what I'll do is, and let me not multiply this by 100 because m1, m2 and m3 are out of 100, so we don't have to multiply it by 100. Okay, so m1 should be greater than equal to 33, m2 and m3 should also be greater than equal to 33, and all of these conditions should evaluate to true. If all of these conditions evaluate to true, then I'll say you are passed. Otherwise you are not passed. So you have passed the exam, otherwise you have failed the exam. Okay, so I can merge these two if statements, or let me make it simple. When I say simple, I mean it will be easier for you to write this. So we are checking for the overall greater than equal to 40%. If that's the case, what we are doing is we are checking the individual marks for M1, M2 and M3 for all these three subjects. So M1 can be maths, M2 can be physics, M3 can be chemistry, and we are simply taking the marks, individual marks of all the subjects. And if the individual marks are greater than equal to 33, you will pass the exam, otherwise you will not pass the exam. So let me run this program and see if it works. So what I'll do is I'll say 33 is my marks for subject 1, 33 is my marks for subject 2, and 33 is my marks for subject 3, and I have not passed the exam because overall percentage is not greater than equal to 40. Now what I'll do is I'll say my marks for subject 1 is 32, marks for subject 2 is 100, and marks for subject 3 is 99. And again, I have not passed the exam. And let me also give the reason here why I have not passed the exam. Due to one of these subjects. And here what I'll do is I'll say due to overall percentage. So your overall percentage is not greater than equal to 40, which is why you have not passed the exam. Let me run this program once again, and I'll say my marks for subject number 1 is 33, subject 2 is let us say 23, and subject 3 is 100. Okay, so if I run this, then you have not passed the exam due to one of the subjects. So you have not passed the exam due to subject 2. Okay, let me run this program once again and let me show you what if the person is passed. You have passed the exam. So this is how this works. Really very simple and straightforward. You took the marks of individual subjects from the user as an input, you calculated the overall percentage, and now after the overall percentage is calculated, you are simply comparing that overall percentage with 40. If it's greater than equal to 40, then you are saying, okay, let me check some other factors. If the percentage is greater than or equal to 40, you are not saying that the person is passed. You will check individual marks. You will check for the individual marks being greater than equal to 33. And once they are greater than or equal to 33, you are saying, okay, you have passed the exam. Otherwise, you have not passed the exam due to one of the subjects. So you are not passed in some of the subjects, okay, or one of the subjects. So this is how this program is working. I hope I explained you the problem number 2 in great detail. So now let's move on to problem number 3, and it'll be easier for you to solve if you have listened each and everything that I told you so far. So a spam comment is defined as a text containing the following words. So make a lot of money. If some text contains make a lot of money, Gmail might decide to mark that email as spam, or Outlook might define that email as spam. If somebody says buy now, so people use these kinds of terms to create fake emails, to create spam emails, and get some traffic on their website which doesn't add actual value. Or they might say subscribe this, or they might say click this. So we need to write a program to detect these spams. Now I'm not saying that the emails or the text which contain all these texts or these strings are actual spams, but some spam system might need to detect such kind of words or set of words and then run some other checks on those words. So we have to create a program which can actually detect all these things. So let's move on to Visual Studio Code and create a file 07 underscore, and let me call it pr03.py because this is our problem number 3. So what I'll do is I'll say spam words is equal to, and I'll simply create a list of all the words which I think is a spam. So let me start writing here. I'll say buy now, and then we have some other words as well. I'll take another one, or subscribe this, or it might be click this. Okay, so I'll take 3 of these. You can add even more and the program will work. Now what I'll do is I'll detect for all these words in a given string. So I'll say email is equal to, and I'll say this is a nice stock, you need to click this and buy this stock. Okay, so So this contains, click this. So what I'll do is I'll simply detect. What I'll do is I'll say if word in email spam is equal to true. Okay, and then I'll say print spam is spam. Now what is this word? You might ask me, what is this word? So we'll have to take each and every word out of these lists. So what I'll do is I'll simply say if buy now in email, then spam is true. If subscribe this in email, then the spam is true. And if click this is inside my email, then spam is true. Now if the number of words in this list are a lot, then it will be tedious for you to write this. And we'll learn in the loops chapter how we'll solve this problem. This is an actual problem. So we are finding it very difficult to type all these words individually. So we'll use for loops in the later chapters, but for now this will work. So let me run this program and you can say spam is true. But how do you know that spam is true for an incoming email? So let me modify this program, and instead of saying that this is the email, let me say email is equal to input enter your email. So you have the liberty of entering the email, and initially I'll say spam is false. Okay, so initially spam is false, and if any one of these if statements executes, my spam will become true. Okay, so let's run this program, and I'll click on run code, and it says enter your email. I'll say this is Bob, how are you Mick, and spam is false for sure. I'll say hey Mick, please click this, and this is spam. I might also say hey please buy now. Okay, I can say this item is great, hey please buy now. Spam is true because it contains buy now. Now I want to ask you a question, and you need to comment below and answer this question. So I need the two-way engagement. Okay, I don't want you to just listen, I want you to answer as well. So what if I type buy now and I press enter? Type in the comments below with the timestamp whether this will print spam is true or spam is false. I need everybody's comments. Come on, let the comments coming. Buy now, will it be true or will it be false? If you guessed it right, it'll be false. Why false? Because we are not taking this case sensitivity into account. We are not checking for each and every combination of lowercase and uppercase characters. So how do we solve this? We can solve this by simply making both of these as lowercase. So when we are iterating this spam words, we can make each and every word lowercase, and we can simply make an email as lowercase. So this will be lowercase, this is indeed lowercase, so we can simply make an email lowercase. So what I'll do is I'll say dot lower. Okay, so this will make it lowercase. And now if I type let me run this program once again, and now if I type buy now, you can say spam is true because I have converted my input email into lowercase thing. So this is how you solve real world problems. You will not always get the solution on the internet or get somebody to tell you the solution. You'll have to use your brain and figure out such kind of solutions. Okay, so I hope this was helpful. Let's move on to the next problem, which is write a program to find whether a given username contains less than 10 characters or not. And this is going to be very easy, so I want you to solve this problem. What you'll do is you'll simply say username is equal to something, and then what you'll do is you'll run the len, which is a len function, to find out the length of the string. It will give you the number of characters in a string and just compare it with 10. If it is greater than 10, then you can tell that it's greater than 10. Otherwise you can simply say it's not greater than 10. So this is how this works. Let's move on to the next question now. Write a program which finds out whether a given name is present in a list or not. And if you want to find out whether a given name is present in a list or not, all you need to do is use the in operator. So let me show you how this works. So this is problem number 5. So I'll simply say 08 underscore pr04.py, and I'll say word is equal to Harry. And I have already shown you this here, but once again, let me solve this problem for you very quickly. I want to show you how quickly I'll solve this problem. Write a program which finds out whether a given name is present in a list or not. So let me say name is equal to Harry, and I'll say names is equal to, let me have some list of names, and let me say Meena. Okay, so let me run this, and so what I'll do is I'll say if name in names, I'll say print what? Print name is present. Else what will happen? Else print what? Else print name is not present. So I'll simply fix this, and let me run this program for you. So name is not present. Why is name not present? Because this doesn't take case sensitivity into account. I have told you once, I've told you twice, and I'll keep telling you many times. If you make it capital HARRY, this is going to tell you that the name is present. Otherwise, it will not tell you that the name is present if you change case sensitivity of your word or of any word in the list. So if I run this program, Harry is not present, otherwise Harry will be present, okay? Or if you say something like this, Shubhi, and if you run this program, you'll say name is not present because Shubhi is not present here, right? So this is how this works, okay? So now what I'll do is, I'll write a program which finds out whether a name is present in a list or not. We have done this. You can write a program for calculating grade of a student from his marks from the following scheme. So 90 to 100 is EX grade, 80 to 90 is A grade, and 70 to 80 is B grade, 60 to 70 is C grade, 50 to 60 is D grade, and less than 50 is F grade. So you can use this scheme and you can simply grade a program. So all you need to do in this question is take the number of marks into account and print the corresponding grade. So it will be a very, very simple if else ladder. I don't want to solve it for you, so you can go ahead and solve this, okay? Now let's come to question number 7. Write a program to find out whether a given post is talking about Harry or not. So you have to detect Harry from a given string. So you can simply convert Harry to lowercase, convert the string to lowercase, and then compare. Do not compare capital HARRY to the given string. Convert the string to lowercase, use Harry as lowercase, and then compare, so that you are sure that this particular thing is lowercase. Harry you have entered is lowercase, so both of the operands are lowercase. Now you can use the in operator and you can find out whether small case Harry or lowercase Harry is present inside the given string or not. So if I were to solve this problem very, very quickly, what I'll do is I'll simply say 09 underscore, and I think this is problem number, I forgot, it's problem number 7. So I'll press F2 to rename, and it's problem number 7, and .py, and then I'll say text is equal to, not test, text is equal to input, and I'll say enter your text. And once my text is entered, what I'll do is I'll simply print Harry in text.lower. So this will be true if Harry is present. Or let me make this program a bit fancier. What I'll do is I'll say if Harry in text.lower, then you print something, then you are printing something. What are you printing? You'll say yes, Harry is present. Else what you'll do? Else you'll say Harry is not present. Okay, so you'll say Harry is not present. So let me say no, Harry is not present. Okay, so let's run this program now and enter your text. If I enter my text as Harry, I'll say yes, Harry is present. Otherwise, if I run this program once again, if I say Rohan is a good boy, Harry is not present. Rohan is a good boy and a friend of Harry. Okay, so this post is now talking about Harry. Let me make this a bit more fancier. I'll say Harry is a good boy. I have changed some of the characters to uppercase, and you'll see that even this works, because print yes, Harry is present will be printed only when Harry is compared to the lowercase version of your text. So I'm comparing Harry with lowercase version of your text. I hope that I am able to explain you what I wanted. So this was about chapter number 6 practice set. I hope you enjoyed it. We'll now move on to chapter number 7, which is really very exciting. We learn about loops. I hope this was helpful. Let's move on to chapter 7 and learn about loops now. Let's now move towards chapter number 7, which is really a very exciting and important topic in Python, which is loops. Let's now talk about loops. What are loops? You might have done certain tasks in your daily life where you are repeating something. For example, when you're combing your hair, what you do is you repeatedly take the comb and you use that comb on your hair more than once. Let me give you another example. In my notes I've written sometimes we want to repeat a set of statements in our program. For instance, if I want to print 1 to 10,000 or 1000 in Python, you might not be able to do that. What I mean by that is you might not be able to type print 1, print 2, print 3 all the way till 1 million or 1 billion for that matter. That will take you very long to type using your keyboard. And that's really not efficient. Is there a way to make computer type more than say 10,000 numbers or 20,000 numbers? Can't I program my computer in such a manner that it repeatedly prints these numbers on its own? Let me tell you what I mean by this. What I'll do is I'll open my Visual Studio Code on this folder and we'll create a file here. And I'll say 01 underscore loops.py. Let's forget about how loops work. I'm going to show you something. I'll say a is equal to 0 and I'll simply write something. Do not worry about this. Do not worry about what this while is or what these brackets are about. I'll simply print something inside this while. I repeat, you don't have to worry about what while is and how all this works. But have a look. You'll see that I have printed the numbers starting from 0 all the way till 99. And all of these numbers have been printed automatically. I didn't type print 1, print 2, print 3, print 4 all the way till 99. So something is working to print from 0 to 99. And it's loop. I'll tell you how loops work. So loops make it easy for a programmer to tell the computer which set of instructions to repeat. So if you want to repeat a certain set of instructions, you can always do that. And you can simply use loops for that. So there are different types of loops in Python. Primarily, there are two types of loops in Python, while loops and for loops. So while loops and for loops have some sort of differences between them. So while loops work in a certain way, for loops work in a different way, but they both are really very similar and we'll look into that. So let's look into these loops one by one. Let's start with the while loop, and the syntax of while loop looks like this. So I've written a while loop over here and this is while loop. And how while loop works is you start from a value, you keep on incrementing that value and you keep on doing something until this condition is true. Let me explain you once again. So in my notes, I have written the body of while loop. So what I'm saying is while the condition is true, what I'm doing is I am executing the body of the loop and I'll keep on doing that until my condition becomes false. And if my condition is true always, then this while loop is going to work always, and that's not a good idea. So what do? We keep on updating something so that this condition eventually becomes false. So what happens is you say while a is greater than say 10 or 20. So if a is greater than 10, then only this body of the loop will execute. Otherwise, it will not execute. So you can see the block keeps executing until the condition is true. So until the condition is true, the block keeps executing. In while loops, the condition is checked first. So first you check the condition. If it evaluates to true, the body of the loop is executed. Otherwise, it is not executed. And now that we are talking about while loop, let's write a while loop from scratch once again. So I'm going to write another program here. I'm going to say while.py. And what I'll do is I'll simply use I equals to 0 and I'll say while I is less than say 20, and I'll say I plus equals to 1. So I'm updating I and I'm printing I inside this loop. So the value of I when I'm at line number 1 is 1, and the value of I is definitely less than 20. So since the value of I is less than 20, this body of the loop will execute. and this print I will get executed. Since this print I is executed, this I plus equals to 1 will also be executed because we have entered the body of the loop. When the condition is true, we enter the body of the loop and everything inside the body will be executed. So print I is executed, I plus equals to 1 is executed, and the value of I has now been updated to 1. So it was 0 before, now it is 1. 1 is still less than 20. So once again, 1 is printed, I plus equals to 1, I is now 2. Then once again, 2 is printed, I plus equals to 1, I is now 3. Once again, I is 4, then it's printed, and this keeps on happening, and eventually I becomes 20. And when I becomes 20, this condition is no longer true now. This condition is no longer true because I is now 20 and 20 is not less than 20. And 21 is also not less than 20. So the value of I is 20 and this condition evaluates to false, which results into exiting of the while loop. So we exit the while loop because the condition of the while loop is no longer true now. So this is how while loop works. So if I come back to my notes, I've written the same thing. If the loop is entered, the process of condition check and execution is continued until the condition becomes false. So eventually the condition becomes false and we exit the while loop. I hope I made it clear for you people. Let's now solve this quiz. We have to print 1 to 50 using while loop, and this is going to be a bit tricky. And why do I say that it's going to be a bit tricky? Because I starting from 0, I'll have to start it from 1. Okay, if I start it from 1, I'll have to stop it when the value of I is 6. And why did I write 6? Why did I not write 5? Because when the value of I is 5, I still want it to print 5. So I want the condition to evaluate to true when the value of I is 5. So this is something you need to keep in mind. When the value of I is 5, 5 less than 6 is going to evaluate to true. But if I make this 6 as 5, 5 less than 5 will not be evaluated, and 1 to 4 will only be printed on the screen. But since I want 1 to 5 to be printed, I'll write 6. If I write here 5, I'll have to say I is less than equal to 5. So if I say I is less than equal to 5, then definitely 1 to 5 will be printed on the screen, as you can see. So this is how all this works. I hope I'm able to explain you how all this is working. Now let's come back to the nodes and see an example. So I is equal to 0, while I is less than 5, print Harry, I is equal to I plus 1. You can even say I plus equals to 1. That's exactly the same thing. So this will print Harry 5 times. Or if you want to do something else, you don't have to print every time. You can increment a value, you can ping a server. There are n number of things you can do inside while loop, and it can be a bunch of statements. You don't have to execute a single line. You can even print 20 lines. It depends on you what you want to do. But every time you are doing something, that something will be executed again and again until the condition evaluates to false. So I hope I'm making sense here, and I hope you are getting the point. So I've written a note here. If the condition never becomes false, the loop keeps getting executed. And this is a problem, and this is called an infinite loop, and we don't want to see infinite loops ideally. Okay, so if you are making a mistake and that is resulting into an infinite loop, then that's a mistake. But sometimes we use infinite loops intentionally. And when do we use infinite loops intentionally? When we are developing games, we need a game loop, and that game loop needs to be ran repeatedly. And such kind of while loops are not problematic because we have intentionally done that. But otherwise, if you are making a mistake and your loop is repeatedly executing, then definitely it's a mistake and you should avoid it. I'll show you an example of infinite while loop. Let me create another program for you and I'll show you an example of infinite while loop. So I'll say 03 underscore infinite underscore while dot py. Okay, so what I'll do here is I'll simply give you an example of infinite while loop. So I'll copy this code, and instead of making it I is less than equal to 5, I'll not update the condition here. So I is always less than equal to 5. I is always 1 and I is always less than equal to 5. And if I run this program, 1 will be printed repeatedly and it will keep on printing because this condition will never ever evaluate to false. Let me show this to you. I don't want to select something before running the program. So 1 is repeatedly being printed. It's being printed. It's being printed. The program has not yet exited, as you can see. So it's printing 1, 1, 1, 1, 1, 1, and I'll have to cancel this program. I don't want my computer to crash. So what I'll do is I'll simply save it and let me open another terminal, and this is still running. Let me delete this. I'll have to delete this because I don't want my computer to crash for any reason because I'm recording a video and I don't want that video to get wasted. So another quiz says write a program to print the content of a list using Python. So we have a list and we want to print the content of a list using while loop. How do you do that? So I'll show you. You can use indexing and let me create a program 04 underscore while print and I'll say list.py. Okay, I'll say a is equal to, I'll enter some numbers and I'll enter banana. And what I'll do is I'll say while I is less than length of a, so a will have some length and I have not initialized I, I'll initialize I with 0. I'll say I is equal to 0 and I'll print what? I'll print AI. What is AI? AI, no, AI is not artificial intelligence here. AI is the value of the list at index I. Okay, so this list at index I. Okay, so we have I is equal to 0. I'll have to increment I plus equals to 1. And is this program okay? Yes, it is. It looks fine because I will start from 0 and it will go all the way till length of I minus 1. So the length of I in this case is 6 and I wanted to go from 0 to 5 because at index 5 we have banana. And this is doing the same thing. So the value of I will start from 0 and eventually it will become 5 and 5 will be less than 6. But when it becomes 6, the condition will evaluate to false and it will no longer run. So let me run this and you'll see 1, 2, 3, 4, 5 in banana. What if I make this 2 as apple? Let me make it apple and show you that it is printed. So this is how you print content of a list using Python. Okay. Let's now look into for loops. And for loops is another type of loop in Python. For loop is used to iterate through a sequence like a list, tuple, or string. You can even iterate strings. So what I'll do is I'll simply write a list here. But before that, let me show you an example of for loop. 05 underscore for.py. I'll say for I in range and I'll say 34 and I'll say print I. What is this range? We never heard of this range function. So range function will simply give you numbers from 0 to the number which you have entered here. Let us call it n. So it will print numbers from 0 to n minus 1. So if I want numbers from 0 to n minus 1, I'll simply say for I in range and I'll say 34. This should give me 0 to 33 in the console and it has given me the same. What if I wanted to print 1 to 33? I'll simply enter that number or let us say 10 to 33. I'll simply enter a number here. I'll say I want to start from 10 and I want to go all the way till 33. The number 34 will not be printed. If I want 34 to be printed, I'll have to write 35 here. Okay. So it's from this number till this number minus 1. So 10 will be printed. I'll show you. 10 is printed. And 11, 12, 13, 14, it will go all the way till 33, not 34. So you need to remember this somehow, that range function will include the first value, but it will exclude the second value. So it will go from the first value to second value minus 1. Okay, so this is how range function works. Let's close these terminals and come back to the notes. What is this for loops? Can I iterate a list using for loop? I'll simply write 06 underscore for iterate.py and I'll use the same list. I'm really very lazy, believe me, and I'm going to do the same thing. I'm going to use the same list. Okay, so what I'll do is instead of while, I'll write a for here. I'll say for I in range and I want to go from 0 to len of a minus 1 and this should give me the desired output 1 apple 3 4 banana. But there's a better way to do this. I don't want to do this. I don't want to use range function. I can simply iterate this list. I can simply say for item in A print item. Yes, and it will print all the items of this list. I don't have to run the len function. I don't have to run the range function. I don't have to write so much of code to increment I every time. No, I don't want to do that. I will simply run this code and this will give me the same output as was given by line number 3, 4 and 5. So I hope I'm making sense here and I hope you are learning for loops here. Let's come back to notes and let's see what I have written in the notes for you. So a for loop is used to iterate through a sequence like list, tuple, and string. So you can even iterate a tuple, you can iterate a string, and the syntax of a for loop looks like this. I've written the syntax for you. So in this list L, you can see that we have 1, 7, and 8. And once you have 1, 7, and 8, you can print 1, 7, and 8 on the screen using a for loop. So I've written range function for you in the notes. The range function in Python is used to generate a sequence of numbers. You can generate the sequence of numbers from 0 to that number minus 1. We have already talked about range. And let me tell you something. I'm going to give all the programs in the description. So you will get a bundle of download. It can be a zip, or I'll simply zip it and I'll send it to you in the description. You can check out the description, and in the description you will get some link, and all the programs including all these PDFs will be there. So just in case if you're wondering, the range function is Python is used to generate a sequence of numbers. We can also specify the start, stop, and step size. So the third argument of range function is also there, which is step size, and step size is usually not used with range, but again, if you want to use it, you can use it. Okay, so let me demonstrate this step size for you. So if instead of let me come back to this. If instead of saying 1034, I type 1034.2 and I run this program, you can see that every second number is being printed. What does it mean? It means that first 10 will be printed, then one number will be skipped. What if I say 3? Then every third number will be printed. Okay, so instead of 12 you will see 13, so you'll see 10, 13, 16. So this is how the step size works. Usually it's not used, but again, sometimes when you use it, it really comes very handy. Let's come back to the notes, and I have demonstrated the range function here. So all these notes will be very useful for you when you are revising something, because we are just starting here. We are remembering each and everything when we are starting from chapter number 1, and there will be a time after say 6-7 months when you'll think about all these things and you'll forget it, and you'll think that, oh yes, I know about range, but I don't remember the syntax anymore. These notes will come in handy at that time. So please take a printout of all these notes and keep it in your desk or somewhere. Keep it safe with you. It should be very accessible to you. You should be able to refer it anytime. Now there is another concept that I want to talk about, and it's really very important because it's asked in interview questions. For loop with else. The first question that an interviewer will ask you is, can you use for loops with else? You'll say, no, we cannot use for loops with else, and we use it with if you don't know Python. You will simply say this and you'll fail that test. But what if I tell you that you can use an optional else with for loops? So an optional else can be used with a for loop if the code is to be executed when the loop exhausts. Okay, so let me demonstrate this to you here. So if my list is 178 and I am iterating this list and I am printing all the items in this list, I want to print done when the loop exhausts, which means that when all the items inside this loop have finished printing. Okay, so before this I want to demonstrate break and continue. So we have a break statement and we have a continue statement. Let me talk about break and continue statement before I talk about for loop with else. Okay, so let me come back to my VS Code, and I'll simply say break continue.py. Okay, so what I'll do is I'll simply say I'll simply create a list. First of all, I'll say 1 2 3 4 5, and I think I have entered these single quotes which are creating problem. So what I'll do is I'll say for item in A, print A. I'm printing A, I'm iterating A, and I'm printing A. And now what I'm doing is sorry, I'm not printing A. I need to print item. I need to print all the items in A. And you can simply say that when I'm running this code, 1 to 5 will be printed, and no surprises there. Okay, so what I'll do now is I'll simply say if item is equal to 3, if at all you encounter a 3, simply break this loop. And when I say break this loop, you are not going to go to the next iteration, you are going to exit this loop. Okay, so let me print another statement here. I'll say print we have finished this loop. Okay, so let me run this program for you. So 1 is printed, then 2 is printed, then 3 is printed, and then this condition evaluates to true. So break is executed. So once we say break inside a for loop, we simply say that abandon this for loop. We are not going to execute this for loop, and we exit that for loop immediately. So after 3 is printed on the screen, this for loop will be exited and you'll see we have finished this loop printed on the screen. So that's how it works. Okay. So we have finished this loop will be printed. What if I say if item equals to 4? You'll simply run this code and you'll see that we have finished this loop has been printed after 4. Now we have another statement called continue statement. What if in place of break I say continue? Now break and continue are different. I'll tell you why they are different and how they are different. When you say break, you are saying I'm not going to look at this for loop ever again. And when you say continue, you are saying that I am not going to look at this particular iteration ever again. There's a difference. You are not going to execute the loop anymore and you are not going to execute an iteration, just a single iteration. So when 1 is printed, you are saying, okay, if is not true, so you don't care. 2 is printed, nothing happens. 3 is printed, nothing happens. 4 is printed, this condition evaluates to true, continue is executed. So when continue is executed, you are simply saying, do not execute anything after this. So let me change this program a bit and show you. I'll simply say print done this iteration for, and I'll print item. So let me show you what happens when we don't have this continue statement. When this for loop doesn't have any a for continue or break. When I do this, the item is printed, and then done this iteration for that item is printed. Item is printed, done this iteration for that item is printed, and this keeps on happening. What if I say if item equals to 4 break, what happens? Let me show you break once again. If I say break after iteration number 3, for iteration number 4, print item will be executed. You can see 4 is printed here. Then I will encounter this item equals to 4 break. And what happens is this is going to forget this loop now and it will directly jump here. It will print we have finished this loop. But if I say continue, or let me change it to 3. So I want to give you a set of different examples so that you can understand. So this print item is printed, 1 will be printed, done this iteration for item will be printed, which means this particular thing is printed. And the same happens for number 2, same happens for number 3. But for number 3, when it happens, print item is printed without any hassles. Then item is equal to 3. Yes, it is equal to 3. Break is encountered. And this means that we are not going to look at this loop anymore. We are directly going to jump outside of this loop. And outside of this loop, we have this particular line. So this is executed and you can see we have finished this loop is printed on the screen. So now let's change this to continue. I want to continue. And if I say continue, I'm simply saying that I want to stop right here and continue the next iteration. Let me show you what it means. When I run this code, it will run for 1, it will run for 2, it will run for 3 as well. Let me run it once again. It will run for 1, it will run for 2, it will run for 3. But while it is running for 3, this is printed. And when the control comes here, what Python says is we have a continue here. We cannot go below this line. Let's continue the next iteration for 4. So it will continue for 4 without printing the lines after continue. So when you say continue, you're simply saying that stop this particular iteration right here and execute the next iteration. I hope I'm making sense here. So it will run normally for the iteration number 4. It will run normally for iteration number 5. And even if we have iteration number 6, 7, 8, 9, 10 will keep on running without any hassles because this continue is encountered only when the value of item is equal to 3. I hope I'm able to explain break and continue. Now let's talk about for loop with else. Okay. So I'll create another program here. I'll say for else.py. And what I'll do is I'll copy all these lines here. And I'll simply say else. And I'll say print. And we'll say we are inside else. Okay. And let me run this program for you. And you can see we are inside else is printed. So whenever this loop is completed successfully, then this we are inside this else is printed. What if I have a break here? I'll show you something. If I have a break here, you can see that we are inside else is not printed. So else is printed. I mean the lines inside the else are executed only when the loop is completed or finished successfully. So what it means is, let me come back to the notes and show you. Only if the for loop runs for item number 1, 7 and 8, then only you will see done. Done will be printed when the loop normally exhausts. Done will not be printed if you are breaking the loop in between. So if you are breaking the loop in between, else will not be executed. And if you're not breaking the loop in between, else will be executed. So all the iterations need to be executed and the loop should exhaust normally. And if the loop exhausts normally, you will see the code inside else being printed or executed. Okay, so this is how for loop with else works. Let's now talk about break statement. We have already talked about break statement, but let me tell you once again. Break is used to come out of the loop when encountered. So whenever you encounter a break statement, it simply says come out of the loop and never ever look at this loop again. So it will instruct the program to exit the loop immediately now. So right away the loop will be executed, and this particular loop will only print 0, 1, 2 and 3, because at 3 this will see a break, and break means that we are not going to deal with this loop anymore. Okay, coming back to the continue statement. Continue statement is used when you want to stop the current iteration of the loop and continue with the next iteration. It will instruct the program to skip this particular iteration. And when I say iteration, let me tell you what iteration means. When I'm iterating this loop, when I'm traversing this, when I'm iterating this list, when I'm traversing this list, number 1 is an iteration, number 7 is an iteration, 8 is an iteration. When I was iterating this particular list, let me show you. 1 is an iteration, then another iteration will be for apple, another will be for 3, then for 4, 5, and then for banana. So this loop will have iterations. The number of time this loop runs means that we are running different iterations. Okay, coming back to the notes, I will say this is printed when the loop exhausts. When the loop exhausts, this is printed. Coming back to the break statement, you know how break works and you know how continue works now. Okay, so here is an example of continue statement. I have already told you about continue, so you can look into this example, and we'll look into more examples and practice it. But let's now talk about pass statement. What is pass? So pass is a null statement in Python. What is this null statement? It will instruct the Python to do nothing. What if you want to do something inside loop and you want to do it later? You just want to write something and you don't want it to throw an error. So I'll show you something. Let us write this program 09 underscore pass.py. Oops. So I need to rename this f2 to rename .py. Okay, and what I'll do is I'll simply say that for I in a. Okay, or let me say range. I don't want to create a here, and I have no idea what I want to do here. What I'm saying to myself is I'll write this loop, I'll finish this loop later, but let me print something. Or rather I'll say let me do something. You can see that we have an error, and this error says expected indented block. So this is throwing an error. It's simply saying that what do you want to do here? Why do we have a colon here? Why do we have this for loop here when you are not writing inside this loop? So I can simply say pass, and this will not throw an error, and I can execute this program without any hassles now. If I don't have this pass, this will simply throw an error. You can see this red colored file name, and this simply says indentation error. So you need to write this pass to get rid of this error. Okay, so we now have an error-free program. So pass is just a statement without which a program with an empty loop will throw an error. So if you have an empty loop, it will throw an error, but if you write pass, it will not throw an error. Pass can also be used inside empty functions, empty classes, but we'll deal with classes and functions later. So this was about loops. We have finished our chapter number 7. I hope you enjoyed. Let's now move on to chapter 7 practice set and practice some questions. So let's now talk about chapter 7 practice set, and we are going to start with these questions. So the question number 1 says write a program to print multiplication table of a given number using for loops, and this is really very straightforward. So 10 underscore pr01 dot py, my problem number 1. Okay, and what I'll do is I'll say I is equal to 10, and I need to use for loops. Okay, so I'll say for I in range 10, and I'll say print and then I'll print something like this, and I'm going to use f strings. So in f strings you simply have an f here, and you can use variables in curly braces like this. So I'll say I plus 1, because remember that I is starting from 0, so I need to write I plus 1. So it will start from I plus 1 and it will end at 9 plus 1, which is 10. So I'll say I plus 1 multiply by or rather I should say something like this. I should use this num here. So I'll say num and multiply by I plus 1 is equal to what? I'll say num star I plus 1. Okay, so this is how we write a program which prints multiplication table of 10. If you want to print a multiplication table of 5 or say any number for that matter, all you need to do is just do something like this. Enter the number, and all you need to do is say \n and you run the code. And I think I have made some mistake here. What's the mistake? I don't think I have any mistake. So I just have to say 8 and we have the table of 8 here. You can even say 15 and you will have the table of 15 here. Now many students, they don't remember the table of 8, 19, 18, 17, 13, 14, 15. So you can use this program. Okay, so let me come back to the next question and write a program to read all the person names stored in a list L1 which starts with S. So we have to greet the people. We have to say good morning Soham, good morning Sachin. So what I'll do is I'll create a program 11 underscore PR02. So this is going to be the next program that we are going to write. So I'll say Shivam and then we'll say Soham, and I'm taking an arbitrary list here. We have something else given in the question, but let me take an arbitrary list here. So I'll say Shivam, Soham, Harry, and let me say Deepika. Okay, so what I'll do is I'll say for item in L1 if L1 dot starts with if item dot starts with, sorry. So I want to do it for every item in L1. So if item dot starts with, if it starts with S, then what I want to do is I want to print that item. Otherwise I don't want to print that item. So I'll say greet item. Sorry, good morning. So you don't say greet Harry, greet Shivam. You say good morning Harry, good morning Soham, good morning Shivam. So we'll simply say print good morning and then item, and if I run, you'll see good morning item. Oops, I made a mistake. I need to write f string here. Now if I run this, you'll see good morning Shivam. Why didn't we see good morning Soham? Why didn't we see good morning? Say if I add something else, let me say Sachin. Why didn't we see good morning Sachin here? We just saw good morning Shivam here. The reason is that Shivam starts with this small case s and Soham starts with this capital S. So if you write capital S, you will have Soham and Sachin, and Shivam will not be there. So if I run this code, you'll see good morning Soham, good morning Sachin, and that's all. That's how it works. Now attempt problem number 1 using while loops, and this is really very straightforward. Converting a program which is written in for loop into while loop is very easy and should be straightforward for you at this point. So all you need to do is simply start using while loops and simply say while something, and you can use list indices or you can use anything you want. I mean, there are a lot of things that can be used to work with while loops, or a program written in while loop can be converted to a program which is written in for loops. Okay, so this is how this works. Okay, write a program to find whether a given number is prime or not, and this is very easy. So you'll have to check whether this number is divided by itself and 1. So there should not be any other number that divides this number. Let's write this program, and this is going to be interesting, and this is asked very frequently in interviews. So I'll say PR04 if I'm not wrong. Is it problem number 4? Yes, it is problem number 4. So what I'll do is I'll say num is equal to, let us say 6, and I want to check whether this is a prime number or not. So what I'll do is I'll say for I in range, and I'll say 6, and I in range 6, I in range 6, and I want to 5 I want to find a number which divides this number. Okay, so what I'll do is I'll start with 2. I'll start from 2 because 1 will definitely divide this number. And what I'll do is I'll say if I percent num, or rather I should say num percent I is equal to 0. And what does it mean when I say num percent I equal to 0? I'm saying when I divides this number, the remainder is 0. If this happens, this is not a prime number. I'll say print not prime, and we are going to break out of this loop. Okay, else we'll say print, and we'll say this is prime, and we'll not use else with this if, we'll use else with this for. And I should write num here, not 6. So I want to check whether I divides the number or not, and I want to do this starting from 2 to num. Now we can do this till root num as well, but I'll not go into those details. We'll simply make this program run and we'll move ahead. So 6 is not prime, we all know that. 13 is prime. Let's see if this particular program declares 13 as a prime number. Yes, this is prime. Let's see if declares 2 as a prime number. I'm just curious if it is able to detect 2 as prime. Is it able to detect 3 as prime? Let's see. And yes, this is prime, it works. So if I say 9, it should not be prime. So not prime. So how this program works, let's talk about it. For I in range 2 to num, I'm starting from 2 and I'm going all the way till num minus 1. And I'm checking whether there exists a number which can divide num, which can divide this number. Is there any number starting from 2 to 9 which can divide 9? Okay, so we'll check 2, we'll check 3, 4, 5, 6, 7 and 8. We'll not check 9 because the 9 will for sure divide. So if this loop is able to run all the way till the end, we can declare this number as prime because we are not able to find a number which can divide num. Okay, so I hope that makes sense. So else will only execute when this for loop has ran all the way till the end. And if this for loop was broken by this break statement, this means that this is not a prime number and this else will not run. Okay, I hope that makes sense. I hope you understood why this program works. Okay, moving to the next question. Write a program to find the sum of first and natural numbers using while loop. And this is very easy. Let me attempt it for you. So pr05.py, and we'll say while I is less than n, and let us say we want to add, we'll say sum plus equals to I. Okay, let me read the question once again. It says write a program to find the sum of first and natural numbers using while loop. So I'll start from 1 because natural number starts from 1. So I'll start from 1, I'll keep on adding n, and I'll include n. So while I is less than equal to n, and we'll add I to sum, we'll initialize sum to 0, and we'll also increment I because we want to add the numbers. So at the end, what I'll do is I'll simply print the sum of first n, and let me use f strings here. So if I write an f here, and if I use this curly braces, I can actually print this as a variable. Okay, so I'll simply say the sum of first n natural numbers is, and I'll say sum. Okay, so this is how this works. So we have n, we have f. What is n? We don't have n initialized. So let's find the sum of first 3 natural numbers. Let me run this code. The sum of first 3 natural numbers is 6. 1 plus 2 plus 3 is 6. Now, if I make it 4, I should get 10 because 6 plus 4 is 10. Let's see if it prints 10. Yes, it prints 10. So this is how we use while loops to print sum of first and natural numbers. Okay, so this is how this is going to work. Okay, write a program to print the following star pattern, and this star pattern is very easy.
All right, so let me be really honest with you, and I'm going to explain how to print star patterns in a really very easy manner. So whenever some star patterns comes in front of me, what I usually do is I simply try to analyze it and I try to relate that star pattern to the mathematics of it.
So let me explain it to you what it means. So let us say this is a star pattern for n is equal to, say n is equal to 4. So for n is equal to 4, there will be 4 rows in this star pattern. And this is also called as a pyramid pattern. So if I draw this pattern, you'll see this pattern and you might think, how do I print this pattern? Oh yes, I know that you can manually print all these stars and spaces, but whenever you look at this pattern, the first thing that should come to your mind is that I have to print certain number of spaces, then a star, and then certain number of spaces. So that star is also variable. Here we have 1 star, then here we have 2 stars, sorry, 3 stars, then 5, and then 7. So what you can do is you can create a grid around this. Let me show you how. So what I'll do is I'll start creating a straight line, something like this, okay? And I just want to explain this to you in a very, very easy manner. So let me draw all these grid lines very carefully. So let us say we have rows and we have columns, okay? When I look at the star pattern now, I can see that I have 3 spaces, 1, 2 and 3, 1 star, and then 3 spaces. Let us consider this as well. So I think I have made some mistake. There should be 1 more star here. And once again 3 spaces, then 2 spaces, then 3 stars, and then 2 spaces. I'm talking about this row. I already talked about this row. Now I'll talk about this row. Here we have 1 space and we have 5 stars and we have 1 space. Then we have 0 spaces, we have 7 stars, and then we have 0 spaces. So did you see the symmetry here? Are you able to now see how easy this problem is? So all you need to do is you need to create a few for loops and you'll be able to solve this problem. So now what I'll do is I'll simply try to start my outer for loop. So what I'll do is, let me change the color. I'll simply say for, I'll say I should go from, I'll start I from 1, I'll go all the way till n minus 1. So when I'm writing n minus 1, this is not Python for loop. I'm simply saying go from 1 and include n minus 1 as well. But if you use range function in Python, you'll have to write n to go from 1 to n minus 1. So this is my outer for loop. Now what I'll do is outside this for loop, the I will go from 1 to n minus 1, the value of I. It will be 1 for n is equal to 4. It will be 1, 2 and 3. So we need to run I from 1, 2 and 3. So this is the value of I till which I need to go. Now if you look at this pattern carefully, I need to start another for loop. So what I'll do is I'll simply say for j goes from, how many spaces should I print? I need to print n minus I spaces. I'll simply say I'll go from 0 to n minus I, and I need to I minus 1 rather, because I need to print n minus I spaces, and this will print n minus I spaces. And that's what I want. N is 4, I is 1, so 3 spaces. Then in the next iteration, n will be 4, I will be 2, then 2 spaces, and I'll be able to print the spaces as per my pattern. So n minus I spaces. Then how many stars? I'll start from 1 and go all the way till 7 for n is equal to 4. So what I'll do is I have the value of I as 1 here, the value of I as 2 here, 3 and 4. So for value of 1 I need to generate 1. For value of 2 I need to generate 3. For value of 3 I need to generate 5. So how do I do that? 2 multiplied by I minus 1. So I'll simply say for k goes from 0 to, and simply what I'll do is I want this particular loop to go from 0 to 2 into I minus 1. So I'll say 2 into I minus 1 and another minus 1, because I need to print 2 into I minus 1 spaces. And while I'll code it in Python, you will understand. Please don't get confused with an extra minus 1 here. 2 star I minus 1 spaces. So k will go from 0 to 2 I minus 2, but I'm printing these many spaces, these many stars, sorry. So I made a mistake here. I need to print these many stars, not spaces. So I'll simply grab my pen and write stars here. And then once again, I'll repeat this particular loop here. So I'll simply write once again, for L goes from 0 to n minus I minus 1, and what I'll do is I'll print n minus I spaces once again. So I'll say n minus I spaces. So we have this blueprint, we'll use this picture and we'll now generate the code. And generating the code is really very simple once you understand how the dynamics of these things are working. But I want to tell you another star pattern that we have in the question. And for that star pattern, I'm going to explain you how things are working. So that star pattern is also very important. Then we'll go to the computer screen and we'll simply try to, find out how we can use that logic to print the star pattern that we want. So this is a star pattern, and this is for n is equal to 3, and this is question number 9 in the practice set. And what I'll do is I'll simply mark I is equal to 0, I is equal to 1, I is my row, and I is equal to 2. And then j is equal to 0, j is equal to 1, and j is equal to 2. So these are the things that I'm marking here. Now what I'll do is I'll simply write some logic. So for 0, 0, I get a star. For 0, 1, I get a star. For 0, 2, I should print a star. Then once again, for 1, 0, I need to print a star. Then for 1, 2, I need to print a star. And then for 2, 0, I need to print a star. For 2, 1, I need to print a star. And for 2, 2, I need to print a star. Do you see any relation between I and j such that we have stars only when these values are printed? So what we'll do is we'll simply say that when I is 0 and j is 0, we print star. When I is 0, j is 1, we print a star. When I is 0, j is 2, we print a star. You can clearly see that at the boundaries, so if I try to draw a boundary, at the boundaries we are printing the star. And how do we define a boundary in mathematical terms? Either I is 0 or I is n minus 1, or j is 0 or j is n minus 1. So whenever this condition meets, we are in the boundary, and otherwise, other than these values, we are not in the boundary. So this is something that you can use. So either I is 0 or j is 0, or I is n minus 1 and j is n minus 1. So you'll end up in the boundary and you can print the star for these conditions. And this is how you can solve the star pattern in problem number 9. Okay, so I hope that this star pattern thing is very clear. So all you need to do is draw a grid, mark the values of I and j's, and simply build logic on top of that. Try to come up with something which can print your desired star pattern. I hope I explained this to you pretty well. And now what we can do is we can simply go back to the VS Code, and after going back to the VS Code, we can simply look into these problems and solve these problems by writing the logic that we have generated. So we'll first use this particular logic that we generated, and then we'll use this particular logic that we generated to print the desired star patterns. Let's go back to a Python and start writing these programs. So I'll come back to this problem and start solving this problem, which is problem number 7. And all I'll do is I'll simply create a program for teen underscore pr07. So pr07.py, and the question is straightforward now. I'll simply say n is equal to int input, and I'll simply say enter a number, and then I'll simply close this and I'll simply start my for loop. So I'm using GitHub Copilot, which is giving me automatic suggestions. I'll deactivate this because maybe you are not using GitHub Copilot and you might think that how I'm writing all these codes. So I'll start my loop from 1 to n minus 1. So I want to start my loop from 1 to n minus 1. And what I want to do is, as per the logic, I'll say for j in range, I want my j to go from, or rather I want to print n minus I spaces is something that I should say. So if I start printing n minus I spaces, I can do this. So I'll simply print a space and I'll say end is equal to blank. And why am I writing this end is equal to blank? Because I don't want a new line to be printed after my print statement. I'm copying this for loop 3 times. So for the first for loop, I'm printing n minus I spaces. For the last for loop, I'm printing n minus I spaces. And between that, what I'll do is I have to print 2 multiplied by I minus 1 spaces. So I'll simply write that 2 multiplied by I minus 1 spaces, and I is starting from 1. And this is something that you need to keep in your mind, that I is starting from 1. Now what I'll do is, after these spaces and stars are printed, I need a new line, and I need a single new line. So if you write something like this, will this print a new line? No, this will print two new lines. Why? Because I have not written n is equal to, I should write something like this, n is equal to blank. So if you do this and you run this program, I think this should give you the desired pattern. For n is equal to 3, we get this. So for n is equal to 4, we get this. So there is a problem here. So when the value of n is say 4, we are getting only 3 rows. So if you start your I from say 0, or rather if you take your I from 1 to n plus 1, you'll get an additional row, and that will solve the problem. So for 4 rows, you can say n is equal to 4. For a single row, you can say n is equal to 1. And for 2 rows, you can say n is equal to 2, and your star pattern is printed. And this problem was definitely very, very easy. Now, problem number 8 is super simple. All you need to do is you need to print the star pattern. So for the first row, print 1 star. For the second row, print 2 stars. For the third row, print 3 star. This is very simple. You don't have to generate any logic for this. But for problem number 9, we have already generated a logic, and the logic was either the value of I is 0 or n minus 1, or j is 0 or n minus 1. So let's quickly solve problem number 9. I'll simply say 15 underscore pr 09.py. And let me tell you something, that these problems are going to get more simple for you once you practice. You might think, how many problems will I remember, and do I need to remember all this? But the reality is there are only 5 to 7 such problems at a very high level. And once you solve all those problems, let me tell you that your life is going to be really very simple when it comes to these problems. Okay, so let me write this loop. So I'll say for I in range n, for j in range n. So what I'm doing is I'm saying start an outer loop, and take I from 0 to n minus 1, take j from 0 to n minus 1. And now what I'll do is I'll simply say if I is 0, or j is 0, or I is n minus 1, or j is n minus 1, you simply print a star. That's all I want from you. I'll say simply print a star. Otherwise, what you do is you print a space. So simply print a star, else. Okay, so I need to put a space here. I think I have messed up the indentation. Okay, so I'll simply print a space here, and do not forget to put n is equal to, do not forget to put this. Okay, so we'll put n is equal to blank later. So after you are done printing, which means that you have printed the row, print a new line. So after my first for loop, I'll simply say print \n, and once I do this, I'll press Alt, and I'll use multi-cursor functionality from VS Code. I'll simply say n is equal to blank, and I'll simply hard code the value of n. I'll say n is equal to say 5. Let's try to run this program. So you can see that for n is equal to 5, we have this pattern. Let's try for n is equal to 4. For n is equal to 4, we have this pattern. So we are able to print this pattern for the values of n. So we have to do this for n is equal to 3. So the question says n is equal to 3. So let's run it for n is equal to 3 as well. And yes, it prints the pattern. Okay. I hope you are able to solve this problem. Now the next problem says that write a program to print multiplication table of n using for loop in reversed order. And if you want to print a multiplication table in reversed order, what can you do? Let's see what we can do. So I'll say pr, I think it was 11.py. I don't know, I'll fix it. It's 10.py, sorry. So I need to press F2 to rename in Windows, and I think it's, yeah, I'm sure it's enter in Mac if you want to rename. Okay. Now what I'll do is I will try to write the logic for reversed for loop. So I'll say for j in range, I'll say for j in range, so we have to print multiplication table of n in reversed order. So I'll simply take the value of n. So let us say n is equal to 10. Okay, so I'll start j from 1 to 11. Okay, so I'll say n plus 1. Okay, so I'll I'll start j from 1 to 10. So I want j to be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, which is why I'm writing n plus 1. But this will give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I'll do is I'll generate another I. I'll say I is equal to n minus j. So if I do n minus j, which is 10 minus 1, it will be 9. So I'll have to do plus 1 to generate 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let me show you something. If I print I as it is, you will see that 10, 9, 8, 7, 5, 4, 3, 2, 1 is being printed. So this is the reverse order of numbers that I have generated. Now what I'll do is instead of printing this, I'll simply generate an F string and I'll say I multiply by, or rather n multiply by I is equal to, and I'll put this value. So I'll say n multiply by I. And once I do that and run this, you can see that we have generated the multiplication table of 10 in reverse order. And you can put int input to take the value of n from the user. So 4 multiplied by 4 is equal to 16, 4, 3, 2, 1. Okay, so I've made a mistake here. So I should not say n, rather I should say 11. So I need to hard code this. And even for I need to hard code this because I don't want to start it from this n. I want to start it from 10 itself. So I'll say 11 minus I because initially I will be 1. So I'll simply say 11 minus j. And this will simplify the logic and let's see if everything works fine. Yes, it works fine. Let's try for 8. And yes, it works fine. So this is how you generate multiplication table of a number in reversed order. I hope you enjoyed this practice set. I hope you learned a lot new by using these star patterns, and these star patterns are going to be the same in all the programming languages. So if you have done it in Python, writing it in C or writing it in Java or C++ is not going to be a very difficult task for you. Let's move on to chapter 8 now and explore more on Python. So now we are going to talk about chapter number 8, which is functions and recursions. So what is a function if I ask you? A function is a group of statements performing a specific task. So let us say we have some statements in Python and we want to group them together. For example, let us say I have a program and I want to add 5 numbers over and over again in a single program. What is a good deal? Should I write that particular function as a separate entity and then keep on using that logic? Or should I repeat the logic again and again? One of the programming practices, and I would say one of the best programming practices, is to use try principle. And what is the try principle? Try principle clearly states that do not repeat yourself. So if you're writing a code, try principle says that you should not repeat something again and again and again. Do not repeat yourself. So every piece of knowledge must have a single unambiguous authoritative representation in the system. So this is what is the basic idea of writing functions. And recursions is a function calling itself, but I'll make it easy for you. Do not worry about what recursion is at this point. So when a program gets bigger in size and its complexity grows, it gets difficult for a programmer to keep track on what piece of code is doing what. For example, if your program has 23 lines of code, there's a high chance that you will understand it. There's a high chance that you might not need comments in that particular program. But as the program grows bigger and bigger in size, what happens is you will need some comments to make sure that whoever is reading your program understands your program, and also you will need some sort of logic separation, I would say. And such kind of logic separation is provided by functions. Let me explain it to you once again. So a function can be reused by the programmer in a given program any number of times. I forgot to write times here, so my bad. So it can be used by a programmer in a given program any number of times. So this is an example and syntax of a function. So the syntax of a function looks something like this. You write def. Def is a reserved keyword in Python. And func1 is the name of the function. It can be anything. It can be func2, it can be Harry, it can be anything. And you use these parentheses, these opening closing parentheses, then a colon, and then you simply say print hello. This function can be called any number of times anywhere in the program. So if you have a program, you can actually use this particular function any number of times. Let's see an example, because this way we are not going to understand it if we don't write some code. So let me open this particular folder in VS Code and let me create a program 01 underscore func.py. So func.py is a program which demonstrate what a function is. So I'll simply use func1, and what I'll do is I'll say print hello Harry, and then what I'll do is let me close this GitHub Copilot, print hello Harry, and what I'll do is I'll simply say print you are good. Okay, so this is how I want to write it. So let me close this. Also, let me save this code, and what I'll do is I'll simply say func1 here, and once I say func1 and once I run this code, you can see hello Harry, you are good has been printed here. Now let us assume that I want to call this function 10 times, and or let us say I want to call this function 5 times. Will I be able to do that? Yes, definitely I'll be able to do that. I'll simply write it 5 times and you will see all this happening 5 times. So instead of repeating these 2 lines 5 times, which would have been 10 lines, I'm actually writing func1 5 times. If that doesn't make it clear, what I'll do is I'll simply say print I am another line. Okay, and so we have 3 lines inside the function, and once we call the function, 3 lines are executed. And if I call this function 5 times, 5 multiplied by 3, which is 15, 15 statements will be executed. So what happens is I should see 15 lines printed on the console if I run this program. And if I run this program, you can see, oops, I didn't save this program, it seems. I am in another line. It says in line number 1 you have okay, so let me run this again, and it works fine. So when you select some piece of code and you try to run it, it actually creates a temp code runner file and it tries to execute it for you if you have code runner extension installed. So make sure that you do not select anything before running any Python code if you're using code runner extension. So I hope this makes it clear what a function is. Can you pass an argument to a function? Can you pass a value to a function? Definitely you can, and I'll show you how you can do that. So this function can be called any number of times anywhere in the program, and it is very easy to use. Now, what is a function call? What does it mean when somebody says I'm calling a function? So when I say that I'm calling a function, I mean that I'm actually executing the lines of code which is written inside the body of the function. So whenever we want to call a function, we put the name of the function followed by parentheses as follows. So what we do is we say func1, and this is called function call. So this is a function call, this is a function call, this is a function call, and these two are also a function call. So I hope this makes sense. Now, function definition. What exactly is a function definition? Function definition is the part containing the exact set of instructions which are executed during the function call. So in this case, what is the function definition? This selected lines of code is the function definition. So these 3 statements, line number 2, line number 3, line number 4, these are function definition. So I hope that makes sense. Now a quick quiz for you. Write a program to greet a user with good day using functions. And this is super simple. All you have to do is you have to write a function named good day. Make sure that your function name should not have spaces. So you can do something like this, but you cannot do something like this. You cannot have spaces between your functions. I'll revert it back to func1. I hope that you understood how to write functions. Now there are 2 types of functions in Python. There are built-in functions, and then we have user-defined functions. These built-in functions are already present in Python, and these user-defined functions are defined by the user. So examples of built-in function includes len, and then we have print, then we have range. We have already seen range when we were talking about loops. You can do something like this. Let me create another file, and I'll say user, or rather built-in functions .py, and what I'll do is I'll try to use them. So print is a built-in function. I am a built-in function called print. So print is definitely a built-in function. We have another function which is built-in, which is range function. So I can do something like this. I can say for I in range 3 print I, and what it will do is it will print 0, 1 and 2 for me. So when I say for I in range 3, I goes from 0 to 2. So let me run it for you and you'll see 0, 1 and 2. Okay, and this particular line is executed because I have this print statement here. So print is a built-in function. I never defined this function. Range is a built-in function. I myself never defined this function. And then we have a lot of other functions which are built in. Len is another function. If you remember, we had our list, we have our strings, and we actually ran this len function, and this len function was able to find out what the length of a particular object is. And this is actually a built-in function because I never defined it, you never defined it, it was already provided by Python. So these were the examples of some built-in functions. Now the func1 function we define, if you look here, is an example of user defined function because we actually defined it using the def keyword. Now let's talk about functions with arguments. What are functions with arguments? A function can accept some values it can work with. We can put these values in a parenthesis. A function can also return values as shown below. So let me explain you with the help of an analogy. Let us say greed is a function. Let us say you are working in a store. You are working in a store and somebody who is a customer, he handed over you 2000 rupees, let us say. Now you have this 2000 rupees. You took those 2000 rupees, went inside the counter, processed the order, and you came back with the goods that that particular customer wanted. So if you are working in a garment store, a person might tell you that this is 2000 rupees and I want an amazing t-shirt. And you can go inside the garment store, you can get that t-shirt for that person and you can return that t-shirt back to that customer because he has given the 2000 rupees to you. Let me explain. In a very similar manner, what happens is def greet is a function. Greet is a function. It is saying that give me name and I will give you hello name. I'll give you another example. We might have a function called average. So what average says is average might say that you give me 3 numbers and I'll give you the average of these 3 numbers. When you go to a cycle store, what the person selling cycle says is you give me the money and what I'll do is I'll give you an amazing cycle. So this is how this works, and this was a very simple analogy. You don't have to remember the analogy, just remember the concepts. So what we'll do is we'll simply say func with arguments. So let us say I have this function called average and it takes 3 values a, b and c. Now what I'll do is I'll simply return a plus b plus c by 3. If you're wondering how I did that using a single key press, actually I'm using something called GitHub Copilot, and you don't have to worry about what GitHub Copilot is. GitHub Copilot is an AI pair programmer and it actually tries to find out what I'm going to type next using artificial intelligence. But if you are a Python beginner, do not worry about GitHub Copilot. Seriously, I'm going to disable it right away. So I'm going to disable it globally. I don't want to use GitHub Copilot anymore for this tutorial. Okay, so I wrote a function called def average a, b, c and then return a plus b plus c by 3. Actually this GitHub Copilot is spoiling my habits. I want to write my own code and this GitHub Copilot is not allowing me to write my own code. So I don't want to use it anymore. But yeah, sometimes I use it when I am working on some heavy code base and I'm running out of time. Then this actually turns out to be savior for me. Now what I'll do is I'll simply say print avg. So avg is actually average of 3, 6 and 4. So what is the average of 3, 6 and 4? So if you add 6 and 3, it's 9, and if you add 9 plus 4, let me make it 3. If you add 9 plus 3, then it's 12. You divide it by 3 and you get 4. So 4 should get printed on the screen and 4 is getting printed on the screen. So how this works is 3, 6 and 3 are passed to are passed to average as A, B and C, I should say. So now A is 3, B is 6 and C is 3. So 3 plus 6 plus 3 divided by 3 is actually 4. And since we have this return keyword here, what happens is this is returned as 4. So AVG is equal to 4 now. I hope you're getting the gist of it. I hope you're getting how all these things work. So all you have to do is you have to write 2-3 more functions. If you are a beginner, you should practice it again and again, and definitely you will get a hang of it. You will get how these things are working in action. I hope all this makes sense to you. So this is how all this works, and this is how functions with arguments work. In this case, if you see this particular example, what I'm doing is I'm saying def greet. Inside greet, I'm passing single argument called name. You can have one argument, you can have two argument, you can even have multiple arguments. So def greet name, I'm saying that I am a function and I take one argument which is called name, give it to me. And what I'll do is I'll do this processing. So what is the processing that I'm doing? Gr is equal to Harry and whatever the name is passed, and then I'm returning this particular value. So gr is equal to hello plus name, and whatever gr contains is returned back to the calling object. So a is equal to greet Harry. Harry is passed as name to greet. Now if I say gr is equal to hello plus name, then name is actually Harry here. So hello Harry will be printed on the screen because I'm returning gr, and gr is nothing but hello plus the name that I initially passed. So gr is equal to hello Harry, and it will be printed here. Harry is passed to greet in name. A will now contain hello Harry. I hope all this is clear, and if it is not, I want you to spend some time on this. I want you to write 2-3 more programs on your own, and definitely you will get a gist of it. Default parameter value. Let's talk about this. We can have a value as default argument. What is a default argument in a function? Say, if we specify name is equal to stranger in the line containing def, this value is used when no argument is passed. For example, if I say def greet name is equal to stranger, by default the value of name will be stranger. And if I pass some value, the name's value will be overridden. Let me explain it to you with the help of example, because this way you are not going to understand it. What I'll do is I'll write the same function greet, and yes, you can have multiple functions inside a single program. Not a problem at all. Name is equal to, let us say, Harry. And what I'll do is I'll say hello, and yes, you can return in a single line. You need not create variables to return values. Okay, so I'll say hello plus name. So if I run greet without the arguments, okay, so what happens if I run a function without the arguments? So let us say I don't have this 3, 6 and 3. It will actually throw an error. It will say that I need these values. So it is saying that missing 3 required positional arguments A, B and C. So what it is saying in a nutshell is that I need these 3 values and you haven't provided me these 3 values. So please provide me these 3 values so that I can actually process and do this and return you the value of A plus B plus C divided by 3. Okay, so let me undo it and I'll simply comment this out. And what I'll do now is I will run the greet function. If I run the greet function, see, I'm not printing anything. So if I run the greet function, nothing will happen. So if I run this greet function with name, say Shubh, and if I run this, nothing happens, nothing is printed. You might say that why is hello Shubh not printed on the screen? I'm not using print statement. There is no print anywhere here or here. If I say A is equal to greet Shubh, and if you say print A, and if I control S, and now if I run, then you'll see hello Shubh. So this particular value is seen by Python after processing as hello plus name, which is hello Shubh. So you can either write greet Shubh here or you can write hello Shubh here. This particular value is actually processed to hello Shubh. Greet is simply saying that I'll return hello plus whatever is passed to me. Okay, I hope that this is clear. Now since I've written name is equal to Harry, Harry is the default value of name. So now that default value of name is present, I need not pass name. Even if I don't pass name, this is going to work fine. Let me show you. Let me comment this one out and let me remove this Shubh. And if I run this program, surprisingly, or rather not surprisingly, we just talked about it, why this happens. Greet will actually return hello Harry. Now the value of name is Harry. Why is the value of name Harry? Value of name is Harry because this is a default value. We just passed a default value to greet And I hope this makes sense to you. So this is all I'm saying here. I'm saying that if you have name is equal to stranger and some function body, now if you write this greet, you'll not see any error. Name will be stranger in function body because name is equal to stranger by default. This is the default value. So if you see, I've written default parameter value. Default value means that even if you don't provide this value, this is going to be name is equal to stranger. And if you pass something, for example, I passed Harry here, what will happen is name will be Harry in function body because Harry is passed as name and stranger will no longer be the value of name. Okay, I hope this makes sense and I want you to try this out. Open your IDEs, open your Visual Studio codes, and I want you to use that computer that you have. Okay, so let me close this, and now we'll talk about recursions. Now recursion is something that might get confusing for beginners, let me tell you. So if you are a programming beginner, I would not say that you skip this topic. You definitely learn this topic, but recursion can go from very simple to very, very complicated recursions. So at this point, what we'll do is we'll discuss some simple recursions. I don't want you to look at recursions and then get confused and then stop learning Python. That's not what I want. What I want you to do is I want you to listen to me, listen to the simple examples that I'm going to show you, and then you can definitely hone your programming skills further and learn more on recursions. And if you're not a maths person, you just simply understand what recursion actually means and how it works, and that's it. We'll move to the next topics after that. So recursion is a function which calls itself. It is used to directly use a mathematical formula as a function. So this line is something that tells a lot about recursion. So this is something that you'll not find in any book. I have written this because this is what it is. So a recursion is actually used to directly use a mathematical formula as a function. For example, let's talk about factorial. Let me make a program called factorial.py, or rather recursion.py. So 04 underscore recursion.py, and I'll simply save it. Now what I'll do is I'll write a function called factorial, and I'll say n, and I'll simply say pass. I'll implement this body later. Before that, what I'll do is I'll write a multi-line comment here and I'll explain you what factorial is. So factorial of, let us say I want to find factorial of 6. Just listen to me very, very carefully and you'll understand what factorial is. So factorial, so let's talk about a formula first. Okay, I'm not a formula guy, by the way, but I just want to talk about a formula. So factorial n is equal to factorial n minus 1 multiplied by n. So it's n multiplied by factorial n minus 1. This is something that you might think that, hey, what are you writing? I don't understand all this, but just hang on and listen to me very, very carefully. So factorial 4 is actually 4 multiplied by 3 multiplied by 2 multiplied by 1. How did I get this? Let me explain. So if I want to find out factorial of 3, what I'll do is I'll keep on multiplying 3 with 2 and 1, and I'll stop. When I reach 1, I'll stop. Okay. So if I say factorial 13, and this is going to be very tedious to write, but still I write 13, 11, then 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2. Oops, I'm writing S. I need to write X. My bad. X. Okay. So factorial 13 is actually 13 multiplied by 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and finally 1. So once you reach 1, you can stop. Okay. By definition, factorial 0 is 1. Okay. So this is something which people find strange, but this is what it is. By definition, factorial 1 is 1. By definition. And if you want to find factorial of some number, can I say factorial of n is factorial n minus 1 multiplied by n? If this sounds strange to you, let me explain you why this happens. Can I write this particular thing as factorial 12? I can actually write 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 as factorial 12. And you can try this out with any number. Just leave that number and multiply it by factorial of number minus 1, and this formula actually holds true when it comes to factorial. So what I can do is I can implement my body of this function. I need not write any for loop and check when it is becoming 1, when I keep on decrementing it. This is going to be very tiring. What I can actually do is I'll say return n multiply by factorial n minus 1. But there's a problem with this implementation, and the problem is that this function never stops. This function never stops. It will keep on multiplying n with n minus 1. Even if I reach 1, it will multiply 1 with 0, then 0 with minus 1, then with minus 2, minus 3, minus 4, minus 5, minus 6, 7, 8, 9. It will keep on going negative all the way to infinity. I need to stop this. So what I'll do is I'll write something called base condition. So base condition actually stops recursion from happening over and over forever. Okay, let me write like the base condition, which is if n equals to 0 or n equals to 1, you need to return 1. Okay, and this or doesn't work in Python, so you simply say or. This actually works in C++ or C, so you simply write or. Okay, now if I try to find the value of some factorials, let us say factorial 3, and obviously since I'm returning, I'll have to say something like this: a is equal to factorial 3 and print a. And if I run this, 6 should be printed, and yes, it is being printed because 3 multiplied by 2 multiplied by 1 is actually 6. If I say factorial 4, the value is 24 because 4 multiplied by 3, 2, 1 is 24, and 24 should be printed. If I say 0, I should get 1. If I say 1, I should get 1. And yes, this function works. If I move a step ahead and if I type factorial table, and if I look into this table, you can see that factorial of different numbers is shown. So if I say 9, I should get this number. Let's check it out. Let's see if we have written the correct program or not. So 362,880, 362,880, and yes, it works. Yes, it works. For 7, it should be 5040. For 7, it should be 5040. And yes, it is right. I don't want to check it further. 5040, our program works. So finally, you understood what recursion is. So this is what I've explained here. Recursion is a function which calls itself. It is used to directly use a mathematical formula as a function. In this example, we used factorial as an example. You can use something else as an example. We have Fibonacci series. We have a lot of things. This is the base condition that I wrote, and this is the program that we wrote. And I have actually explained you whatever I explained you here. I've actually explained you in the notes, so that you simply download the notes, and even in the future, if you are forgetting, you can recall. So factorial 4 is 4 multiplied by factorial 3. Then factorial 3 can be broken into 3 into factorial 2. Then factorial 2 can be broken into 2 into factorial 1, and this keeps on getting executed 4, 3, 2, 1, and function is returned because now we don't have any further pending calls. So when I'm breaking factorial 4 into factorial 3, it will say 4 multiplied by, wait, let me find out the value of factorial 3. Then it will say 4 multiplied by 3 into, wait, let me find out the value of factorial 2. Then it will say 4 multiplied by 3 multiplied by 2, wait, let me get the factorial 1's value, and then we'll do the calculation. And now it is ready to do the calculations. 4 multiplied by 3 is 12, multiplied by 2 is 24, and function will return 24. And this is how it works. Okay. The programmer need to be extremely careful while working with recursion to ensure that the function doesn't infinitely keeps calling itself. So if a function keeps on calling itself, then the loop runs infinitely, and this will actually harm the programmer. And recursion is sometimes the most direct way to code an algorithm. But also, if you try to force solving a problem using recursion, you might get into troubles. So when should we use recursions and when should we not? I would say use recursion when it's actually straightforward to use recursion. And this actually comes by solving more and more problems. The more and more problems you solve, the more you get the answers to these questions. So if you tell me the set of problems which can be solved using recursion, there is no list that I can read out and tell you that these are the set of problems you need to solve using recursions. This actually works like this. You just practice and you just learn and you get experience. I hope you understood what recursion is. We looked into recursion, we looked into factorial, we looked into function, we looked into function with arguments, default parameter value. Make sure that you download these notes from the description. These are amazing notes and I've put in a lot of hard work to write these notes. I hope you'll download these notes and get benefited from these notes. Let's move on to chapter 8 practice set now, and we'll practice some functions and recursions questions. So the first question says that write a program using function to find greatest of three numbers. So what I'll do is I'll simply say 05 underscore pr01.py, because this is the first problem of our chapter 8 practice set. So what I'll do is I'll write a function. I'll name it greatest. Num1 is the first number, num2 is the second number, num3 is the third number. And I have to find which one out of these numbers is the greatest. So what I'll do is I'll simply say if num1 is greater than num2. So let me talk about the strategy first. What I'll do is I'll find out which one out of num1 and num2 is the greatest. And then what I'll do is I'll find out what out of the greatest of num1 and num2 and num3 is greatest. Okay, so let me put it this way. I'll say if num1 is greater than num2, I'll say greater is equal to num1. Else what I'll do is I'll say else greater is equal to num2. So now what I'll do is I'll say if num3 is greater than greater, I'll say greater is equal to num3. If num3 is greater than greater, then greater is equal to num3. Otherwise, greater is the greatest number out of these three. So I'll say return greater. Let's check whether this function works. I'll say a is equal to greatest of this, this and this. And I'll say print a. And let's run this particular code. So you can say 21 is the greatest. If I make 63 as greatest, 63 is the greatest. If I make the first number as greatest, you can see that 333 is the greatest. If I make it 653, 653 will be the greatest. How does it work? Okay, let me explain it to you once again. So what I'm doing is, let us say we have three people and they want to fight. Ideally, we don't like fights, but again, let's just assume that three people are fighting with each other. And we want to see, and let's assume that they are fighting professionally. They are professional wrestlers. So we have wrestler number 1 and 2. What we'll do is we'll hold a match between wrestler number 1 and 2. We'll say both of you please fight and let us know who wins. And whoever wins will have the greater tag. Now that person will fight with wrestler number 3, and this will prove which one out of these three is the greatest, is the strongest person. So this is how this logic works. I hope this logic is pretty simple and I know that you understood it. Let's now solve problem number 2 from chapter number 8 practice set. And the problem number 2 says write a Python program using function to convert Celsius to Fahrenheit. So what I'll do is I'll say Celsius to Fahrenheit code and I'll simply copy this formula. So I needed the formula, by the way, not code. I'll write the code myself. I'll say def cell to far and cell. And what I'll do is I'll say return. This is the Celsius value, CEL. And I'll replace this x with star. 9 by 5 plus 32. And this is how this function is going to work. So I'll say cell to far. I'll convert 35 to degree Fahrenheit and I'll print A. Okay, so let's see whether this works. Let me run this code. 95 is the answer. So if I say 35, is 95 the answer? Oh yes, 95 is the answer. If I say 135, is 275 the answer? Let's check. So let me put 135 here. And we have the answer as 275, which means this works. And let's see if what happens if I put 137. is not divisible by 5, by the way. So 278.6 is the answer. So let me punch in 137 here just to check whether this works. 278.6. Oh yeah, our program works. V1. So this is how we can write a function to convert Celsius to Fahrenheit. Okay, if you don't know the formula, you can simply Google, but these are basics, and these are taught in class 6 to 8th most of the time, sometimes in class 10th. But again, if you struggle to find the exact formula, and even if you don't struggle to find the formula, you remember the formula, I always suggest you that you go to the Google and check the formula, because if the formula turns out to be wrong, your program will be wrong and your code base might suffer, and you don't want your code base to suffer. Let's move on to the next problem, which is how do you prevent a Python print function to print a new line at the end? And this is an interesting problem. How do you prevent print to print a new line at the end? And let me solve this problem as well, because this is important. If I say print Harry and I say and Raj and Simran, what happens is Harry and Raj will be printed and Simran will be printed on the next line. But what I want is I want it to print on the single line. So what I can do is I can add another parameter, which is end, and I can say that end is equal to nothing. End is equal to nothing. So what happens is Harry and Raj will be printed and no new line will be printed. By default, a new line is printed after every print statement, but I don't want any new line to be printed. So what I'll do is I'll say end is equal to this. End is equal to this means print nothing at the end of this print statement. And let me show this works. Yes, this works. Harry and Raj and Simran. So not even a single space is printed. What if I make it a space? If I make it a space, we'll see a space after Raj. Let's check it works. Yes, it works. What if I make this triple hash as end? So after the end of this print statement, this triple hash will be printed, as you can see. By default, a new line is printed, and if you pass this end parameter, then whatever you pass as the end parameter will be printed. So this is quite simple. But if you want to prevent print statement to print a new line, all you need to do is you need to write end is equal to simply blank. Okay. So I hope this helps you. What I'll do now is move on to the next question. What is the next question? So if you can see here, the next question says write a recursive function to calculate the sum of first and natural number. And this is quite simple. Let me tell you why. Let's write 08 underscore pr04.py. Let us say I want to sum 1 to 8. So I'll say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay. This is sum 8. Okay. Sum of first 8 natural numbers. And let me comment it out. Can I say that sum of first 8 natural numbers is sum of 7 natural numbers plus 8? So can I say sum of first n natural numbers is equal to sum of first n minus 1 natural numbers plus n? Can I say that? And yes, I can say that. And on the basis of this, what I'll do is I'll write a recursive function. I'll say sum n, and what I'll do is I'll say return sum of n minus 1 plus what? Plus n. And I'll put a base condition, because if I don't put a base condition, this will keep on happening. I'll say if this is just like factorial. Let me tell you, if you have watched the factorial part of the video very carefully, I don't think you will face any problems with this, because this is really very straightforward. If n equals to 1, what happens is 1 is returned, because sum of first one natural number is 1. Okay. And otherwise, sum of n minus 1 plus n is returned. Now I can simply say a is equal to sum of 4. And if I print a, what happens is, you can see if I run this code, 10 is printed. Is it true? 4 plus 3 is 7 plus 3 is 10. Yes, it's true. If I say 5, then it should be 15, because 10 plus 5 is 15. Is it true? Yes, it is true. So our program works. Okay. And this is how we can use recursions. Recursions means what? function calling itself. Sum is a function, it calls itself. This is a function, it calls itself. This is a recursion. Okay. This is really very straightforward and simple. And let's now move on to the next question. Write a Python function to print first n lines of the following pattern. So all you have to do is enclose this logic inside a function. Let me show you how you can do it. So I'll create a file 09 underscore pr05.py and I'll simply say print pattern and I'll say n and I'll say for I in range n, and what I'll do is I'll print star n times. So I'll say print star, and while I'm saying print star, I want you to say n is equal to nothing. Why I'm doing that? Because I don't want a new line after every print statement, and once this loop finishes I want to print a new line. So new line is \n, and if I run this program, oops, I haven't called this function. So if I say pp print pattern, I'll say 4, and I don't have to print it because inside the function itself we are printing. Let's run this code. Let's run this code, and 4 times this is being printed. In order to solve this problem, what I'll do is I'll say for I in range n, and what I'll do is simply print the value of I. So I'll say print I. And once I print I don't want to print this \n. Let me tell you why. I'll run this and you can see 0, 1, 2, 3. But what I want is I want this to be printed in reverse order. So I'll simply say n minus I. So n minus I will actually print it in reverse order. As you can see 4, 3, 2, 1. And this is what I want. I want this to be printed 4 times, this to be printed 3 times, this to be printed 2 times, and then 1 times. So what I'll do is I'll simply say print n minus I multiplied by star. So I want to print star these many times. So I'll say star, I want star to be printed these many times. So I'll say multiply by this, and that should do, and this works. So I'll remove this print \n. I don't need this anymore. Let me try with print pattern 3. Yes, it works. And this is how you write the code. So sometimes you need to build the logic to solve a particular problem. And a lot of people ask, how do we build the logic to solve a problem? What I will tell you is, if you practice more and more, automatically you can build the logic, and there is no book you can read to build the logic. There is no food you can eat to build the logic. All you need to do is get your hands dirty and start coding in your laptop. And once you start coding, then only you will be able to build logic like this. A lot of people will ask in the comments, how do I know that I need to type this? How do I know I need to use for loop? And instead of asking these questions, I want you to go and solve few problems out there. They can be even these problems. Why don't you solve these problems and watch how I'm building the logic? And once you complete the course, you'll be able to solve most of the problems, and you'll be able to definitely solve all the easy problems. So this is how basically this works. You don't have to read any book. You don't have to do some particular thing to build the logic. All you need to do is practice, practice, and practice, and definitely you will succeed. Let's move on to problem number 6. Write a Python function which converts inches to centimeters. Pretty straightforward. I don't have to solve this. I've already told you convert Celsius to Fahrenheit program, and all you have to do is simply go to Google, find the formula, punch in the formula in your Python function, and that's it. You'll get the answer. Write a Python function to remove a given word from a list and strip it at the same time. So what you have to do is remove a given word from a list and strip it at the same time. This is an interesting problem that we are going to solve. So this is problem number 7, and I'm going to solve it. Let me delete this temp code runner file. I didn't create it. 10 underscore pr07.py. And what it says is you have to process. So I'll simply name this as process, and there is a given word and we have to do something. That's all I know. So we have a given string, a given word from a list. We have a list, so I'll call it L, and we have a word, and what we have to do is we have to remove a word, okay, and strip it at the same time. we have to strip the list as well. I know this problem might sound a bit strange, it might sound a bit vague, I would say, but let me tell you what I mean with this problem. So what I want you to do is, you just have to say word is equal to word dot strip. Okay, I want you to strip a word. So if a word contains spaces at the end and starting, it will be stripped. And then I want you to use this l dot remove function to remove this word from the list. So let's see if this works. I'll say L1 is equal to Harry and Rohan, and then we have Akash, and then we have Shubham, and we have Lavish. So let's process this. Let's say process L1, and I want to return L1. So I'll simply say L1 is equal to process L1, and then I want to print L1. And yes, L1 accepts second argument as word. So I want to, let us say, remove Harry from this. Let me run this, and you can see that Harry has been removed. What if I add some spaces before Harry? Will Harry be printed? Yes, it will be printed. What if I make it Hardy? X is not in list, so X is not in list. So what I'll do is I'll say if word in list, then remove it. Okay, so this will make a program error prone. So sorry, not list, I'll simply say L, because L is the name of my list. Now you can see that Harry is not removed. But what if I make it Rohan and add few more spaces? If I run it, you can see Rohan has been removed from this list. And this is how it works. I hope you got the point. Okay. Now what I'll do is move to the next question, which is write a Python program to print multiplication table of a given number. This is very straightforward and you can definitely do it. I don't want to do it. I want you to go ahead, write def multiplication table and simply pass a number and then use for loop and then simply give your multiplication table a very beautiful look and then print it. You can also write a function to actually store that printed list or the printed multiplication table inside your file. So you can have multiplication table of 19.txt, you can have multiplication table of 12.txt and so on. So with this we have completed our chapter 8 practice set, and after this what we'll do is we'll create a game, and it is going to be our first project and it'll be fun, believe me. So let's move on to project 1 now, and what we'll do is we'll build a game. I'm really very excited and I hope you are excited as well. Let's move on to project 1 and start building our game. So this is our first project that we are going to code in this Python course. This is called Snake Water Gun Game. If you don't know what Snake Water Gun Game is, let me explain it to you. So let me explain you the rules of the game. All you need to do is you have to either choose snake, water or gun, and the computer will choose snake, water or gun as well. Okay. Now what happens is, if the computer has chosen gun and you have chosen water, then water will win. Why will water win? Because there is some sort of logic which says that the water can actually drown gun and gun will no longer be functional. Snake can drink the water, so snake and water, if competed, snake will win. And water, and out of snake and gun, gun would win because gun can shoot snake and snake will die. Okay. So this is how it works. Let me open this particular folder in VS Code and let's start coding this game. So I'll simply say main.py because this is the only file that we are going to have in this folder. So what I'll do is I'll simply create a function, or rather what I'll do is I'll simply start writing my logic. So what I'll do is I'll say choice is equal to, I'll simply say it can either be snake, which is S, it can either be water, or let me make it small so that it's easier to play, and it can be gun as well. Okay, so this is the set of choices. Now what will happen is I'll generate a random number, so I'll import random, and I'll use a random function. So what I'll do is I'll say mine is equal to random.ranint. Okay, and what does random.ranint do? It actually returns a random number from range A to B. So what I want is I want to return a random number in the range 0 to 2. What does it mean? I either want to generate 0 or I want to generate 1 or I want to generate 2. If I generate 0, this will mean that it is a snake. If I generate 1, it will be water, or else it will be gun. Okay. So instead of calling it mine, I'll say computer, and mine will actually be input. I want the user to input, choose either snake, water or gun. Okay. You can write a comprehensive message as well. Choose S for snake, W for water and G for gun. I just want to keep it short and simple. So choice is equal to SWG and comp is equal to random.randint 0 to 2, but comp should either be SW or G. So what I'll do is I'll say comp is equal to choice comp. So what I'm doing is I'm actually choosing one out of these three. So if the comp is 1, the comp is now water, which is W. If comp is 2, comp is now G, because what I'm doing is I'm saying comp is equal to choice comp. Comp is the index, choice is this tuple. So I'm actually converting this number into SW and G. As simple as that. Okay. So now what I'll do is we have comp, we have mine. Now what I'll do is I'll say when is equal to, and I'll say snake, water, gun. SWG is a function. I'll pass it comp, I'll pass it mine. I'll pass it both of these, and I'll create this function. It's called snake, water, gun, and it has comp, it has mine, and let me not procrastinate. Let me write it fully right away. Okay. I'll say win is equal to SWG comp mine, and win will be true if I win, and it will be false if I lose. So I'll say if win, I'll say print, I'll say you won. Else what will happen? Else you lose. Oops, I accidentally pressed shift enter. When you press shift enter, it actually runs. So anyways, what I'll do is I'll say you lose. Now what I'll do is I'll actually try to create this function. So let us say comp is equal to snake. Okay, what are the possibilities of me winning? If comp is equal to say snake, if computer is snake, what are the possibilities that I'll win? I'll have to choose gun to shoot the snake off, and then only I can win. So I'll have to say and mine equals to gun, then I'll win. Then I'll say win is equal to true. Then I'll say return true. Elif, otherwise, what is the second possibility that I'll win? So let us assume the computer is water. If computer is water, only possibility for me to win is to drink that water. So I'll have to be snake to win. So I'll say elif this, just return true. Okay. Elif, what if computer chooses the gun? My only resort to win is actually water. So if computer chooses gun, I'll have to choose water to drown that gun and win. And I'll say return true. In all other scenarios, I'll lose. So I'll return false. And that's about it. That's all about the function. Let's start playing the game. So choose either of SW or G. I'll say S, you lose. So I also want to print the summary of the game. I'll say you chose, I'll write an F string here. I'll say you chose mine, and the computer chose what? Comp. And also what I'll do is I'll give a colon here so that it looks beautiful. I'll run the code yet again. Okay, so I am having a syntax error. I forgot to close this parenthesis for the print function. So I'll simply press G. So it says you chose G and the computer chose water. So your gun thrown into the water. So you lose. Why am I losing again and again? I want to win this time. I'll choose snake. Oh God. Okay, so I chose snake. Computer chose snake. It has to draw. So if you want it to draw, then you'll have to say something like this. If comp equals to mine, then the game is draw. So I'll say return none. And here what I'll do is I'll say if win is none, I'll simply say match drawn. So I want to draw the match if win is none. If win is actually true, it will print you won. Else it will say you chose this, computer chose this, and you lose. And in any case, I want to print the summary. So I don't want to put it inside else. I'll put it outside. I'll say you chose this, computer chose this, and match can either be drawn, you might even win or you might lose. Okay. Let's run this now. Let me choose gun this time. So you chose gun, computer chose S. I shot the computer and I won. Okay. So this is how I won. Let me try water this time. Oh yeah, I won again. So I actually chose water, the computer chose gun, and I won. So this time I'm winning all the time. Okay, so I lost eventually. SG, the gun shot me, I died, and hence I lost. So was this game interesting? Not really, not a lot interesting, but in order to make it more interesting, what you can do is you can actually make yourself play this computer 10 times. And if you win, let us say more than 5 times, you won. And if computer wins more than 5 times, computer wins. So you can actually try to play this game with your friend as well, instead of randomly choosing this particular comp variable. You can actually make your friend choose either snake, water, or gun, and then you can hide the keyboard, and then you can press either SW or G, and once you press enter, the result will pop on the screen. So this is pretty interesting game as is as well. I mean, you can make it more interesting, but I don't think it's not an interesting game. Actually, it's a very interesting game. I am going to play this in my free time. But for now, I have to record further of this lecture. So once I cover the remaining topics of this lecture, I'll play this game. So this was about the project one. I hope you liked this project. We have covered all the possibilities. We built some logic, and I hope you understood how we built the logic of this game. I hope this was helpful for you. Make sure you access all the notes, and I'm saying this again and again because I've written these notes with a lot of hard work, and I want all of you to access these notes. So with that said, let's move on to chapter number 9 now and study further topics of Python. The next topic in this Python course is file IO. What exactly is file IO? Let's talk about files and how do we read and write files in Python. Before we talk about file IO and actually read, write, and append to files, I want you to have an understanding of what RAM is, what your hard disk is, and how all these things work together. Because after you have the understanding of all these things, you'll be able to understand file IO better. So the random access memory is volatile, and all of its contents are lost once a program terminates. So you must have heard of memory when we talk about program efficiency. Memory is nothing but a RAM. If I go to my task manager and I try to see how much RAM I have, you can see my computer stats here. You can clearly see that I am using 64 GBs of memory. It means that I actually have a 64 GB of total RAM installed on my system. So this 64 GB of RAM is actually required to run the programs when they load. So when I fire Google Chrome, my RAM will actually hold the contents of it. When I'm actually loading the Windows, it will hold some of the contents of the programs that are running in the background. And once I turn off my computer, all of those contents are lost. But sometimes what I want to do is I want to actually write something to my storage. For example, I might create a video and I might want it to persist there forever. So for instance, I'm recording this video. I want this video to persist on my hard disk so that I can upload it on YouTube. So a file is data stored in a storage device. So the device which actually contains all the files that persist forever, even when the computer is turned off, is hard disk drive and solid state drives. File is the data stored in those storage devices. A Python program can talk to the file by reading content from it and writing content to it. So here's a visual representation. So let us say this is me. I'm writing a program. This is the computer program written in Python. What I can do is I can actually write to this file, and I can read from this file, meaning that that content is not lost when I turn off my computer. Since this content is not lost even when I turn off my computer, this type of storage is called non-volatile storage, and RAM is the volatile storage. If I turn off my computer, all the data of the programs which is unsaved will be lost and I'll not be able to recover it. So that kind of storage is volatile storage. So whatever is stored in RAM is volatile storage. We are going to deal with non-volatile storage using file IO in Python, and we'll be able to write, read, and append to files. Okay, so let's talk about two types of files in Python. There are two types of files: text files and binary files. Text files are the ones that you can open using Notepad and read the content from them. It can be JSON, it can be some sort of source code like .c, it can be some sort of source code like .py, and we can actually read, write, and append using a Notepad. In case of binary files, the data is stored in the form of zeros and ones, and it is usually a bit tricky to edit these kind of files. So in order to edit such kinds of files, we'll need some sort of program which can help us edit these files. So .jpg, we need some sort of photo editor to edit this file. .dat, we need some sort of program which can write to .dat files. So Python has a lot of functions for reading, for updating, and for deleting files. We'll have a look at these functions. Let's talk about opening a file. How can we open a file in Python? Python has an open function, and yes, it's a built-in function. You can use open function. The first argument is the name of the file, and then second argument is the mode of opening. The mode of opening is actually the mode which tells the computer, which tells the Python interpreter what you want to do with this file. So you're given a file name. Okay, so this is the file. What do I do with it? Should I read from it? Should I write to it? Or should I prepare to append to it? So whatever mode we give in advance, the Python interpreter will be ready to perform the actions corresponding to this mode. Okay, so it takes two parameters, file name and mode. We'll give the file name, we'll give the mode, and open is a built-in function. Let's try out reading a file. So what we'll do is we'll actually read from a file in Python, and we'll try to use this open function. F is equal to open, this.txt is the file name, R is the read mode, and we want to open the file in read mode. The next thing we can do is we can actually perform a read operation in this file object. So F is a file object, F is equal to open this.txt R. We can read content from it, then we can print this text, and finally, and yes, this step is important, we need to close the file. When I say close the file, you need to run app.close so that all the resources that this particular program is blocking can be released. So app.close is really very important and you must do it. Running .close on F simply tells the program that you are done with the file and other programs can read, write, or append to this file. So let's come to a Visual Studio Code. I'm going to open this folder in Visual Studio Code so that I can explain all these things to you. Let me create a program called 01_file.py and let's try to do all these things. What I'll do is I'll say F is equal to open and I'll simply say this.txt. And since I want to open it in read mode, I'll say R. Now what I'll do is I'll say text is equal to f.read. Now I can print this text as you can see here, and this text will be printed on the screen, but there is no file called this.txt. So if I try to run this program, this is going to give me an error that there is no file called this.txt in the directory you are running this program from. So what I'll do is I'll create a file called this.txt and I'll say this is a file in Python. Okay, these are some random set of characters, please ignore these. I'll simply run this code so that I can read this file, and if I say this is a file and if I remove in Python, what happens is if I run this program, it'll read this file again and it'll print this is a file. So basically I'm able to read from this file and these set of lines work. Now in a similar fashion, I can even write to a file. In a very similar way, I can even append to a file. Let's discuss more about these things. We can specify the number of characters in read function. You can actually say f.read2. This will read first two characters from the file. Let's try this out as well. If I say f.read6, I should get first 6 characters. So 5 and 1 6. So 1 2 3 4 5 6. I'm getting 6 characters from my file, which is great. Did you see I missed something here? What is it? I should have run f.close. Whenever you are hungry at night and you have a refrigerator at your house and you want to eat some apples from the fridge, what do? You just go to the refrigerator, you open the refrigerator, you take the apple out of the refrigerator and you close the refrigerator. You close the refrigerator. We are doing the same thing here. We are actually using the file, we are reading text from it, and finally we are closing the file, just like we close the refrigerator after we are done eating the items from the fridge. So this is how it works. You should close the file so that all the resources which are held by this pointer can be released. Okay, now let's come back to this particular f.readline function. Let's create another function, or let me do the same here. Instead of read, what I'll do is I'll simply say text is equal to f.readline. So text is equal to f.readline. Okay, and if I run this code, the first line has been read. Okay, so second line, third line. Okay, so what happens is, as you keep on running this f.readline, next line will keep on being read. So if I run this, oops, cancel. If I run this twice, which means if I say f.readlines twice, this particular text variable will contain the first line, and the next call to read lines will contain the second line, and the third call to read line will actually contain the third line. You can see this is a file, and then second line, and if I run it once again, I should get third line, and you got the point. Now there is another function called read lines, and what it does is, let me actually do something like this, and I want you guys to keep this code. So I don't want to delete this code. I want to keep this code so that you can recall what has been discussed in the course. Now if I print text, let me do Control D to replicate and Control S. Now the text is a list. So now, since I've called f.readlines, what readlines does is it actually reads all the lines and stores them into a list and returns that list. So this time text is not a list. Sorry, text is not a string, it's a list. So let me call it text list. I don't want to confuse you, so I'll name my variable very smartly so that I can remember that f.readlines actually returns a list and not a string. Okay, so this is how this works, and let's come back to our nodes and let's look into modes of opening a file. So we saw other methods to read the file. I told you read line. I also told you about read lines, and both of these functions comes handy as well. If you want to read all the lines from a file all at once, you can use read lines, or if you want to read the lines one by one, you can use this f.readline. Now we'll talk about modes of opening a file. Now we have this R mode, which is plain and simple reading. Then we have this W mode, and W mode is used for writing. Remember, the mode is the second argument of this open function. The third type of mode is append mode, and A is actually written when we want to open a file for appending. We use plus if you want to open a file for updating. Now, these are not the only modes. Let's talk about some other things as well. If I add B to this R, this means that this file is open for reading and in binary mode. If I say RT, it means this file is open for reading in text mode. So RT means reading in text mode, RB means reading in byte mode or binary mode. Okay. Let's now learn how to write files in Python. In order to write to a file, we first open it and write or append mode in write or append mode, after which we use the Python sep.write method to write to that file. Okay. And I have an example here. I'll show you this example. What we'll do now is create another file, create another Python source file. I'll say file underscore write.py. And since this is following the same syntax, what I'll do is I'll say write.txt, and instead of writing R, I'll say W. And now what I'll do is I'll use this f.close as well. But more than that, I'll use the write function. So write function actually takes a string, and I'll say this is a text I want to write to this file. Okay. So I'll simply save this and I'll run this. See, there is no write.txt here. But what I'll do is I'll create a write.txt by running this program. So once I run this program, a write.txt file will be created. And you watch out for that here. Once I run the code, you can see that write.txt has been created and this string has been inserted inside this file write.txt. So this is how we write files in Python. I hope this was straightforward and simple. So f.write, this is nice. This can be called multiple times. So let me show you how this can be called multiple times. I'll say second line. And if I run this program once again, you can see that this write.txt contains this as well as this. But I'll do one thing here. I'll append a backslash in here so that you can see this in second line. So you can see this in second line. So this is how writing to a file works in Python. Okay. Now let's talk about with statement. But before that, I want to tell you about append mode. So I'll create another file. I'll say file underscore append. And here what I'll do is I'll rename this to file underscore read. Why am I doing all these renames? Because I want you to have this source code as a resource which you can use to revise your Python programming. Because you are doing this course with me, you need to keep these files and you'll have a good understanding of what you learned while you were doing this course. So this is why what I'm doing is I'm naming these files very, very carefully so that you can go back with these files and notes and you can revise Python programming as and when required. So we are here. What I'll do is I'll copy all the code here, and instead of opening it in write mode, I'll open it in append mode. And let's see what happens. Write.txt is a file which already has 2 lines. Let's see what happens when we run this program. When we run this program, these 2 lines are appended to write.txt once again. And if I keep on running this program, I'll keep on appending lines to this file. You can see that this file keeps on growing as and when I run this program. So in append mode, what happens is I keep on adding lines to the file. Okay, I'll stop here. I'll not append any more lines to this file. So what I was saying is, if you want to open this file in append mode, all you have to do is use an A here. And once you use an A here, whatever you write to this file will now be appended at the end of the file. So the content of the file will not be lost. But if you write W, whatever is there in the file will be cleared out, will be washed out, and then your content will be written inside the file. So this is something you need to be aware of. This is a mistake actually which people do. What they think is that they are writing to a file, they are writing to the end of the file, but when actually what they are doing is they're wiping out all the content of a file and then writing to it. So you might lose content of a file. For example, let us say this is some important 32-line document that I have, and it's a .txt file. If I accidentally open it in write mode, and if I run this, I lose everything. I lose everything from this file. So you need to be very, very careful when you are opening files using Python. Okay. Let me do one thing here for you. I'll say write mode and then I'll say append mode. So if I put A here, this is append mode. So this is how write mode and append mode works. Now what I'll do is I'll come back to the notes and talk about with statement. Instead of saying f is equal to open, then f.write, f.close, you can actually write these 2 lines. And what these 2 lines does is it will automatically close your file. So you can do something like this. And this is something that you'll usually see. So I'll say 04 underscore with.py, and you can do something like this. With open mine.txt in write mode as f and then f.write. Oops. This file is mine. Okay. So this is something that you can do. There is no mine.txt here, by the way. If I run this program, you'll see a mine.txt is created and this particular text has been inserted. So this is a shortcut that you can use with statement and this will automatically close the file. No need to call f.close if you're using with. So this completes our chapter number 9, which was file IO. I hope you enjoyed this chapter. Let's read what I have to say here. The best way to open and close a file automatically is the with statement. You can use this syntax and don't need to write f.close as it is done automatically. So this actually helps a lot and you will find with statement a lot when it comes to opening and writing to files. So this completes the chapter number 9. Let's move on to chapter 9 practice set now so that we can practice more on file IO. Let's move on to chapter 9 practice set now. So let's move further now and let's talk about chapter 9 practice set. So this is a practice set which I've created for you and we are going to practice some of the questions from this practice set. So the first question says, write a program to read the text from a given file poems.txt and find out whether it contains the word twinkle. So let me do one thing for you. Let me write a new program. I'll say pr01.py. And what I'll do is I have this poems.txt right here. I'm going to pull this file out of here. Okay, I'm going to move this file outside this new folder. So this is the poems.txt file. It actually contains the word twinkle. And we are going to write a program which can detect whether this contains twinkle or not. So I'm going to open this file. I'm going to say with open, what's the name of the file? Poems.txt in read mode. And we are going to say as f. And I'm going to say f.read. Or rather, I can write my logic right here. If the word twinkle in f.read, what I'm going to do is I'm going to say print yes twinkle is present, else what I'll do is I'll say no twinkle is not present. So I'll say print and I'll say the word twinkle is not present and I'm going to run this program. Yes, twinkle is present. And let me remove the word twinkle from here. I'm simply altering the file so that it doesn't contain the word twinkle anymore. And once I do that, and once I run this program again, you can see that word twinkle is not present. So this is how you can detect a word inside a file. So what I'll do now is I'll move on to question number 2, which says the game function in a program lets a user play a game and returns a score as an integer. You need to read a file highscore.txt which is either blank or contains the previous high score. You need to write a program to update the high score whenever game breaks the high score. So this is a function that we are going to write. So I'm going to say 06 underscore pr02.py. Game is a function. So let me write def game. I'm going to implement it later. Now what I'll do is I'll import random. Random module will allow me to generate some random integers. I'll say score is equal to random.randint and I'm going to store and I'm going to say 100. So because I want to generate a score from 0 to 100, I want to print the score as an f string and I'm going to say score and yes, it returns this score. I'm just printing this score so that I can know which score is being returned by the function game. Now what we'll do is we are going to read a file highscore.txt. So I'll simply say with open, I'll say highscore.txt and yes, I'm going to open it in write mode. I'm going to say score or rather high score is equal to f.read and yes, this high score is going to be a string. So let me correct the syntax here as f and I'm going to parse this as integer. And now what I'll do is I'll simply say if high score is greater than score, if score is greater than high score. If score is greater than high score, what we need to do is we need to once again write the score back to highscore.txt. So here I was reading this file. Now I'll write to this file. So let me show you how I'm going to do all these things. I'm going to say f.write, and I'm going to write str and high score. I'm going to write this high score or other score. Let me explain what I'm doing here. But before that, I'll have to call this score function. I'll have to say score is equal to game. So score is equal to game will actually return a score, and that score is going to be stored inside the score variable. Now what I'll do is I'll see whether this score is greater than the high score, is greater than the existing score. If it doesn't, then we are not going to do anything. But if it does, if we have broken the high score, then what we'll do is we'll open this high score file, and this time I'm going to write. So I need to open it in write mode, and I'm going to write this to the high score file. Let me create a high score.txt, and let me say 5. So let us say 5 is the high score. Let me run this program. Okay, so it says ran int missing one positional requirement b. Okay, so I need to pass 2 integers to ran int. Let me run it once again. The score is 6. 6 has been printed. Now let me call it again. Score is 32. So 32 has been updated. Now if I call it again, the score is 50. It should update. Now let me call it again. The score is 62. It should update once again. Let me call it once again. It's 48. It should not update this time because 48 is not greater than 62. And yes, it has not updated. So as and when we break the high score, 69, it should update. As and when we keep on breaking the high score, it will keep on updating the high score.txt file. 80. Once again, yes, we have broken the high score, so it will update. It will not update. Once again, it will not update. It will not update. You can see it has not updated since 80. Once again, 43. Once again, 92. It should update this time, and yes, it has updated. So this is how all these things are working. I hope you understood the point of the question, and I hope you were able to understand the logic behind the question. Write a program. I'm solving question number 3 now. Write a program to generate multiplication tables from 2 to 20 and write it to the different files. Place these files inside a folder for a 13-year-old. So I know there are many 20, 25, 30, 35, 40, 45 years old as well here watching this video who are not good at multiplication tables. So I should have updated this to say some n-year-old. What I'll do is I'll move on to solve this problem. I'll say 07 underscore pr03 dot py, and what I'll do is I'll generate some multiplication table. So I'll say for I in range, and we need to generate multiplication table from 2 to 20. So I'll say 2 and I'll write 21 because I want it to go from 2 to 20. So the range function actually includes 2, but it doesn't include 21. So range 2 to 21 will go from 2 all the way to 20. Now what I'll do is I'll generate the multiplication table. I'll say table is equal to blank, and what I'll do is I'll simply say for j in range 1 to 11 because I want it to go from 1 to 10. I'll say table plus equals to, I'll write an F string here. I'll say j, and let me also write I. So I'll say I multiply by j is equal to I multiply by j, and I'm actually performing the calculation here, and at the end I want a backslash n. Okay, and this table once generated will be stored inside a file with open table slash, and let me create an F string here. I'll simply say I.txt because this is multiplication table of I, and I'm going to explain this program once again, so you need not worry about what I'm doing here. I'm just building the logic, and I'm going to tell you how I built this logic. So what I'm doing here is I'm simply starting from 2 and going all the way to 20, and I'm doing for all these numbers this particular thing. What is this particular thing? I'm creating a blank string, and inside this blank string I'm iterating from 1 to 10, and I'm putting this I multiply by j is equal to I multiply by j, which is the multiplication table of I. So I is going from 2 to 20. So I'll start from 2, I'll print the multiplication table of 2, this will first generate the multiplication table of 2, then 3, 4, 5, all the way to 20. While I'm generating multiplication table of say 2, this will be executed from 1 to 10. So 2 multiplied by 1 is equal to 2. 2 multiplied by 2 is equal to 4. 2 multiplied by 3 is equal to 6. This is being written inside my table variable, which is a string. And finally, what I'm doing is I'm going to write this table inside my table/i.txt file. In this case, table/2.txt file. And let me see if it works. And it says no file or directory, table/2.txt. I need to create an empty folder called tables, and this will work now. Let me run this. And yes, it worked. Let me open this and you can see the multiplication table of 2 is generated, 3 is generated, 4, 5, 6. Let me check for 14. Yes, it's generated. 19. Oh yes, it's right. So all these multiplication tables have been generated. You can hand it over to some 13 years old or 17 years old if he doesn't know how these multiplication tables work, and if he doesn't remember these, you can hand it over to that person as well. How this works is something I'm going to explain you once again. So I am doing this particular thing from 2 to 20 because I want to generate multiplication table from 2 to 20. Let us say we are generating multiplication table for 2. Every time I'm generating a multiplication table, I'm actually creating an empty string. Now what I'm doing is I'm going from 1 to 10 because range function actually includes 1 but doesn't include 11. It goes from 1 to 10. I'm going from 1 to 10 and I am adding this particular string to my table string. Initially table string was blank, so I'm adding 2 multiplied by 1 is equal to 2. Then once again this loop will add 2 multiplied by 2 is equal to 4, a new line. Then once again 2 multiplied by 3 is equal to 6, a new line. 2 multiplied by 4 is equal to 8, a new line. 2 multiplied by 5 is equal to 10, then a new line. And finally 2 multiplied by 10 is equal to 20, a new line. Now my table string contains this particular thing. I'll show you what. This particular thing will be inside my table string. I'm actually writing this string to 2.txt. So I is starting from 2 to 20. So in this case, I'm writing this particular string which I generated to 2.txt. And this will keep on doing this for 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So I have these multiplication tables generated. I hope you got this point. I hope you got how we generated these 19 tables. We don't have table of 1. It doesn't make any sense. So I started from 2. I hope this question helped you understanding file IO and how you can write inside a folder. Okay. Now let's move on to question number 4. Question number 4 says a file contains a word donkey multiple times. You need to write a program which replaces this word with this by updating the same file. So this is not a good word. You should not use donkey, I mean for a person. And just because somebody is using this word in context of a person, we want to replace it with this. Let's see how we can do this. So what we'll do is we'll read from the file, we'll update the string and we'll write it back to the file. So let's do it. This is question number 4. So let me say 08 underscore pr04.py. Let us say this file is called file.txt. I'm going to read this file with open file.txt as if, okay. Oops, I should have written this inside this program and not there. So I want to read this file. Let us say this contains hey, you are this is not a good thing for donkey. Okay, so I'm going to write this. Now let us read. So I'll say text is equal to f.read, and obviously I'm going to open it in read mode. Now what I'll do is I'll say text is equal to text.replace, and I'm going to replace this word with 1, 2, 3, 4, 5, 6. Okay. And now what I'm going to do is I'm going to do exactly the same thing, except the fact that instead of reading, I'm going to write this time. And I'm going to write this time and I'm going to write this text. And yes, I'm going to remove this equals to. I hope the syntax is correct. And yes, it is. Hopefully, let's see if it updates the file. Yes, it does update the file. Okay. So I hope you understood how these things are working, how I solved this problem, and let's move on to the next question. So repeat program 4 for a list of such words to be censored. So we are actually censoring this particular thing. So if you have a list of words to be censored, for example, we had donkey in this case. You might have a list of words and you want to actually replace them with these hashes. So what you'll have to do there is you'll have to replace this line with a for loop, and you'll have to iterate through that list which contains words like donkey, and you'll have to keep on running dot replace on text. So I want you to try it on your own. Okay, let's move on to question number 6 now. Write a program to mine a log file and find out whether it contains Python. So all you need to do in this program is you need to read a file, the log file, and you need to find out whether it contains Python or not. And this should be easy. You just have to perform an f.read, and once you read from a file, you have to find out whether Python is inside that string. So if your string is say text, you can say if Python in text, then return true or else return false if you're writing a function, or you can print something. I hope this is also clear. Moving on to question number 7, write a program to find out the line number where Python is present from question number 6. So what you'll do is you'll keep on performing f.readline. So you can say f.readline and keep on doing until you find the word Python, and keep on maintaining a variable. So let us say I have a variable I. I'll keep on running f.readlines, and every time I run f.readline, not read lines, read line. Okay. I have to run f.readline to read the first line. Then once again, I'll have to run f.readline for the second line, then for the third line. And what I'll do is inside a loop, I will keep a variable and I'll keep on incrementing that variable. And once I find the word Python, I can actually use that variable to find out which line number contained the word Python. I want you to try this on your own. I want you to take it as a challenge and try this question out. I know you'll have to think a bit about it, but I want you to actually solve this problem so that you are exercising your muscles as well. So write a program to make a copy of a text file this.txt, and this is going to be very easy. All you have to do is read a file and write to another file. So you can do this. Question number 8 is super simple. Question number 9, write a program to find out whether a file is identical and matches the content of another file or not. This is super simple as well. Read both the files and do the string matching. I don't have to do this question for you because this is super simple. Write a program to wipe out the contents of a file using Python, and this is once again super simple. I'll tell you why. Because all you have to do is you just have to write to that file an empty string. Just say f.write an empty string, and it is going to wipe out all the contents of that text file. Question number 11, write a Python program to rename a file to renamed by python.txt. We are going to do this. This is going to be fun. I'm going to solve question number 11. pr11.py. So I'll say file name is equal to input. I'll say enter the name of the file to rename. Which file you want to rename, and new name. Let me call it old name, new name. Let's enter the name of the file. You want to enter the new name of the file. So what I'm going to do is I'm going to read the old file. So I'll say with open, and I'll say old name in read mode as f, and I'm going to say text is equal to f.read. Now what I'll do is I'm going to use this new name, and I'm going to say f.write, and I'm going to say text. Now you might argue that I'm not renaming it, I'm actually creating a new file and dumping the content of the previous file. If you want to delete it, you can use a utility called OS module in Python. I can actually delete using OS module, and if you don't know how to delete, you can say how to delete a Python file, delete a file in Python using OS. And you will find out how to do this. os.remove is a function which can help you out with that. So you can actually use that. So you can say os.remove, and let me import os. I can say I want to remove this old name file. Let's try this out now. So we have this write.txt here. What I'll do is I'll run this program. I'm going to say write.txt and I'm going to say new name by python.txt, and it says no such file or directory. Okay, so I should have said write, my bad, because I'm writing. I'll say mine.txt, or I'll simply say write.txt, and I'll say renamed by python.txt, and yes, it is renamed by python.txt, and write.txt is no longer present. So kind of I've renamed the file. Not the best way to rename a file in an operating system, because if the file is extremely huge, this method might not be the best way to rename a file in Python. But again, you can do this, you can simulate few things and practice your Python skills. This is going to help you a lot. So with this, we have finished chapter 9 practice set. I hope you guys enjoyed this. Now we are going to do another project, which is amazing as well because it's another game. Let's move on to our project 2 and see what it has to offer. So now that we have learned so many Python concepts, we are going to look into project number 2 and let's see what project number 2 has to offer. As you can see, the name of the project, or rather the game, is the perfect guess. We are going to write a program that generates a random number and ask the user to guess it. So we have a user, we have to generate a random number and we want user to guess it. If the user guesses the number right, then he wins definitely, and if he fails to guess the number, then yeah, he loses. But let's add some spice to the problem, or rather the game, and make it more enjoyable. So what we are doing is, if the player's guess is higher than the actual number, the program displays lower number please. This is going to make the task easy for the guesser or the person playing the game. So let us say the number is 46 and you entered 63. You will be told that the number you guessed is actually lower or higher, whatever the case is, and then you can actually tweak your guess and try to reach the number. In a very similar way, if the user guesses too low, the program prints higher number please. When the user guesses the correct number, the program displays the number of guesses for the player. And yes, the less the number of guesses, the better the guesser the person is. Okay, so we are going to use random module for sure, but let's see how. So let's dive a bit deep into this one and let's open this with code. So I'm going to open this particular folder with VS Code and I'm going to create main.py. So I'll click this plus icon and I'll say main.py. Why did I say main.py and why am I not making 01 underscore main.py? I just want to tell you that this is the only file that I'm worried about when it comes to project number 2. So corresponding to project number 2, this is the only file that I want to make. So let's now do import random, because we are going to use this random module. And what I'm going to do is I'm going to say that guess the number. So I'll say guess is equal to int of input, and I want to ask user to guess the number. And the user is going to guess the number. Then what I'm going to do is I'm going to generate the number, but before asking user to guess the number, I want to generate the number. So I'm going to say random.randint and I want to pass two numbers. I'm going to use 1 to 100. And now what I'm going to do is I'm going to say if the user guess is greater than the number, if it's greater than the actual number, we are going to tell the user that, hey, guess another number. So we'll say guess is equal to guess another number. This one is too big. Okay, so we are just telling that this one is too big. We want you to guess another number, and the person guessing the number will hopefully guess it right next time. We'll say this one is too less. So we'll say if the guess is lesser than the number, then we are going to make him guess once again. Now what will happen is this will keep on happening until the guess is equal to number. So what I'll do is I'll say else You guessed it. So I'll say print. I'll say, yeah, that's the number. You guessed it right in these many attempts. And attempt is going to be a variable. So I'll say attempt is equal to 1, and I'm going to use this inside here. And yes, I need to make this an f string and close the print statement. So this is the program that I wrote. So what happens is I'm generating a number from 1 to 100. I'm setting my attempt variable to 1, and what I'm doing is I'm asking the user to guess the number. I'm saying guess is equal to int input guess the number. So I'm saying guess the number, and once you guess, we want to compare the guess with the actual number. If it's equal to the number, then it will go inside else. Otherwise, if guess is greater than the number, this will happen. If the guess is less than the number, this will happen. And if guess is neither greater nor lesser than the number, it means the guess is equal to the number, in which case it will go into the else statement. And since it is going inside the else statement, this will print. But we don't want this to happen just for one single time. We want this to happen again and again and again. So what we are going to do is we are going to run this inside a while loop, and this while loop will keep on running forever. And if it runs forever, we are never going to stop, and this will be a problem. So once the user guesses the number right, I'm going to break out of this loop. So what I'm saying is, I'm saying if you are able to guess correctly, we are going to break out of this loop. Okay, so this is what happens. Okay, so what I'm going to do now is I'm going to increment my attempt variable. Why do I increment my attempt variable? I want to increment the attempt variable because if the guess is not right, I want to say that attempt should be increased by 1. And let's see if this program works. I mean, I don't know. Let's see if this program works. I might have made some mistake. So it says that this one is too big. Let's try 34. It says this one is too less. Let's try 40. It says this one is too less, which means I need to increase the number. I'll say 45 this time. If I say 45, this one is too less, so I need to increase it. 49. 49 is too less as well. Is 52. Is 52 the number? No, 52 is too less. Is 54 the number? It says this one is too big. It means 53 should be the number. And yes, it says, yeah, that's the number. 53 is the number. You guys did right in 8 attempts. Did I took 8 attempts, or did I just, wrote the program wrong? This was my first attempt. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I guessed it in 8 attempts. And this is the program. Okay, this is the game. So how do two different people play this game and compete against each other? What you can do is you can make yourself play the game and note down the number of attempts you took to guess the number. And then you can ask your friend to play the same game, and you can note down the number of attempts he took to guess the number. And you can repeat this process 3 times. So this is one match. So there's a high chance that you and your friend guessed the number in say 4 attempts. So this is the first match. It tied. Then you can play the second match. It might not tie or it might tie. Then you can play the third match. It might tie or it might not tie. And you can play 5 different matches. Whoever wins more than twice, or whoever wins more than the other person, wins the game. And there is always a chance of tie. Even if you play it 51 times or 100 times or 200 times, there's always some probability that it will tie. That's a different story, but this is the game, and I hope you enjoyed this game. So I want you guys to play this game with your friends, because I know you have played Cyberpunk, you have played GTA, you have played GTA 5, GTA Vice City, you might have played Road Rash. I want you to play this game because this is something that you have created yourself, and you'll be proud of yourself when you make you and your loved one play this game. So this was about the project number 2. This is the project number 2 PDF. Download all the resources, including the source code, everything from the description. I'm saying this again and again because I'm supplying everything to you for free in the description. So you need to download all the material. Let's now move on to the next chapter, and we'll now talk about object-oriented programming. Object-oriented programming is really very important, and I want you to listen to me very, very carefully when I explain you OOPS concepts. So let's move on to chapter number 10 and see what OOPS has to offer. Let's now talk about object-oriented programming. Once again, one of the most important topics, hands down, and I'm going to explain this topic to you in great detail. And you need to listen to me very, very carefully if you are listening to me. What is object-oriented programming? It's a programming paradigm. Procedural programming is a programming paradigm. How is object-oriented programming different from procedural programming, and what makes it different? Why is everybody talking about OOPS concepts these days? Why is everybody talking about classes and objects? Why is everything being done using classes and objects when the complexity of the program increases? We are going to talk about this. So solving a problem by creating objects is one of the most popular approaches in programming. So one thing that we need to remember is that object-oriented programming is not something that you need to learn to accomplish something. Definitely you accomplish few things like clean code, better maintenance and all these things, but anything that you are going to do using object-oriented programming can be done using procedural programming, or something that we have already seen, like functions, writing lines of codes one after the other without creating any function, or using the modules altogether. Okay, but this is a concept, this is an approach of programming which makes few things easier. So this concept focuses on using reusable code. One of the concepts which was focusing on reusable code was functions. We talked about functions, okay, but this is something that takes it to another level. So what we want to do is we want to implement dry principle, and we want to keep everything organized. What we are basically doing in object-oriented programming is we are modeling our code using the real world implementation of something. So let us say I am into business of making cars and I want to model cars. I want to say have colors for the cars, different designs for the car, different types of handles for the cars, different types of steerings for the cars, different types of wheels for the cars. If I want to do all those things, what I can do is I can write a class for my car. So class is a blueprint for my car. So Maruti Suzuki 800 can be a class. Maruti Suzuki WagonR can be another class. Maruti Suzuki 800 represents one car. Maruti Suzuki WagonR represents another car. I can create more than 100 WagonRs using my blueprint. So Maruti Suzuki company should be having some sort of blueprint, and they must be using that blueprint to create cars for their customers. In a very similar way, what we'll do is we'll create a blueprint. You can think of blueprint as a blank form, and we can fill that form to accomplish few tasks. Let's see what it means. So let's talk about class. Let's talk about the concept of class in object-oriented programming. A class is a blueprint for creating objects. It's as easy as that. How do I explain this to you? Let me explain it using a blank form example. In front of you is a blank form, and this contains info to create a valid application. Let us say you are going to the railway counter and you want to get your bookings done. In India, we have to go to the railway counter, ask for the form, fill that form and give it to the counter. And once we give it to the counter, we can get a ticket to travel with Indian Railways. So in a very similar way, a form can be filled by a student. You can get a blank form, you can download the PDF from the internet, or you can do whatever it takes to get the blank form. Now what you do is you fill in that form using your details. You fill in your name, you punch in your age, you punch in your date of birth, you punch in your whatever information is required. You can punch in your marks in class 12th, 10th, marks in class 11th, what you want to apply for, where do you want to go for the exam, your center, and all those things. You can apply for everything, and whatever is being asked in the form. There will be fields in the form, you will have to fill those fields. Now this is not a blank form anymore because you have already filled this form. This is your application. You can call that this piece of paper is my application. Before filling that form, you can say that this piece of paper is a blank form. Now what you are going to do is you are going to say that this piece of paper is my application. So you have associated this word my with this form just because this form contains your details. Now, since this form contains your details, this form is yours. So this is an object, and the blank form was a blueprint. It was not associated with you. It was not representing anything meaningful. Now it is representing something which is really very meaningful for you, and it is your application. In a very similar way, we have class. Class contains info to create a valid object. Blank form contained the info to create a valid application. Why did you go for the blank form? Why didn't you go for a blank piece of paper? Just because that blank form contains all the fields you need to fill. In a very similar way, class contains the info to create valid object. And once you instantiate that object, you can look at instantiation as filling the form. Once you instantiate the object, this is an entity which you can work upon. Let's look into the syntax of class. Enough of talks. I'm going to look into the syntax of class now. I'm going to open this particular folder in Visual Studio Code, and I'm going to write a program 01 underscore class.py. Just look at this statement. What I'm doing is I'm saying class employee, and I'm saying name is equal to Harry. And what I'm doing is, I'm simply saying marks is equal to 34. The next set of things that I can possibly add to this implementation is, say, center, where I want to apply for the exam. I can say Delhi. Now what I can do is, if I run this program, nothing is going to happen, because what I've done is I've created a blank application. Just like we had this blank application form, this is a blank application form, and this is not going to do anything. Why do I say that? Because I have not instantiated any object out of it. This is a blueprint. This is information to create an object. This is not an object. What is an object? I can create an object called Harry. I can say Harry is equal to, I can say employee. Now I've created an object called Harry. It behaves like a variable, but what I can do is I can print all these fields like this. I can say Harry.marks, and once I say this, you can see that 34 is being printed. I can say Harry.center, and you can see that Delhi has been printed. I can say Harry.name, and definitely Harry will be printed. So you can do all these things using classes and objects. Okay. So this was very, very basic introduction of class, and this was the basic object. I can say a basic object, and here also I'll write a comment, a sample class, a very basic, and you'll come to know why I'm calling it a very basic sample class. I'm calling it a very basic sample class because we don't have instance variables, we don't have constructor, we don't have getters, we don't have setters. We are going to talk about all these things very soon. So this was the basic example of class. Okay, let's move ahead. Class name is written in Pascal case. So this is something that you need to keep in mind. So whenever you are naming a class, you don't have to, name the class using small letters. I could have used small e, then MPLOYEE, but I'm using a capital E because when we are creating a class or rather naming a class, what we try to do is we try to keep it in Pascal case. Pascal case means that the first letter of a variable is capital, and anything that goes after it is also started with capital. For example, if I have to write employee for, say, LG, I'll do it something like this. I'll say employee for LG. So E is capital, F is capital, L is capital. So this is called Pascal case. Okay. Let's now talk about object. What is an object? An object is an instantiation of a class. When class is defined, a template is defined. Memory is allocated only after object instantiation. What does it mean? So we had a blueprint, we had a class. This was a blueprint to create object. This was some information which can be used to create objects. What is an object? Harry is an object here. So Harry is an object. I could have created another object called Sham. I could have created another object called Ranjit, Rohan, or anything. I can even, I can even say something like this. A is equal to employee. And this is a valid syntax. I can create any number of employee using this employee class now. And these all the employees that I'll create will have all these name, marks, center, set. Okay. So this is something that we can do. But Once we create a class, what happens is only the memory for storing this code is reserved by the interpreter. But when we create Harry is equal to employee, memory for this particular object is reserved. So all the storage which is required to store name, marks and center for this particular variable is reserved by the interpreter. So this is something that you need to remember, and this is what I'm saying here. An object is an instantiation of a class. When class is defined, a template is defined. Memory is allocated only after object instantiation. In this case, the moment I write Harry is equal to employee and run this code, the memory is allocated at line number 7. But if I don't write this, memory will not be allocated for Harry object. Only this blueprint will be defined, but as and when we create this object, the memory will be allocated. This is something that we need to remember. Objects of a given class can invoke the methods available to it without revealing the implementation detail to the user, and this is called abstraction and encapsulation. What I'll do is I'll create a sample method inside this class for you, and I'll show you how it works. But let's move to another program just to keep things simple. I want you to refer to this program and look at just this piece of code so that it's easier for you to understand what a class is. So I'll say class with methods.py, and I'm going to start from here. Let me save this code. Let me save this one as well. And let's add a method here. So I'll simply say def print, and this by default takes self. Okay. Now what I'll do is I'll simply say, or let me call it print obj, because print is already a built-in function in Python. I'll say def print obj self. Now what I'll do is I'll say print, I'll use an F string. I'll say the name is self.name. Can you see this implementation of self? And I'm going to explain to you what self is. And let's just print the name. I could have printed marks and center as well, but I'm not doing that. I'm just keeping it simple by printing just the name. So now what I can do is I can say harry.printobj. And let's see if this piece of code actually runs. So I have not called the function. Since printobj is a function, I need to call it like this. Now if I run it, you can see that none has been printed because this particular thing doesn't return anything. So I should not print it because I'm not returning anything from it. If I'm returning something from it, I can print that thing. But if I'm not returning anything, I just need to call it and it will be invoked. So the moment I say harry.printobj, this particular piece of line is invoked and this function is returning nothing. I could have added a return statement and returned something, but I don't want to do that. Okay. So harry.printobj will actually print this line of code or rather this line of text. This name is Harry. Okay. So I hope you got the point. I hope you understood what methods inside a class is and how they work. But let's talk about this self a bit more. The moment you write a function inside a class, you need to add this self. You need to add self as a parameter. Why do you need to do that? Why do you need to add self as a parameter? Let me tell you. What happens is the moment you are running this function on some object, definitely if you are creating an object, you will run this function only on that object. You cannot run this function as is by simply saying print obj. If I say something like this is not valid because print obj will not work like this. If I write something like this is going to throw some error. You can see this is saying that print obj is not defined. I can call this upon an object, but I cannot call it like this. So I need to define this function. I need to add this self so that I can use all the properties of my class or rather this object. And yes, then I can operate this print obj inside that object. Okay. I hope you got the point. Now what I'm going to do is I'm going to move further and talk about abstraction and encapsulation. The moment we create a class employee, we are basically abstracting any information from somebody who might use this class. So I can give this class as code as a service. You don't have to know what is written inside the code. You just use it. I can simply say that employee is a class. You can use this to instantiate a basic class and use these methods. These are the available methods. And you don't have to understand how I have written this class. A very good example of this is NumPy. let's talk a bit about NumPy. So if you go to NumPy, NumPy gives you few syntax to write arrays in Python. So they simply tell you that we have these functions, you can use this class, this, that, another, but it doesn't tell you how it is implementing all these things behind the hood. And it should not tell you all these things because you are not interested in all those things. You are simply interested in how you are implementing or using the offering from NumPy. So you want to create an array, you are only interested in creating an array. For example, if I'm using a software to merge two PDFs, I don't care how they are merging the PDFs. I just need my PDFs merged. When you're using Facebook, you don't care how Facebook is storing your data or how Facebook is working behind the hood. You just want to talk to your friends. You just want to send messages. You just want to update your timeline. That's all you are interested in. In a very similar way, a user might only be interested in using your code and not knowing the detailed implementation of your code. And this is called abstraction. And when we say encapsulation, basically what I'm doing is I'm encapsulating all these variables and functions inside a single capsule, or rather inside a single class. And this process is called encapsulation. I hope you understood what encapsulation is. Modeling a problem in OOPS. Now, this is something that you need to understand. How do you model a problem in object-oriented programming in Python? So what we do is, in order to model a problem in object-oriented programming, what we do is we identify the following for a problem. What is a noun in a problem? What is the adjective in a problem? And what is the verb in a problem? Let us say I want to model employee. Okay, the name or the noun is actually the class name. So in most of the cases, this is not something which will fit in as is in your programs or in your problems, but in most of the cases this works. So you find out the noun in your problem. In my case it was employee. Then you find out adjectives, and they are going to be the attributes in most of the cases. For example, name, age, salary, and then you find out the verbs. And once you find out the verbs in your program, get, salary, increment, they will usually be the methods. So noun will map to the class name, adjectives will map to the attribute names, and verbs will actually map to the method names. And this works in most of the cases. This is a thumb rule. This is not something that will, work as is for all the problems. This is not some sort of, magical problem modeler. You just simply look into this, find out the nouns, find out the adjectives, find out the verbs, and try to map this particular format in your problem. Let's talk about class attributes. And a class attribute, or rather an attribute that belongs to the class rather than a particular object, is called class attribute. In my case, name is mapping to the class. This is not unique for an object I'm creating. I can create Harry, I can create Shyam as another object. And I can say Harry.marks, Shyam.marks, and they are going to work. Okay, Shyam.name will also give me Harry. Okay, but what if I want to set Shyam.name is equal to Shyam? I should be able to do that, right? But in this case, I cannot do that because these three variables are actually part of this class and not part of this object. So a class attribute is something that belongs to the class and it doesn't belong to the individual objects. In this case, class employee company is equal to Google. This is specific to each class. So even if you create an object called Harry, or if you create an object called Rohan, Harry.company or Rohan.company is going to give you Google, no matter what. Okay. But you can actually change the class attribute. So I can actually change the class attribute. Let's try to change the class attribute. So in order to change the class attribute, let me create another program. Class attributes .py. Okay, let's copy this code and let's paste it down. So I have an object called Harry, I have an object called Shyam. I can print Harry.name and I can also print Shyam.name. So let me print Shyam.name, print Shyam.name. So if I print Harry.name, I'm going to get Harry. If I'm going to print Shyam.name, I'm going to get Harry again. What if I want to change Shyam.name? Let me change it Shyam. Okay, let me change it to Shyam, and if I do this, what happens is this is going to set an instance variable for Sham. I'm going to explain to you what instance variable is, but now if you print sham.name, it is going to print Sham. Let me show you. So Harry, Sham, and if you print Harry.name, it will show you Harry. As you can see, Harry, Sham, Harry. Okay. Now this particular thing is not changing the class attribute. This is something that you need to remember, and you might get confused at this, but let me explain to you what instance attributes are, and then we are going to be mapping class attributes with instance attributes, and we'll understand both of these, or rather the attributes concept together. This is very important. This is something that you need to listen to me. So here, if you want to change the class attribute, you should not use object. You need to add employee.company is equal to YouTube, and then this will change the class attribute. Let's talk about instance attribute, and we'll come back to the class attributes. What is an instance attribute? An attribute that belongs to the instance and not to the class is called instance attribute. What is an instance? Instance is nothing but the object that we are creating. In this case, Harry is an instance, Sham is an instance. Okay. So an attribute that belongs to the instance is the instance attribute. Assuming the class from the previous example, so I created a class employee and I created a variable called company. If I say Harry.name is equal to Harry, or Harry.salary is equal to 30k, this is actually adding instance attributes. So instance attribute is different from class attribute. Here what I did was, here name was a class attribute. Let me write it here. Name is a class attribute. And here when I'm saying sham.name is equal to Sham, I'm actually setting an instance attribute. I'm actually setting an instance attribute to Sham. What is an instance attribute? Instance attribute is personal property of this object. It is a personal property of this object. It is not the property of a class, but class attribute is personal property of a class. And since this object is being instantiated from this class, this will import all these things. So this will get all these name, marks and center from this class. So when I say Harry is equal to employee and Sham is equal to employee, I'm creating a very basic object out of class employee. If I say Harry.name, the first thing it does is it tries to see, or it looks up for instance attribute named name. Is there any instance attribute for Harry? What is an instance attribute? Personal property of the object. This particular object has no personal property called name. The next thing it will do is it will say, okay, you don't have any personal property called name because it has never been set. It will say, let me look at the personal property of your parent class, or rather your class, the class that created you. So employee created Harry. Harry was created by this employee class and it had this name called name. So it will say, okay, you have a class attribute. Let me print that class attribute for you. The same will go for this one. But the moment I say sham.name is equal to Sham, this will set an instance attribute to Sham. Now Sham has a personal property called name. This name is Sham's personal property. And this is this employee's personal property. So the moment I say print sham.name, the first question which will be asked to Sham is, do you have a personal property called name? Sham will say, yes, I do have. So what will happen is sham.name will actually print Sham. Now the moment I say print Harry.name, the first question which will be asked to Harry is, do you have a personal property called name? No, Harry doesn't have any personal property called name. It will say, okay, let me go to your class and ask to that class the same question. Do you have any personal property? The class will say, yes, I do have. This name is equal to Harry. It is my class attribute. So this class attribute will be printed. This is setting an instance attribute. What if I want to set a class attribute? What I can do is I can do something like this. I can say employee.name is equal to Harry new. Okay. The moment I do this, this particular property, which is a property of the class, will change. So from Harry, it will change to Harry new. And the moment I run this program, I'll tell you what is being printed and why. The moment I say print Harry.name, Harry didn't add any personal property at this point. Till this point, Harry didn't add any personal property and Sham also didn't add any personal property. So personal property of employee class will be printed, which is Harry new, Harry new, Harry new. But the moment the program reaches line number 16, Sham has his personal property or the instance attribute called name. Now if I say Sham.name, Sham will be printed. And if I say Harry.name, this particular thing will be printed because Harry doesn't have any personal property or personal instance attribute or the attribute which is specific to Harry called name. So employee's name will be printed, which is not Harry. It was Harry until line number 10, but it was changed to Harry new at line number 11. So Harry new will be printed once again. I hope this is clear. And if it is not, I insist you watch the entire thing that I talked about, these instance and class attributes once again. You can rewind the video and watch it once again because this is something that I've explained in great detail now. So coming back to the example from the notes, I created a very basic class. If I say employee.company is equal to YouTube, it will change the class attribute. If I say Harry.company is equal to something, it will change Harry's personal thing or rather Harry's instance attribute. Okay, you can try this out. You can write few code and you will understand this. Instance attributes take preference over class attributes during assignment and retrieval. This is something that you need to keep in mind. If you say Harry.name is equal to something else, instance attribute will take preference and instance attribute will be set and not class attribute. In order to set the class attribute, you write something like this. And let me write this comment. Setting a class attribute to employee for employee. Setting a class attribute for employee. This is something we are doing here. Okay. So Harry.attribute1 is attribute 1 present in object is the first question which is asked. Is attribute 1 present in class is the second object which is asked. So if you have an object called Harry and you are trying to print or you are trying to set attribute 1, the first question which is asked is, it will say, is attribute 1 present in object? If yes, it will be printed. If it is not present in the object, then it will be looked up in the class and that will be printed. So first preference is always for instance attribute or the object's personal property, then it will go to the class. If you have your pen in your pocket, you'll use that pen. So first priority will be you are using your pen, your own pen while giving your exam. But if you fail to, get a pen to the examination hall, in which case this is really very pathetic, you should get your pen. But for some reason, if your pen doesn't work or you forgot the pen or somebody stole your pen while you were about to write the exam, the next preference is you'll ask your classmates. You'll say, hey, class 2, do you have another pen? Can you give me another piece of pen so that I can give my exam? This should not happen. You should always keep back a pen, but I'm just giving you an example to explain instance attributes and class attributes. Okay. So this was really very easy and straightforward. You should not ask any more questions. And if you have any more question, I insist you to rewind this video and watch this thing all over again. This is really very simple and easy. Self parameter. Let's talk about self parameter. Self refers to the instance of the class. So self parameter is something that we have already used. So self dot something actually talks about this particular object on which this method is being called. Let me explain this to you once again. When I say Harry.print obj, self is actually Harry. Self is what? Self is actually Harry. Let me tell you what this Harry.print obj is converted into. This is actually converted into employee dot print obj Harry. This is something what this particular line means. And let me show this to you. Let me run this for you and show you that these both things mean exactly the same thing. So if you say Harry.print obj, yes, you can say that, but this is as good as saying this. And this actually explains why you need this self here. I could have written self this, and I could have written self this here as well, and this would definitely work. Okay, let me show you. So self is not something that you need to use as is. This is a good convention. People are using self since a very long time. This is another thing. But when you are saying print obj, or rather Harry.print obj, what you are basically saying is you are saying employee.print obj and that particular object. So you can say Harry.print obj or you can say employee.print obj Harry. these two things are exactly the same, and this is converted to this particular thing, line number 18, which is why we need self here. So Harry is passed as self to this method, and this method will run, and self will be this particular object, this Harry object. Okay, I hope I explained it to you very well. Okay, so self refers to the instance of the class. It is automatically passed with a function call from an object. So if you say Harry.getSalary, it is equivalent to saying employee.getSalary Harry. I just showed this to you, and here self is actually Harry. So when you're passing this particular object to this particular method, this object is passed to this method as self. So the function getSalary is defined as class employee company is equal to Google, this particular thing. And when you say Harry.getSalary, you're not saying Harry.getSalary. You are basically saying employee.getSalary Harry. So you're saying go to the getSalary method from employee class and pass Harry as self. So now if you say self.company, it will be Google. Okay, so self.company will mean Harry.company. If you have changed Harry.company, then something else will be printed. But if you run this method as is Harry.getSalary, this particular thing will be printed. Salary is not there, or whatever you want to print. Okay, it will depend on the implementation. Let's talk about static method. Sometimes we need a function that doesn't use the self parameter. We can define a static method like this. You can use the static method decorator. And what is a decorator? Decorator simply mark this method as a static method. So when you are saying @static method, you are simply saying that this method doesn't require any self, and this method can be used as is without any object. Okay, let me show it to you and let me explain why we need static methods. Let us say you have a very complex class and all the methods of your class are using any object, some or the other object. Okay, so in this case print obj is using an object. You might have something else, you might have increment salary or something, and increment salary might use the object. So, and in most of the cases it will definitely use the object, because if you are saying Harry dot increment salary, you are basically incrementing salary of Harry, so you need to perform some sort of operation on Harry object. But sometimes what we need to do is we sometimes need to write some code where we are not doing anything with the object, but rather we are doing some basic thing. For example, let us say I want to write a greet method, and all I want to do is to say good morning. That's all, or rather good day. Not good daru, good day. Now since this method is not using any object, I can simply say @static method, and what I'm basically saying is I'm saying this method doesn't require any object. So you can call it using the object. You can say Harry.greet, or you can say employee.greet. Both of these will work. Let me show it to you. So the moment I run this program, you can see good day is printed. Okay, so this is called static method in Python, and you can actually mark your static methods like this. This is a decorator to mark static methods. I hope you got the point. Let's now talk about constructors, and constructors are really very important things for a class. They are a very important constituent of a class, and you need to learn about constructors. And constructor, or rather __init__, we call it dunder init, is a special method which is first run as soon as the object is created. So the moment you instantiate your object, this method is called. And what you can do is set your instance variables using this constructor. So you can use __init__, which is a special method which is first run as soon as the object is created. This method is also known as constructor. So you can call it dunder init. If you call it __init__, this is going to sound really very odd. Just call it dunder init. It takes self argument and it also take further argument. So let me show you an example and then we'll implement this in code. For example, if I have an employee class, I can say self, and another thing that we can pass to this dunder init is name. I can write self.name is equal to name, and this will set name for this employee class. This is a bit difficult to understand using just the theory. So we are going to go to Visual Studio Code and we'll implement this in code. So let's go to Visual Studio Code and write constructor.py. I meant to write constructor.py, and I'm going to create an employee class which I have already created. I'm going to remove all this. We have name is equal to this. I'm going to get rid of all this, and what I'm going to do is I'm going to say def, and I'm going to write dunder in it. Okay, I'm going to remove this. I simply want to write this this particular constructor. I'll pass in name. I'll pass another attribute as well, which is going to be marks. And I'll say self.name is equal to name is equal to name. And same thing goes for marks as well. And now if I say Harry is equal to employee, I can pass this name Harry, and I can pass Harry's marks. And now what I can do is I can call this method harry.printobj. Let me update this printobj. I'm saying the name is this, the marks is self.marks. Okay. So this is something that we are interested in. Let's run this code. The name is Harry, marks is 34. I can even create another object called Rohan, and let's set Rohan's marks to 94. Rohan is a good boy, so he is actually scoring 94 marks. Let's see if this works. So for Harry, it prints the name is Harry, the marks is 34. And for Rohan, it prints name is Rohan, marks is 94. You can have any number of attributes. These are instance attributes. I just want to point this out because these are not class attributes. The attributes that you are setting inside constructor are instance attributes. And something you write here will be class attributes. So if you say name is equal to not known, I need to write it as string. If I say name is equal to not known, or let me call center is equal to not known, and if I print center, self.center, this will actually print not known for Harry and for Rohan. It's not known. Marks is not known. Sorry, center. I need to change this to center. Center is not known. Center is not known. Center is a class attribute. These two are instance attributes. These are class attributes, the self.center for Harry and for Rohan, because we have not set instance attributes which is named center. Okay, so this particular thing is being used. The moment I create a center, let me call this self.center is equal to center, and I'll have to add this here, center. So employee Harry 34, employee Rohan. I need to add a center. Let me say center for Harry is Delhi, and for Rohan it's Kolkata. Let me run this code now, and you can see center is Delhi, center is Kolkata, because we have instance attributes set this time. Coming back to the nodes, class employee, I'm setting self.name is equal to name. This is setting the instance attribute, the name instance attribute, and you can use harry.name to print that instance attribute. Okay, so object can be instantiated using constructor like this. You can pass these values, and the first thing that gets called is underscore init or dunder init or constructor. Okay, so this was a story of constructor. This was a story of classes and objects, and I hope I was able to explain you classes and objects in great detail. Now, as part of the next step, do one thing: download all these notes. These notes are really very important and valuable for you. We'll go to the practice set and we'll see chapter 10 practice set, and we'll see what sort of questions are mentioned there and what they have to offer for us. Chapter 10 practice set is going to be very important. I want you to come to chapter 10 practice set and listen to all the questions, or rather the techniques I use to solve those questions very, very carefully. Let's move on to chapter 10 practice set now. Let's now look into chapter number 10 practice set. And yes, oops is important, which is why we are going to look into all these questions very, very carefully, and we are going to solve all these problems. Let's move to the first question. But before that, what I'm going to be doing is I'll open Visual Studio Code and I'll be creating another file 05 underscore pr01.py, and let's solve this problem. What does this problem say? It says create a class programmer for storing information of few programmers working at Microsoft. So I'll simply say programmer, and we just have to store information about these programmers. Let's create a constructor, or let's not do that. Let's say that type language is equal to language. What am I doing? Let's create a constructor def underscore underscore init. Okay, so let me tell something here, and I just want to throw some light on this one. See, sometimes the question that your interviewer asks, or even if it is asked in some exam, it is quite vague, and you just have to infer a few things. If the question is vague, instead of complaining about the question or criticizing the question or saying that the question is wrong, all you have to do is you simply look into the question, see what things you can assume, and just proceed with the question. If you're confident enough that question is missing something, then you should definitely solve the question assuming what you think is missing. You might be wrong, you might be correct, you might not understand the question altogether, but in all these cases, assuming few things which you think are missing, I think that is the best deal. That is the best you can do. So you should always do that. In this case, it is not told whether you need to create a constructor or not. I just have to store information of few programmers. I'm going to add name as well. So name should be before language. So I'll simply say name, and let me type self dot name is equal to name, and let's instantiate few objects. So what I'll do is I'll say Harry is equal to programmer, not process lookup error, programmer, and I'll enter the name. So I'll say Harry. I'll enter the language, which is Python, and I'll do the same for other programmers, and you got the point. You can add a method and you can do a lot of things. Okay, so I'll say Java, and I'll say print rohan.name, and I'll do the same thing for Harry as well. And yes, we are able to store the information about the programmers, and that solves the question. Okay, let's move on to the next question, which says write a class calculator capable of finding square, cube, and square root of a number. So we need to write a class called calculator. So let me create another file for this one, pr02.py, class calculator. And once I do this, what I'll do is I'll simply write three methods, square, cube, and square root. But before that, what I'll do is I'll create a constructor. I'll say self dot number is equal to number. Okay, and I'll simply say number. This is nothing but the return type, and I just don't want to use it at this point. But what I'll do is I'll create square. I'll say self, and after saying self, what I'll do is I'll say return self dot number multiplied by self dot number, and this is a square. Same thing goes for cube as well. I'll say self dot number multiplied by self dot number multiplied by self dot number. This is cube. And yes, you can implement the same thing for square root as well. So let's implement square root as well. In order to do that, what I'll do is I'll create a method called square root. Let me make it camel case. Camel case means first letter of the word will be a small letter and remaining letters will be capital. So square root, R will be capital, the S will be in lowercase. And if I was to enter the same thing in Pascal case, I would have changed this S of square to uppercase. Okay, I hope that makes sense. Let's now implement square root. What I'll do is I'll import math class. So math is a built-in module in Python, if you know that. I'll say return math dot sqrt, not match, math dot sqrt self dot number. So we have square, we have square root, we have cube. Let's try few numbers. I'll say 2 is equal to calculator 2. Let's print 2 dot let's print 2 dot number, then we'll print 2 dot cube. Let's print 2 dot square, and let's print sqrt. I want you to tell me, will these three lines, line number 18, 19 and 20, print cube, square and square root of these numbers or not? Just enter your answer in the comment sections as yes or no, as plain yes or no. I don't want any explanation. I just want you to tell me whether this will print the square, cube and sqrt or not. I'll wait for your comments. Just put the timestamp of the video so that I can see your comment, and just comment below whether it will print or not. Okay, so spoiler alert, I'm telling the answer. It will not print cube, square and square root because I have not called the function yet. So I need to use these parentheses in order to call the function. So I'll have to run this, and it says, okay, so another reason why your answer should be no is that sqrt was spelled wrong. Okay, anyways, that was a minor one, but you can see that cube of 2 has been printed, square of 2 has been printed, and square root of 2 has been printed. You can try this out with other numbers as well, and you got the point. We have solved the question. Moving on to the third problem, create a class with a class attribute A. A will be the class attribute. Then it says create an object from it and set A directly using object.a is equal to 0. The question says, does this change the class attribute? The answer is no, it doesn't. It doesn't change the class attribute, because when I say object.a is equal to 0, I'm basically adding an instance attribute. I'm not changing the class attribute. In order to change the class attribute, I'll have to write the class name dot a is equal to 0. That will change the class attribute. So let's try this question out. I'll say 07 underscore pr03.py, and I'm going to create this class. What is the name of the class? It says create a class, no name. I'll simply say my class. I'll simply say a is equal to say 0 or rather 9, and let's create an object of this class. I'll say object is equal to my class, then I'll say print obj.a, and what I'll do is I'll simply say obj.a is equal to 0. This line will print 9, but this line will print 0 because I have set an instance attribute. Let me write it down here. I am setting an instance attribute by doing this. Okay, this is something that you need to know. Let's run this code and you can see 9 and 0. But this doesn't change the class attribute A. Class attribute is still 9. So if I were to print my class.a, this will print 9. And let me show this to you. This is going to print 909. So this is something that should be crystal clear to you at this point, because this is super important. Now coming to the next question, add a static method in problem 2 to greet the user with hello. And we have done this already. We have done this while we were discussing object-oriented programming. I want you to try this out on your own, and definitely you will be able to do this. Question number 5 says write a class train which has methods to book a ticket, get status and get fare information of trains running under Indian Railways. Okay, so this question sounds really complicated, but it is actually not complicated. So write a class train which has methods to book a ticket. So you can have class train. Let me solve this for you and prove that this is not a very difficult problem. So I'll say PR0, I'm not sure, I think it's 6, and it's not 6, it's 5. Okay, so let me change it to 5. I'll change it to 5. PR05.py. I'll simply say class train. Let's add a constructor and let's add the methods. So I should have the methods to book a ticket, get the status and get fare information. So book ticket, get status. Book ticket and get status are two methods. So I'll say def book tickets, and yes, I need to write self and get status. Def get status self, and then get status and then get fare information. So get fare info, pass. Okay, let's do this. Book tickets, get status, get fare info. and the implementation will depend actually on what you are doing and how you are doing, how I'm getting the fare information, how I'm getting the status of the number of seats, and how do I book the ticket. I should have some method to reach out to Indian railway servers, which is really very complicated. So here what I'll do is I'll say seats is equal to 78. I've simply created a or rather what I'll do is I'll not do this. I'll create a self.seats is equal to 78. Let us say there are 78 seats, and once you book the ticket, what happens is self.seats is equal to or minus is equal to 1. Okay, so simply I'm decrementing 1 from the number of seats once you book a ticket, or let me call it book ticket. Get status simply prints the seats, print self.seats, and get fare info, I'll say print self.fare. Okay, and let me keep it simple. Let me say the cost of a ticket is 175 rupees, and you can say tr is equal to train, and I'm not passing anything to the constructor to keep things simple, but you can always pass the seats and fare as variables. You can do it yourself. You can add seats and fare as parameters to init, and definitely it is going to work. So tr is equal to train, and what I'll do is I'll call tr.getFareInfo. This will simply print the fare, and then I'll say tr dot get status, and then tr dot book ticket, and then tr dot get status, not fare info. I need to get status. So why I'm calling this get status twice is because I want to check whether this is actually decrementing the number of seats or not. Let's call this and let's see the status. So the get fare info is printing 175, get status printing 78 because there are 78 seats. I have booked the ticket, so I have reserved 1 seat. So now if I run get status, I should actually see 77. I should see the total number of seats minus 1. Okay, so this is how this works, and we have solved this problem, and this problem was easy, wasn't it? Can you change the self parameter inside a class or something else? Say Harry. Try changing self to SLF or Harry and see the effects. I have already told you this. You can change the self to SLF. You can change this self to Kareena Kapoor. You can change this self to Angelina Jolie. You can change this self to Katrina Kaif. You can change this self to Harry. And this is not going to harm your program in any way, provided that you are referring to the self inside this method as Harry. So inside the init, I'll have to replace all the selves with Harry, and then it will work as expected. Let me save this code. Let me run this code. 175, 78, 77. So you can change the self to Harry, but it's not a good idea. So I'm going to revert it back to self. And this solves the question. So the answer to this question is yes, you can. You can change it to something else, but you'll have to change it in the entire function. And try changing it to the self to SLF. I've changed it to Harry. You can try SLF. It will also work. And the effects are nothing actually changes. Only thing is readability of your code reduces, and we don't want that. You can use SLF, but SELF is something that everybody uses, and it makes your code readable because other code bases are using self, and you are used to seeing this self written in the code, and you should write self. Okay, so I hope this answers all the questions, and we have solved all these questions on object-oriented programming. I hope you enjoyed this practice set. So we'll now move on to the next chapter. We'll look into some advanced Python stuff, but before that we'll look into inheritance, and we'll look into how these things work with object-oriented programming concepts. So let's move on to chapter number 11 now. Let's now move on to chapter number 11 now. This is going to be fun because inheritance is one of the most important topics when it comes to Python, and I feel that inheritance makes understanding of OOPS concepts a lot easier because things starts making sense all of a sudden when you understand inheritance. You'll understand more about object-oriented programming, and it will help you a lot. Let's look into what inheritance actually is, and then we'll look into more topics in object-oriented programming. Inheritance is a way of creating a new class from an existing class. Just like you are son of your parents or daughter of your parents, in a very similar way, a class can be a child class of a parent class. That might sound weird to you, but this is what it is. For example, you can have an employee and you can have all the methods and attributes inside a class named employee. We call it a base class, just like we call somebody parent when they have children. We call a class as the base class. And when we derive a new class from the base class, what it means is the base class will give everything it has to the child class, and child class will have some more things on its own. Let me explain this to you. Employee is a class. We have some code. We have some implementations inside class employee. What we'll do now is we'll create a class programmer. We'll use the syntax. We'll say class programmer. Inside the parenthesis, we'll name the class employee, and then we'll write some code here. This is the derived class or child class. Now this thing might sound a bit strange at a first glance, but let me tell you something. Once you start creating some child classes, you'll get a hang of it. So let's move ahead and create a child class from a parent class. What I'll do is I'll close this folder from VS Code and I'll open this particular folder. So let me open this folder in code and let's create a first file, child.py. So we are going to use inheritance here. Let's write the code from my notes. Let's say class employee, and I just want to say a is equal to say 34. And now what I'll do is I'll say class programmer. I want to use employee, and then what I'll do is I'll say b is equal to 34. Now if I say pr is equal to programmer, and if I say print pr.a and pr.b, I will actually be able to print a as well as b. So let me change this b to something else. You can see that when I say pr.a, 34 is printed. When I say pr.b, 32 is printed because the value of b is 32 here. What if I try the same thing using the employee class? What if I say em is equal to employee and then print em.a and em.b? If I say print em.a, then yes, you'll see 34 from here. But if I say em.b, there's no b in employee. Employee just have a single class variable, which is a. And you can see that this particular piece of code throws an error because employee doesn't have any b. So it says attribute error. Employee object has no attribute b. It is saying, I don't know what b is. What are you talking about? Okay. So this is something that Python interpreter is saying to us. And I should get rid of this error, and I should type a comment here just to tell you that this line throws an error. Okay. Now if I run this program, this line has been commented out, so this will no longer throw an error. I hope you understood how extending of classes using inheritance works. So this is also called extending classes. So I'm extending class programmer from class employee. Okay, so this is something that you need to add to your vocabulary. We can use the methods and attributes of employee in programmer object, as we just saw. I showed you a live demo of that. Also, we can override or add new attributes and methods in programmer class. We can definitely do that. We can definitely have some more methods here. We'll get all the methods from employee plus the methods that we manually add here. Okay. Now there are three types of inheritance: single inheritance, multiple inheritance, and multi-level inheritance in Python. Now single inheritance is the most straightforward form of inheritance. It occurs when child class inherits only a single parent class. So we have a base class, we have a derived class, and we are simply using the base class to get the derived class. And this is a classic example of single inheritance. We have a class employee, we have a class programmer, we are using the employee class to create the class programmer, and we are getting all the methods and properties of class employee in the class programmer. We have already seen this in action. We'll see another thing in action, which is multiple inheritance. Multiple inheritance occurs when the child class inherits from more than one parent class. Let us say we have parent 1, we have parent 2, and we are creating a child class from these parent 1 and parent 2. We can even have a parent 3. and the syntax will definitely follow. But let me create a file here, multiple.py, and here I'm going to demonstrate multiple inheritance. So let me create a class parent1 and I need to use Pascal case. I'll say a is equal to 4, and let's do the same thing for parent2 and also for child. So I'll say child, we'll use parent1, we'll use parent2, and let me change this to parent2, let me change this to b is equal to 2, let me change this to c is equal to 9. And yes, if I say ch is equal to child, and if I say print ch dot a, print ch dot b, and print ch dot c, this will actually work because child is getting a from parent1, b from parent2, and c on its own. Okay, so let me run this program for you and let me show you that this actually prints ch dot a, b, and c. I actually selected something and ran accidentally, which is why it created temp code runner file. So I'll delete this temp code runner file, I don't need it. So sometimes when you select a piece of code and you run it, it actually creates a temp runner file and it puts the selected piece of code inside that temp code runner file, and it executes it. It's a bit annoying, but I'll just simply run this program from here. You can see 4, 2, and 9 has been printed because the value of a is 4, b is 2, and c is 9. Pretty straightforward example, isn't it? Let's come back to the notes. We understood multiple inheritance. It occurs when the child class inherits from more than one parent class. Let's now look into multi-level inheritance. So when a child class becomes a parent for another class, it simply causes multi-level inheritance. Let me explain this to you. So we have a parent, we have a child 1, we have a child 2. Parent can be your grandpa, child 1 can be your dad, and child 2 can be you. This is a very classic example of multi-level inheritance. I'm just trying to explain it using some real-world examples. So let's create a file called multilevel.py, and we'll copy everything from here. So we'll say C1, we'll say C2, or let me follow the notes. Parent, child 1, child 2. I'll follow the note. Parent, child 1, and child 2. So this is child 1. Child 1 is actually using parent, and child 2 will use child 1. So I'll create an object of child 2 and it should have access to A, B, and C. Let's run the code and you can see that it has access to A, B, and C. If I create an object of child 1, it will not have access to C, which is why this particular line will throw an error. Let me show this to you. It says that child 1 has no attribute C, but child 1 has an attribute B, it has an attribute A, it doesn't have an attribute C because it has never seen C is equal to 9. Okay, so let me revert it back to child 2 so that this example actually works when you try to run it. This is how multi-level inheritance works. So this was a basic example of single inheritance, multiple inheritance, multi-level inheritance. So this is something that is used a lot in the industry. People say use multiple inheritance to solve this problem, or they simply say in between of a huge sentence, they simply say that I am using multi-level inheritance to actually do this. And if you don't understand what multi-level inheritance means, you might face trouble understanding what the other person is saying. Okay, coming back to the notes where we left off, super method. What is this super method? Super method is used to access the methods of a super class in the derived class. So let us say we have a derived class, we have a base class. Now I want to call the constructor of the base class. So let me demonstrate this to you using a program. I'll simply say 04 underscore super.py. Let me do one thing here. I'll create constructor for all of these classes. I'll say parent. So we have a constructor for parent. We'll have a constructor for child 1. Child 1. We'll have a constructor for child 2, And inside the constructor, all I'm doing is I'm simply printing child1, child2 as is. So using a constructor like this doesn't make any sense, but I'm using it for the example's sake. So we have two constructors, three constructor for parent, child1 and child2. Let's run this code and see what happens. So you can see that child2 has been printed, but no child1 and parent has been printed. What does this imply? This simply implies that the constructor of this particular class has been called and the constructor of child1 and parent is not called. If you want to call the constructor of child1 from child2, what you can do is you can do something like this. You can use a super keyword, and after using the super keyword you can do something like this, and this will actually call the constructor of child1 as well. So let me show this to you. So the mistake that I've committed is I need to write it like this, and now this will definitely work. So if I run this, child1, constructor of child1 has been executed and the constructor of child2 has also been executed. So this was executing even before, but now since we have added a call super.init, this particular constructor is also getting executed. So if I add another call like this, if I say super.__init, if I do something like this, the constructor of parent will also run. So you can see child1, parent, child2. This is the order in which these constructors are getting called. So first what happens is child2 constructor is being called, but this particular function says that first you resolve this particular call, and after you resolve this call then we'll print child2. It will say okay, let me resolve this call. While resolving this call it printed child1, so child1 has been printed so far. Now what happens is it says that before going back you have to resolve this call. This call simply returns parent, prints parent. So this will print parent and then finally this child2 is printed. So just like a regular Python program, this Python program or rather these set of statements are being executed. Okay, so I hope you understood what super keyword does. Super method is used to access the methods of a super class in the derived class, and this simply calls a constructor of the base class. Okay, now what we are going to do is we are going to understand what class methods are and why we need class methods. Okay, so let me give an overview to you and then we'll see what is written in the notes. So when you are using some class attributes, and what you are essentially doing is you are simply altering or playing around with those class attributes. You don't need the object upon which that particular method is being called. All you need is the name of the class. Okay, in order to use or rather implement this effectively, we use class methods. So let's come to the notes and see what class methods has to say. A class method is a method which is bound to the class and not the object of the class. So this particular method is bound to the class and it's not bound to the object of the class. It has nothing to do with the object. It has to do with the class. So we are using the class attributes when we are implementing the class methods. This is a decorator that is used in Python, @class method. This decorator is used to create a class method, and this decorator can essentially mark your method as a class method. Let's write a class method and let's write the syntax of class method. I have added syntax of this class method inside the notes just so that when you come back to these notes after say 3 months or 4 months or 10 months, you should have a clear-cut idea of what this class method is and how the syntax of class method looks like. So let's create a program 05_class method.py, and what we'll do is we'll say class employee, and what I'm going to do is I'm going to say a is equal to 1, b is equal to 4 and c is equal to 6. A, b and c are class attributes. A, b and c have nothing to do with any object. Now what I'll do is I'll add a decorator class method. No space, simply the class method. I'll say CLS method, and the first thing that I pass is CLS, and then I'm going to pass A, B and C. Now what I'll do is I'll simply say CLS.A is equal to A, and the same thing for B and C. So I'm going to say CLS.B is equal to B and CLS.C is equal to C. Okay. Now if I instantiate an object from this class, I say emp is equal to employee, and if I say emp dot cls method, or rather I want to call it set attribute, I want to call it this because it is essentially setting the attributes, and I say 1 2 3, this should set my attributes A, B and C to 1 2 and 3. So now if I print employee dot A, employee dot B and employee dot C, it should give me 1 2 and 3 instead of 1, or rather 10 4 and 6. So let me make this B, I'll make this C, and I'll print these A, B and C values before calling this method as well. Okay, so I'm calling these, I'm printing these attributes before calling this method as well. So 10 4 and 6, and now they are 1 2 and 3. Why did I use the class name and not the emp, which is the object name? Because I wanted to show you that A, B and C are properties of class and not of the objects. So we are essentially changing the class attributes and not the instance attributes. So this is something that you need to keep in your mind. Moving forward, let's talk about property decorators. So I'll say 06 underscore property, and I'll simply say property.py, and I'll copy this particular thing and paste it here. And now what I'll do is I'll simply say property, and I'll say def, I'll say length, and I'll simply say return self.a, and let me call it self. Now if I use this property decorator, what happens is instead of calling it as a function, I can directly call it as a property. Let's read about property decorators. Consider the following class. This is an employee class. We have a name function and we have a decorator, property decorator, just above the name of the function or the definition of the function. If I say if e is equal to employee is an object of class employee, we can print e.name to print the ename variable. Let me show this to you, and let me show this to you using my example. In this case, if I want to print name, I'll have to, or rather length, I have this length as the name of my method. If I don't have this property decorator, I'll have to do something like this. Let me remove this. Let me remove this as well. And let me say print, I'll say emp dot length. I'll have to do something like this. If I run this, 1 is printed because I'm calling this function. Length is a function. But what if I want to use this length as a property? I don't want to use these extra parentheses. If I do this directly without the property decorator, you can see that this simply prints this bound method employee dot length of this particular object at this particular location. I don't want to see this, but what I want to see is I want to see 1. So to accomplish this, what we do is we use this property decorator and this property def length self returns self dot a. If I run this code, you can see that 1 has been printed. So this is something that you should understand, and you should know how this works. Okay, so I hope you understood how property decorators work. In a very similar way, we have getters and setters in Python. And how getters and setters work? The method name with property decorator is called getter. So we already know what getter is. Now let's talk about setter. So let us say you want to set some value. Okay, we can define a function plus @name dot setter decorator like below. So we have a name dot setter and we have a function called name. So what this particular function essentially is doing is this will set the value of this name property. Let me explain this to you. So since I have this length as a property, what I'll simply do is I'll say I'll say length dot setter. Now what I'll do is I'll simply write this function length. I'll say def length. As we have a name here, we'll use length here because we are creating a setter for length. I'll simply say self and I'll say value, and I'll simply say self dot a is equal to value. This is something that I'm doing. Now what I'll do is if I say emp dot length is equal to 78 and run this program, You can see initially the length was 1, but now I can directly say emp.length is equal to 78. Can you do this without the setter, or rather name dot setter decorator? No, you cannot do that. Why? Because length deep within this class employee is a method. It's not an attribute. But here it looks like an attribute. It simply looks like an attribute. You can see we are printing emp.length. It seems as if there is a length attribute defined inside this class, but actually length attribute is not defined inside this class. It is a function with property decorator, which is making it appear like this. But what if I want to directly say emp.length? I'll have to write this syntax, which is a setter, and I can add or create a setter for this length property. And length property will now have a setter, and I can directly say emp.length is equal to 78. If I get rid of this syntax is no longer valid, because emp.length is equal to 78 doesn't make any sense. Length is a method. You cannot say that method is equal to a number. This doesn't make any sense. But with the help of this setter decorator, all of this makes sense, and you can actually set this particular length to 78, and deep inside what it will do is it will set the value of your a to the value that you are providing, in this case 78. I hope you got the gist of it. You got how and why we are using all these things. Let's not talk about operator overloading in Python, and this is fun. Let me tell you, this is fun. Why is this fun? Because you'll enjoy doing this. I'll tell you why. Operators in Python can be overloaded using dunder methods. So we have something called dunder methods. Operators in Python can be overloaded using these dunder methods. So far we have seen dunder init. We'll see some other dunder methods. These methods are called when a given operator is used on the objects. And definitely I'll be giving you plenty of examples to support the text written in this notes. So operators in Python can be overloaded using the following methods. So p1 plus p2. You can override the default property of this plus operator by using this method. So I'll show you how. So what I'll do is I'll simply say dunder methods.py, and let me simply say a is equal to 45, b is equal to 48. Okay, or rather let me make it 40. So a is 45, b is 40. If I print a plus b, this will simply print 85, and yes, it makes sense. 45 plus 40 is 85. Okay, now let us say I want to add two objects. Let me show this example to you. Let me create a class. Let me call this employee, and let me say a is equal to 45, and or rather let me create a constructor. I'll say self.a is equal to a, and I'll pass this a here. So I'm passing this a here, and I'll create an employee object. I'll say employee 45, then I'll say employee 40. Okay, employee 40, employee 45, employee 40. If I say a plus b, let me show you what happens. It says unsupported operands of types employee and employee. It's basically telling me that you don't have a dunder add method here. So if I add an add method like this, what I can do is return self.a plus obj.a. And what is the obj object? It is the object upon which this particular operation is being operated. Okay, so I have some indent error here. Let me fix that indent error. And now if I run this code, you can see 85 has been printed because I have defined what happens when I use this plus symbol. Okay, so this is something that you should keep in your mind while you are creating objects and using these kinds of operators on your objects. Okay, so p1 plus p2, if you want to implement this, you need to implement this method. If you want to implement this subtract sign, if you want to make it work, you need to implement this. If you want to make this work, you need to implement this. If you want to make this work, you need to implement this. For double slash, you need to implement this. Okay, I hope all this makes sense. Now there are some other dunder or magic methods in Python. str is used to set what gets displayed upon calling this particular method, str obj. Now len, this particular thing is used to set what gets displayed upon calling this method itself or len of obj. For example, let me show this to you. Let us say I want to add this under str and I want to simply return self.name, and let me add a name here as well. Self.name is equal to name is something that I'm going to write, and I'm using alt click to get multiple cursors in VS Code. Okay, I know a lot of you will ask me in the comments. And also let me say Harry, and let me say Rohan. And if I use print a and print b, or rather let me call this like this, print a comma b, you'll see Harry and Rohan. What if I don't have this str method? What will happen? If I don't have this str method, I'll get something. I'll get this main.employee obj at this location, main.employee obj at this location. But if I want to see the name of the person who is being printed, I need to use this str. And the same is the case with len. Let us say length of an employee is the salary of that employee. I know it doesn't make any sense, but let me return self.a when the len object is, or rather len function is called. So if I say print len of a and print len of b, I should see 45 and 40 printed on the screen. So len of a is 45, len of b is 40. If you're modeling real world thing using classes and objects, you will use something meaningful. You'll print something meaningful while your object is being printed. For example, when an employee is being printed, I printed the name and not the salary or a or the increment. If you want to know who is whom, you'll know the name. You want to know the name of that person and not the employee code or something else. In a very similar fashion, if you want to implement this add method, you'll add something meaningful from the two objects. For example, in the case of complex numbers or in the case of vectors, we actually add the corresponding axes in the vectors. And also if you're adding two complex numbers, you will add the real numbers with real numbers and complex numbers with complex numbers. Ignore it if it doesn't make any sense, if you don't know what complex numbers are. I basically want to say is whatever you are modeling using classes and objects should be meaningful in your production code, in your serious code. Whatever I have implemented here is simply to explain you how these things are working. But when you go in production, when you go in some company, when you are writing some meaningful code, you should put the readability first. You should keep in mind the readability of the code. You should keep in mind what you are doing and what overall purpose your code is serving and all those things. So now we'll move on to chapter number 11, practice set, and we'll talk more about all these concepts which we have learned in this chapter. I hope you enjoyed this object-oriented programming chapter, and I hope that you now know how object-oriented programming works. Let's move on to chapter 11, practice set now. Let's now move on to practice set of chapter number 11. So what I'll be doing is I'll open this practice set of chapter number 11 and let's move towards the first question. So it says that create a class C2D vector and use it to create another class representing a 3D vector. So what we are going to do here is, let me close all these programs which are open and let me write 08 underscore pr01.py. So I'll write a class called vector2d and we have to create a class vector 3D using this vector 2D. But here what I'll do is I'll simply write the constructor and I'll say self.I is equal to I and self.j is equal to j. So what is I, j and k? I is the x-axis, j is the y-axis and k is the z-axis. In a 2D vector we have I and j, and in a 3D vector we have k as well, which is the third dimension. So here we have just two dimensions. In order to create a vector 3D using this vector 2D, what I'll do is I'll simply name this class as vector 3D and I'll use vector 2D as the parent class of vector 3D. Now what do I write inside the constructor? I'll simply say self.k equals to k. And what about I and j? Let me pass k as well. I'll simply say super dot init. and I'll pass I and j. So this is how all these things work. Let's now try to instantiate objects using this. So I'll say v2 is equal to vector 2d, and I'll say 1 comma 5, and then I'll say vector 3d, and then I'll say 1 5 and 9, and let's see if these work or not. So it says it takes 3 position arguments, but 4 was given. I don't have to write this self here, my bad. So sometimes I don't remember syntax, but that doesn't mean that you don't know. At times you might not remember syntax, and that's totally fine. So we are able to create v2 and v3. Now let me create another function called print. I'll say def print vector, and what print vector does is, let me say self here. It will simply print the vector as I cap, j cap, and k cap. So what I'll do is I'll print an f string. I'll say f, and what I'll do is I'll say self.i, I'll simply say self.i, and then I'll say plus, then I'll write j, and then I'll write k. But for a 2D vector, it's going to be j and I only. There's no k. But what if we have a 3D vector? When we have a 3D vector, what we'll do is we'll use k cap as well. So we'll say self.ii, and then we'll have k cap as well. So if I say v2.print vector, and if I say v3.print vector, you can see that we have 1 5 and then 1 5 9. You can even say 11 5 9, and I think I need to add some spaces near plus just to make it a bit more readable, but that's upon you. That's totally fine. Even if you don't put the spaces, this is going to work. So this is how this vector is working, and we are able to represent a 2D vector as well as a 3D vector in Python. Let's move on to question number 2, which says that create a class pets from a class animals and further create class dog from pets. Add a method bark to class dog. And this is a straightforward question. I want you to try this out. You have to create a class pets from a class animal. So create a class animals first, then create a class pets, make p as capital, and further create a class dog from pets. So p will be capital here. I have made a mistake while writing this down. Add a method bark to class dog, and just simply add a method called bark and simply print bark or something, or bow bow or something inside that bark method. So this is super simple. You can do this. Create a class employee and add salary and increment properties to it. Write a method salary after increment with a property decorator with the setter which changes the value of the increment based on the salary. Sounds complicated, right? It's actually very simple, and I'm going to implement and show this to you. So this is problem number 3. I'll say 09 underscore pr03.py, and I'm going to write this class employee. So the question says that you have to write a class employee, add salary and increment properties. So what I'll do is I'll create a constructor, and I'll say self.salary is equal to salary, and then I'll say self.increment is equal to increment. Okay, so we are going to say salary and then increment. So we have these two methods, these two properties. And now what I'll do is I'll say emp1 is an employee with a salary of 12,000 rupees and an increment of say 10%. So I'll say 0.1. Okay, so 10% increment and 12,000 rupees salary. Now what I'll do is I'll create this method salary after increment. So let me create this method. So I'll say salary after increment. Okay. Now this is a property, so I'll put a property decorator. So this is a property decorator, and I'll simply say self, and I'll say return self dot salary plus, or rather multiply by 1.1. Do you know how this 1.1 is coming? Where is this coming from? This is simply coming from 1 plus 0.1, which is the increment. Or rather, I'll not write it like this, because the increment might change. Increment is 0.1 in this case. My bad, I can't hard code it here. So what I'll do is I'll say 1 plus self dot increment. Okay, so this is how it works. So this will return salary after the increment. So this is a property, and I can simply say print emp1 dot salary after increment. And yes, this is going to print salary after increment. As you can see, this is the salary after increment. If I make it 1 lakh, or if I make it 10,000, it should be 11,000, as you can see. So 10% increment every year. Okay. So what I'll do now is I'll add a property decorator, and I've already added the property decorator, by the way. I'll add a setter. And how do you add the setter? We have already seen it here. And let me tell you where we learned about setter. We learned about the setter here. So what I told you was you write the name of the property dot setter. So we are going to do the same thing. We are going to say add salary after increment dot setter. And now we'll write the same function. We'll say self.salary is equal to self.salary is equal to self.salary multiplied by this. So we are updating the salary. So now if I say that emp1 dot salary after increment is equal to something, let us say I want to set the salary after increment to 11,000, it should change my increment, or rather it should change my salary to this thing. So this is a very basic implementation of this, and this can be used to set the properties. So this is how we solve this question. I'll save this program. We'll move on to the next question now. Write a class complex to represent complex numbers along with overloaded operators. So we can represent a class complex to represent complex numbers with plus and multiply operator, which adds and multiplies them. So what we can do is we can simply write a class, and let me write a program. I'll say 10 underscore pr010, 10 underscore pr0504.py. This is problem number 4, right? Yes, it is. I'll write a class complex representing complex numbers, and I'll write a constructor here. I'll say self.a is equal to a and self.b is equal to b, and we'll add a and b here. So a and b. I'll simply say that def underscore add. This is a add dunder method with an object. So what I'll do is I'll say self.a plus self.b. I'll say return complex. I'll return a complex number with self.a plus obj.a. And I'll explain this to you, don't worry. Self.b plus obj.b. What am I doing here? You must be thinking, what am I doing here? I need to write self here. Now what I'll do is I'll say C1 is a complex number. C1 is a complex number with 1 and 4 as real and imaginary values, and C2 is a complex number. Now I want to print C1 plus C2. Or rather I can say C3 is equal to C1 dot C2. I'll say C3 is equal to C1 dot C2, and I can print C3 dot A and C3 dot B, and then from there we can see if this addition works. So if I run this program, you can see that 11 and 1 has been added, 4 and 3 has been added. Let me now explain this to you. So every complex number has a real part and an imaginary part. So this is the real part, this is the imaginary part. So we are creating the complex number using A and B, where A is the real part and B is the imaginary part. So when we add two complex numbers, we add their real parts and add their imaginary parts and construct another complex number out of those real parts and imaginary parts. So real part of this particular object, which is say C1, is self.a. For another object, it is obj.a. And since I'm adding these two things, I'll put the real part and imaginary part like this, because my constructor of complex takes the real part and imaginary part to construct the complex number, and I'm returning that complex number. So C3 is a complex number. Now for that complex number I can print the values of A and B, which I'm already doing, and you can see that C3.A is 12 and C3.B is 7, which makes total sense. I hope you got it, and I hope this is very clear to you. So this is how we can add. And when it comes to multiplying, let me Google it. Multiplying two complex numbers. So multiplication of complex number is a bit tricky, but again, I'm going to pull the formula out of some article and we are going to directly implement that formula. If you are into maths or you want to learn more about complex numbers, you can look into all these things. But for the sake of this tutorials, we are not going to discuss complex numbers anymore. So if p plus iq is a complex number and r plus is is another complex number, so z1 multiplied by z2 is this particular thing. So you can implement this formula, and this is the real part and this is the imaginary part. You can implement this and write your multiplication function. I've already told you which dunder method to use for multiply. It's called MUL dunder method. You can use this dunder method and you are good to go. Now let's talk about the next question. Write a class vector representing a vector of n dimension. Overload the plus and star operator which calculates the sum and dot product of them. So you can have a vector just like we created a vector class in the question number 1, and you can overload these methods, the add method and MUL method. I hope you'll do it. Now write a str method to print the vector as follows. We have already done this. So what I'll do is I'll solve this problem for you. So this is problem number 6, 11 underscore pr06.py, and I'm going to copy the code I've written in problem number 1. Now what I'll have to do is I'll have to write an str function. So what I'm doing is I'm simply writing a str function, and what am I returning? I'll be printing this. Or rather I'll return this string. I'll return this f string. So I'll say return this f string. Self.i cap, self.jj cap, self.kk cap. And let's get rid of this print vector function. Let's assume it's not there. Now if I print my v3, I'll see this particular thing. Let me see if it works, and yes it does. 11, 5 and 9. So this is how you can implement dunder str to print your vector beautifully. Okay, so there's another question here, question number 7. It says override the alien method on vector of problem 5 to display the dimension of the vector. So you can simply override the method len to calculate the dimension of the vector. In this case, this is 3. So if you have solved problem number 5, which simply says that write a class vector representing a vector of n dimension. In this case, you'll have to create a list to represent the vector. You'll have to write this particular method to find out the length of that list. I think we need to solve this question. So initially I thought of not solving this question, but let me solve this question for you. If you want to skip this question, or if you have already solved this question, you can skip it. But I'm going to solve this for you because I think this will be an important question. So we have to represent a vector of n dimension. So I'll say class vector. Now what I'll do is I'll simply create a constructor. This will have a list L1 which will contain the list of all the values, all the n values. Simply I'll say self.n is equal to len of L1. This is the dimension of the vector, or rather let me call it dimension. Self.dim is equal to len of vector, and we have already stored it in a list. Okay. Now what I'll do is I'll overload the plus and star operator which calculates sum and dot product of these two vectors. So in order to create the sum, in order to calculate the sum of this vector, what I'll do is I'll write this method add, and it will be added to another vector. I'll simply say return generate a vector by using this list. But what is this my list? My list is equal to obj dot data. Let me say self dot data is equal to L1. I'll say obj dot data plus self dot data. So we are adding these two lists. So I need to pass self here, and what I'm doing is I'm creating a vector out of this my list. Now what I'll do is I'll simply say v1 is equal to vector, and I'll say 1 2 3, and then I'll say v2 is equal to vector 11 12 13. Now I'll say print v1 plus v2. So once I do this, let me see if it works. It says in it takes two positional arguments. but 4 were given, which is wrong. So I need to give only one positional argument here because I need to pass a list to my vector. Let me run this program now and it should work. So it says main vector. So v3 is the vector. Let me call v3 as v1 plus v2, and let me say v3 dot data, and let's see if we get this data or not. So v3 dot data is 11 12 13 1 2 3. So we need to add the list items one by one. So what I'll do is I'll use a for loop. I'll simply say for item in my list, or for I in range of length of my list. So what I'm doing is I'm simply saying that for I in range of length of obj.data, sorry, not my list. So what I'm doing is the first vector, I'm taking the length of the first vector and I'm starting from 0 and going all the way till length of this vector minus 1. So basically I'm iterating through this list using the index. I will be 0, 1, 2, 3, 4, 5. So in this case, I will be 0, 1 and 2. Now what I'll do is I'll say my list dot append. I'll simply use this obj dot data I. Let me use multi-cursor functionality. And this is going to be simple. I hope you understand this part. My list dot append this, and I'll get rid of this. I'll make this an empty list, and this should work. So if I run my code, 12, 14 and 16 has been printed. 11 plus 1, 12 plus 2, 13 plus 3. So I'm adding the items of the list one by one. So 11 will be added to 1, 12 will be added to 2, 13 will be added to 3. So my V3 will be 12, 14 and 16. So this is my V3. I hope you understood how we are adding these two vectors. So we have already created a method to add two vectors. Now we'll do the same thing for multiplying two vectors. And this is going to be easy. And why do I say that? I'm saying that because here we need to find the dot product of two vectors, which is going to be simple. So what I'll do is I'll use the same loop. But instead of doing this, what I'll do is I'll say dot is equal to 0. And instead of appending this to a list, what I'll do is I'll multiply these two values and I'll add these two values to what? To dot. So dot is equal to, or rather dot plus is equal to this particular thing. And finally I'll return dot. So this is how we find the dot product of a vector. If you don't know vector algebra, this might sound a bit difficult for you, but let me tell you something. I'll say v4 is equal to v1 multiplied by v2, and make sure that v4 is not a vector. Let me write it down. v4 is a scalar and not a vector. Dot product of two vectors is a scalar and not a vector. v4 is a scalar. Okay, so this is something that you need to understand. And if I print v4, I'll simply print the value of v4. It is going to be a single value. So let me see if this value 74 is coming out to be correct. So 11 plus 24 plus 39. So 11 plus 24 plus 39. And this should come out to be 74, which is correct. So this dot product is correct. I hope you understood the techniques. I hope you understood how I have implemented all this. I wanted to solve this problem number 5 for you because for some of you guys, this might have gotten trickier. So if you're not into vector algebra and you didn't understand this, that's totally fine. You need to learn vector algebra first and then understand this. But if you're not into vector algebra or you are not going to code vector algebra in your life ever, you don't even have to bother about this. So these were my 2 cents about vector algebra, whether you should learn it or not. If you think that this is important for you or for your career path, you can learn. Otherwise, that's totally fine. You can ignore it and you can move ahead to chapter number 12, where we are going to learn about advanced Python stuff. But let's look at this question number 7 as well. What is it saying? It says that override the len method on vector of problem 5 to display the dimension of the vector. And this is going to be super simple. All you need to do is you need to say len and just return length of self dot data. We already have this dimension, but again, let's not use the self.dim. Let's calculate it when somebody runs this len. So if I say print len of v3, let's see what gets printed on the screen. 3 is being printed on the screen, which is fine. So we have solved the question number 7 as well. So I hope you understood how these things are working, how object-oriented programming works, how we create classes, how we use inheritance to create classes. I hope everything is clear, and I hope you like these notes. Make sure you download these notes because I have put in a lot of hard work to create these notes for you. So you should not take this for granted. Definitely download the notes and watch this video completely and mark the parts of the video where you think that you might need to come back in the future. You can do that by posting a comment below of the timestamp. Let's move on to chapter 12 now, where we'll talk about some advanced Python stuff, and chapter 12 and 13 are going to definitely help you a lot. So let's move to chapter 12 now. So now we are going to start advanced Python 1, wherein we'll cover some of the topics which are usually not under any broader topic. So these topics are not really very difficult to understand. Do not take this word advanced for difficult Python. It's not difficult Python, it's straightforward. These are some of the topics in Python that you need to know definitely, and they will save a lot of your time. So let's get started. Let's talk about exception handling in Python. There are many built-in exceptions which are raised in Python when something goes wrong. For example, let us say you are running the code and your code is actually talking to a server. What if that server goes down? What if you're talking to an API and there is some problem from their end, not from your end? What will you do? You cannot do anything because your code will definitely throw some error if their API is down. If the code doesn't work as expected, your users might suffer or your program might just crash. In order to save your program from crashing, what we do is we use try except. So the syntax of try except looks something like this, but let's talk a bit more about exceptions. What exactly is an exception and what is a Python try block? So there are many built-in exceptions. Built-in exception means that some broader category of problem which occurred. So exception is some sort of problem which might occur, which was unexpected. For example, let us say you are running a code and you expected user to enter an integer, and instead of that integer, the user entered a string. What will you do? You cannot do anything about it and your program might crash. So you can throw an exception from your program and save your program from crashing. We'll see how. So there are many built-in exceptions. We'll talk about those built-in exceptions. Exception is an object in Python. We'll talk about that object, and you can raise those exceptions when something goes wrong. Exceptions in Python can be handled using a try statement. The code that handles the exception is written in the except clause. So if you are writing some code which should execute when that problem occurs, it should be written inside the except clause. Let's look into the syntax of try except. As you can see that I have opened my Visual Studio Code on this folder. I'm going to create my first program and I'm going to name it tryexcept.py. So let me call it tryexcept.py. Now what I'll do is I'll simply say try and I'll say print hello world. Now this particular piece of code is not going to throw any error. And then what we do is we say accept exception as E and we print the exception. Now let us say what I'm doing is I'm saying A is equal to int input, and then we'll say enter a number. Now we'll do the same thing with B, enter another number. And now what I'll do is I'll simply say print A plus B. What do you think will happen? If I run this code, I can enter first number, 3, 8, and yes, 3 plus 8 is 11. It works as expected. But what if I say Harry? It says invalid literal for int with base 10. Now as you can see that this is not printed as an error. Our program encountered no error, and if we were to print something, let us say if I print something like this, if I say there was no errors, there were no errors, let me fix it. So there were no errors. If I run this code, it's asking me for a number, and if I enter something which is not a valid integer or number, you can see that there were no errors has been printed after the error message. Now let's try to understand it by removing this try block and except block and see what happens when we have no try and except block. So I'm getting rid of these try and except blocks. So I'll get rid of this except block, I'll get rid of this try block, and I'll try to execute this code, and I'll try to do the same thing. I'll say Harry, and you can see the program gets halted there itself on this line. So you are not going to see any of the statements executed after line number 4, because line number 4 throws an error. Line number 4 tells the program or tells the Python interpreter that, hey, we have encountered some problem, please stop right away. So you will not see this, there were no problems or there were no errors printed on the console, because this line is never executed. Let's now bring back a try block and except block. In the presence of try block, we are actually handling the exception, and while we are handling the exception, we are simply printing that exception. Let me change this by saying that this problem occurred, and what I'll do is I'll simply print this E as an F string. So this is what I'm doing. Let me cancel the execution of this program. Let me run this program once again. I'll say 8, I'll say 9, 8 plus 9 is 17. There were no errors. But if I say 78 and if I say Harry, you can see the problem occurred, or rather I should say this problem occurred. So this problem has occurred and our Python program is printing it. How does it print it? It is printing it inside the except block. So whenever there is a problem in the try block, except block will be executed. And when except block is executed, any line after that except block will be executed as well. So this is something that comes in very handy when you have a lot of lines waiting to get executed after this. So let us say this program contains say 110 lines. If we encounter an error during the first 10 lines, then it will be very problematic for us. We don't want that. In order to get rid of those problems, we are using this try except. So this is how try except works. When the exception is handled, the code flow continues without program interruption, which is why you see this particular print statement getting executed. Now we can also specify the exceptions to catch like below. So you can catch specific exceptions. For example, the specific error that we encountered while we wrote Harry in place of integer was a value error. So we can catch value error only using a special except statement. We can say value error occurred. So let me show this to you. We'll say except value error and we'll simply say value error occurred. So this is something we can do, and you can see the syntax of this here. We can catch the zero division error, we can catch the type error, we can catch other types of exceptions. And let me run this code for you and show you that this block will be executed. So if I say Harry, you can say value error occurred. There were no errors. There were no errors because we handled the exception. So this block will be executed because value error occurred. Sometimes what happens is, let us say I'm dividing two numbers. So let us say instead of a plus b, I'm saying a divided by b. Now, whenever I'm entering a value which is not an integer, I'll encounter a value error. But if I enter b as 0, that will be zero division error because you cannot divide by 0. So let me run this code and let me say first number is 5, second number is 0. And you can see this problem occurred, division by 0. So it checks whether this is a value error or not. No, this is not a value error. So this block will not be executed. The next thing it checks is whether it is some other kind of exception or not. So any other exception will execute this particular line. What if I write except zero division error? And if I print and I say this is a zero division error, what will happen if I do something like this? And yes, you guessed it right. If I say 6 and 0, I'll see this particular line getting executed because I have written a block for zero division error. And what if I enter some invalid value for integer? it will simply execute this block because value error has been encountered and value error will be catched using this block. So I hope you understood how we can specify the exceptions we want to catch, and I have entered this syntax for you in my notes because I want you guys to take these notes and I want you guys to print these notes and take them with yourself. So this is something which will help you a lot. All the other exceptions will be handled here. So let's talk about raising exceptions, how you can create your custom exceptions and you can raise them in Python. We can raise custom exceptions using the raise keyword in Python, and I'll show you how you can raise custom exceptions. So what you can do is you can simply say if b is greater than 199, I can say raise, or I can simply say raise exception, and I can say this number is too large. Now if I run this code and if I enter something which is greater than 199, you can see that it tells me this problem occurred, this number is too large. So we can raise the exceptions and we can make programs stop before it's too late. So let us say this value is not valid for this program. I don't want my user to suffer some other consequences. I will stop my user right away. I'll tell him or her that this particular value is too large to handle for us and we don't want you to proceed with the program. So this program will be halted right at line number 6. Instead of making user wait for some other statements to be executed and instead of wasting users time in executing some other lines of code, we want to stop the user early. So this is something that you can do using the raise keyword. So this was raise keyword in Python. Now there is a syntax for try with else clause. Sometimes you want to run a piece of code when try was successful. So whenever try is successful, else will be executed. So this else will be executed only if the try was successful. I'll demonstrate this for you. So if I write else and if I print try was successful, you'll see that this will be executed only when no exception occurs. So if I say 37, it says try was successful. But if I say Harry, it will not say try was successful. If I say 3 and 0, it will not say try was successful. If I say 4 and 8888, it will not say try was successful. It will only say try was successful when try was actually successful. So this is something that you need to remember. Whenever try is successful, else will be executed. Otherwise, else will not be executed with try. Do not confuse this else with if else. This is not related to if else. This is an else with try, and this is a part of Python syntax. So you can use else with try block. I have made it really very clear in the notes. So if you download these notes, this is going to be the best resource for you whenever it comes to revising Python. Now let's talk about try with finally. Just like we talked about else with if, else with try, we have another block called finally. So whenever you have something to try and then you have something to accept, there is a block called finally which is executed regardless of what happens. So this will be executed regardless of what happens. I'll tell you what it means. So Python offers a finally clause which ensures execution of a piece of code irrespective of the exception. So let me demonstrate finally using another program. I'll say 02 underscore finally.py. So let me try this. Let me say a is equal to 8, b is equal to 0, and as we know that this is going to throw an error, let me copy this from here. Let me copy this as well. I think we can reuse this piece of code. So I'm printing a divided by b, and we are saying this problem occurred, and we don't want to use else, but we want to use finally. And I'll say I will always be executed. I will always be executed. So this will always be executed. Let's see if this is true. So when we have this try block successful, this is executed. What if there is an error? What happens if there is an error? This is executed. Now, there is something that people get confused with, and I'm going to explain and make clear that particular point. What if we have this finally? What's the use of this finally? A lot of people ask me that what is the use of this finally when we can do something like this? Instead of writing this, we can always do this. And this will always be executed because we are handling the exception. Then what is the use of this finally? There's no use of this finally. But I'll tell you the use of this finally despite exceptions being handled. Let us say we have a function. Let me wrap this inside a function. I'll say function and let me make this part of a function. Now I'll simply say function. Now let us say I'm returning this value. I'm returning a by b. And here when the problem occurs, I'm returning say 0. Now if I do something like this statement is not reachable. You can see code is unreachable. And if you want me to prove this, I can prove this. I'll say 6, I'll say 9, and you can see I will always be executed as not printed. But with finally, this is not the case. If I run this piece of code, if I say 6 and if I say 9, you can see I will always be executed. Even if there is some exception, this is always executed. So we are returning from the function. Despite of us returning from the function, this finally is executed. So this finally will always be executed. It will not obey the function being returned or something. It will always be executed. So this is really very useful, and this is the purpose of finally. You need to use finally to clean up some resources. Let us say you have some files open and some exception occurred. So regardless of whether the exception occurred or not, you would definitely want to close that file. So you can use this finally clause to close the file or do the cleanups. Or let us say if you have made connection to a database, you need to successfully close the connection to the database. You can use finally block to do that. I hope I made it clear for you. And this example is going to be very important. Whoever tells you that finally has no use, you can always use something like this. You can show them this example and they'll know what is the use of finally. So if name equals to name in Python, let's talk about this. So you must have seen this particular thing a lot. If underscore name equals to underscore main, we actually call it dunder name and dunder main. So let me call this main. Okay, I'm simply printing this. Now if I run this code, you'll see enter a number, let's say 5, let's say 9, and this main is printed because we are using this. But what is the use of this if name equals to main? If I put this function as well inside this, you can see that the same thing is happening. There's no change in the program. But let me tell you something. You'll see the difference when you import this module. Let me import this name main.py. So what I'll do is I'll simply say import 02 and let me call this a02 finally, just to make this name valid. So I'll say a02 underscore finally, and this has been imported. Now if I import this and if I run this program, you'll see nothing is happening. As you can see, nothing is happening here because I'm just importing this a02 underscore finally module. What if I don't have this name equals to main? Let me show you. And now run 3 underscore name underscore main. Just listen to me very, very carefully. You can see that this program is getting executed. Did you see that? Did you see that? This is executing because when I'm importing this, it's literally taking this file and putting it here. Now here, if I have this if name equals to main, what exactly happens is that name will evaluate to which file we are in. So if we are in the same file, underscore name is evaluated to main. So let me print underscore name for you. So if I print underscore name for you and run this code, make sure that I'm running a02 underscore finally.py. You can see that it is main. So name, dunder name I should say, dunder name is underscore main underscore when we are in the same file. So we are in the same file, which is why the underscore name is this. But if I run this code from some other file, you can see it evaluates to the name of the module. It evaluates to the name of this module and not underscore main. So if name is equals to main means that if we are in the same module, and if we are running this from the same module, then do this. So if you are running this file, then this will be executed. But if you are importing this file, this will not be executed. I want you to write down these words. I want you to write down whatever I'm saying. If underscore underscore name equals to underscore underscore main, if dunder name equals to dunder main will evaluate to true if we are in the same module, if we are running the file from the same module, if we are running this particular file. But if we are not running this file, or if we are importing this A02 file, then underscore underscore name will be name of this file, and it will not be underscore underscore main, and this thing will not evaluate to true. And since this will not evaluate to true, these two lines will not be executed. I hope I made this clear for you, and this was a clear-cut explanation of underscore underscore name equals to underscore underscore main in Python. I hope you got the point. So dunder name evaluates to the name of the module in Python from where the program is ran. If the module is being run directly from the command line, the name is set to string underscore underscore main underscore underscore. Thus, this behavior is used to check whether the module is run directly or imported to another file. So whether the module is being run directly or being imported from another file can be determined using this thing. So we put this to ensure that we are running this file and not importing this file. So if you are running this file, this will be executed. If you are importing this file, this will not be executed, but you will get all these functions and classes from this file. Let's talk about global keyword. The global keyword is used to modify the variable outside of the current scope. What does it mean? It simply means that you can use this keyword to modify variable outside of the current scope. So let me give you an example, and we are going to write 04 underscore global.py. So let us say I have a is equal to 9, and let us say I have this function and I have a is equal to 8. What will happen if I print a here? What will happen? And what will happen if I print a here and call this function? So let me show you. The value of a here is 9, but the value of a here is 8. What if I say a is equal to 900 and then print a? I'll show this to you as well. So firstly, the value 9 is printed, which is the global value of a. Then what happens is this a is printed and this 900 is printed, because now the value of a is 900. Now if I print a, will 900 be printed or will 9 be printed? Definitely 9 will be printed, because we are talking about this value. Now what if I want to modify this value and not the value we are talking about inside the function? Now if I say global a, I'm basically saying that I want to modify this global value. So if I run this program now, you can see initially 9 was printed. Now when I call this function, 8 will be printed, because now the value of a is 8, then 900 will be printed. But this print a will also print 900, because I am actually modifying the global value of a from this function. So this is the use of global keyword. I hope you understood the global keyword clearly. So in a nutshell, what we are doing is we are creating global variables from local scope. So from inside the function, we can create global variables. I hope you got the point, and I hope you understood how global keyword works. We'll now talk about enumerate function in Python, and we are going to use this enumerate function a lot. If you are working on some Django application, or if you are into data science, you'll definitely use enumerate function a lot. So the enumerate function adds counter to an iterable and iterates it. Let me explain you what enumerate is by creating a program, because this text doesn't explain enumerate clearly, right? If I have a list, and let us say I have 1, 5, say 6, and let us say I have apple inside this list. Now let us say I want to iterate this list and print all the items of this list. I'll say for item in A, print item, and yes, this will work. Definitely this will work. 1, 4, 6 apple. Now let us say I want to say something like this. I want to say F first item number I is this, item number 2 is this, item number 3 is this. If I want to do something like this, I'll have to create a variable I. I'll say I is equal to I plus 1. And here I'll say I is equal to 0. And since I is equal to I plus 1 here, what I'll do is I'll run this program. And you can see item number 0 is 1. If I put this increment statement above this statement, we'll see the counter starting from 1. Item number 1 is 1, 2 is 4, 3 is 6, 4 is apple. But isn't this a lot of pain to create a new variable and then increment it and then use it inside the f string? Can we not do better? Definitely we can do better. Let me explain what we can do. Let me comment this out and I'll show you another way to do this. I'll say for I comma item and enumerate A, and we don't have to increment anything, we don't have to do anything, we just run it and you can see that we have item number 0 is 1, 1 is 4, 2 is 6, 3 is apple. So in 2 lines of code we are doing something which was being achieved in 4 lines of code. And yes, you can make this I plus 1 to make this counter start from 1, not a big deal. I know a lot of people will ask me this question. How do I make this I start from 1? This is starting from 0. This will start from 1. If you want to make it start from 2, you can simply say I plus 2 and so on. So this is the basic usage of enumerate function. The enumerate function adds counter to an iterable and returns it. So you can add a counter to an iterable and return that counter. Okay. So for I item in list 1, print I comma item. This will simply print this index along with the item. So prints the item of list 1 with index. As simple as that. Now another topic I want to talk about is list comprehensions. List comprehensions is an elegant way to create list based on existing list. What does it mean? This doesn't explain it enough. Let me create a program, list comp.py. If you are a beginner, you will not understand list comprehension just by reading this text. So I'll make it easy for you. Let us say we have a list 1, 2, 3, 4, 5, 6. Now let us say I tell you to create another list out of this list. Listen to me very carefully, please. I am telling you to create a list out of this list which will contain square of the items of this list. How will you do it? You can use a list comprehension. You can. So let me discuss the naive approach first and then we'll see how we can use list comprehension to make that better. So you'll say L2 is equal to an empty list. Then you'll say for item in L1. Then you can say L2 dot append and then item. Okay, L2 dot append item. Multiply by item because we want to have a list which contains the square of the items in L1. So if we print L2, you'll see that we have 1, 4, 9, 16, 25, 36, which contains the squares of these numbers. Very simple to do, but can we do better? And definitely yes, we can do better. Let me show you how we can do the same thing in 1 line of code. We'll say I star I for I in L1. That's it. And you'll be amazed to see that this particular line of code can do the job better than these 3 lines of code, because these 3 lines of code is a lot of pain and it adds lines of code to your program and is not as readable as this. So what you are doing is you are saying I need I multiply by I for I in L1. So this is something that you can do. You can also use if statement here. You can say if I is greater than 2. If you do something like this, then you'll only get items where I is greater than 2. So for this, it will not be executed because 1 is not greater than 2, 2 is not greater than 2. It will start from 3 onwards and it will give you 9, 16, 25 and 36. So you can use if statements like this along with this list comprehension. In a very similar manner, we have dictionary comprehensions, we have set comprehensions, and I want you to explore all those things. I have given an example of this if statement here as well. So you can run this example as well. And indeed, it is an elegant way to create lists. So this was about advanced Python 1. This doesn't contain anything which is difficult to understand. A lot of people confuse advanced with difficult to understand. I think it's not that way. You should not look at advanced as difficult to understand, but rather these are the topics which doesn't come into a broader topic, which is why I have separated these topics into another chapter altogether, which is Advanced Python 1. Let's now move on to chapter 12 practice set and see how we can practice these Advanced Python 1 topics. Let's move on to chapter 12 practice set now. Let's now move into chapter 12 practice set and see what questions we have to solve here. So this particular problem says write a program to open three files, 1.txt, 2.txt and 3.txt. These are three separate files. What we have to do is we have to print a message without exiting the program that this file is not present. So basically what it means is that you need to use try except. You need to try this code, and if this code fails, you just have to print the message. So let me show you how we can solve this particular thing. We'll say 07 underscore pr01.py, and since we are writing this thing, we have to say try, and I'll say with open, let us say 1.txt, and yes, we want to read it, so read mode and as f.read. Okay, we just have to read it. We don't have to print the content or do something else. In a very similar way, I'll do 2.txt, and in a very similar way, I'll do 3.txt. And as you can see that if none of these files are existing, or if one of these files are not existing, there will be an error, and accept exception as E. Let me fix the syntax. I'll simply say the file is not present, program, or rather I should say reason, and I'll say E. Now I'll use this f string because I'm using this E variable, and let me run this. None of these files are present. So right when it tries to open 1.txt, there will be an error, and the error is printed here. The error is not thrown because we are using try catch. We are simply printing this particular thing. So the program is not exited. So whatever I write here will also be printed. Thanks for using this program. If I do something like this, thanks for using this program will also be printed, as you can see, because the program is not exited. It doesn't exits here. It simply stops here and it throws the exception, but the exception has been handled by us, and we are printing the file is not present, and we are printing the reason. So the exception has been handled by us, and there's nothing that we are doing wrong here. We are simply handling the exception. So this is how try catch is working. The syntax is try and then accept exception as E. Let's move on to the next question. It says write a program to print third, fifth and seventh element from a list using enumerate function. So we have this enumerate function and we want to print third, fifth and seventh element from a list. Let's do it. So I'll create a program called 08 underscore pr02.py, and what I will do is I'll simply say list1 is equal to 1, 2, and I want to keep my list straight and simple. Why am I doing that? Because I want to check whether I'm printing the third, fifth and seventh element or not. So I'll say for item in enumerate list1, and I'll also write index. So this is the syntax for using enumerate. Now what I will do is I will say if index plus 1 is equals to 1, or index plus 1 is equals to 3, or index plus 1 is equals to 7. You must be wondering, what's this index plus 1? Why not index? Why index plus 1? So the first element is index 0. Second element is index 1. Here the program, or rather the question says that we have to print third, fifth and seventh element. So if index plus 1 is third, fifth or 7. So let me write 3, 5 and 7. I'll say print item. Else we are not doing anything. Else we are not doing anything. Okay. So I'll simply run this program, and you can see third, fifth and seventh element printed from a list. So when index plus 1 is 3, it's the third element. When index plus 1 is 5, it's the fifth element. When index plus 1 is 1, it's the first element. So index for the first element is 0. I hope you got the point. I hope that you understand that index in Python starts from 0. But if I talk about the first item, then it will be at index 0. So which is why I have written this index plus 1. If you think about it, you will definitely understand why I have written index plus 1. Now the next question says that write a list comprehension to print a list which contains the multiplication table of a user entered number. So user enters a number and we have to print the multiplication table. Once again, a really simple and straightforward problem. Let me solve this for you. So I'll say num is equal to int input. I'll say enter a number. And then what I'll do is I'll say multiplication is equal to, I'll say I multiply by number for I in range 1 to 11. What is this 1 to 11? You must be thinking. Let me print the multiplication for you and then I'll explain you what these 3 lines of code mean. Or rather what this single line of code means, because you understand what this line is doing and you definitely understand what print statement is doing. Let me run this code for you and let me show you that this multiplication table actually prints the multiplication table of 5. What I'm doing is I'm saying I need I multiply by num for all the values of I ranging from 1 to 10. Now you need to understand that the range function goes from 1 all the way to 11 minus 1, which is 10. So the first element of the range is included, but the last one is not included. It goes from 1 to n minus 1. In this case, n is 11, so it goes from 1 to 10. And this is how range function is working. And I hope you understand how this range function is working. Okay, so we are simply printing the multiplication table here. And this is how this program works. And we have solved this problem. Pretty simple, pretty straightforward. I hope that you understood this and I hope you got my point when I said the advanced Python doesn't mean difficult Python. This is the easiest concepts of Python that you are going to learn. So I hope that you got the point and you understood all these questions very well. Fourth question says that write a program to display A by B where A and B are integers. If B is equal to 0, display infinite by handling the zero division error. And this is something I want you guys to solve, because while we were talking about these concepts, while we were talking about try and catch, I explained all this to you. So since we have already talked about this stuff, I want you guys to solve this problem on your own. All you have to do is you have to specifically handle this zero division error and you have to print infinite by handling this error. That's all. So A by B where B is equal to 0 is infinite. But when you try to do the same thing in Python, it throws an error. And this question says that do not throw an error, but rather than throwing an error, what you do is you give infinite as output to the user. So this is something which is being told in this question, and you can solve this question pretty simple. Now question number 5 says that store the multiplication tables generated in problem 3 in a file named table.txt, and this is something I want to solve, and I know this is easy as well, but once again I just want to solve this problem. pr05.py, and what I'll do is I'll copy this to this, and what I'll do is I'll write this multiplication. I'll say with open mul.txt as f, and I want to open this in write mode. I'll say f.write. I'll say multiplication. And if I try to run this program, I'll say 5, and it says that you need to convert this to string first before you can write it to a file. Okay, let me do this, and I'll say 5, and yes, mul.txt will contain this. You can even beautify this piece of code and write it to a file in a very similar way we have already done during file IO. So in file IO, we already created a multiplication table and wrote all these tables to a file. I hope you can do all those things here as well. And for some of those people who don't want to solve this problem or who are facing issues in solving this problem, just refer to the program I wrote here. I'll just pull that program out. So here, while you are handling the zero division error, let me solve this problem for you as well. I'll say pr04.py. I'm solving this because We already have it solved, right? So A is this, B is this. I want to get rid of this. Print A by B. I'll not print A by B here. I'll print A by B here. And I'll get rid of this else. I'll get rid of this. There were no errors. And when there is a zero division error, I'll simply print infinite. That's all we need to do. Okay, so let's run this code 50 and it says zero division error. I think there is some problem here. Okay, so my bad. I should have created a variable C and I should have done something like this. And I'll print C. So what I'll do is I'm printing infinite here, or rather let me say C is equal to infinite if zero division error occurs, and at the end I'll print C. So the exception should not occur here. It should occur inside try. So inside try at line number 5, this exception will occur and it will be handled. So let me show this to you once again. If I say 50, it prints infinite, but let's check whether it prints correct division values or not. So 15 by 10 is 1.5. Yes, it does. Let me divide 16 by 8 and yes, it's 2. So this is working. This is working quite well. So we have solved all these questions. I hope you understood how we solved these questions using the concepts we learned in chapter number 12. Now we'll move on to chapter number 13 and learn more about some Python concepts. Let's move on to chapter number 13 now. So now we are going to look at chapter number 13. So let's open this PDF so that we can look into the concepts that we have in advanced Python 2. So the first concept is virtual environment. And let's talk about this because this is really very important topic. If you are working in applications like Flask or Django, even if you are going forward and looking for working in data science or machine learning, you'll definitely encounter virtual environment at least once in your lifetime. So an environment which is same as the system interpreter but is isolated from the other Python environments on the system. Let me explain. So what I'll do is I'll open this particular folder in VS Code, and when I run a Python file, so let me create a file called venv.py. If I run this Python file, if I say print hello world, print hello world, and if I do something like this, let me show you my terminal. See that Python is being used to run this particular file. If I say Python, you can see that this particular interpreter is running. I'll exit my Python interpreter or REPL, which is a REPL. Now let us say I want an application which runs on Python 3.6, but I have Python 3.9 installed. Or let us say that I have this Python 3.9.4, but we have an update for Python, let us say 3.12. Now I want this application to work as expected, but also I want to update my Python interpreter. Let us have another scenario wherein we have two different Python versions and two different apps which work on these two different versions. How do we run these apps? How do we lock the environment? And when I say environment, I mean the Python installation. On this computer, I can either have 3.9.4 or 3.8 something when I'm typing Python. How do we solve this problem? We solve this problem using virtual environment. And listen to me very, very carefully. Once you listen to me, definitely all of your doubts will go. So we'll install a package called virtual environment. And before we type pip install virtual environment. So virtual environment is a Python package which you can use. So what we can do is we can use this venv and we can create virtual environments. I'll show you how. Now, in order to use virtual environment, what you'll have to do is you'll have to say Python -m venv and name of your environment. And the moment I fire this, you can see that a new env folder has been created here. This has a standalone version of Python, and I can use this particular Python environment to run my Python scripts. How do I activate this virtual environment? If you are on Linux, I'm not on Linux by the way, but I'm telling you for Linux, you just have to say source, and then you have to say env, then bin, and then activate, and just execute this. But since I'm in PowerShell, I'll say env, and I'll say scripts, and I'll say activate.ps1. So activate.ps1 is the script which activates the virtual environment. As you can see that env is being shown here, which tells me that this particular virtual environment has been activated. So this env tells me that this environment is activated now, and I can use this environment as and when I want. Okay. Now what I'll do is, if I say Python, you can see Python 3.9.4. If I say pip install pandas, pandas will be installed inside this virtual environment. No surprises whatsoever. But once I come out of this environment, pandas will no longer be installed. I'll show you how, and I'll show you this particular thing. So let all these things install. Then what we'll do is we'll import pandas, and we'll see that pandas works fine. And then what we'll do is we'll come out of this virtual environment, and after coming out of this virtual environment, we'll see that pandas is not installed. So what I'll do is I'll simply say deactivate, and once I say deactivate, I am out of this virtual environment. Remember that this virtual environment has pandas installed. Now I might have pandas installed in my Python interpreter as well. Let me check it by writing import pandas. And yes, I think I do have pandas installed because I work with data science very often. So if I run this code, nothing happens, and this works as expected. Now what I'll do is I'll activate my virtual environment after uninstalling pandas. So I'll say pip uninstall pandas. I'm not inside my virtual environment. As you can see, there is no env written here. So I'm not using this particular Python installation. The moment I say pip uninstall pandas, it's asking me whether I want to uninstall pandas or not. And now if I try to run this file, you can see that I am getting module not found error, and no pandas module has been found on my computer. Now what I'll do is I'll simply say env scripts activate.ps1, and I'll try to run this file. I'll say python 01 underscore vn.py, and it runs as expected. Why does this happen? Because my env folder, or rather my env virtual environment, has pandas installed. So I can isolate particular Python environment and install a set of packages inside that particular environment. So this is called a virtual environment. I can create as many virtual environments as I want. Okay. So what I'll do now is I'll come back to the notes, and I'll show you a few other things. So virtual environment means an environment. When I say environment, I mean Python installation, or the Python installation environment where we are in. An environment which is same as the system interpreter but is isolated from the other Python environments on the system. So if I have Python 2 and Python 3.9, once I create a new virtual environment, that is isolated from my system interpreter. Okay. Now how do we use it? You can either use virtual env package, or vn is it has been newly introduced, and you can directly use python -m. I just told you the syntax. You can use this particular syntax to create a virtual environment. Okay, both of these syntax works. Now you can create a new virtual environment by using virtual env. This is another way to create a virtual environment. Let me show this way as well. So you can even say pip install virtual env, and virtual env will be installed. And once virtual env is installed, you can use virtual env to create another environment. Virtual env env2, and env2 folder will be created here, and another environment will be created. So as you can see that another environment has been created. Now what we can do is we can activate or deactivate this virtual environment just like we did for our env. So I can say env2 scripts activate.ps1, and it activates env2 now. Okay. The next step after creating the virtual environment is to activate it. You can activate any virtual environment, and you can install any number of packages in a given virtual environment, and then definitely you'll be able to use those packages only when you are inside that virtual environment. Okay. We can now use this virtual environment as a separate Python installation. Just like a separate Python installation, you can use Python virtual environments. Let's talk about pip freeze command now. Pip freeze returns all the packages installed in a given Python environment along with the versions. So let us say we have this env environment. As you know that I have installed pandas inside my env, what I'll do is I'll activate my env. So I'll change this env2 to env, and you can see that env has been activated. Now what I'll do is I'll run pip freeze command, and what pip freeze command does is it gives me the list of all the packages which have been installed inside this particular environment. You can see that we have all these packages inside our virtual environment env. Now coming back to this, you can fire this command and this will create a requirements.txt file. Let me show you how. So if I say requirements.txt, you can see all this content has been written to this file. Okay, so all these packages have been written to this file, and you can use this file to install all these packages in a separate virtual environment. Let us say I want to create a virtual environment 3. Let me create that virtual environment first. So I'll say env3, and then after creating this virtual environment, let us say I want to install all these packages, all the packages from requirements.txt. I'll simply say pip install -r requirements.txt. So you need to put this -r flag, and some of the packages have been installed, some of the packages are installed. Let us say if I put Django, and if I try to install, you can see that Django was not installed. So Django is being installed once again, and it takes some time, and finally it will get installed. So all these packages will be installed if you fire this command pip install -r requirements.txt. Now the above command creates a file named requirement.txt in the same directory containing the output of pip freeze. So as we saw that requirements.txt file is created in the same folder, and also you can use this file to create another virtual environment. So you can distribute this file to other users and they can recreate the same environment using this particular command. I just showed you this. So instead of shipping env folders, we don't ship env folders, we ship requirements.txt file, which is a few kbs of size. You can see that it's 414 bytes. It's not even in kbs, it's in bytes. But if we try to look into the size of env, you can see that it's more than 10 MBs. So you tell me which is easier to ship, this one or this one. Definitely this one. Okay. Coming back to the nodes, we have lambda functions. What are lambda functions? Functions created using an expression using lambda's keyword. So you can use this particular syntax to create lambda functions. So you can do something like this. So in a single line, you can create a function and they work just like a function. Okay. So if you are familiar with JavaScript, you must have heard of arrow functions. Lambda function are not exactly the same thing as arrow function, but yeah, you can map some similarity from JavaScript arrow function to lambda functions in Python. Let's create another file, 02_lambda.py, and we'll see how lambda function works. So if I create a function like square, and if I do something like this, n, and if I say return n into n, I can print square of say 4 and it should give me 16. No surprises, it will give me 16. Okay. Oops. Okay, so we have this 16. I'll deactivate my virtual environment. And then I'll run it and it will give me 16 for sure. I could have done the same thing by writing something like this. Square is equal to lambda x, x star x. So I could have done something like this. So you tell me which is easier to write. Is this easier to write or doing this is easier to write? Definitely this is easier to write, and yes, I'll put the lambda keyword as well. So lambda x, x star x, and if I run this, this will also give me 16. So you can look at lambda functions as one-liner functions, and they are really very useful when the logic of your function is very short and concise. So if you want to write multiple lines of code, you'll definitely use def keyword and you'll use this particular syntax to write your function. But if your function is really very simple and straightforward, you'll use this particular syntax. I hope that makes sense, and I hope you are able to map the similarity between these def functions and lambda functions. So this is something that you can do. You can even have multiple arguments. So let us say x. Let me create something like this. Divide is equal to lambda xy, and I want to return x divided by y. So you can do this, and if you print divide 4 comma 2, you should get 2 as the answer. So you can see that we get 2 as the answer. And yes, this lambda syntax is amazing. Let's now talk about join method in strings. So join and format are two methods in strings, and we'll look at all these syntax, how to use join and format. Now let me tell you something. Join and format and all the syntax that I'm going to tell you in this particular chapter, you might not see this because there are better alternatives to these. For example, a better alternative to format is f string, and you should use f string instead of format, is my personal opinion. But in the older code bases, you'll find these methods, and you should not struggle when you see such kind of methods in your code base. So this is something that you need to learn. So let's talk about join and format. So I'll simply create 03 underscore join.py, and join is really very simple. If I say friends is equal to Rohit and then Shubh and then Preeti and then Neha and then Disha. So let us say I have these friends, and now what I'll do is I simply want to print their names in a specific format. What does it mean? I'll simply say dash dash dot join, and I'll say friends, and let me store it inside a variable, and let me print a. So I'll simply print a, and let me show you what it prints. So it will simply join all the values inside this list with this particular delimiter or separator. If I put exclamation mark, you can see that this is being printed. If I do something like this, is a friend, so and then off, and see, this is going to be fun because all this will print this. Rohit is a friend of Shubh, is a friend of Preeti, is a friend of Deha, is a friend of Disha. Okay, so if you want to do something like this, you can use join. So what it will do is it will take this string and it will put this string between all these commas and join the values inside this list as a string. So this is how join method works. Really very straightforward. It creates a string from iterable objects. It need not be list. It can be another iterable. Anything you can iterate, you can use join with that particular object. So if you say and dot join L, this will say apple and mango and banana. So you can try this join method yourself on some other lists. Let's now move on to the format method. What is this format method? What does it do? Let's write some code and try to understand. So I'll say format.py, and let me write something like this. I'll say a is equal to, I'll say I am a good boy and a friend of, and I'll do something like this, and I'll say dot format, and I'll say Harry, and just see what this is going to print. If I try to run this, you can see that I am a good friend and a friend of Harry. So whatever I'm writing here is coming here. Okay, let us say I am a good boy on this, and let me write earth. And if I run this, you'll see that I am a good boy on earth and a friend of Harry. Now let us say you want to put this Harry here and you want to put this earth here. So you can put a 0 here and a 1 here. And the 0th element from here will come here, and the first element from here will come here. Let me run this code for you, and you can see I'm a good boy on Harry and a friend of earth. So you can do something like this. Really very straightforward syntax. It formats the values inside the string into a desired output. So you can get the desired output using this format method. The syntax is template.format. And what is this template? Template looks something like this. So I have given a very simple example of format. This will tell you what format is. So if you say Harry is a good boy, or boy is a good Harry. So you can see output for 1 and output for 2. So here we have these curly braces, and we have Harry and boy here. So Harry will come here and boy will simply come here by default. But if I put numbers here, if I put 0 here and 1 here, Harry will come at 0 and boy will come at 1. So output will be boy is a good Harry. So this is how format function works. Now let's talk about map, filter and reduce. And for explaining map, filter and reduce, I'm going to map filter reduce.py, mfr.py. I'm going to write this particular file. So in order to understand map, filter and reduce, we'll look at the syntax and we'll try to implement it in code. So map applies a function to all the items in the input list. So let us say I have this input list and I have a function and I want to apply this particular function to all the items of this list. It can be a lambda function or it can be a normal function. I can do that. So let me get this particular function from here. And what I'll do is I'll get a list from somewhere. I'm searching for a list. I'm searching for a list. I'm not getting a list. So I'll write my own list. I'll say L is equal to, I'll simply say L is equal to 1, 2, 3, 4 and 5, comma 5. And once I do this, I can use map. I can say C is equal to map this function, which is square, to this list. And if I print C now, you can see that this function, this is a map object, so I'll have to convert it to list. So if I typecast it to list, you can see that this will return me 1, 4, 9, 16 and 25 because I have ran this square function on all these values. So this is something that you can always do. You can map the square function to all these values. Okay, so I hope you understood the gist of this thing. Now let's talk about the filter function. So map function was used to map a particular function to all the items of a given list. Now what I'll do is I'll talk about filter. Filter creates a list of items for which the function returns true. So let us say I have a function. Let me show you filter here itself. And what we'll do is we'll say demonstration for map. Then I'll write demonstration for filter. And then we'll see demonstration for reduce as well. But for the demonstration of filter, what I'll do is I'll simply say A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 89. So these are few random values that I have put here. Now what I'll do is I'll write a function. I'll say greater is equal to lambda x, and I'll simply say x is greater than 4. It will return whether x is greater than 4 or not. Okay. Now what I'll do is I'll say filter. Now I'll put a function which is greater and I'll simply put a. And I'm going to put d is equal to this thing and then print d. I'll do print d and I'll run this code. And yes, I'll have to convert it to list. So once again, I'll simply say list of d. I'll have to close this. And you can see that 54, 67, 81, 8 and 9 is being printed because anything which is greater than 4, greater will return true. And for all the values for which greater returns true, they will be filtered out of A. And you will see only those values for which this particular function returns true. I hope this makes sense. I hope you understood how these things are working. Now, this is how filter works. This can be a lambda function, and I forgot to write the second argument for filter. My bad. It should be comma some iterable. So you can make this correction in this notes. Reduce applies a rolling computation to sequential pair of elements. How do we do this? What does it mean? Let's talk about reduce, and only through an example you will be able to get the demonstration for reduce into your head. What I'll do is I'll use this list and I'll shorten this list. So let us say I want to apply a function to these two values, and then whatever comes out of these two values, I want to apply the same function with that value and this value. Let me show you. So if the function computes sum of two numbers and the list is this, so that function will be applied to these two values first, and whatever the value comes out of applying that function to these two values will come here, and then we'll apply the same function to these two and then same function to these two, and this is how reduce is going to work. So the first argument to reduce is the function and second is the list. So what we'll do is we'll say reduce sum a. So sum is a function. By the way, sum is a built-in function in Python. It simply gives you the sum of the numbers. So if I say d is equal to this, and if I print d, this will throw an error. Why? Because reduce is something that you'll have to import from functools. So this thing is important. So this is something that you need to understand and remember that reduce is a function from functools module. And if you don't import reduce from functools, you'll get into trouble because reduce is a function from functools module, and if you don't use reduce from functools and try to use it without importing it from functools, so you'll get some error. Let's see what happens. So it says int object is not iterable. What I'll do next is I'll write my own implementation of sum. So I'll say lambda xy and I'll return x plus y, and that's it. And now I'll run this program and you can see that 13 has been printed. So 1 plus 2 is 3 and 3 plus 3 is 6 and 6 plus 7 is nothing but 13. As you can see that this is printing 13. So this is how reduce works, and I have demonstrated this in a very good visual in our notes. So make sure you download these notes because I have put in a lot of hard work to write these notes. I've written these handwritten Python notes just for you. So make sure you download these notes, and also if you want to practice more and more, you should download the practice sets as well and try to solve them once again after completing the course. This will give you a very good grip on Python. So now we'll be practicing some of the questions from this particular chapter. Let's move on to chapter 13 practice set now. Now we'll start solving some of the practice set problems from chapter 13 practice set. So the first problem says create two virtual environments, install few packages in the first one. How do you create a similar environment in the second one? So the question is very simple and straightforward. What I'll do is I'll simply open my terminal, and what I'll do is I'll say python minus mvenv, and what I'll do is I'll simply type some name. I'll say environment1, and as soon as I press enter, the process of creating this virtual environment will kick off. So what I'll do is I'll simply say environment1 slash script slash activate.ps1, and the moment I do that, you can see that environment1 has been activated. What I'll do now is I'll simply install few packages. Let me install Flask, let me install Django, let me install sklearn, and let me also install something else. Let's install, say, let's install cv2, which is OpenCV, and let's see if this installation works. So Flask worked, Django worked. Okay, so we are getting this error, and the reason is that in order to install OpenCV, you need to write OpenCV Python, and the moment I do that, this should install OpenCV Python. Now what I'll do is I'll simply delete this requirements.txt file, which was previously created by me, and I'll create a new requirements.txt file. So let me say pip freeze, and I'll simply run this command. I'll show you which command I'm talking about. So I'm going to open this PDF. I'm talking about this command, pip freeze, and then there's greater than symbol and then requirements.txt. What this will do is this will store the output of pip freeze to this requirements.txt file. So let me run this command. I'm waiting for this to finish, and once this finishes, what I'll do is I'll simply fire this command, pip freeze requirements.txt, and this will actually store the output to requirements.txt. Let me fire this. Since my installation has been completed now, you can see that requirements.txt now has this particular thing. Now the question says that you need to create another environment and you should have the same packages that you had in the previous one in the second one. So I'll simply deactivate the environment. I'll simply say, okay, so I made a mistake here. I should have activated environment 1. So what I'll do is I'll simply delete this file. Did you see the mistake that I made? So here environment 1 was activated, but here environment env was activated. By default, for some reason, VS Code is taking this env as a virtual environment. So what I'll do is I'll copy this command and I'll paste this command here so that pip freeze, or rather let me copy this from here again, and I think I have copied, and now I can run this. So requirements.txt now contains the packages from environment 1. Previously I ran this command while I was in environment env. If I do this, all the packages from env will be copied to this requirements.txt file, which I don't want. So I'll simply say deactivate, and now what I'll do is I'll simply create another environment which is env2. I'm simply looking for the command to create this virtual environment. Now I'm creating another virtual environment which is named env2, or rather environment 2, sorry. What I'll do is now I'll activate this environment. In order to activate this environment 2, I'll simply run this command. And now what I'll do is I'll say pip install -r requirements.txt. We have seen this command before. We have seen this command here, and this simply takes the requirements.txt file, reads all the packages from requirements.txt file, and it install it in your current virtual environment. So our current virtual environment is environment 2, as you can see. So all these packages will be installed inside environment 2, and these environments are really huge. They are around 10 MBs and even more depending on the packages you have installed inside these. So you might want to delete all these environments later after you have learned how these environments are created. And even if you are pushing your files to Git, do not push environments to Git, because environments are really huge and they can be recreated using requirements.txt. So you can simply give this requirements.txt file to the person who wants your source code, and they can create this particular environment again using requirements.txt file. Now the question number 2 says write a program to input name, marks and phone number of a student and format it using the format function like below. So we need to create this template and we need to format the string like this. Okay. So name of the student, marks of the student and phone number of a student are placeholders here. So what I'll do is I'll simply copy this. The name of the student is Harry. Let me type it here. The name of the student is Harry, or rather I'll give a placeholder here, and his marks are then another placeholder here, and phone number is another placeholder here. Now let me create a new file. I'll simply say 06_pr02.py and I'll paste this string here, and what I'll do is I'll say st is equal to this. I don't want to use Copilot as of now. I'll close this terminal. Now what I'll do is I'll simply say st.format and I'll give the values of all these placeholders. So I'll say Harry, and then I'll say 34, and then I'll say 98888 is the phone number. Do not call me, okay? This is not my phone number, okay? So now what I'll do is I'll simply say print a. Let me say a is equal to st.format, and if I print a, you'll see that this has been printed, and I hope you got the point. This is automatically taking the CNV environment and activating it the moment I create or open my terminal. But yeah, you can delete this virtual environment if you don't want to use virtual environment. Now what I'll do is I'll move on to the next question. The next question says that a list contains a multiplication table of 7. Write a program to convert it to a vertical string of same numbers. And yes, this is very important. Okay, so let me create a new file 07_pr03.py. So we have a list, let's call it A, and we have multiplication table of 2, say 2 here, and I'll generate multiplication table of 2 like this. I'll say I start 2 for I in range 1 comma 11. So this is multiplication table of 2. Now what I'll do is I'll simply say for item in A, I'll say st plus equals to item plus backslash n. What am I doing here? You must be thinking. And I'll explain it to you, do not worry. So I have a blank string here. Now what I can do is I can print this sc. So this is the program to achieve the same thing. So you can see that st plus equals to this type error. Okay, so item is actually an integer, so I need to convert it to str. So a lot of learnings from this question. So you cannot add a string to an integer. You'll have to convert it to string, and then only you can add a string to an integer which you want to consider as a string. So you'll have to typecast using str, and this will definitely work. So this is the output that we wanted. We wanted to create a vertical string, and we have done that, as you can see. So it was a multiplication table of 7. So let me change this to 7 because the question demands multiplication table of 7, and yes, vertically the table of 7 has been printed. I hope you got the point of the question, and I hope you understood the concepts that we applied in this question. The next question says that write a program to filter a list of numbers which are divisible by 5. So what I'll do is I'll create a program, and what I'll do is I'll create a method is divisible, and I'll simply say that return if n% 7 equals to 0, return true, else return false. Okay, and I need to put n. Okay, so the number was 5 and not 7, so I'll have to say 5. Now what I'll do is I'll create a list. I'll say 1 2 3 4 5 6 7 8 9 and 10. Okay, so there are two numbers which are divisible by 5. I'll say print list filter. The first argument is a function, so I'll give is divisible, and the second argument is the list, and this should print the filtered list. So I need to put another bracket because I need to close this as well. So I'll run this, and you can see 5 comma 10 has been printed. So all the numbers which are divisible by 5 are printed. So what if I add 60 here? Will 60 be printed? Yes, it will be in the list. So you can see that 5, 60 and 10, all these three elements are there in the list. Moving on to the next question, and the next question says that write a program to find the maximum of the numbers in a list using reduce function. Now this is once again one of the easiest problems of this practice set. I'll import reduce. I'll say from func_tools import reduce, and after importing reduce, what I'll do is I'll create a list. Let me add few numbers to this list. Now what I'll do is I'll create a max function. I'll say def max. I'll say 1 comma 2 3. I'll say if not 1 comma 3, I need to put n m comma n. I'll say if m greater than n, return m, else return n. So this is the implementation of my method. Let me bring this down. Now what I'll do is I'll simply say max num is equal to reduce, and the first argument is a function, and it's going to be max. What is the second argument of reduce? The second argument of reduce is the list you want to perform sequential computation on. I've already told this in this particular topic, map, filter and reduce. So what I'll do is I'll pass in a, and this should give me max of all these numbers. So if I print max num, I should be getting 675, and you can see 675 has been printed. What if I make this the largest number of the list? You will see this printed on the screen. As you can see that 1111 has been printed as the maximum number from this list. So I hope you got the point, and I hope you understood how the dynamics of these things work. So this was about reduce function. Now the question number 6 says that run pip freeze for the system interpreter. Take the contents and create a similar virtual environment. Let me do this for you as well. I'll delete this requirements.txt. I'll run pip freeze and let me deactivate. And why am I deactivating? Because I'm already inside a virtual environment. So this is something that you need to take care of. You should not be inside a virtual environment. I'll say pip freeze requirements.txt, and this will create a requirements.txt. Now I can create a virtual environment by saying python -mvenv, and I'll simply name it system. And if I call it system, a virtual environment named system will be created here, as you can see. Now what I'll do is I'll activate system. I'll say system scripts activate.ps1, and this activated my system. Now I'll say pip install -r requirements.txt, and this command will take all the packages mentioned in requirements.txt, and it will start installing all these packages to my virtual environment system. I hope that this question is clear to you, and you can do the similar thing using some other virtual environment. You can take the contents, or rather the packages installed in a single virtual environment, and install all those to other virtual environment. So these things can be done very easily using pip freeze command. Now the next question says that explore the Flask module and create a web server using Flask and Python. And this is really very easy. All you need to do is you need to go to Google and you need to say Flask minimal app, and this will give you a quick start documentation of Flask. All you need to do is simply copy this, and once you copy this, all you need to do is you need to run these two commands, and this will definitely run your server. So let me show you how this is done. So I'll simply close all these things, and we'll create a new file 10_pr06.py. So I'm going to do this, and also what I'll do is I'll simply say app.run, and this will start my development server. But before before starting my development server, I should have Flask installed. So if Flask is not installed, then you will face some problems. So you need to install Flask in your virtual environment or in your system interpreter for this to work. So now if I control click this link, I'll see hello world. What if I make this hello world 2? If I make this hello world 2 and if I save this, what will happen is once I restart the server and reload, you will see hello world 2. So Flask is a framework which is used to create websites in Python, and this can be used by looking at the documentation. There are a lot of concepts of Flask, so I will cover Flask in some other video, definitely in the future. So if you need a Flask tutorial, just comment below and I'll create a Flask tutorial very soon. So this was about the chapter 13 practice set. I hope you enjoyed chapter 13 practice set. I hope you enjoyed the questions, the concept of virtual environment and everything. Let's now look into our third project, which is a web framework, Django. Yes, we are going to build a website using this beautiful framework, and we are going to understand a lot of things about this Python programming framework. So you can look into this project 3, and it simply says that you need to use Django to create a website. So what we'll do is we'll write Django docs, and let me show you something. Django has a beautiful documentation, but more beautiful than that, what I feel in my opinion is Django tutorial, and absolutely beautiful tutorial. Why do I say this? Because this is beautiful. You'll read it and you'll find it out that this documentation, or rather Django tutorial, is very well organized. Let's copy this particular thing. I'm going to copy this command and I'm going to install Django, and I'm going to use a few best practices, for example creation of virtual environments and separating the concerns. Let me fire a command python -m env, and I want to create this env environment and activate it before I start doing some Django specific stuff. So env has been created, and what I'll do is I'll simply say env scripts activate.ps1, and I'll install Django inside this, but it says no module Django. Oops, I need to install Django first. I copied the wrong command. So let me simply say pip install Django, pip install Django and this will install Django. Django has been installed and now we can start using Django, and hopefully this command will also work, and it prints the Django version as 3.2.5 as you can see. So now what we'll do is we'll look into the Django documentation and I'm going to explain everything you need to learn about Django. So Django has a concept of creation of project using a utility called Django admin. Do not get confused with the code that it's going to generate. You simply type Django admin start project, and let us say we are going to create a portfolio website. Just type the name of a project and it's going to create a folder with that name, portfolio in my case, and you'll see that it has a bunch of files, in fact a lot of files, and these files can be used by us to use Django framework. So let's now look into another thing. These people have explained all these files. They are saying manage.py is a Python utility, it's a command line utility, and then the inner my site directory is the actual Python package. Let me do one thing. What I'll do is I'll cd into this portfolio directory so that I'm inside this directory now. And what I'll do is I'll simply do ls, and you can see we have a folder called portfolio and a manage.py. The moment I say python manage.py run server, which is a command to start the Django development server, I can use this. So let me control click, and once I control click, you can see that this Django starter page tells me that the install has worked, and this is how I can actually start using Django. So this is not something I want to see, because definitely if I'm creating a portfolio website, I'll create some of the files of my own. I'll write some HTML, I'll write some CSS. So those things definitely I'll have to write on my own, but I'll look into the documentation and keep moving forward. You can see that Python manage.py run server has been written in the documentation as well. And yes, you will get this particular prompt. We have already got this, and it's telling me that run this command, and it's asking me to do a lot of stuff. But now the next thing that I'm going to do is I'm going to create an application. So let me tell you the difference between project and apps. So it's telling here what's the difference between an app and a project. An app is a web application that does something. For example, let us say you have a project portfolio. Now you might also start a merchandise. Let us say I am a very famous programmer or something, and what I want is I want to write a blog. I want to write some website content for somebody else, and I can call it sponsored guest post. And also I want to run a shop on the same website, and I can create 3 separate applications for this. This simply separates the concern of a blog, of a shop, and of a portfolio sponsored project or something, or whatever else I want to do. Let's say I also want people to contact me. So if I want people to contact me, what I can do is I can have a contact application, and using that application I can make it easy for people to contact me. They can email me, or they can send me a text on my phone, or they can directly call me on my phone. So I can separate this concern to another application. So while we are creating an application inside a project, we are basically separating the concerns. We are separating a blog from a shop. We are separating a contact utility from a shop or from a blog. So the first step that I'm going to create is home. While we start a project, it's highly likely that you'll have only a single application. You want your Django project to do a very basic stuff. So in that case, what we do is we just name our app as home. So I'll simply run this command, python manage.py start app home. And what this will do is this will simply create a home folder here, and this home folder will have this directory structure. Let's try to understand the directory structure. Let's try to understand the content of this portfolio home folder and the folders and files inside this home folder. So looking at the portfolio, this particular folder, this is the name of our project. Portfolio was the name of our project, and it will have these files. These files have their own purposes, but the most important file out of these files is settings.py, and settings.py is a file which contains all the global settings for a Django project. So this is the file that we are going to edit a lot. Then another important file is urls.py. This will actually tell my Django project where to go for what URL, and we are going to come back to this in a while. Let's go to the folder that was created while we created our home app, and this has these files. Init.py tells that this particular folder is a Python package. Another important file is urls.py that we are going to create inside this folder. Then we have views.py and we have models.py that will hold all the models of a Django application. So we'll look into all these files one by one, and when we start doing stuff in Django, you'll definitely understand what these files are for. Manage.py is a command line utility. db.sqlite is a default database. If you don't know, SQLite is a database and it's a file-based database where all the content is stored in the form of .sqlite3 files. Manage.py is a command line utility. You can run manage.py and some command and it will do something on your Django project. So coming back to a Django project, let's start writing our first, let us say, page. So what I'll do is inside portfolio, I'll create a folder called templates. And inside the template, I'll create a file called index.html. So let me call index.html and I'll close this db.sqlite. I opened it by mistake. Now what I'll do is I'll put an exclamation mark and I'll simply say hello Django. Now how do I serve this particular file when somebody comes to my home page? So what I'll do is I'll open two files. First is the urls.py from my portfolio, which is the name of my project. I'll open this urls.py, and another file that I'm going to open is urls.py from my home project. So I'll create a urls.py from my home project. It's not there. So I'll create urls.py, and what I'll do is I'll simply use the comments from this file to create urls.py for my home page. So urls.py for my settings page will tell my project where to go for what. So what I'll do is I'll simply write path and I'll include this include as well, and I'll use this syntax. I'll simply say that whenever somebody is trying to access a URL starting from blog, you go to blog.urls, that is urls.py of my blog folder. But in this case, what I want to do is whenever somebody wants to go to say any URL, I want that person to be sent to home.urls. And what I'll do is inside urls.py of my home, let me copy this urls.py here. What I'll do is I'll map the URL to a view. How do I do that? I'll simply map this URL with a function. So what I'll do is I'll copy this. I'll simply say path. Whenever somebody comes to this thing, you just go to views.home, and I'll have to import views. So I'll simply import views. So let me import views by saying from home import views, and this error will go away. Let me start my development server and let me see if things work. So it says that there is a no home function inside my views.py. So I'll have to create one. I'll simply create my home function using this syntax. And what I'll do is I'll return HTTP response and I'll say, hey. So I'm not using my template file as of now, but we'll be using it very soon. I've imported HTTP response. Let me go to this file and you can see this hey has been printed. So how does this work? How is this hey being printed here? What happens is my urls.py will start searching for this URL pattern. What is the URL pattern? URL pattern is the home page. It will say, is this the home page? No, it's /admin. Is this the home page? Yeah, it might be home page. Let's check home.urls. So it will go to home.urls, that is urls.py of my home folder, and it will check for a path that matches a blank, because there is nothing after the slash here. It's a blank URL. So blank URL is being mapped to views.home, that is the home function. What if I want to create an about page as well? I'll add a comma, I'll give it a name about, I'll give the function name about, and I'll also say about like this, and I misspelled about, so I'll fix that. And what I'll do is I'll create another function and I'll say about. I'll save this file and I'll open this file. I'll go to /about and it says that this particular URL is not found. We have made some mistake and we are going to fix that. So in order to solve this problem, what I'll have to do is I'll have to remove the slash from here, which I've already done. I wrote /about, but I've changed it to about, and let's see if this fixes the problem. And yes, it does. So this particular site is giving me hey, and /about is also giving me hey. So let's try to change this to about, and let's see if we are able to serve this content. So yes, we have created a website. This particular page is giving me this, slash about is giving me this. And if I want to create another endpoint, which might be slash contact, so what I'll do is I'll simply put my cursor here and I'll start typing contact, and I should get another response called contact once I write my contact function. So I'll finish writing my contact function, and once I go to slash contact, this will give me contact. So we have three pages in our website now. The first one is the home page, the next one is the slash about, and the next one is the home page. Okay, home page, slash about, and slash contact. Now what I'll do is I'll try to map this to a website, because this is not serving any HTML. I want to serve an HTML using my endpoints. So what I'll do is I'll use the render function. I'll say return render. The first argument is the request, and the second one is the name of the template, which is index.html. Let's try if this works. And yes, it's not going to work. I'll tell you why. So it tells me that template does not exist at slash. So basically what happens is when you write return render request index.html, it's trying to load the template using the template directory. So this particular directory, which is slash templates inside this portfolio, this is not present in my templates dirs variable. Where is this variable? Inside settings.py. So if you remember, I told you that inside settings.py we have all the global settings for a Django project. So if you go and try searching for template dirs, you'll find that this is the variable that we need to edit. So if I add templates inside this dir, then this should fix the problem. So if I reload the page, you can see hello Django. How did this happen? How did this fix this error? So what I've told Django is that I have a folder called templates inside the home folder. So please try to use the templates inside this folder whenever I call render. So whenever I use this render method, what happens is this particular render method will try looking for this file inside the templates folder. So this is a file that it will look for, this index.html, and where will it do this file for? Inside the templates folder. I hope this story is clear to you and you understood how these things are working together. In a very similar way, I can create about.html and I can get rid of this HTTP response. HTTP response is mostly used when we have a very quick content to serve, but in our case, we don't have a very quick content to serve. Rather, what we have is an entire HTML file. So now what I'll do is I'll add about.html and contact.html inside my templates directory. Now ignore this error for now. You have 18 unapplied migrations. Your project may not work properly until you apply the migrations. We'll talk about this very soon, but let's ignore this for now, and this is not going to hamper the progress you are going to make. So I have this error. Even if you have this error, this should not bother you. Okay, so we'll come back to this. Now what I'll do is I'll try to use slash about endpoint and I'll get an error that template does not exist. And yes, this is right. We don't have any template called about.html. We don't have any template called contact.html. This is true. So what do we do? How do we solve this problem? We'll have to create about and contact HTML templates. Let's do that. Let's create an about.html file, and also let's create a contact.html file. Inside about.html, I'm going to write about, and I'm going to say this is my about page. The moment I do this and reload this page, you can see the title is updated and the content is also updated to this is my about page. I'll do the same thing for contact.html as well. I'll set the title to contact and I'll set the content to contact us here. If I reload this page, or rather this page, you can see that the title and the content have been updated. Now this doesn't look good. We don't want to design the entire website from scratch. That is going to take an eternity. We don't want that. You want some quick and easy way to get to a website, or rather a clean and responsive website design. Is there any shortcut to that? And yes, there is. And it's called Bootstrap, and it's free. It's fun. We are going to use this. So let's copy the starter template from Bootstrap and start using it. So what we'll do is we'll start with index.html. Let me copy the starter template. Let me paste it and let me say hello Harry, and we'll see that once I reload this page, hello world is a title. And did you see this design being changed? Yes, this is due to Bootstrap. Let's now go to components of Bootstrap and let's try to pull the navbar out of here. What I'll do is I'll copy this code, and Bootstrap is basically copy paste. Let me put it in very simple and easy words for you. It's simple copy paste. Just copy the starter template and start copying the components, and you'll get these components rendered as is. Let me show this to you. So I'll get rid of this hello Harry and I'll paste this navbar component. I'll save it and reload my index.html. You can see the navbar has been printed. So I can also call the title as Harry portfolio, okay, or rather Harry's portfolio. I can do something like this, and my title will be updated after the reload. So once I reload, you can see the title being updated. Now I can change this content to Harry's portfolio, and I can even update the links. For example, if you look at these links, I can say slash, and then again for this link I can say about, I can say slash about. Let me get rid of these LIs. I don't want these LIs. What I mean by LIs is list item. It's an HTML tag which is giving us this drop down and disabled. I don't need drop down at this point. So all I need is home and about, and I have put that out there. So I can go to about and it will take me to about page. I also want to add another LI which will take me to contact page. So let me do that as well. And also what I want to do is I want to copy this template to about.html and contact.html. And when I'm in contact.html, I want to put this area page is area current is equal to page inside contact.html so that it is highlighted when we are in contact. And also I'll cut this from here and I'll put it inside about, and this particular about will be highlighted when we are inside about. Also what I'll do is I'll remove this active class from here and I'll give it to contact. Also I'll remove this active class from here and give it to about when we are in about. What does this do? Let me reload and show you. When I'm in about is highlighted. When I'm in contact is highlighted. Also I want to change the titles when these things are updated. When we go to a new page, I want my title to get updated as well. So I'll say about Harry's portfolio. So once I reload, you can see we are in contact, we are in about, we are in home. So now what I can do is I can actually implement this search using Django. I can write some logic in Python. I can do a lot of things using Django, but for the sake of this tutorial, I know this is not a Django tutorial. This is a Python tutorial. I just want to get you introduced to Django. So what I'll do is I'll simply copy few cards and few components from Bootstrap and get you familiar with some of the important components of Bootstrap. So accordion is one of the components, and I like accordion a lot. I use it a lot. You can copy this code, and what you can do is you can put it inside index.html. So what you can do is you can create a container. So I'll say div.container and I'll put it inside this container. I've saved it. I'll reload this and you can see that this accordion has been copied to my website. So this is now a part of my website and I can use this accordion. But I want some gap between my navbar and this particular container box. So what I'll do is I'll simply put a class my3 and this will add some margin to my container. Let me show you how. So you can see that we have some spacing between our accordion and navbar now. Is this website responsive? Oh yes, it is. Let me show you. This website is fully responsive. You can use it in your phone and this will work as expected. So this is the beauty of Bootstrap. You get a clean design, a responsive design, all for free. and I love Bootstrap for that. You can even change this nav bar. You can change it to dark. In case you have this question in your mind, I'll tell you how to do that. You can change this nav bar light to dark and this BG light to dark, and once I reload the page, you can see that we have the dark nav bar. So in case you are a dark mode fan or dark color fan, you can use this nav bar. And this will not change in contact and about. This will change just in this particular page because we have changed it in index.html only. In a very similar way, we can design the contact page. I'll revert back to, or rather I'll keep it this way in case you want to use a dark nav bar. Or let me keep it light because I know that you can always change this to dark if you have watched the video. So I'll revert it back to light. Now what I'll do is I'll copy a few form syntax inside our contact.html and I'll simply create a container here. Now I'll go back to my forms. I'm searching for forms. In case you see that, just let me know. Why am I not able to find forms? So I think they have changed the layout of the website. So when the Bootstrap was in version 4, forms used to be part of a component, but now it's no longer a component. They are keeping form as a separate tab here, which is fine. We can always copy paste from here, and I'll simply copy this form. Let me copy this form, and you can customize this form as per your liking. So let me see how the basic form looks like. This is how my basic form looks like, and I'm going to put a margin once again above and below my container so that we have some space. I'll also add an h3 tag and I'll say contact us, or me rather, because this is a portfolio website. I'll reload and you can see this contact me. If you need some spacing, you can always add a class of my2, my3 or something. I'll add my2 this time so that I have some smaller space between my this thing and this form. I hope I have added class is equal to my3. If you want some more gap, you can always go for my3 or mb3 even. This will give margin bottom 3. mt3 will give you margin top 3. So these are the things you can remember. Did you see that we just increased the spacing between this heading and this form? You can change all these fields as well. You can copy paste, you can do whatever you want. What I will do is I'll simply copy this. Let me format the document so that it looks a bit beautiful. Now what I'll do is I'll copy this div and I'll paste it again and I'll change this to name. I'll say name and I'll remove this div. I'll say name and then I'll simply call this name again and I'll simply call this ID as name as well. And you can see that name, email address, and you can create as many fields as you want. We have this checkbox as well. We can even submit this form using Django. There is a lot you can do. In a very similar way, you can customize your about page, just like I customized home page and contact page. I want you guys to customize the about page and show me once you customize it. And I want this particular link to go to the home page. So let's do that. What I'll do is I will go to my Harry's portfolio. I'll change the href to slash. Once again, I'll do the same for contact page. Where is my Harry's portfolio? It's here. I'll change this to slash, and also I'll change this particular thing to slash. So this is how you can use Harry's portfolio as a link now. So if I click on Harry's portfolio, this is a link, this is a link, this is a link, again this is a link, this is a link, and you can navigate and a website works. So this is an example of a very basic website that we have created using Django. I hope you like this website. Now we are going to talk about models, and no, we are not going to talk about any fitness models or music video models. We are going to talk about Django models. So before I talk about Django models, I want to do some things. I'll close my Visual Studio Code and listen to me very carefully when I do this. I'll close my Visual Studio Code. I'll delete this virtual environment. You might think, why am I doing that? Why am I deleting this virtual environment altogether? After all, we created it to use a Django project, right? To use the separate environment for a Django application. But I'm going to create it inside this portfolio folder. So whenever you are creating a Django application, what you should do is you should first create a project, and then inside that project folder where your manage.py is staying, you create your virtual environment. So let me show you how this is going to look. So I'll simply say python -m venv. This is going to create an env. Yes, it has been created now. So let's do one thing. We are going to now activate this virtual environment. We are going to click here and it is going to detect this virtual environment. And if not, you just restart your Visual Studio Code and it should definitely activate your virtual environment by its own. So it is not finding it. So let me find it for my python.exe. I'll simply select this interpreter and yes. So now this particular interpreter is in use. So now if I click on new terminal, this is actually using my virtual environment. Let me delete this terminal and let me open this terminal once again. And the moment I open this terminal, you can see that this environment has been activated. And if not, you can always manually activate your virtual environment. So now that we have this virtual environment activated, I'm going to pip install Django because we haven't installed Django inside this environment. We have created this environment from scratch. And now what I'll do is I'll simply run python manage.py run server. So python manage.py run server, and this will start this server and our website. Now we are going to talk about models. Models are nothing but information to create a table in the database. What does that mean? Let us assume that this particular contact me page is actually functional. What will I want? I will want this contact me responses to be seen by me, to be exported by me, or to be used by me so that I can know that who has contacted me for what. And I should be able to get all these fields. So before we create our model, what I'll do is I'll come to this contact.html. Let me open this contact.html. I'll close this one. And what I'll do is I'll simply gather name, email address, and phone number. So instead of saying this, I'll say phone, and inside ID as well, I'll say phone. Type is equal to phone, for is equal to phone. And then what I'll do is I'll do the same thing for, I'll remove this check me out. And that's all what I'll do. If I reload, you can see name, email address, phone. And definitely if someone is coming to a contact form, they will want to write something. So I'll simply say text, and I'll simply say description, or rather, how may we help you? Okay, we can do something like this. Let me reload, and yes, we have an input tag here. I want to replace this with text area. So I'll say text area and I'll close this text area. And now this should look a bit better. Yes, it is looking a bit better. So I've made some quick changes to this form. Let me tell you all those changes. I've added a name field. So name for the name is name for the email is email, name for the phone is phone, and name for the text is text. This name is used to identify which field to pick from the form by the backend server. We'll look into this very soon. Another change is the text area, and now after I change this to method is equal to post and action is equal to /contact, we are actually making post request instead of get request. So the difference between the post request and get request is that whenever you are sending a get request, everything will be visible in the URL. We don't want that. We want to send some more data as a post request to this URL, to this endpoint. Now let me try to submit some data. You can see that I'm trying to submit some data, and once I submit, it forbids me, and we are going to talk about this, what is happening here. So before I do that, let me tell you something, that whenever we are submitting this form to /contact, what happens is this will go to this /contact and we can handle the form here. So let me write handle the form here. And what I can do is I can simply say if request.method is post, what I want to do is I want to simply say that when this request method is post, just print the request.form. Okay, that's all I want to do. But since we have this CSRF error, we are going to solve this. Let's go to the Django documentation and see if they have solved this problem somehow. So if you read this documentation, it is really very good, let me tell you beforehand. But again, to quickly get hang of the things, you should listen to me as well. And after you listen to me and read this documentation, things are going to get easy. But let me see if they have talked about CSRF. So there's a syntax to add CSRF token. I'll show you where that syntax is. So let me search for CSRF here. They don't have it here as well. I remember on some page they have the CSRF token, and once you add this CSRF token, and this is the way to add CSRF token. What is CSRF token, by the way? Let me tell you. Let me explain what CSRF token is. But before that, I'll simply add this CSRF token and this issue will go away. CSRF token is a security measure which will protect your form from being submitted by bots from some other origins. So this token actually takes care of the fact that the form is being submitted from the same origin. CSRF stands for cross-site request forgery. And if somebody else is using the form and submitting it directly from elsewhere, they might do something malicious and we don't want that. But for the sake of this tutorial, we'll skip the details and let's reload the form first and try to fill the form once again. And once I submit, it simply says that Whiskey request object has no attribute form. So I cannot print request.form. So in order to get rid of this error, I'll have to say request.post and I'll enter name attribute of the field that I want to see here. So I'll simply print request.post and name. And once I do that, let me show you. I'll submit the form. Let me reload this form and continue. And you will see this name has been printed here. What if I do the same for, say, I'll pull some field out of here. I'll do the same for phone and we'll see what can be done. Let me reload this once again and you will see that the phone is also being printed. So we have all these fields here. Now we want to save it to some sort of database. So we'll look into the models now. Come to models.py, and before I come to models.py and start writing the models, I want to add my application to the installed apps. So this application, the name of the application is home, is not installed yet. So what I'll do is I'll come to code portfolio and I'll open my settings.py. And what I'll do is I'll come to the installed apps and I'll add this app to my installed apps. Which app? This particular app. So the name of this application is home config. So what I'll do is I'll copy this home config and I'll add it to my settings.py right here like this. And this is now inside. So I'll say home.apps.homeconfig. So this is the way to put it inside installed apps and the server is back up running again. So this is something that you need to do for all the apps you are installing. I'll close settings.py. I'll start writing a class. I'll say contact and C should be capital because we want to use Pascal case for the classes. Now what I'll do is I'll enter these three fields. We have name, we have phone, we have email, and then we have description. So for the name, what I'll do is before I enter anything, I just want to use models.model. I want to extend this content class from models.model. This is plain and simple inheritance and this is pretty straightforward. What I'll do now is I'll say models.char field and I'll simply put some default value. I'll say default is a blank. And I'll do the same thing with models.char field with phone. I'll say default is equal to none, or rather let me put it blank. I'll do the same thing for email as well. We have something called an email field, so we'll leverage that. I'll use this email field and then we'll use a text field for this description. So I'll do this and this simply says that character fields must define a max length. So I'll have to define a max length for this. I'll say 123 characters for name and I'll say 11 characters or 12 characters, 12 maximum characters for phone number. So I can do this, and once I reload this page or click on contact, I'll come to this page and I can fill this form yet again. I'll submit, and once I submit, you can see that this and this has been printed, but we haven't used a model yet. Also, we don't have any tables created in the database yet. Let me introduce you to the concept of Django admin first. So this is a schema that we have created. This is something which simply defines a contact model. Model is nothing but some information to create a table in the database. Now what I'll do is, I want you to follow along without asking any question, and I want you to type python manage.py create super user. Now you might ask, super user for what? Who is this super user? And what are we managing? Where is the account? Just don't ask these questions. I'm going to explain everything in 5 minutes or so. But we are getting this error which says no such table auth user. So to get rid of this error, we'll have to run the migrations. What are migrations? When you say python manage.py make migrations, this simply creates migrations for the models. So what it basically does is it creates a Python file which will be used to create the tables in the database. So make migrations will create something called migrations in Django, and migrations are nothing but these Python files which contains the information to create a table in the database. And the moment I say python manage.py migrate, what it does is it directly creates the tables in the database. All these migrations will be run, and now I can use my Django admin to create a super user. So the moment now I say python manage.py create super user, it will ask me for a username. I'll use Harry. I'll keep the email address as blank. I'll choose password as Harry. I'll choose password as Harry again, and I'll confirm that I want to bypass password validation. Now what I'll do is I'll simply start my server by saying python manage.py run server. What it will do is start my server. Now I can go to /admin and I can log into my admin account. The username is Harry and the password is Harry. So I'll be able to see all my models here. But there is no model contact that we created. Why is that so? I was expecting a model contact here, but it's not present. Why is it not present? Because we have not registered this model. So you will have to come to your admin.py, and what you'll have to do is register your model. I'll say from home.models import contact. Now what I'll do is I'll say admin.site.register contact, and what it does is it registers my model. Now if I reload the page, you'll see this contact has been shown here. Now I can add entries to my contact table. So behind the hood, everything is contained inside my db.sqlite3 file, which is this, and all the tables are created inside this file. As and when you create the data, as you keep creating the data, you will see the size of this file growing. But Django very beautifully manages everything, and this is something that I love about Django. So you can close this admin.py and you can now come to views.py, and what we want to do is we want to import this model right here. So what we'll do is we'll say from home.models and we'll import contact, and we'll simply say c is equal to contact, and we'll use all these things. We'll say name is equal to name, and then we'll say phone is equal to phone, and also desc is equal to desc, and we have another field here, email is equal to email. So this particular object is being created, and this is the constructor which we are calling. We are saying the name field is name. What is name? We'll create this variable. We'll say name is equal to this, and we'll do the same for email and for the phone, and we'll do the same thing for desc as well. So we'll save it, and we'll simply say c.save to save the data into a model. So did you see this? We have created a name variable which is nothing but the string that is typed by the user here. This is also a string which is entered by the user in the phone field here, and desc is the field is a string which is entered by the user here. Okay. Now what I want to do is I want to submit this form such that it is saved in my database. So let me open my Django admin. Where is my Django admin? It's here. So what I'll do is I'll submit the form here and you will see the contacts being added here. Currently, if I reload the page, there are 0 contacts. Let me try adding a contact and I'll make sure that it doesn't contain any error. I'll say, hey, how are you? I'll submit and we have a problem. It says multi-value key error. And the problem is that here I'm calling it text, but I should call it DESC because I'm using DESC here. Okay, so I'll try again. I'll simply say continue. It will throw error again. So let me fill this form yet again. I'll say, hey, how are you? And this time it should go through, and yes, it went through. Let me reload this, and yes, I have this contact object present here and it has all the fields that I filled inside the form. What will happen if I fill this form once again? If I say Rohan and I say rohan@gmail.com, I simply punch in some random number. Hey, how is everything going? If I do something like this and if I submit, and if I come back to contacts, you'll see another contact object. Now, when you look at this particular list of contact objects, you will see contact object 1, 2, 3. But can we not change it to something meaningful? And yes, we can do that. We can add a str field to a model. I'll show you how. Come to models and simply define a dunder string method. And what you'll have to do is you just return something from here. So what I'll do is I'll simply return name or rather self.name. I'll say self.name. So this name will be shown here. I'll reload this and show you how. So Rohan, Harry, now I have some idea who has sent this form to me. You can also change it to email or write a custom string or something. For example, if I put an F string like this, I'll show you how. I can close this here. And if I give a space and say self.email here, you will see something like this. So whatever you enter here will be displayed here, and it will make it easy for you to look into these model responses. So all these are responses. As you keep on adding things here, you'll see the model responses here. So this is how it works. This is how Django model works. And we have a website which is static but also accepts dynamic form responses. You can submit this form and your users will be able to submit information to your form which is created and managed by Django. I hope you like this particular thing about Django, and I personally use Django a lot when I need some admin panel. So this admin panel is not created by me. This admin panel is built into Django, and this is the beauty of Django. A lot of people ask me, how do I change this particular text and this particular text in this Django admin panel? So simply Google how to change Django admin text and we'll come to something which will tell us hopefully how to do this. And yes, I can see this. Let me copy this to my urls.py as this website says. And this definitely works. I've tried it and I'm telling you this will work. So what we'll do is at the end of urls.py, I'll say programming with Harry admin, and I'll say pwh admin panel, pwh portal. Let me save this, and if I reload, you'll see programming with Harry admin. Welcome to pwh portal. And I'll show you something else. If I log out and if I log in again, you'll see programming with Harry admin. This is coming from here. So you can update all these 3 variables and you can definitely change the look and feel of this. Now there are a lot of other ways to change the look and feel of Django admin, but we are not going to go into those features of Django in this tutorial. I hope you understood everything that I told you. Now we'll talk about static file serving. What does it mean? Static file serving simply means that we are serving some files which are static in nature. For example, some text files, CSS files, JavaScript files. Where do we keep all these files? We keep all these files inside a folder and we can serve static files from that folder. So let me create a folder called static And I'll simply create a file called 1.txt inside this static folder. So here's my static folder. I'll click on it and I'll simply say 1.txt, and I'll add two variables to my settings.py. One is static URL, which is already added. Another is static files dir. So I'll say static files dirs, if I have spelled it right. Let me check if I've spelled it right. I'll look into the Django documentation to see whether I have spelled it right. So static files dirs, and I'll simply copy this and I'll paste it here. So static files dirs, and what I'll do is I'll simply say static. I'll simply add static here. So static is a folder and in lowercase. Now what I'll do is I'll use my server and I'll say static slash 1.txt, and you can see that 1.txt file is being served. Let me add something. This is a file. I have saved this file. Let me reload. This is a file, and yes, we are able to serve this static file using Django. Okay, so this was about static files dirs. You can add multiple directories as well, which is why it is a list. You can add more than one directory, but in most of the cases we use just a single directory to add static file folders to that. So what we'll do now is we'll look into template inheritance. So let's look into template inheritance in Django, and what we'll do is we'll simply use a concept which can actually help us in repeating ourselves, or rather I should say that it will avoid us or help us avoid repeating certain things in a website. Let me explain you what I mean by that. So did you see this nav bar? This nav bar is being repeated here, here, here. Now let us say I want to make change to this particular part of the nav bar. I'll have to make the change in 3 different pages. Ideally, I want to change a single component, but I'll have to do that change in 3 different pages. How do I avoid that? To avoid that, we use template inheritance, and let me explain what it means. So what I'll do is I'll create a base.html inside my templates folder, and what I'll do is I'll simply copy this, I'll paste it here. So anything that is coming inside the container, let me remove this, I'll cut it, or rather I'll get rid of it. The base.html will now contain the nav bar and not the body, or rather the body of the container, the container div. It will just contain the nav bar. So let me save this file and let me come back to index.html. In index.html, what I'll do is I'll get rid of this nav bar and the boilerplate, and once again I'll get rid of this nav bar and the boilerplate. What I'll do is I'll simply save this file and I'll extend this file from the base template. So I'll recommend you one extension for Django. I'll simply write Django here, and it's a very beautiful extension. You can simply use this extension to get the syntax. So you can see that I'm getting base.html. So I am extending base.html. Now what I'll do is I'll say block body, and inside the block what I'll do is I'll put all this content. And even in my base.html, what I'll do is I'll create a block. I'll say block body will come here, and I'll close the block. Or rather, to close the block, I'll have to say end block body. So I've ended this block. I've started this block and ended this block. So this is how we use block body and end block body. Will it work? Will my index.html work? Let's check. And yes, it works. Now what I'll do is instead of writing this nav bar again and again, I'll extend my template from base.html. So at the top of every file, I'll write this. So let me come back to about.html. So I'll get rid of everything. I'll say whatever I want to enter will come here. So I'll simply say end block body. Okay, so this is something that we'll do. And after about.html, what I'll do is I'll do the same thing for contact.html as well. So I'll simply paste it here. So block body and block, and let's see if the website works. So home, about, contact, home, about, contact. As you can see that we have the same website once again. So home, about, contact, and let us say I want to make this contact as contact 2. I'll have to make the change only here and not to 3 different pages. The moment I make a change here, I change this contact to contact 2 or other contact me, it will be reflected all over the website. So this is the usage of template inheritance, and template inheritance really helps in doing this thing. So I hope you'll use template inheritance in your Django applications from now onwards. Also, I want to talk about serving static files. Now let us say I want to create a link here and I want to serve 1.txt. So in order to go to 1.txt, instead of putting the entire URL for 1.txt, what I can do is I can actually load the static file. So I'll show that to you. So I'll simply Google load static in Django and I'll get something from the Django documentation. So you can see that I can simply say load static somewhere in my website. I'll say it here, or rather just above the body. You can call load static somewhere, and after you call load static, you can actually write this syntax. And once you write this syntax, you can serve your static files. So I want to serve my static files here. So instead of saying example.jpg, I want to serve 1.txt. So I'll say 1.txt and I'll simply say go to 1. So once I reload this page, what will happen is I'll click on go to 1 and this is not serving the file. So there is some problem. I'll have to look into the problem. Okay, so the problem is I've not used percentage. I'll have to use percentage sign here and here as well. And now it should definitely work. So let's see if it works. So I'll reload the page and I'll go to 1 and you can see that I am able to go to 1.txt. Why is this important? Why do we not write the entire URL and use this syntax? We are not writing the entire URL because we don't want to change the URL in the future and break this link. So let us say I was to change the static into static 2. If I change this to static 2, I'll have to make a change here as well. But if I use this syntax, it will automatically take the entire URL from my settings.py, which is really very beneficial. So I hope that this tutorial of Django gives you a good enough introduction on using Django. If you want to see more of Django, I have another course on Django, which you should definitely check out. I will give you link to my Django course. You can go to my playlists and we have a Django course here where I have covered everything in great detail. I hope you will love this Django tutorial. Now what we'll do is we'll look into the deployment of Django website. I'll quickly tell you how to deploy a website and then we'll conclude this video. Now I'm going to talk about how to deploy this Django website. And in order to do that, what we are going to do is we'll come to an article that I have written for you. And I'm going to find that article, how to host Django application using Gunicorn and Nginx. So this is a blog that I've written for you and I'll link this blog in the description, and this blog contains all the information that you need to know to deploy your Django website. But in order to deploy a Django website, we need a VPS. Now what is a VPS? VPS stands for Virtual Private Server, and in DigitalOcean it's called a droplet. So it's basically a server that you can build. What I'll do is I'll build a $5 server. So all you need to do is sign up for DigitalOcean and you will need a $5 basic droplet. And then what you can do is you can choose a data center region and then it asks for an SSH key, or you can also use a password. If you want to use a password, you can create a root password and then you'll be able to log in to your droplet using password. But if you want to create it using SSH key, you can definitely deploy your SSH key here. But if you don't know what SSH key is, use a password. Now I want to create one droplet and I'm going to call it PWH Django tutorial, or rather let me call it Python tutorial. So I'll call Python -pwh tutorial and I'll create a droplet. Now, after creating this droplet, what I'll do is I'll log into this droplet. And in order to log into this droplet, I'll use SSH. And these things might sound strange to you at this point, but follow along. And as and when you keep deploying your websites, you'll definitely learn a lot more about all this stuff. So I'm waiting for this droplet to be built. And once this droplet is built, we'll log into this droplet and we'll deploy our Django application. But in the meantime, what I'm going to tell you is what a VPS is. So VPS is basically a server which is there on the cloud. So DigitalOcean has maintained a plethora of servers for us, and they basically manage this server using some sort of computer program or something. But at the end of the day, after SSHing into this IP address, I can go into this computer, or rather access the terminal of this computer, which has a certain amount of RAM and certain amount of disk space. So this is a virtual computer. So the best thing about this computer is that it is open 24/7. So I'll simply say SSH root at the rate of IP, and I'll be able to log in after I type yes. And I'm able to log in without a password because I used SSH key from this machine. If you are prompted for a password, you should definitely enter your password and you should be good to go. Now what I'll do is I'll use this blog and I'll step by step install everything that is required. So I'll update the package index using this sudo apt update. This actually updates the package index, so whichever package we are installing inside the server will be latest. The next thing we want to do is we want to install Python inside the server and Nginx inside the server. So I'll run this command. This will install Python and Nginx, and it's asking for a prompt. So I just entered Y. In fact, I typed Y and pressed enter. I'm waiting for Nginx and Python to get installed, and in the meantime, I'll grab the next command, which is creating a virtual environment. So you can either install virtual env or simply say Python 3 -m venv and the name of the virtual environment. So let me follow this way. I'll copy this. I'm waiting for this Python 3 to get installed on this VPS. I'm waiting for it. I don't want you to think of this VPS as a computer which is there in front of me. I am actually using terminal of a cloud computer, which is a VPS. So VPS stands for virtual private server. I hope you understood what a VPS is. So we are basically using this server, and now I've created, in fact not created, I've installed a package called virtual env, which I can always use to create a virtual environment. So what I'll do now is I'm creating a directory, project dir, and I'm inside this project dir because I have entered cd project dir. Now I'll create a virtual environment called env, and it has created a virtual environment. Now what I'll do is I'll activate this virtual environment and then install everything that is needed for this Django application. So let me run this command to activate this virtual environment. And this is how you activate a virtual environment in Linux. In Windows, we use activate.ps1, but in Linux, we use the source and followed by env/bin/activate. And after doing this, what we'll do is we'll say pip install Django gunicorn. So we are basically installing Django and gunicorn inside this virtual environment. So let me press enter and pip install Django gunicorn. Now what I'll do is I'll simply copy this. So what I'm going to do is I'm going to start a project called textutils, but let me not do that. Let me copy this code to this VPS. And how can I do that? I'll tell you how to do that. So just search for an application called FileZilla on the internet. So I have actually opened this FileZilla app. If you don't know what this FileZilla is, you simply go to the internet and install FileZilla. I've written blogs on this topic as well, but just install FileZilla client. And once you install FileZilla client, you'll be able to open this. Enter the host, enter the username, and leave password as blank. So what I'll do is I'll simply use my IP address, which is this, and I'll put it here. Then I'll put 22 as the port and I'll press quick connect. If you're using a password, simply enter your password here. Now what I'll do is I'll go to this project dir folder and I'll copy everything from my Django application except the virtual environment, to this FileZilla. So I'm waiting for all the files to get uploaded, and once all these files are uploaded, what I'll do is I'll simply run other commands. So I'm waiting for all these files to get uploaded. These are uploaded now. Now what I'll do is I'll simply run make migrations and migrate. So let me run make migrations. So it says permission denied, project dir manage.py migrate. I am root. How can it say permission denied? So it says permission denied. So what I'll do is I'll simply say python manage.py, and it says no changes detected. Now once again I'll add python here as well, and it says no migrations to apply, which means that we don't have any migrations to apply because I already pushed db.sqlite. So all the migrations are applied, all the data is set. Now what I'll do is I'll run the next command, which is opening the port 8000. So I'm opening this port 8000 because I want to use this port. Now I'll try to run this application, and it says permission denied once again. So I'll add python, and this IP address can now be used to access the Django application. So what I'll do is I'll enter this IP address :8000, and once I press enter, it says that you need to add this to allowed host. Let me explain what this is. So what you need to do is you need to go to settings. So you can do cd and then portfolio, and then you can do vim settings.py and go to this allowed host list, and you need to add the domain. In this case my domain is the IP address. So let me press I. Yes, I can insert. I can now simply right click to paste the IP address. I think I lost my IP address. I need to copy this IP address. So I just copied my IP address, and now I'll paste this IP address here, and now simply I'll enclose it like this. Now I'll simply say :wq, and now what I'll do is I'll go back and I'll run the server once again. So I'll say python manage.py run server, and I've done that. Now if I reload, you can see this particular file has been created. So we have home, we have about, we have contact, and we have the static file. So as you can see that I have this website hosted, and you can also host your website like this, but this is not a correct way to host the website. So this Django app works for sure, but what we want to do is we want to use Nginx to serve this application so that we can use the security features of Nginx. Also, we don't want to use development server from Django. It's not safe for production. In fact, it says itself that this server is not suitable for production. It says starting development server at this particular address. So we need to find some other way to host our Django application. So if you follow the blog, you can simply use this gunicorn command. So simply copy this command and paste this command and replace text utils with portfolio, because in this case the name of our website is portfolio and not text utils. Now simply deactivate your virtual environment. Now gunicorn is working, so we'll simply deactivate the virtual environment. Let me copy this deactivate, and let me deactivate my virtual environment. All you need to do is just follow this blog and you are good to go. Now what I'll do is I'll open this and create a file. Now I'll copy this particular thing. In fact, I'll simply press copy and I'll paste it here. And now I can press escape :wq to save this file. Now what I'll do is I'll create another file. I'll create a service for gunicorn, and inside this what I'll do is I'll simply copy this and I'll paste it here. I'll simply change this text utils to portfolio. I simply need to change this user to root, and this is not recommended. I'm using root user just for the sake of this tutorial. It is not recommended to use root and run your application. In this case, I've created a user and I'm using that. You can also create a user and you can definitely use that user. Now it created a symlink, everything is set. Now I'll copy this particular command, and I have created a file called text utils. In fact, I should have created portfolio, but this is the name of the conf file, so it doesn't matter. But whatever I type in here should match the name of my project. So what I'll do is I'll simply go to the server name and I'm going to simply change the server name to the IP address. So I'll copy the IP address and I'll put it here. And now what I'll do is I'll copy this command and I'll paste it, and I'll not change this text utils because the name of my file is text utils, but change it to portfolio. It's good. Do not put it as is. Now once again I'll restart my Nginx and my website should work without the port. So I'll remove the port from here and this website should work, but it says 502 bad gateway. We need to find out what's the reason for this bad gateway. The reason in fact is that inside this file I should have changed this user to root. I should say something like this because we are using the root user, which is definitely not recommended, but we are just using for the sake of this tutorial. Otherwise, I want you to create another user, and after creating another user, you should use that user to serve your website. Now, once again, I get 502 bad gateway. Is there any other reason I'm getting this? So my server name is right. The location is right. I think I need to change the same thing for this file as well because there is no user called Harry. I need to change this to root. So I'll change this directory to root. I think there is another Harry inside this file. I need to change. So I'll simply go to this file and I'll change this Harry as well. Okay, so another thing that you need to do is allow Nginx because you need to allow port 80 on your machine. So simply run this command sudo ufw allow Nginx full and port 80 will be opened. So another issue is for my case, the directory is not /home/root, it's /root directly. So I'll have to edit these files once again. And strongly I suggest you to create a user before you do all these things. So let me remove this home from here. And I think we are good for this file. And also I'll have to edit another file, which is here. So I'll edit this file as well. And instead of /home/root, I'll go to /root and here as well. I know it's a lot of work when you're using root user. Do not use root user. Simply create a user on your server. And if you don't know how to do that, simply read my blogs and definitely you'll come to know how to do that. So I think we'll have to restart everything. So I'll restart Nginx. I'll restart gunicorn as well. Let me run these commands once again. And now I think we should be able to access our Django website. And yes, we are able to access our Django website. I hope you understood how to access your Django website using Nginx and gunicorn. And this is one of the best ways to deploy your Django website because this method is scalable. It scales very well. This is safe. Your development server is not safe. And it is fun and easy. So I'll give you a link to this blog and definitely you go check out this blog and follow the steps. Here is a link to this blog. You can simply go to this blog or simply search this title with Code with Harry and you'll get it. I hope you liked this video. I hope you understood everything that has been taught in this course. I hope you understood Python very well. Before you go, do not forget to download the zip file of all these nodes. What I'll do is I'll zip all these files and I'll put it somewhere in Google Drive or something. I'll give you the link in the description and definitely you can download these nodes. Definitely download these notes. Do not skip this step because these notes are created by a lot of hard work from my end. And if you download these notes, definitely I'll be very happy. And I hope I was able to explain you Python in a very fun and easy way. So that's all for this video. Thank you so much guys for watching this video and I will see you next time.